Hello and welcome to the C for Beginners programming class. My name is Jason Fedden and I will be your instructor. I want to thank you for signing up for this course. It's going to be a ton of fun and I'm going to do my best to motivate you and help you learn all about the C programming language. Let's get started. First, I want to tell you a little bit about myself. I have a Master's of Science in Computer Science from Binghamton University, and I also have a Bachelor's of Science in Computer Science from SUNY Oswego. I received my Master's in 2001. I've been a software developer for over 16 years. I've been an online instructor for over 11 years. I've instructed over 20 different classes, ranging from everything from object-oriented programming to compiler theory. I have a vast amount of experience with programming and computer science in general. I've been working with the C programming language for over 16 years. Basically, as soon as I got my first job, I started writing C code. I've also created beginner C and advanced C classes at multiple universities, so I have a good amount of experience with curriculum and presenting C concepts to students. I've been a software developer at Xerox Corporation for around 10 to 12 years. While I've been working here, I have been writing C code mainly and also some C++ code. We run our entire source code repository on the Linux platform, and we write real-time code. I mainly concentrate on object-oriented languages and mobile programming. This is what I love to do, so things like C++ and Java. But the C language is really what I have my expertise in. I also focus on writing high-quality code. This is a vital, important concept that I'm going to emphasize throughout the course. I want you guys to focus on writing good code. Not just writing code that works, but writing good code that will help the maintenance of the program be much easier. So some of the topics we're going to cover in the class include the following. And by the way, when we cover these topics, I'm going to provide lecture material, I'm going to provide hands-on exercises, I'm going to provide assessments. I'm going to walk you through code and programming concepts as I'm editing it in an integrated development environment. So it's going to be really hands-on. We're first going to talk about C in general, give you a little overview of it. I'm going to tell you how the C programming language is very efficient. It's also portable. You can write it across multiple platforms. It has a lot of power and flexibility, and it's programmer-oriented. I'll also provide you a short history of C just to give some context. We'll follow that up by describing some of the common language features of C. C is an imperative language. This is the most modern type of language. It's organized around functions. It has a module design. It's a structured programming language. And you can also have top-down planning when you're writing your code. The advantages of using C we'll focus on. C is great for small, fast programs. It's very reliable, very easy to learn, and very easy to understand. If you were to take a C program from a fellow peer or fellow developer, you would be able to follow it pretty quickly. We're going to use a modern cross-platform integrated development environment. We're going to edit code. We're going to also use the IDE to debug our code, which is very important. And so this will be presented as one of the concepts. I'll kind of walk you through the environment and show you how to use the tool. We're first going to start off with basic C concepts. I'm going to describe to you what a C program looks like and give you an example. I'm going to show you the structure of a basic C program. We'll talk about how you can provide comments in your code and also basic output using the printf function. We'll go through a hello world example and also have you write your first program in C. We'll follow that up with talking about makefiles. We won't go into a lot of details about makefiles, but I want to touch on it to help you understand how you can use this tool to build and compile your code. We're going to talk about the most basic programming concept there is, which is creating and using variables. Variables is the idea of associating memory, data in memory for your program with a name. And you're going to create many variables and many different statements in your code. We'll talk about data types, which includes the int, float, double, and char data types. And then later in the class, we'll talk about more advanced data types like enums and then providing your own data types by using a typedef keyword. I'll provide information on basic operators. These are things like doing addition or subtraction, math operators. It also includes logical operators like and or. This would be in kind of like decision statements. We'll talk about how you can assign data to a variable using an assignment operator. Making decisions in your code, very important programming concept. We'll touch on this. These are called conditional statements. These are keywords like if and switch. We'll provide examples and go through the various constructs of this. Follow that up with talking about repeating code, mainly looping. The big looping constructs in C are for while and do while. They're all the same, they're just a little different syntax. We're going to talk about how you can store data and categorize data to different using arrays. So we'll discuss how you can define initialize arrays and then multi-dimensional arrays, which is kind of like a matrix, spreadsheet type of concept. Functions are one of the biggest, most important concepts related to the C programming language. Everything should be used and organized around a function. This is referred to as module type programming. You're going to learn how to declare a function, how to use it, how to pass data to it, how to return data from it. We'll also talk about more advanced concepts like call by value and call by reference. Debugging. Debugging is a vital concept and essential for all programmers. It's this idea of finding and fixing your errors. We're going to discuss the call stack, which can show you if your program crashes, where it crashed. Very important concept. I'll provide you with common mistakes that many C programmers make so that if you do see these mistakes, you understand how to fix them. And then the compiler. The compiler will check your code to make sure it's syntactically correct. And if it's not, it will give you error messages or warnings. You need to understand what the compiler is telling you. So we'll talk about the compiler messages and how to understand them. We're going to discuss structs. You're going to learn all about structs, which is similar in arrays in that it stores data. It's a data structure. We're going to discuss how you can initialize structs, how there's this concept of nested structures. For those of you that are familiar with objects, it can be kind of relatable to that, but is not as robust. Character strings, which is essentially a string in C, alphanumeric characters inside double quotes. This is one of the basic data types, but it's thought of as an array in C. It's a little different concept. We're going to go through that. We're going to talk about some of the operations you can perform on strings and so forth. Pointers. Pointers are probably going to be our most important concept in this entire course. So we're going to spend a lot of time on it. Pointers is this concept in C where you have to manage your own memory. It may be a non-familiar concept to you if you programmed in other languages because this is usually done for you. Specifically, if you program Java or C#, you don't have to worry about pointers. In C, you have to worry about managing your own memory. So pointers are a big deal. I'm going to tell you how you can define and use pointers, how you can use them with functions and arrays, how you can call different standard library calls to create memory, and also how you can dereference pointers. It is an important concept, like I said, and we're going to spend a lot of time on this. I'm going to provide you with a lot of examples, a lot of real-world type scenarios, so that pointers are really driven into your brain because you can't use the C programming language without fully understanding pointers. We'll spend a lot of time on this. The preprocessor we're going to learn about. This is a step that happens before the compiler. Specifically, there are directives that you need to understand, like define and include. We'll go through that. We're going to go through input and output, how you can read and write data to the console. We talked about printf. We're going to go in a little more detail into that by using getchar and scanf, format specifiers, things like that. We're also going to talk about how you can read and write data to a file. This is another sort of important concept when you're writing code. It's a way of storing data. There are many different file operations in C, and we're going to discuss some of those. C is a very low-level language in that it can do a lot of things efficiently and fast. And file writing and reading is at that low level. It can interact with the operating system pretty nicely. There's a standard C library that comes with the C programming language where there's a lot of different functions that you can utilize. There's string functions, string manipulation functions. There's math functions, utility functions. We're going to go through all of these basic functions that you can use that help you write code more efficiently. Just like different libraries in other languages, C is going to provide you with some of the basics. Again, in order to write and read from files, manipulating strings, if you want to get cosine and tangent for math functions, that's all provided for you by the language. We're going to learn about that. And those are the main topics that we're going to cover, beginning topics. We're not going to go into any advanced topics yet. but we're going to cover the basics, the fundamentals. So at the end of this course, you should be able to write beginner C programs, understand the fundamental aspects of the C language, know how to provide input and output, do file and I/O, drill down the concept of pointers, etc. You're also going to, as we go through this course, focus on writing high quality code, efficient code. This is very, very important. Again, it affects the maintenance phases of the software lifecycle. So if you want to find and fix your errors, it's much easier to do that if you have high quality code. So as we go through examples, as we learn these concepts, we're going to learn how to do it the right way. We're going to learn how to make things modularized so that things are grouped into functions. We're going to make sure that in our different files, we have low dependencies, low couplings, so that they don't affect one another. When you have a lot of dependencies in your code, you can, it's much easier to find and fix your bugs. And if you ever want to add new functions or add new code to a program, it's much easier to do that if it's modularized, if it's organized in functions. So we're going to focus on this concept of writing high quality code. We're not just going to get things to work. We're going to do it the right way. At the end of the course, you'll be able to find and fix your own errors. An essential part of becoming a good programmer is problem solving. We're going to focus on problem solving techniques and how to debug your code and how for you to become an efficient problem solver. This includes understanding the compiler messages. It understands how to run a debugger, how to use the call stack, all these nice things. Problem solving is going to be drilled in all lectures. You're going to understand the fundamental aspects of the C programming language, topics I mentioned previously. This is going to be basic C stuff. Lastly, you're going to have fun. I'm going to do my best to motivate you. I'm going to have fun and exciting examples. I don't want you to fall asleep during lectures or exercises, so I'm going to make them lively, and I'm going to do my best to motivate you and help you throughout this course. So I'm looking forward to it. I'm really excited, and I hope everybody is ready to learn a lot about the C programming language. Thank you. Hello and welcome back. In this lecture, I wanted to talk a little bit about how the class is organized. The reason I wanted to provide this quick, short lecture is so that it can help you better decide on whether or not you want to sign up for the class, purchase the class. So this class is a little different than many of the classes on Udemy in that it's not just a how-to. This class is organized around explaining all the concepts of a programming language. It's really focused on the why. In addition to providing the how, I'm going to provide many how-tos on how to write certain programs and demonstrate different concepts. But again, it's a little unique in that it's just not a how-to. You're going to understand concepts. You're going to understand why you're doing the things you're doing when you're writing your code. So it's a complete learning experience. At the end of this class, you're going to fully understand the programming language. Specifically, you're going to understand how the programming language works and all the concepts associated with that language. And again, as I mentioned earlier, I find this is lacking in many of the Udemy courses. Many of the Udemy courses are nothing more than demonstrations of projects, of certain how-tos on how to create a particular coding project without fully understanding what you're doing or why you're doing it. I also want to describe how I'm going to present this information and how you're going to learn it. First and foremost, we're going to have all video lectures. You know that the policy in Udemy is mainly that. The way they're going to provide a lot of some of the material is I'm going to provide it through PowerPoint slides. And some people are negative on PowerPoint slides. They don't really like to learn from PowerPoint slides. They're just real not keen on it. The reason I provide PowerPoint slides is because I have to provide these concepts and definitions often is the case. And they're very abstract. And I can't just go into an IDE and demonstrate the code. I have to provide the concept in some kind of text. Now, I could provide that in Notepad, WordPad, any other editor. I choose PowerPoint because it has a nice visual representation, and it's very useful in that manner. I'm not going to just be reading from the slides. So I will hear some complaints often in other classes where, hey, you're using PowerPoint slides and you're just going to read from them. Well, no, I'm not just going to read from them. I'm going to provide insight via my experience. So the PowerPoint slides, again, they're designed to provide for you the understanding of the material. I'm not sure any other way I can do that without providing at least some PowerPoint slides. especially concerning abstract concepts and definitions. I just don't know no other way to do it. You have to listen and you have to try to understand from it. Now, that doesn't mean we're not going to provide other concepts of learning, but there are going to be PowerPoint slides. So understand that coming into class, and these are going to contain thorough explanations via my experience. It's a way for you to understand the concepts in the class. It's not the only thing that I'm going to provide, but you are going to see PowerPoint slides. So don't just necessarily get negative on the entire class because there are PowerPoint slides. It's one technique in helping you learn, and I think a technique that is needed in the class. In addition to the PowerPoint slides, I'm going to do tons of practical hands-on demonstrations of code. So I'm going to bring up the IDE. I'm going to bring up an editor. I'm going to show you how to write the code in an editor. I'm going to provide code examples. I'm going to type in the code. These are going to be concrete. They're going to be real world. So this type of learning will be more practical and it will be more hands-on learning. And I know many students like this, and it's needed. I love it because it's more practical and you can see how I'm writing code. Again, though, if I'm trying to present information or concepts such as polymorphism, I also want to provide a lecture or a PowerPoint slide associated with that to give you a formal definition. So that we don't just dive into the code and then you have to kind of scratch your head and say, what exactly is he doing in the code? So PowerPoint slides, in addition to demonstrations, are going to be provided in this class. This will help supplement your learning of the language itself. In addition, you need a way to assess how well you're doing in the class and what you're learning and if you're learning. So we're going to provide challenges. Challenges are essentially coding assignments. They're additional projects. How it will work is I'll provide you with this assignment. I'll tell you the requirements, explain, maybe give you some tips on how to complete the challenge, and then you'll go off and do it on your own. And then I'll provide another video which will be a solution to that lecture so you can see whether or not you did it correctly. The solution will be a complete walkthrough or what is called a code along of the solution. I'll go line by line explaining every line of the solution in an integrated development environment, in an environment where you write your code. I'll run it, I'll demonstrate how it works, everything. And then in addition to going through this video walkthrough, I'll also provide all the source code to you so that you can download it and you can compare the source code to your source code in text. But again, I wanted to just provide this quick lecture so that you know how the class is organized in terms of how you're going to learn and what you're paying for. And if you see a lot of PowerPoint slides, try to give you an idea of why I provide them and why I think they're useful. Again, I want to provide a complete learning environment. And I don't think I can do that by just doing a how-to of walking through projects. So I hope you appreciate this lecture, and I hope you understand where I'm coming from and how you're going to learn in this class. Thank you. Hello and welcome back. Let's talk about the fundamentals of a program. Since this is a beginning programming class, specifically we're going to be talking about C. Before you can understand even a programming language, you need to understand what a program is. So I want to describe some basic concepts to you before we get started in the details of C. Computers are very dumb machines. You guys are, I'm sure, more than not familiar with what a computer can do and what it does. Specifically though, under the hood and what's going on in terms of when you click your browser, when you click your different applications that you use, what's happening under the hood is there is some kind of program that's running, and that program is telling the computer what to do. Computers are really dumb. They only do what they're told to. So the basic operations of a computer will form what is known as the computer's instruction set. Right? An instruction set, if you can kind of think about that, it's just how it's going to do something. So we need to tell this computer how it's going to do. We do it in the form of a program. At an even lower level, each computer has what's called an instruction set. And an instruction set is basically the instructions on the CPU, the processor of the computer. So to solve a problem using a computer, by telling it what to do, you provide this solution by sending these instructions to the instruction set. So that's what's happening when you write a computer program, is you're sending specific instructions to solve a specific problem via commands to the CPU, the processor, okay? And the approach or method that is used to solve the problem is known as an algorithm. So for you guys that understand math, an algorithm is just again, how you're solving a problem. So for example, if you were to create an entire program and all it does is test whether or not a user enters an odd or even number, what would be described as the algorithm itself is the test, whether or not the number is even or odd. That's the algorithm. The statements that solve the problem in its entirety becomes the program. And we'll discuss this concept in algorithm. Algorithm is even more kind of related to module programming. So we'll talk about that when we talk more about the details of C. But again, I want to let you understand what you're doing when you're writing code. What's going on at the very, very lowest layer. You're going to write these algorithms that are contained inside of a program. So to write a program, you're going to need to properly write the instructions to implement the algorithm. These instructions can be expressed in any kind of statements of a particular language, programming language. So we're going to focus on C for this class, but I'm sure you've heard of other programming languages like Java, C++, Objective-C is used in iOS applications, but actually more now. It's Swift is used. But there's all these different programming languages that you can learn that essentially are going to allow you to send instructions to the CPU in the form of algorithms and statements. Also, wanted to talk about some basic terminology. The CPU, the central processing unit. This is the brain of the computer. This is where most of the work is being done. This is where instructions are executed. Memory. You often hear this term memory, and students often get memory very confused with the hard drive. Memory is not the same as the hard drive, right? Memory is often referred to as RAM, which is random access memory. All of the data that's stored in memory, it's a separate hardware component. It's not an actual disk drive. All of the data in a program is stored in memory, this separate hardware component. So it stores the data of the program while it's running. And we're going to talk about variables and what they mean, but a program needs to have data in order to perform calculations, in order to do algorithms. That data is going to be stored in RAM, memory. The reason we store it in memory as opposed to storing it on a hard drive is that memory is much faster. It allows the program to run much quicker. But memory is also usually not persistent across reboots, another kind of clarification. But you should understand just this term RAM. It means memory. It's the variables and the data in the program itself where it's stored. It's a separate hardware component than the hard drive. The hardware drive is something you buy with the computer that's permanent storage. This is usually really, really large, contains gigabytes, terabytes of data. This stores files that may be resources of a program. And when you turn the computer off and turn it back on, those files are still there. When you turn the computer off and on, and the program actually stops executing and there's nothing in RAM. So understand the difference between RAM and hard drive. It's an important concept. Again, think of RAM as related to programs, hard drive related to permanent storage, and we usually put resources on there. We'll have operating system files, all sorts of different program resources. An operating system is developed to basically make your life a lot easier when you want to use the computer. Because at a very low level, a computer is just doing what it's told, and it's just instructions on using an instruction set, it would be very, very difficult to use if you were to have to understand all these instructions. So there's a program called an operating system that makes it easier for a user to use a computer. It controls all the operation of the computer, handles all the input and output via hardware, so it understands how to interact with a keyboard, a mouse, a monitor. It also manages the computer's resources, handles execution of different applications. An operating system is a completely separate class. There's a lot that goes into an operating system, but understand the basics of it. It's just allowing you to use your computer in an easier manner. Some examples of very common operating systems are things like Windows, right? Everybody uses Windows, Windows 10, Windows XP, whatever the case may be. Linux, Unix, which we'll talk more about when we talk about the history of C. Android is an operating system for mobile devices. iOS. These are specific programs that are very large that may contain many different programs that interact and make your life a lot easier with interacting with the computer. The FEX execution cycle. This is the life cycle of a CPU. I only mention this because, again, we're just describing basic terminology. This is how, when you send instructions to a computer, the CPU, what's actually happening is You're fetching the instructions from memory because that's the program, and then you're going to execute that on the CPU. And it's this kind of loop. You're doing it over and over and over. You're repeating it. And if you've ever heard of the term gigahertz, a gigahertz CPU can do about 1 billion times a second, 1 billion instructions a second. So you can kind of imagine what's going on when you're running a computer with this fetch execution lifecycle. And here's a little illustration that I took from an image on the internet that shows you this fetch execution cycle a little bit clearer, what's going down when you're interacting with the CPU and these instructions. What's happening is you're grabbing from RAM, and RAM, remember, contains programs data. You're grabbing data there for instructions, and you're constantly decoding the data, which is stored in registers in RAM, and then executing it on different parts of the CPU, either the control unit or the ALU. And it's a loop, though. It just repeats over and over and over. And again, for CPUs nowadays, you get 1 billion times a second. So when we talk about C programs and writing C programs, at the very low level, underneath everything, we're just interacting with the CPU via our higher level programming language. So a higher level programming language. Higher level programming languages make it easier to write programs. Now, if we were to have to, again, understand all these instructions on the CPU, it'd be very difficult to write. And to understand all the instructions, that usually means it's an assembly language. If you've ever heard the term assembly language, it just means you're writing a program at a very low level, where it's such a low level that you understand the instruction set. And you can imagine that if you were to write all of your programs with all these instructions, it would be very inefficient and very difficult to write a program. So higher level programming languages are the opposite of an assembly language. It's a much higher level. An example is C. C is a higher level programming language. It describes the actions that the program is going to perform in a much more abstract way. You don't have to memorize the instructions on the CPU. You just understand the language itself, and you solve problems through these algorithms. It looks much more like the English language. It's much more easier to understand. If you were to look at an assembly language, what you're going to see is move commands with registers, with numbers, basically just numeric statements. And by using a higher level language like C, you don't have to worry about any of this. You don't have to worry about the instruction set. You don't have to worry about assembly language statements. So it's much more efficient, and it's much easier to accomplish and solve problems. And so we're going to study C as our higher level programming languages, but other examples would be Java, Objective-C, things I mentioned. These are high-level programming languages that make your life a lot easier and are much more efficient. In addition to these higher-level programming languages, if you have this language that's more abstract, you have to be able to take that language and then run it on a CPU. You have to convert it, essentially, to instructions that the CPU understands. And so this is where a compiler comes into play. Often when you write code in programming, you're going to use a compiler that translates this high-level language, source code, into detailed machine language instructions, basically assembly language. So you're going to write a program that's going to do high-level, more abstract thinking, and then the compiler is going to generate all the millions of instructions that go to the CPU on the instruction set. So we're going to use a compiler in this class to do exactly this. We're going to write source code in a much high-level abstract form, and then we're going to run a program called a compiler to convert that code into something that the CPU understands. Nice. The other thing about compilers is they're also going to check whether or not your program has valid syntax. So when you write code, you have to follow the rules of the language. The rules of the language are essentially the syntax, whether or not you have a semicolon at the end of a statement, whether or not you use certain keywords. If you do these things incorrectly, you're not going to be able to run your program. So the compiler is going to find all of these errors, and it's going to tell you and report back to you and say, hey, you didn't write your code correctly. You have to fix them before we're going to actually convert this stuff to the instruction set on the CPU. So we're going to get familiar with compilers in a general sense, how to use them, how to understand what they're telling us. High-level languages are much easier to learn, much easier to program in than machine languages. That's the gist of this slide right now, is that by utilizing a language like C, it's going to be much more efficient and easier. When we write a program, we're going to actually perform multiple steps. And I found this illustration that really describes the steps in a really nice way. So I took this from a book. It's a basic set of steps when you write any kind of program. From the first step of defining the program objectives, understanding the requirements, to maintaining and modifying the program. So let's just walk through these steps real quick, and you're going to be finding that you're going to be doing this in this class. You're going to be, when you start to write a program, you're going to follow all of these steps. The first step is going to be to define the program objectives. This is where you're going to understand the requirements. You cannot start writing code unless you understand what you need to do. So you need to get a clear idea of what you want to accomplish in this step. After you understand the requirements, you're then going to start to design the code. When you design the code, this is how the code is going to meet the requirements. What's the user interface going to look like if it's required? How are you going to organize your program? Are you going to create different functions and try to create different algorithms and so forth? Then you're going to start implementing code. This is where you actually write the code and put it into an editor or an integrated development environment. You translate the design to the syntax of the programming language, in this case C. Understand the rules of the C language. So you can use any text editor. We're going to actually use something called code blocks. You'll typically want to use something more than a text editor, something called an IDE, which we'll talk about. Once you're done writing the code, you have to compile it because it needs to convert it, the source code, to the low-level language. We talked about this already, so this is a pretty basic step. And then you run the program. Running the program is executing it, is using it. And then that's going to be the fifth step. After you run the program, you're not done, because even though you wrote the code and it may be meet the requirements of the language, it might not do what it's intended to do. So you have to test it, and you have to find and fix your errors. So just because a program is running doesn't mean it works. I get a lot of students to say, hey, it compiled, I'm done. No, you have to make sure that when you run it, it meets the requirements and it does what you think it's going to do. So you have to constantly test. And you'll be performing steps 1 through 6 over and over and over again. You're going to be finding that you're going to be writing code, testing, writing code, testing, writing code, testing. And typically when you do this, you want to do it in very small chunks. You want to write 2 lines of code, test, another 2 lines of code, test, and so forth. So you need to test and debug. Debugging is another concept. We'll have many lectures on debugging, but this is when you find and fix your programming errors. There are certain techniques you can do, certain tools you can use that help you find these errors. And you'll learn a ton by testing and debugging, because you always can learn a great amount of information by making mistakes. And that's going to be normal. You're going to compile, and the program's not going to do what you set it to. And you're going to learn from that. And that's what we're going to do in this class. I'm not just going to show you the correct way to do things. I'm going to show you the wrong way to do things, and then you're going to see why this is wrong. The last step is maintenance. This is when the programs are released and then used by many people, but still may have bugs. So for example, when Windows 10 is released, you'll notice that it still has bugs or still crashes. And so you're constantly getting updates. And when you get those updates, that's called maintaining the program. So just because you're done writing the code and releasing it to the public, it doesn't mean you're done maintaining it. Maintenance is often the most expensive phase, most expensive step, because when you release a program, it could be out there for 5 or 10 years. You're going to have to fix these bugs so that your customers are happy. You may also want to add new features to keep it up to date in the market. So maintenance is really important as well. Maintenance happens after you release the product to the customer. So for all these steps, you may jump around, execute steps in different order, depending on what programming methodology. That's a whole other lecture as well. You're not always going to necessarily do these steps in a kind of waterfall approach where you start at the beginning and end at the last step. You may be designing and then going back and doing your testing and then going back and redesigning and so forth. So you're going to be jumping around, all depending on what's the most practical. From my experience, many new programmers in many of the classes in Udemy are ignoring steps 1 and 2 and going directly to writing the code. They're showing you how to write the code, but they're not showing you why you're writing the code. So this is a big mistake. When you start to write code, you need to understand the concepts. You need to understand the requirements. And you can get away with this in really tiny programs, but with larger programs, you're going to need to fully focus on design. Okay? So the larger and the more complex the program is, the more planning it requires. You should develop the habit of planning before coding. Do not just dive in. And you're going to notice from the lectures in this class that I do a lot of planning. I'm going to tell you in the challenges, when you start to write some code, that what you need to do and how you should design it. Right? Because this is going to make it easier for you to actually implement the code, which is step 3. So keep that in mind. You can often plan things by writing things down on paper. There's all sorts of nice documentation, designing languages out there and things you can use. But you always want to basically plan efficiently. And then as you're coding, I mentioned this earlier, but this is another very, very important concept. You always want to work in small steps, divide and conquer, and you want to constantly test. You do not want to write 100 lines of code and then say, oh, I'm done, let me go test, right? Because now, if it doesn't work, there could be an error in any 100 lines of code. It's going to be much harder to solve that problem. But if you write code in little chunks, 5 lines of code, test it, then write another 5 lines of code, test it. It's going to be much easier to find and fix your errors. So let's focus on divide and conquer when we write our code in this class. So I hope this helped. Again, this is just some basics. I wanted to provide some basic terminology. A lot of you may already know a lot of this information. But when you're learning a programming language, you have to understand these basics. Thank you. Hello and welcome. Let's talk about the C programming language. We can finally start learning a little bit about C. I want to provide a overview and give you a little idea of how C came about. So C is a general purpose imperative programming language. It supports structured programming. Now we talked about higher level languages and we described how C is a higher level programming language. This just means that it's easier and more efficient to use than writing an assembly language, understanding instruction sets. Specifically though, it's very general purpose. And what this means is you can write all sorts of applications in the C programming language. Some programming languages are very application specific or domain specific. So for example, a programming language like COBOL, you can really only use to write business applications. A programming language like MATLAB or a tool like MATLAB, you can only write certain applications. C, you can write operating system applications, you can write general programs, all sorts of different types. It's also an imperative computer programming language, which means that it's basically organized around statements, variables, things like that. If you were to study computer programming in more detail, you would see that there are different types of programming languages, things like functional programming languages or logic programming languages, where that just means that the programming language is organized a bit differently. For example, like logic programming languages just have a set of predicates and ask questions. C is imperative, a set of statements explaining what to do. So you're going to use these statements, you're going to write this line of code in your program, and essentially what it's going to do is it's going to change the state of the code or the state of the data. It's going to focus on how to get things done, and you're going to be creating variables and data and memory and algorithms and using statements to do this. It's one of the most widely used programming languages of all time, and that's just a fact. And that's one of the great reasons to learn it, is because it's used on so many different applications and so much different code. It's been around quite a while as well. It's a modern language. And what I mean by this is it uses most of the basic control structures, and these are things like conditional statements, if statements, and features of modern languages. So it has functions, it has variables, all this nice stuff that most modern languages employ. It's designed for top-down planning, which means you can start right at the top and go down when you plan. So you can start at the user interface level, and then you can go down to the lower level and actually implement lower level code. It's organized around the use of functions. So for you math people out there that understand what a function or a module design is, this is pretty basic. But functions are a way to organize your code. We're going to give a lot of examples on functions in module design. So it's not important to understand this right now, but you should understand that at a high level, C is going to be organized around this concept. And it's very reliable and very readable. Reliable means that when you write the code, it's going to do what you tell it to do. It's not going to just crash for no reason. And readable means that when you look at it and you look at the source code and the statements, that you can kind of understand what's going on if you understand the language. You don't have to kind of guess and say, well, what are they trying to do here? Or what does that mean? Or it's not complex. It's very easy to read, to understand a C program when you see it and after you understand the language. It's used on everything from mini computers, different operating systems, mainframes. It's, like I said, it's widely used, so very useful to learn. It's the preferred language for producing word processing programs, spreadsheets, and compilers. A lot of compilers are written in C. We understand we understood what the term compiler means from our last lecture. This is a reminder. This is what takes the source code and translate it to that instruction sets. So you can actually write a compiler, which is just a program in the C language. Very nice. It has become very popular for programming embedded systems. Embedded systems are things like microprocessors found in automobiles, cameras, DVD players. Embedded usually implies the program has to be efficient. It's running on not as much memory, not as much high-level hardware. So embedded, you can also think of real-time programming. And it's become quite popular in that because it is so efficient. It also continues to play a strong role in the development of Linux. And when I talk a little about the history of C, you're gonna notice why. But Linux is a very popular operating system. For those of you not familiar, it's similar to Windows. It's just a different way to interact with your computer. It's used a lot. It's the basis for the Mac operating system, Macintosh. And C has a big role in the writing of that operating system. So again, another important reason why you want to learn this language. I mentioned earlier C programs are high level, and that means they're more or less easy to modify and easy to adapt new models or languages. Another benefit. In the 1990s, many software houses began turning to the C++ language for large programming projects. Now you may ask yourself, well, why does that matter? We're learning C, not C++. Well, the reason that matters is because C is a subset of C++. So C is organized, I told you it's organized around functions, module design. C++ is organized in terms of objects. We're not going to study objects in this class, but the reason I'm mentioning C++ is because if you learn C, you're going to know a lot about C++. And C++ is another really popular language. So any C program that you write is going to be a valid program in C++. So it's going to be great if you ever want to move on and you want to learn C++, you're already going to know half the language because you're going to know C. So very important. C is a subset of C++. C remains a core skill needed by corporations, and it always ranks in the top 10 of desired skills. Again, another reason to learn it. I use C every day at my job. I work at Xerox. I use it every day. We program on Linux operating system, and we write C applications, and we also write C++ applications. It's not an old language. It's never used anymore. It's used quite a bit. So if you're sitting there thinking, "No, I don't want to waste my time with C. I want to go learn something new and interesting, Ruby or something even newer like Go or something," C is still popular and still widely used and still a skill that's required by many, many industries. So by learning C, you're going to have a very marketable resume. You're going to be able to get a lot of different positions. C provides constructs that map efficiently to typical machine instructions. So we talked about this idea of a compiler, and machine instructions are at the lowest level. Because this mapping is so easy in C, it's often used by programs that were previously implemented in assembly language. And also the reason for this reason, it also is very easy to write operating system or embedded programs, like I mentioned, for this reason. So it provides low-level access to memory, and it has many low-level capabilities. It can directly interact with hardware. A lot of drivers. Drivers are programs that interact with hardware. A lot of drivers are written in C. And it requires minimal runtime support. And the reason for this, again, is because it easily maps to assembly instructions. Now, a little history about C is it's an older language. It was invented in 1972 by a guy named Dennis Ritchie of Bell Laboratories. He was working on the Unix operating system, which is a precursor to Linux. It's basically an operating system that's running on different hardware. Linux runs on PC hardware. So it's older, which is an advantage. You think it may be a disadvantage, but it's older, so it's been tried and tested. It's reliable. It was created as a tool for working programmers. The main goal when designing the language was for it to be useful and for it to be easily readable and writable. I mentioned readability is basically looking at the program and being able to understand what's going on quickly. So it's not that complex. Writability is being able to write the code quickly, efficiently, be able to do things quickly. So if you were to write some code, you don't have to write 20 lines of code to add 2 numbers. You write 1 line of code. It's very easy to write. So readability and writability are important goals and important advantages of programming languages, and C easily meets this. Some more history. It initially became widely known as the development language of the Unix operating system. And virtually all the new operating systems that were written after 1972 are written in C or C++. Okay, again, very popular, very, very useful. It evolved from a previous programming language named B. Go figure. That's why it's named C. I guess they weren't very clever, and they just said, hey, B, C. There's also a language called D, by the way. It uses many of the important concepts of B while adding some data typing and other powerful features. You might not have a clue what data typing is. Don't worry about that right now. Know that it added some new features from B. Mainly B had this issue of typeless, meaning data didn't have types. And C improved upon that. It's also available for most computers. So this is an advantage, meaning that if you want to write a C program, you can write it on most operating systems. You can write it in Windows. You can write it on a Mac. You can write it on a Linux operating system. And it's also hardware independent, another important factor when writing code. If it's hardware independent, that means it's more portable. What that means is you can take the program, you can run it on a different operating system. So available for most computers means that you can write a C program. It doesn't necessarily mean it's going to work unless it's portable. So by being hardware independent means it may work on many other systems. So by the late 1970s, C had evolved into what is now referred to as a traditional C. This is what you're going to see in this class, traditional C. The rapid expansion of C working on many different hardware platforms led to many variations. So I want to talk a little bit about the different variations of C. And what this really means is there's different standards. So just like there's a Windows 10, a Windows 8, a Windows 7, there's different versions of C. There's C89, C90, C99, and C11. And this basically represents the years, 1989, 1990, 1999, and 2011. So there's standard versions of C. A program written only in standard C and without any hardware-dependent assumptions will run correctly on any platform with a standard C compiler. It's always important to have standards. So what we're really just saying here is there used to be many different variations of C, and we started to standardize it in 1989. And by standardizing, we can now run it basically anywhere. We don't have, oh, hey, Microsoft is going to release their version of C. Google's going to release their version of C. We don't have that problem anymore. We standardized it. If you have non-standard version of C, it might not work on different operating systems or different devices. So standardization is important. I mention this because I want to tell you what standard we're going to focus on and tell you a little bit about the standards. C89 is the first standard, 1989. It's supported by almost all the C compilers. Most of the code you see out there today written in C is based on C89. It has the basic constructs. And so each standard may have new features of the language and so forth. That's another reason that it's important. But C89, since it's the oldest, it's the most widely used. C99 was a little revision where it expanded on some of the functionality of C, some of the capabilities. It hasn't been widely adopted, and not all the compilers support it. But we'll be focusing on mainly C99. So the current standard is commonly referred to as C11, 2011. Not used as much, but it does have a lot of cool features, a lot of awesome different things. We'll talk about all three standards, but we'll focus on C99. And just to describe a little, the C11 compiler may not implement all the language features mandated by the standard. That happens sometimes. But we'll base our examples and concepts off of C, all three standards, focus on newer concepts in C11, but mainly C99, which is the basic concepts. So I mentioned this before, but again, I want to reiterate. For all the reasons I mentioned so far, this is why C is so important. This is why it's important to learn, and this is why it's popular. And the reason for this is because people like it. It's easily to write, easily to read. And as we mentioned earlier, Dennis Ritchie's goal was to make it, to have it be used by developers. It's a developer language. So in the past decade or two, you may have moved from C to languages such as C++, Objective-C, and Java, but C is still important. And again, I'm beating this to death, but it is important. By learning C, you can easily migrate to these other languages as well. So for all these reasons, this is why you want to learn C. A basic introduction, a little bit about the standards, a little bit about the history, and now we'll dive into more details of the programming language. Thank you. Hello and welcome back. In this lecture, I want to discuss some of the specific features related to the C programming language. So we know all the advantages of C. I talked about that kind of ad nauseum. We know that C produces compact and efficient programs. That is a language feature, though. That's important. It's one of the most important programming languages and will continue to be so. We know all this. So I just, again, want to reiterate it. But the main features of the C language are that they're efficient, portable, powerful and flexible, and programmer-oriented. And we're going to cover these in more detail, what this means. But these are important characteristics of C. We need to understand them, again, in order to understand how to write the code in this language. So what does efficiency and portability mean? Well, C is an efficient language. It takes advantage of all the capabilities of current computers. It's very compact programs written in C. They're very fast and compact. I talked earlier about how the mapping of C and C statements to instructions in assembly language is very efficient. This is one of the reasons it's so fast. One of the complaints about Java in the past used to be, hey, Java's really slow. Well, you don't have this problem with C. When you write a program in C, it runs fast, it's very compact. So that's a language feature. That's an efficiency. Programmers can fine-tune their programs to make them even more efficient because it is such low level. They can use more efficient use of memory. You can't do things like this in Java. Java has its own garbage collector, and you can't manipulate the memory to be more efficient. So C is an efficient language. And it's a portable language. So I touched on this briefly in a previous lecture, but this is important because what this means is if you write a C program on one operating system, you can run it on another operating system without modifying it. One of the issues when writing code in today's world is sometimes it's not going to work unless you write it in multiple languages or modify it extensively. So for example, if you write an Android application for an Android phone, it's not going to work on an iOS phone. Right? You don't have those types of issues with C. You write C and it will work on all sorts of different hardware, all sorts of different operating systems. In fact, C is the leader in portability, this capability, and the compilers are easily available. You can get a compiler on Windows, Linux, no problem. Linux, Unix systems typically come with a C compiler, so you don't even have to download it when you're on Linux, Unix. Same with the Macintosh. So you can start writing C programs immediately. No external downloads. They're also available, obviously, for Windows, but typically for Windows, you will have to download a compiler. And we're going to be doing that when we download our required software. So there's a good chance that you get a C compiler for any device that you're using. You could probably get a C compiler also for an Android device or an iOS device. Really low-level micro or mini computers as well, like processors and automobiles. It's also very flexible, which is important, and it's also very powerful. So the Unix Linux kernels are written in C. What is a kernel? Well, we know Unix and Linux is an operating system. We know an operating system will help you more efficiently use a computer, and it controls a lot of the aspects of interacting with hardware and so forth. The kernel is the brain of the operating system. So just like a CPU is the brain of a computer, a kernel is where really all the brain and knowledge of the operating system goes. So it typically contains interfaces of the hardware and the kernel. It manages memory. It does all sorts of different things. And that is all written in C. So that can tell you the powerful aspect of the language. If the kernel of an operating system is written in that language is powerful. So many compilers and interpreters for other languages are built on C or have been written in C. So if that doesn't tell you the powerful nature of the language, I don't know what will. But Fortran, Perl, Python, any compilers that are written in those type of languages are written in C. So C programs have been used for solving physics and engineering problems and even for animating special effects for movies. Widely used for many different things. Flexibility is also important, especially when you're a developer and you're writing this code. You want to be able to do things in different ways. You want to be able to solve a problem in many ways. More flexibility, typically the better. However, there is a trade-off between flexibility and performance. So you want to so sometimes it's catchy when you're designing a language. But C was designed to be flexible and is very flexible. So you can do just about everything you want in a C program. You can write all different application types, and you can also manage memory and do different things that many other languages restrict you on. There is a trade-off because sometimes the flexibility causes more bugs or causes developers not to fully understand certain concepts because they may be more complex. But ultimately, flexibility is a good thing, especially if you're a developer that understands the language very well. It's also the basis for more advanced languages such as C++, mentioned that earlier. It's used for developing mobile phone apps in the form of Objective-C. Objective-C is a proprietary language by Apple. Basically, it's C with objects, just like C++, but they decided to write their own language. But it is used in iOS, less and less so, because Swift is being more popular. But it's also easy to learn because of its compactness. It's an ideal first language to learn if you want to be a programmer. And I think I've given the rationale for that pretty good. You're going to acquire sufficient knowledge for practical application development very quickly and very easily. So that's why it's a good first one to learn. And that's what you're going to notice in this class is, wow, now that I learned C, wow, it's much easier to learn Java. It's much easier to learn PHP. It's a lot easier to learn these other languages because it has everything that those languages have, and it's very easy to learn. It's programmer-oriented. That's a language feature. It fulfills the needs of the programmers. I told you how Dennis Ritchie, when he created the language, wanted to make it more developer-focused. And he did that. He accomplished that goal. It gives you direct access to hardware. It enables you to direct access to memory and manage your own memory. So the flexibility comes into play when it is programmer-oriented. In Java, you can't do a lot of these things like manage your own memory. C also has many other capabilities that allow flexibility. And I think that flexibility allows be more programmer oriented because programmers like that. They like that flexibility. They don't want to be told what to do. It contains a large selection of operators, which allow you to express yourself succinctly. Now, this means we don't know what an operator is yet, but an operator can be things like adding and subtracting mathematical operators or assignment operators, assigning data to memory. And the more operators you have, allow you to express yourself more in your code. And so a language feature with being more program-oriented is this list of operators, which we'll talking about in a lot more detail. It's less strict than most languages, limiting what you can do. Kind of talked about this already. I mentioned the trade-off with this, flexibility versus strictness. It's an advantage in that you can do things in many different ways. However, it could be a danger because it's more prone to error. Programmers, especially with something like pointers. So the fact that you can manage your own memory in C is very flexible, but it's also very complicated sometimes. And as a result, many programmers introduce bugs into programs. Now, Java doesn't allow you to manage your memory, but it's also less flexible, but it also reduces your bugs in your program. So there's a trade-off. You want to basically have flexibility by also allowing things to be less complex. C gives you more freedom, but also puts more responsibility on the developer. And that's why it's program-oriented. C implementations have a large library of useful C functions, so you don't have to write everything in C if you want to do something. Programming languages would typically contain other program functionality that comes with the language. So, for example, if you want to read input from the user, you don't want to write low-level C code to do that. There will be codes in C that already does it for you, and you just reuse that code. And that's usually encapsulated in something called a library. And so C has all sorts of library functions to read data from the keyboard, to write data to files, to create all sorts of nice things with different processes and thread. I mean, all sorts of nice things. So the fact that that a lot of implementation comes with the language and you don't have to actually implement it yourself, you just have to learn how to use the libraries, is very advantageous and very programmer oriented. Some other features of C are it provides low-level features that are generally provided by the lower-level languages. We talked about this. But again, the best example of this is memory management, direct access to memory. Programs can be manipulated using bits. Wow, if that's not low-level, I don't know what is. It is the ability to manage memory representation at a bit level. Bits and bytes are how we actually store data on computers. Provides a wide variety of bit manipulation operators. Again, something in the language that we'll talk about in more detail. Pointers play a big role in C. This is a concept that you may have heard of before, you may not have heard of, but it's related to memory management. We're going to have many lectures on pointers. But it is a very, very important feature of C that you should be familiar with at the very high level. C, manage memory. C, pointers. Often when you think of the C programming language, first thing you think of is pointers. And all this is direct access to memory. Disadvantages of C. We talked about that flexibility trade-off, flexibility versus freedom. It also requires added responsibility. Some view this as a disadvantage. Some view that pointers are abused. And as a result, many people write bad C programs. Well, yeah, if you give somebody a tool to do something and they do it incorrectly, who's at fault? It's kind of, again, do you want to restrict that tool because it's abused, or do you want to allow that tool to allow flexibility? So you can often be more flexible, but it's at the risk of making more errors, and a lot of times these errors are very difficult to find and trace, especially if they're memory stuff. So that can be a problem. Other things, because of its wealth of operators and its conciseness, it makes the language difficult to read and follow sometimes. For the most part, C is very easily readable. But if you use a lot of these different operators, that can make it more complex. So there's an opportunity to write obscure code, but any language can be badly written. So you can use the English language when you speak and you can have bad grammar. It's no different when you use a programming language. But some say with C it's a disadvantage because of all these operators. It could be if you use it incorrectly, it can be harder to follow the code. So just to summarize, this is a nice illustration again I found on the web that I'd like to provide you with. The core features of the C language: fast and efficient, portable, a lot of nice libraries where you can reuse code and you don't have to do things on your own. Modularity, talked about earlier, but this is the idea of organizing your code around functions. Easy to extend, and then all of these powerful operators that allow you to do things. So a lot of nice features, and most of the features that we just talked about are in many modern languages because they're built off of C. Hello and welcome back. In this lecture, I'd like to talk about what goes into creating a C program. So there are 4 fundamental tasks in the creation of any C program. And what these tasks include editing, compiling, linking, and executing. All right, we talked about the different steps that you'll employ when you write a C program in terms of you're going to understand requirements, you're going to design your code, you're then going to write your code, you're then going to test and debug it and so forth, and then maintain it. This is what I'm talking about here is what you actually need to do after when you start to write a program. We kind of talked about editing, compiling, but linking and executing are also important. And what I want to talk about here is the details of this. So these tasks are going to become second nature to you because you're going to be doing it every time you write a C program. You're going to be editing your source code. You're then going to be compiling. You're then going to be linking, and then you're going to be running. You're going to be doing this very, very often. So the processes of editing, compiling, linking, and executing are the same for developing programs in any environment with any compiled language. This is not unique to C. If you're writing Java, a Java program, you're going to write the source code. You're going to compile the source code. Linking you might not be as aware of in Java, but it's going to do some kind of linking. And we'll talk about what linking is. And then you're going to run the program. You're going to be doing all of this. What I'm describing here, again, is how it's done in C. So editing is exactly what you would think it is. It's the process of creating and modifying the actual code, the C source code. The C source code is going to be inside of a file, and it's going to contain all the statements and all the instructions that you write. All C source code files end with the .c extension, and that's how you can identify that it's a source code file. Before that .c extension is going to be called the base name. You want to have your file names be meaningful. If you write a C program that adds 2 numbers, you may have a file called add.c that contains the source code. And remember that a C program, in most C programs, are going to have many, many different files. So your files should have good names. But the way that you can identify C source code is the .c extension. They all contain the .c extension. Now, when we edit our code for this class, we're going to use an integrated development environment. We're not just going to use a simple editor. An example of a simple editor would be something like WordPad. We're going to use something that has an editor, but also has many other things that help you write your code more efficiently. The IDE, and this is referred to as an IDE, Integrated Development Environment. The one that we're going to use for this class is code blocks. I'm going to cover in detail, but we're going to use code blocks for the editing task. But you can use whatever you want. If you want to use Notepad, if you want to use something even more minuscule, you can. Atom, there's Visual Studio IDEs, but the one we're going to cover in here is how to edit your code, and code blocks. And this is a nice IDE, and the reason I chose it, we'll talk about in more detail, but it is cross-platform and easy to use. So editing is the basic process, writing the code. Compiling, we know what a compiler does. It just takes that high-level language code and converts it to machine language, and it also detects and finds errors in your code. After you edit your code, you're going to run the compiler. So the input to the compiler is going to be all of your source code, all of your .c files, everything that you're editing. And again, a C program can have many source files. But the input to the compiler are these source files. Compilation itself, converting this code, is a two-stage process. The first stage is called the pre-processing phase, during which your code may be modified or added to. And the second stage is the actual compilation. It generates the assembly language code. And we'll talk about this in more detail, this pre-processing phase, but you just need to know now that there's two stages when you do compilation. The one that we're going to focus on, or the one that's easy to understand, is the generation of the object code. So the compiler is going to look at each statement, and it's going to make sure that the syntax is correct and that the semantics of the language is met. Syntax is to make sure that the structure of the code is right, that you have semicolons at the end of the statement, that you're using data types, that you're following the rules of the language. Semantics is the meaning of the words. So if you use an if keyword, that's a condition. Semantics happen in the compilation phase by creating a symbol table and so forth. But the compiler is important. It's going to generate this object code. It's going to tell you if you have any errors in your syntax. It can also sometimes recognize whether or not you have dead code, where basically code's not being used. It does not find logic errors. It only finds syntax errors. Again, syntax is the rules in the language. Logic errors are the meaning. Like if you made a mistake in logic, you may make a mistake in the functionality. So your code can run, it can compile, but it may not work as intended. And this is referred to as a logic error. The compiler is not going to tell you if you have a logic error. If you meant to ask the user for a number instead of a character, a string, or you ask the user for their last name before their first name, that's a logic error. Compiler is not going to tell you those types of errors. Typical errors reported by the compiler are going to be things like undeclared variables, expression that doesn't conform to the syntax, you don't have the right parentheses, you have, blocks that don't have ending blocks. You're going to become very, very familiar with the compiler errors and what they mean. Hopefully, after you've learned the C language and you run the compiler, you're going to see an error and you're going to be able to fix it immediately. You say, whoops, forgot a syntax, or whoops, forgot a semicolon. Oh, I forgot to provide a right bracket to end that block of code. It's going to become second nature. So after you fix all the errors and your compiling is successful, it's going to translate into assembly language and generate this object code. So the actual object code is a .o file. It's the actual assembly language code that gets run. It has an extension .obj or .o. .obj typically on Windows will be the extension. .o on a Linux or Macintosh system will be the extension. You're going to see that file generated after you compile your code. And that's just the end phase of the compilation. That's the actual assembly language. It's going to be binary. It doesn't look like text. You're not going to be able to look at it. It's just going to have a .o extension. And that's what the compiler generates. The way that you run the compiler in C is you actually use a command. You probably won't need to do this much because the IDE, the editor in the integrated development environment, is going to do it for you by just clicking a menu option. But it's important to know what's going on. So when you issue the compiler command, it's typically using a GNU compiler, which is a GCC command. But at the basic level, you just run a compiler program, either CC or GCC. You run that program, and then you specify the input. Remember, the compiler takes as input the source files. You specify the input by using a -c flag, and then specifying the source files, one after the other. So examples here are cc-c myprog.c, or if you're using the GNU compiler, which is a popular one, gcc-c. And if you omit the C flag, your program will automatically be linked as well, which is the next step. But really, it's easy to run that compiler if you're at the command line interface. It's even easier if you just use a menu option, which we'll probably be doing in this class. But again, it takes input the C source files. In code blocks, as I mentioned, you're going to be just clicking a menu option and it will automatically compile, link, and then you can click another menu option and it will automatically run. But again, what's going on under the hood is you're actually issuing the compiler command with the -c flag and the input source files. After you compile, you link. Like I said, every programming language has a linking, but a lot of times it's transparent. You won't even know what's happening. In C, the linking process is important because it's not always transparent. But with most modern IDEs today, it is. But I do have to emphasize that it is a little, it is important in C. So after the program has been translated into this .o code, this object code, it then is ready to be linked. The reason we link is if we're using external libraries, we have to grab all those other libraries and put them into one program. So linking is just getting all of the dependencies in place and building an actual executable file. So the .o file is the objects. You then link all the .o's into one executable. And again, this is usually transparent, usually happens automatically when you compile, but again, it may not. And you may have to do a separate command, like a -l or something. But it takes all those object files and builds one executable. And the executable is what you run. So it's going to combine all of those, and then it's also going to combine, and you may have .o's that are additional libraries, that other programs that you may want to use that somebody else wrote, or other libraries that come with the C language. You're going to take all of those and put them together. And the linking phase will also detect and report errors. They're two separate phases. Linking, again, will usually be like redefinition errors, or you're trying to call a function that doesn't exist. So if you don't have that .o file to make up the entire program, you're going to have a linking error. And you'll need to have all the .o's. And again, the .o's may not even be yours. They may come with the C language. They may be part of the standard library, or they may come with another program that somebody else wrote. But you need all those .o's to form one executable. So program libraries support and extend the C language by providing routines to carry out operations that are not part of the language. Input and output libraries are example. Mathematical libraries, string manipulation libraries. This is just the same thing. If you're familiar with the Java program, it's the same thing as the Java API. It's the same thing as packages. It's this concept of I want to write data to a file. I don't want to implement it myself. I'm going to use an existing library that comes with the language. It's still written in C, but it's not part. It's just C comes with that. So there's all sorts of different libraries that we're going to learn about and use. This happens part of the linking phase. So a failure during the linking phase means that once again you have to go back and edit your source code to make sure that you can find that object file. So a lot of the failures usually mean that you just need to include a file or something like that. This will become second nature as well. Success. If you're done compiling successfully and you're done linking successfully, that will produce an executable file. In a Windows environment, the executable file will have a .exe extension. In Linux and Windows, it will just have by default a.out. You can change the name of a.out to something more meaningful by just issuing something along with the compiler command. But most IDEs and code blocks as well will have a compile and link program in a single operation, and it will produce the executable, and then you can just double click the executable. Or you can run the executable from a command or from a menu option. But no, at the low level, if you're on Linux, you're going to see an a.out by default as your executable. On Windows, you'll see a .exe. A program of any significant size will consist of several source code files. I mentioned this earlier. Each source code file needs the compiler to generate the object file that needs to be linked. The program is much easier to manage by breaking it up into a number of smaller source files. You will want to use many source files, and you don't want a source file that contains 5,000 lines of code. That's not cohesive. That's not easy to manage. So you're going to create files that contain source code, and the source code is going to be specific. It's going to have a specific functionality. It makes it much easier to develop and much easier to debug, and is much more cohesive. So you're going to have many smaller source files. You don't want large source files with thousands of lines of code. And all these source files are going to make up the entire program. They're all going to have their own .o's, and they're all going to be input to the compiler. These concepts that make up the program essentially are also considered a project. You can think of it as that at a higher level. It's your project. It's your program. After you've finally done all of this and you've linked it and you've got your executable file, you can then run the program. In most IDEs, this is just going to be a menu click. Or you can double click in Windows, you can double click the exe. And if you're on Linux, you just type in a.out. Now, when a.out, you have to have certain permissions, so you have to maybe issue a change mode command. But to run it, you can say ./a.out, and that will run the program from the command line Linux. But again, usually you don't have to worry about this. So the execution stage is where you run your program. Each of the statements of the program is sequentially executed in turn. If the program requests any data from the user, the program will pause and get that input. It can get the input via the keyboard, or it can get the input via graphical user interface if you have libraries for that in your C code. Results that are displayed by the program appear in a window called the console. And we're going to show you examples of this when we talk about code blocks. But when you run your program, typically you're going to see output. Not always. Sometimes programs will do things that don't produce output, but usually they produce output, and you see the output right on the terminal or the console. The execution stage also generates a wide variety of error conditions. So you may produce the wrong output, which is just a logic error, and you have to go back and edit your source code. It may sit there and just do nothing because you have logic issues. And then lastly, it may crash your computer, which is the worst case scenario, which means that you did something really bad in your program, and it was so bad that the program just died. Or it actually caused other programs on your operating system to crash your entire computer. Right? So running the actual C application can cause problems. If the program does not perform the intended functionality, then you have to go back and edit the source code. You may have to reorganize or redesign. And this is where we talked about the different steps. This is known as the debugging phase. To find and fix your errors, we're going to have a whole section on debugging because it is that important. I mentioned earlier that one of the best ways to learn is to learn through your errors. You're going to constantly go back and edit source code and debug. The entire process of compiling, linking, and executing the program is repeated until you're done, until you have all the results that you need for the functionality of that code. So here's again another nice illustration I like to provide. This is taken from a book called Beginning C by Horton. But this is the process that you're going to have. You're going to edit your source code. You're going to create a file with a .c extension and a meaningful name. You're going to use an editor to do that, or an IDE, integrated development environment, something like code blocks. You're then going to compile it. The compiler is going to generate an OBJ file, an O file. If it doesn't generate that file, that means you have errors and you have to go back and fix them. After you create the OBJ files, the object files, you then have to link them all together to create an executable file. And you could also have errors in that phase where they're not linked properly. You have to go back and edit your source code. Once you actually have no errors and you have an executable file, you can then run your program. And again, after you run your program, you still may have errors because there could be logic errors. So then you would go back and edit your source code. So this is going to become a repetitive process that you're going to be very familiar with. Edit, compile, link, execute. And this again is typically what you do in all languages. You're going to be doing this over and over and over again until your program meets all of your requirements. Hello everyone and welcome back. We're now into a new section which is basically installing the required software. I want to just give a quick overview so there's no confusion on what you need to install. It all really depends on what operating system you plan on writing your C code in. So really quickly, there are a number of lectures in this section. You'll be able to skip some of the lectures, again, if you're not on the specific operating system. So first, if you are on Windows and you plan on writing code for Windows with C, you're going to need to install the C compiler and you're going to need to install an integrated development environment. So I provide a lecture for installing the C compiler. The C compiler we're going to install is called Cygwin. It really simulates a Linux Unix environment. The reason I'm using this compiler is that it allows you to write more advanced C applications using sockets and using some of the threads and some more advanced code. So eventually, when you do write this advanced code, you don't have to switch compilers. So I'm going to have a lecture that shows you how to install the Cygwin C compiler. It's pretty straightforward. You only need to do this if you're developing on Windows. You cannot use the MinGW compiler. That's another compiler that comes on Windows. That's not sufficient for this class because it doesn't support some of the things I just mentioned, some basic C concepts. The other thing you're going to need for Windows is you're going to need an integrated development environment which allows you to edit the code and also allows you to debug. Suggested integrated development environment that we're going to use for this class is something called CodeLite. It's a real easy to install IDE, and you're going to be able to use that for any of the platforms that you install on. The course is not dependent on any specific IDE. You can use any editor, any integrated development environment you want. These are just some suggestions because they are free and they are some of the better ones out there. They're really easy to use. So I'll provide a lecture on how to actually install CodeLite on Windows. In addition, we'll also discuss how you can configure it so that the configuration will point to the right Cygwin compiler. You can basically just set a path inside the settings to point to that compiler, and that will all be detailed in the upcoming lectures. So these are the two things you're going to need for Windows installation: a compiler and an integrated development environment. So make sure you pay attention to the lectures in this section that are Windows specific. Now, if you're going to be using a Macintosh, an Apple computer for this class, you will have to install a C compiler. Unfortunately, even though it's a Linux environment, it doesn't automatically come with the C compiler. It's pretty basic to install it. Really, you just have to install the developer tools that come along with Xcode. I'm going to show you how to do this. Although, even if you don't have Xcode, you can still install the developer tools. But if you have Xcode installed already, then you don't have to install the C compiler at all. You can skip this lecture. So there's going to be a lecture on installing the C compiler on a Mac. There's also going to be a lecture on using an integrated development environment. This will include installing the CodeLite IDE in a Mac environment. Again, pretty straightforward process. And then also, in addition, Xcode should also work. If you want to use Xcode to install, at least for the beginner C class, you can use that IDE as well. So CodeLite or Xcode. But we'll have details on CodeLite and also how to configure it to create a project and so forth. So just like with Windows, make sure you only pay attention to the lectures that are titled for Mac installation, installing the C compiler and an IDE. If you're on Linux, Linux is probably the most easy installation because it already comes with a compiler. It already comes with a GNU compiler. I'll show you how to verify that in a lecture. You can just go bring up a terminal, type in GCC, and you'll see that the compiler is already installed. And then I'll show you how to install CodeLite. Again, a very simple process, just like on previous platforms that I mentioned earlier. Linux, the nice thing about Linux is it has a lot of other editors, and really you can use any editor you want or any IDE. There's gedit, there's VI if you're old school. You can use all these basic editors, and then you can compile from the command line. And you can just run the GCC command right from the terminal. You can also do that in Linux or in Mac as well if you want. It's just a little bit more complicated. You got to remember the command. But this is how this section is going to be organized. You can skip some of the lectures that don't pertain to the operating system that you're going to be writing the code. Remember, if you're Windows, focus on the Windows lectures. If you're Mac, focus on the Mac lectures, and Linux, focus on the Linux lectures. So hopefully this helps, makes it easier to organize all these different lectures you're going to see in this section and what you can follow and what you can ignore. Thank you. Hello and welcome back. In this lecture, I'm going to show you how to install the C compiler for Windows. This is required for the class. You need a C compiler in order to write C programs. The compiler that we're going to install is the GNU CC compiler. The reason we're installing this is because it's more portable and it allows you to write code from the C89 standard. It supports a lot of different features. It allows us to use more advanced features as well. So you need to install the GNU CC compiler. Also, you're going to need to install the make utility and the GDB debugger. We're going to download this from cygwin.com. It basically simulates a Unix environment, and that's what we're aiming for. The GDB debugger is really useful for finding and fixing your errors. So you need to download either the 32 or 64-bit version of the setup file, which is cygwin.com install.html. And then it's just setup x86-64, setup x86-32, one of the two. And so let me show you how to do that. So here I have my Chrome browser. I'm just going to type in cygwin.com/install.html. You can also search for it if you want. This is going to take you to the Cygwin page, and you're going to need to install, download the setup. So again, it's right here on the home page, installing and updating Cygwin for 64-bit version of Windows or 32-bit versions. You just select either the setup-x86 or the setup-x86 64, one of these two. All right, I have 64, so I'm going to just click that. When I click it, you have to download it. I download it to my downloads directory. And then once it's saved, you'll want to run that file. So you can run it right in the browser once it's done saving. Once that's been downloaded, you can just double click on it and run it. And you'll end up seeing something like this. And you can typically keep all the defaults the same. So you can just hit next. Install from the internet is fine. Hit next. I install it in the C:\Cygwin64 directory. You can change it if you want. I usually keep all the defaults again. Hit next. And then again, defaults, direct connection, I say next. And then it will start downloading everything. You can select a download site that best fits your location, or just again, keep it by default. I'm going to keep default, hit next, and it's going to start downloading everything that we need. The next screen you're going to see is the select packages to install screen. It's really important to understand that the screen may change. So Cygwin comes out with different versions and they change things. So what you really want to focus on is if there is no bin column, do not worry about it, because some of the newer versions may have bin as default. The main purpose is that you select that drop-down list and you make sure that a version is selected. As long as a version is selected and it's showing up in the drop-down list, then that's going to be installed. You don't have to worry about the check mark for the bin for newer versions. Again, Cygwin comes out with all sorts of different versions, so this graphical screen may look different based on what version it is. Just make sure you have the drop-down list and that you actually select a version. And as long as you have a selection and they don't say skip, those are going to be installed. You'll notice it has this big window with all these different packages. We're going to only need to install 3 packages, as I mentioned before. We're going to focus on GCC-core, which is our compiler, GDB, which is the debugger, and then the make utility. First thing we want to do is we want to change the view to full. And then what we want to do is we want to search for GCC-core. And here we'll see what we want to install. And so the one we want to install here is GCC-core. We want to make sure that's checked and that we install that version. The other versions should say skip. So just make sure that it doesn't say skip. We also want to install GDB, so we can search for GDB. And in here, we want to make sure we install GDB. And again, it shouldn't say skip. It should have the version number. So we want to install this GDB version. And really, that's all the one we want to install. You can install libgdb4, but that's not required. So just select GDB. Make sure that it doesn't say skip and that you have checked for binaries. You don't need the source. And that will be the development category. Last thing we want to check to install is our make. So we can select make here. And what we want to find is the make utility install, which is right here, make. And we can say install this with a certain version. We want to make sure it doesn't say skip. We can make sure it has a certain version number, the latest version checked. And that is it. All the other packages that are required will automatically be selected. So then you can just select next to connect to the download site, and these 3 packages will be installed. So just hit next, and it will ask you to review and confirm the changes, and you just want to say next again. After you're done installing, you're going to see this. You can add a desktop icon if you need to, or start menu. I usually just leave them blank, and then I hit finish. And so your C installation is all done for your compiler. Now you only have to do that for Windows. The next step we need to do is we need to make sure our path is set up correctly. This allows us to use the GCC binary anywhere in any directory. So we're just going to bring up Windows Explorer. We can hit the Windows key and hit E, or we can go and bring it up from the start menu. And this will be our Windows Explorer box. We can then go to this PC. We can go to our C drive. This is where we installed our Cygwin environment. So here we want to go to C, and I installed it right in C, Cygwin64. So I'm going to select that. I'm going to go to the binary directory, which is bin. I'm going to select bin, and then I'm going to copy the path for the bin directory. So you can get the path right here at the top if you just select the arrow, and then you can say right click, or you can hit right click and say copy. And then what you want to do is you want to go to your this PC, right click, and you want to go to properties. And this is going to bring up your kind of control panel type thing. For system security, you want to hit advanced system settings, select that. And then from advanced system settings, we're going to be able to set up our environment variables for our path. So here we go to the bottom, we just say environment variables. We want to make sure we select the system variables here at the bottom. We want to go down and we want to select the one that says path.
right here, path, and we want to say edit. And then from edit, all we want to do is we want to add the new one we just copied. So we can say new, and then we can say Control V, or you can right click and say paste. And this is going to add in our SIG164 bin path. And then you just say OK and say OK again. And just keep hitting OK. And once we have done that, we can verify that it worked by bringing up the DOS prompt. So here we can just go to our Windows command and we can type in CMD. And this will bring up the DOS prompt. First thing we want to do is we want to see if SIGWin was installed, so we can use one of the binaries. We can say CYG check, SIG check, -C SIGWin. And this tells us that SIGWin was installed, status is okay, package is good. Next thing we want to do is we want to check to make sure the C compiler was installed. And to do this, we can use a command GCC. So we can say GCC, and we'll just say -- version. And this is going to tell us that we have GCC installed 7.4.0, and we're good to go, and we have successfully installed the C compiler.
Now, if this didn't work and you had any errors at all, for example, you might have typed in the command and it said command not found. That means that you didn't properly set up your path environment variable, so you have to go back and do the step that I just did, setting up that path environment variable so that it points to the SIGWin bin directory, so that it can actually see the executables and run them. So if you write SIGWin check and it says unrecognized command, or if you try to do GCC unrecognized command, you have to go back and fix your environment variable.
And so we're good to go. We installed the C compiler, and again, we only have to do this for Windows. With Mac and Linux. Linux come with the C compiler. With the Mac, we will have to install some developer tools, but I'll show you how to do that in that lecture. So the next few lectures, I'm going to show you how we can install other IDEs to work with the C compiler. Thank you.
Hello and welcome back. In this video, we're going to go ahead and install the CodeLight Integrated Development Environment. It's important that you've already installed the C compiler, so if you haven't done that, please go back to the previous video and do that. That's a video where we install SIGWin, the SIGWin setup, and we install C. That way the compiler will be installed before we do this next step. So if you head over here to codelight.org, we can install the CodeLight Integrated Development Environment. You're going to see a web page very similar to this. You'll see some links in the middle of the page, but what we really want to focus on is this green button labeled download at the top. So I'm going to go ahead and select this, and he says here you have a support page. If you want to support CodeLight, you can give them a donation with PayPal. That would be great. I'm not going to do that. I'm just going to go to the next page, and here I am in the downloads. These are the latest downloads, 17.1 at the time of this video, obviously, and 17.0. If you want to get to the previous downloads, you can come over here to download and select archive, and you get 17, 16, 15, all the way back. We don't use these often, but sometimes there are problems with new releases, and we go back to previous releases just so we can get something that is working. In this case, I want to do this again. I want to select the 17.1 build. Do not install the 17.0 build. This was really buggy and it's got a lot of issues. Some of them were fixed in 17.1. So if you select the Windows 64 installer, it will download and install a file to your computer. Now I've already done that and it's already on my desktop. So let me show you where it is right now. And this would be the file that I just downloaded. Now I can go ahead and I can double click on this file and it will start the installer. My Windows machine is telling me that, are you sure you want to install this thing? Because it's not from a Microsoft store, it's an unknown publisher. Obviously I want to run this, so I'm going to go ahead and go ahead and right click on this, on the installer here, and go to show more options, and then select properties. And in the properties down here, you can tell to unblock it, so we'll definitely run it and bypass the security. I'm going to apply and click OK, and now I'm able to run it by just double clicking on it again, and it's asking me if I want this app to make the changes from device, and yes I do. So I'm going to select yes. Here's a license agreement. You can go through it and accept it if you like. I'm going to accept it and select next. And this is going to now display the destination location. I'm just going to stick with the defaults, program files CodeLight. And I'm going to go ahead and install it here. Now here I would advise you not to install on a shared drive. I don't advise you to change the name or just basically pick the default and leave it as it is.
Do not put it on OneDrive. Don't install it anywhere else. Just install it on a local drive. So I'm going to go ahead and select Next. I'm going to name it CodeLight and keep all the defaults. If you want, you can create a desktop shortcut and also a quick launch shortcut. I'll go ahead and keep those, and I'll select Next. I'll then select Install, and now it's going to go through the installation process, and it's a pretty quick install, but basically you're just going to see a bunch of installation going on now. And that's it. It's installed. In the next video, we'll launch it, we'll configure it, but at this point you should have the C compiler installed and CodeLight installed. In the next video, again, we'll start the configuration and complete everything so we can actually start writing some code. Thank you.
Hello everyone. In this video, we'll configure CodeLight so that it will work with the compiler that we installed. So obviously the prerequisite for this video is the compiler must be installed and CodeLight must be installed. Okay, so let's get started. I've got an icon here, shortcut to CodeLight. I'm just going to double click that, and that's going to open up CodeLight for the first time. And it says, welcome to the setup wizard. Let's run the setup wizard. You only have to do this one time. So I'm going to select Next. Select your development profile, which is going to be C, C++ development. I'll select Next. And now we can scan for a compiler. Let's do that. It probably won't find the compiler that we installed because it doesn't always find pre-installed compilers, but let's try it. And if it does find it, great. If it doesn't, we'll install it manually. So either way, we're covered. So I'm going to select Scan. And it says it could not locate it. That's fine. Would you like to install one now? No, we've already installed it. So I'll select Next. You can see that it found the Rust compiler. That's a different programming language, and that's okay. You can just ignore that. I'll select Next. Pick the color scheme that you want. I'm going to use this default scheme. Normally I would use the dark scheme because it's easier on the eyes, but I'm going to use this because I think it shows up better on video. I'll select Next. This dialog is asking you about white spaces and indentations and so forth. Just leave the defaults as they are and click Finish. CodeLight will close up and then it'll open up again. So now the first thing we have to do is, since it didn't find the compiler in the setup, we need to manually install the compiler in CodeLight. Really easy to do. Click Settings and then Build Settings. And then we click this blue plus symbol. It might be green on your screen. It depends on whether you've got the light theme or the dark theme. So I want to click that right there. Remember, we're on the Compilers tab. I want to click that plus. It says Add an existing compiler. So I'm going to do that.
So after hitting the plus, you'll see this dialog. We want to navigate to the path where we installed our Cygwin C compiler. So I installed it in the C drive. So you want to go down to your C drive and select that, and then go to Cygwin 64, wherever you installed it. By default, it's in C Cygwin 64. And then inside Cygwin 64, you have your bin directory. From there, you can just say Select Folder. And then here you can actually name it. Let's just name it Cygwin, just so we know which one it is, and we say OK. At this point, if you select the Tools tab, or if it's already selected for you, you're going to see all of the build settings filled in for you. Some of these are not correct, so you actually need to correct them. The C++ compiler you don't care about, you don't need to worry about, we haven't installed that. But the C compiler, you actually want to use GCC. So if you select the C compiler, then the ... you can navigate again to the bin directory and just select gcc.exe. So you go down there and you go gcc.exe, and that will run the GCC compiler. For the assembly name, you can actually just again, you can either use the ... or you can just type it in. And the program you want to run is as.exe for the assembler name. The linker, you want to use GCC. So again, you can just manually edit or hit the ... You just want to make sure this is gcc.exe for linker. For shared object, again, we're going to use GCC. So again, we can either use the ... or just say gcc.exe -shared -f-pic. For the archiver, we're going to go ahead and use, again, ar.exe with the RCU as a program argument. The make, we're going to use make.exe inside bin. So that should be correct. If not, it should be make.exe. And for GDB, we want to, again, modify that to use GDB. So we can go to the ... go to gdb.exe, and we can use that. And then you want to make sure these settings are really important, so you might want to pause the video again to make sure everything's correct. Again, C++ compiler doesn't matter. C compiler gcc.exe, assembler name as.exe, gcc.exe, gcc.exe shared for the shared object in the archive, ar.exe. And so then you can go ahead and hit apply and hit OK.
All right, so in CodeLight, let me make this full screen here. In CodeLight, we've got several windows here, and I'll go over this in more detail in future videos. We have a workspace view, and this is where we create workspaces, a collection of projects. So we can have a workspace with project 1 and project 2 and so forth, and each one of those projects is a program that we're going to write. Here we can create a new workspace, open a workspace, and a lot of that you can also get to from the tabs. As you know, with these modern user interfaces, there's usually 4 or 5 ways to do the same thing. Okay, so let's create a new workspace. I'm going to select New. Make sure you've got a C++ workspace. That's what we'll be doing. I'll click OK. Now, what's the path to my workspace? I'm going to put it right off my user folder, right there. And what I want to do there is create a new folder where I can create all my workspaces. So let's do that. I'm just going to come in here, and right in my home folder here, I'm going to create a new folder, and I'm just going to call it Workspaces, or My Workspaces, or whatever you like. What's really important here is no spaces, no special characters, no ands and dots and all kinds of weird characters. Just name it a real simple name like Workspaces, and that'll be fine. That's it. So I've got the folder. I'm going to choose it. And what is my workspace name? Well, this workspace will be, let's say, Workspace 1 or Section 1 or whatever we want to call it. I'm just going to call it Workspace 1. And you can see down here where the workspace is going to be created, and it's going to create a .workspace file. Make sure that this little check is checked. Create the workspace under a separate directory. That way we've got separate directories for all of our workspaces, and it keeps us nicely organized. I'll select OK. And you can see that this window now went away. It's a big white area here. And there is our workspace, our first workspace. Now, we can't really do much with a workspace. We need a project within the workspace. So I can select my workspace and do File, New, Project. Or I could just right-click on the workspace and say New Project. And that's what I'm going to do. All right, so this is probably the most important part of this video, is setting up the project. So what is the name of my new project? I'm going to call it Project 1. Make sure you create the project in its own folder. And now we're going to fill in these drop downs right here. What's the category? What type of application are we building? It's going to be a console application. That's a non-graphical application that runs from the command prompt.
The next thing we have to select is the type. And the type is basically going to be Simple Executable GCC. This is a C program, so Simple Executable GCC. The compiler that we're going to use, we just created the compiler that we're going to use, and hopefully you named it Cygwin, so you can actually just go and select Cygwin. If you left it default, you'd have to select that name. The debugger that we're going to use is GNU GDB Debugger. And the build system that we're going to use is we're going to actually use the CodeLight Makefile Generator Unix. So again, these are very important settings. So again, take a look at these, pause if you need to, but the category should be console, type should be Simple Executable GCC, compiler should be Cygwin, debugger should be GNU GDB Debugger, and the build system should be CodeLight Makefile Generator Unix. So we go ahead and hit OK. So what you should notice is that inside your Project 1 folder, you now have a source file that was created called main.c. .c is the extension for the C programming languages. And so that was automatically created for you, and you can double click it, and then you'll see that the editor comes up with a little tab, Project 1 main.c. And you'll see this is some C code. This C code is not important right now. We're just setting up our environment. We're trying to make sure that we can build and compile and everything. What you'll notice is if you try to edit this file, you'll notice when you write in code that there's a little red circle up there. That means that the file's not saved. You always want to make sure that it's saved before you build and compile. So you can hit Control S to save it, and you'll see the red goes away, right? Or if you want to save it as well, you can go up to File and you can just say Save File. So that red dot tells you whether or not your source code is saved. Again, this is C code. You don't have to worry about this. We're just going to try to build and compile. So you have your main.c. You'll notice that you can actually change the settings of the actual compiler and things like that by selecting the wrench up here. So if you select the wrench up here, here you see all of your project settings. And some of the things will automatically be filled in for you. So if you get to General, you'll see some of the things that we automatically set when we installed the compiler, Cygwin compiler. So you see the makefile generator is CodeLight makefile generator Unix, compiler Cygwin, and so forth. Most of these can actually just be marked as default. And we'll actually go through a lot of these settings maybe in a later video. But the general you should see basically filled in from what you did before. The compiler settings, if you select compiler on the left, you'll notice that there are some command line arguments you can actually pass. We don't have to worry about C++, but for C compiler options, if you select the ... it'd probably be a good idea to actually select the C99 features. So you can use like Boolean and things like that. We'll talk about again that later. So if you say enable C99 features, that'll pass in a standard C99 argument. And if there's anything else, I don't think we really need anything else for the compiler options. This is pretty much good to go here. So you can hit OK. And then you'll notice it just passed in std equals C99. Everything else can also stay the same. If you go to the linker, as far as linker options go, you may want to again go to the ... for the linker options and just select static linking. That way we don't have any library problems later with linking. Mark that check, static linking -static. And again, hit OK. And so we'll cover this more in more detail later, but everything should be set up now so that we can actually try to compile and run our code. So let's go ahead and hit apply and OK. And here now we see our source code. So now we can try to build or compile our code. And so if we go up to build and we say build project, you should see that the code is being built and you should have no errors because this is just a templated C code. Now if you were to add some syntax or something and you save the file and you try to build it again, you may see an actual error, right? And you also, so you want to make sure that your code compiles by following everything. So, we can basically just modify the source code, say something like hello testing, and then go ahead and build the project. You can always clean and build, and we'll talk about these options later. But we're just going to build the project, and you'll see there's no errors, and all our configuration was set up correctly. Now, if you have any errors, they may be, and they're not any syntax errors, they're actually something wrong with the setup. You'll have to go back and either go to the settings, go to the build settings, make sure that all of your tools and your paths are correct. You want to use GCCS, AS, make sure all that. Make sure the make file is make.exe and everything. Make dir should be blank. You want to first check all those settings to make sure they're okay. And then if you, again, still have problems, you can go back to the wrench tab and again, go to the general. Make sure you're using CodeLight makefile generator Unix. Cygwin. Again, these all should work by default, but you can just go and maybe play around with things if you keep having errors. Post something in the Q&A if you can't figure it out. But you should, at this point, be building successfully. Now that I've actually compiled the program successfully, I can actually run the program and see what the output is. So I can highlight the project right here in the workspace, project run, and I can go up to the menu option under build and I can say run. And once I do that, the program will try to execute. This box will come up by default. You can select the remember so it doesn't ask me again. You don't need to build and execute again. You can just execute because since we already built, it is 2 steps. Or you can say build and execute again. Either way, it's okay, but you don't really need to compile again if you already did. So I'm just going to say execute. And now what you'll see is this sort of DOS window come up with the output of the program, which says hello testing at the top. A little bit difficult to read, but it says hello testing. And it also has additional information with it. It says program exited with Xcode 0. That's a good thing because it means there was no issues when running the code. and it returns 0, and so there's a 0 there. It also tells you how long the program actually took to run, and then press any key to continue. Now, if we were to run this program from the command line, we wouldn't see this extra output. We would just see hello testing, because that's the output of the source code. But the IDE CodeLight comes with some extra information that's nice to have, but we don't really need that information. So we can go ahead and press any key to continue, and this box will disappear like that. And so that's how we can run our program. And now there also, you'll notice at the bottom, a lot of different tabs and information. The two most important tabs down here are the Output tab and the Build tab. The Output tab tells you kind of what's going on. It says, your program exited and so forth, and you're running things. The Build tab is basically what happens when you compile it. And so whenever you compile and you say build and you say build project, you'll notice it tells you how to compile. In this particular case, I'm missing a semicolon, so there's an error there, right? And it kind of tells you there's an error. So on a successful build, let's say we add the semicolon, we say save, and we build it again. What you should notice on a successful build is you see the exact command that's being executed, which we already set up in our settings, right? You see gcc.exe, -c is for compile. It's compiling our source file main.c. It's using the program arguments that we set in the settings for build, right? gdwarf2, standards c99 -wall, right? It's all coming together, all those settings. And then it also has gcc.exe, which is then linking. It's the -o option. And then you see -static, which we also added. So all this is kind of coming together through the settings. Now, as I just showed you, if you don't compile successfully and you have an error, so for example, just like I had earlier, you don't have that semicolon, you're missing it. Now when you build, you'll see that there's an error. Right? There's no actual semicolon. It kind of tells you error expected semicolon before return. And this happens a lot, right? These syntax errors is what you end up seeing. And this is typically, if you do have a problem running your program, this is what you could post in the Q&A, the build tab, and I can actually see what's going on to help you out. But syntax errors are common when you write your C code. And so, understanding the compiler and the compiler errors, we're going to actually go through in a future video. But this build tab is important to kind of see the output and whether or not you successfully compiled or you have errors. Again, common errors, missing the semicolon. Sometimes students will, forget the D in standard IO. So they have the semicolon, I save it and they build it. And you'll notice that red arrow moves because the red arrow tells you where the error is. The compiler will actually tell you. So here in this case, you misspelled standardIO.h, which is a C package that you can include, right? And if you're missing the semicolon, the red arrow would be here, right? But again, you save, you compile, and you run again, right? And so once we fix these errors, we then can build project again, or we can rebuild project is another option where it rebuilds everything. It cleans it and rebuilds it. And then you can see the outputs, you can see successfully no errors, and then again, you can run it just like before. Build and execute or just execute. So this is how you can compile and run your program and set up all your settings. Now, if you have any issues at all, please post to the Q&A. A lot of these questions have been asked and answered, so you can kind of look at them. Whether or not it's setting errors in your build environment or whether or not it's actual code and you have syntax errors. There's all sorts of different syntax errors that can happen. And we're going to learn that as we go through the course, how to write proper C code. But the build tab's important, the output tab's important. In subsequent lectures, we're going to go through how you can actually set up a template so that you don't have to necessarily do all these settings and so forth. When you create projects, you can just create the same project over and over. Again, the code here you might not understand, but hopefully at the end of this lecture, you're able to at least get this up and running a simple C program. Thank you.
Hello and welcome back. In this lecture, I want to show you how you can check to see if your C compiler is installed on your Mac operating system. And if it's not installed, you can actually go ahead and install it either by installing Xcode or just installing the developer tools for the Macintosh operating system. Now, typically, if you have your Mac and you do not have Xcode installed, you're not going to have the developer tools, so you're not going to have your C compiler. So the first thing you can do is you can check to see if Xcode is installed. If Xcode is installed, then you're good to go. You don't need to do anything. So you can go to the Finder. If you double click your Finder and you go to Applications, you can see if Xcode is installed just by looking inside here. If it's not installed, you can go to the App Store and you can install Xcode. That's one option if you want to install that IDE. If you don't want to install the IDE and you just want to install the developer tools, then you can actually just install developer tools through the terminal, which I'll show you in a second. But if you go to the App Store, you can just quickly type in Xcode. If you can go to Develop, and you can actually probably just scroll down, you'll probably see it there. And you can install this IDE. This IDE will allow you to write C programs, but it's not suggested for the class. Right? So you would just go ahead and install this. The better way to do it is, if you don't want to have too much overhead on your system, is you can go to the App Finder, you can go to your Utilities folder, double click that, and you can select the terminal. Terminal is basically your command line interface to your programs. You could also use the terminal to manually compile your C programs. So the command to compile your C programs, and I'll talk about this in later lectures, is GCC. And in Linux and Unix and Mac, you can type in which GCC, and this will tell you the path of the compiler. Typically, it's installed in user bin GCC. To see if this is installed and working, you can check the version of it, so you can type GCC -- version. And this will tell you if it's installed. And right now, I don't have it installed, so I get a little box that says, if I want to use the compiler, I need to either install Xcode or I can just install the developer tools. I'm going to go ahead and say install the developer tools. And this will just give me a license agreement. I'm going to say I agree. And this is going to go ahead and try to install the developer tools so that I can now use the C compiler. It may take a couple seconds here to install. After you finish installing it, it should say that the software is installed. You can select Done. You can then go back to your terminal window and you can type in which GCC again. This just tells you where it's installed, user bin GCC. And then you can try typing in GCC -- version. And this will tell you that it has been configured and that it is installed. And so it's using the CLang version of the compiler. Now you could test this if you wanted to by just creating a document. You could say VI test.c. VI is just an editor where you can add some stuff. If you hit I, you can insert some code. We don't know anything about C yet, but I'm just going to create a simple C program to test this. And again, don't worry about the details here. This is just going to print out hello world. But here, I just created a sample file. If I gcc test.c, it's going to try to compile it. It compiled it. I can run the executable by /a.out, and it does hello world. This is how you can compile and run C programs from the terminal or the command line interface. We're not going to be doing this too much, but it is an option in the Mac operating system and Linux. But that's basically all you need to do to install the C compiler for Mac. Again, it doesn't come pre-installed unless you download the developer tools, which I just did, or you download Xcode. If you download Xcode and you have it installed in your system, this is the common IDE that Apple use, then you should be good to go. Let me know if you have any questions. Thank you.
Okay, so now that we've downloaded and installed the command line tools and the C compiler, we're now going to install the CodeLite integrated development environment. And CodeLite is an open source, free, cross-platform integrated development environment. It works with C, C++, PHP, and JavaScript. It runs on OS X, Windows, and Linux. So once you learn it on one platform, it's really easy to use it on others. So what we're going to do is we're going to go to the website for CodeLite. And you can see I've already got a browser open and I've typed in codelite.org. That's CODELITE.org. And you're going to get a website. And as I've said before, websites change over time. What we're going to be looking for is a download link. Now, at the time of this recording, CodeLite 14.0.0 was just released. So this is the latest and greatest, and that's what I'm going to install right now. So I'm going to look for a download link. You can see, obviously, this big green box right here. You can always go to the downloads as well. So I'm just going to click this. And that's going to take me to a page where I can donate to the developer if I choose to. I'm just going to select the download link right here. And we're looking for the OS 10 version. And you can see it's the third one down here, CodeLight 14.0 app bundle for OS 10 10.15, which is Catalina.
Now, if you're unable to find the download for the Mac OS under downloads, you may have to go to the archive. So you can go to the archive. And if you go down to 14.0, you can see that the codelight.app.tar.gz file is right there. And that's the one you want to select to download if you're unable to find it.
I'm going to select that, and that'll start the download. Now, I've already done it before, so you can see that I'm doing it right here. So I'm just going to cancel that download because I've already done it. And I'm going to come up here to my downloads link. And you could see right there. Now, you can see that it's downloaded as a .tar.gz file. Now, if you're not familiar with that, the GC just means it's compressed, and the tar means that it's an archive. So it's really very, very similar to a zip file, if you're familiar with that. So what we need to do is we need to decompress it and untar it. Sounds complicated. All you need to do is double click on it. So I'm going to show it in Finder, and you could see right here is the file. So all I'm going to do here is double click on it. Okay, that's really it. Then you can see the CodeLight application is now good to go. You can see the icon. Don't worry about this file down here. That's just the recording file that I'm using. So all we need to do now is grab that and drag it into our applications folder here. So I'm going to select it and just drag it down to my applications. And that's it. It's now installed. Now we just need to run it. So what I'm going to do to run it is I'm just going to come up here. I'm going to close my browser and get it out of the way. I'm just going to come up to Go, Applications, and select CodeLight. I could also type it into Spotlight Search, but there's CodeLight right here. Now, if I try to run it, which I just did, you sometimes will get this message. CodeLight cannot be opened because the developer cannot be verified. This is pretty normal. It all depends on what your security settings are like. So you can move it to the trash or you can cancel. Well, I don't want to do either. I don't want to throw it away and I don't want to cancel. But what I do want to do is run it. So what you can do is you do cancel here and then come up to your system preferences. And let me close this down just to get it out of the way as well. So you go to your system preferences and you can come to security and privacy right here. And I'll just select that. And go to General, and then you can see right down here it says CodeLight was blocked from use because it's not from an identified developer. And what we'll do is we'll just say open anyway. And at that point, it's good to go. Let me open it. Here we go. Now it's a little bit different, right? Now it says open. So I'm going to click open, and that's going to run CodeLight. I'm not going to do that right now. I'll do that in the next video where we'll configure it to run. So at this point, we've installed the command line tools and we've installed CodeLight. So it's just a matter of getting it all ready to go. In the next video, we'll configure it so we can program. I'll see you in the next video. Welcome back. In this video, we're going to configure CodeLight to run on Mac OS 10. Now I'm running Mac OS 10 Catalina and I'm installing CodeLight 14.0.0 in this case. Before we do this, we've got to be sure that the compiler and CodeLight have been downloaded and installed. I did that in the previous videos. If you haven't done that, please go back and do that. So again, I've installed the compiler and CodeLight. Now I'm going to run CodeLight for the first time. You can come up to Spotlight Search and type CodeLight, and you can see CodeLight shows up right here, version 14.0.0, and I'm going to double click that to run it. Now, this is pretty normal. You may or may not get this error message here. This is very common when you're installing software from the internet that's not coming from the Apple App Store. It says the CodeLight can't be opened because the developer cannot be verified. So what does that mean? That just means that you have to allow it to run. Okay, it's a security feature. So what we're going to do is we're going to cancel here. And again, you may not get that message. It all depends on how your system has been set up. Come up to the Apple and go to System Preferences. And then you're going to select Security and Privacy right here. Let me move this to the center here. I'm going to select Security and Privacy. And then in the first tab, the General tab, you can see right down here, it says CodeLight was blocked from use. because it's not from an identified developer. Again, all that means is that this app didn't come from the App Store. It came from the internet. So I'm going to select open anyway, and that will run CodeLight. And again, now you can see I get the same message, but now I get the open button. So I'm going to click the open button, and let me close this system preferences, and that's going to run CodeLight for the first time. And this is what you get the first time you run CodeLight. Now, there's a lot going on here. I've got a workspace view over here. I've got a welcome window, and it looks like a wizard wants to run a setup wizard. And I also have this message down here that says CodeLight now offers a better editor color theme. So again, there's a lot going on. You may or may not get this message down at the bottom about the color theme. If you do, then what I'd like you to do is cancel the wizard. We'll run it manually in a moment, and say yes to this fix. So I'm going to select yes right down here in the bottom right, and I'm going to click yes. And it says a CodeLight restart is needed. Would you like to restart it now? I'm going to say yes again. Now CodeLight will close down and restart, and it should be back in a second. Okay, perfect. Now what we need to do is we need to run the wizard, the setup wizard. That's the one we canceled a second ago. So let's run it manually. We come up to help, run the setup wizard. Okay, I'll do that again. I'm going to select help, run the setup wizard. Now it's important that we do this. We only have to do this one time. Right now, that's it. Once this is done, we don't have to do it again. So welcome to the setup wizard. I'm going to select next. What's my development profile? In other words, what kind of development am I going to be doing with CodeLight? Well, I'm going to be doing C, C++ development. CodeLight supports PHP, JavaScript, Node, I believe. I'm just going to select C, C++ development because that's what this course is about, and select next. Now, this is a really important step. Remember, we've already installed our compilers, so we're going to let CodeLight set up those compilers for us. So we're going to click on the scan, and CodeLight will scan our system for those compilers. So I'm going to select that now. And you can see that 3 compilers show up. Now, that's pretty normal. It's really the same compiler with 3 different names. So this is exactly what we want. If nothing comes up here, then it's very likely that you didn't install the compiler. So go back to the previous videos and install your compiler. I'll select next. Here you can customize your colors. I'm just using the defaults here. The dark, the light, the gray, whatever you prefer. Again, I'm just selecting the default. I'll select next. For white space and indentation, I'm just going to leave these defaults as they are, and I'm going to select finish. Now we're done. CodeLight's going to close up and open up again, and our compilers and our environment should be set up. First thing, we need to verify that the compilers were indeed set up correctly. So we can do that by coming up to Settings, Build Settings, and then you can see right here under the Compilers tab, when you select GCC, we're going to use GCC. Now, the important thing is that when you select GCC and compilers and then tools, you see stuff here. We see those paths here. If there's nothing here, then again, most likely something went wrong with your compiler installation. Okay, so that's it. I'm going to select OK, and our compiler is set up. Okay, so CodeLight, as I mentioned, is an integrated development environment, which means that we can build and run and debug our C programs. It uses a workspace model. So the idea is that we can create a workspace, and we create workspaces on this left side here. You can see workspace view up here. And then we can add multiple projects to a workspace. Now that's pretty cool. We can have one workspace and a whole bunch of projects within it. A lot of other IDEs don't work that way. They basically just allow you to work on one thing at a time. So this is a pretty nice model here. Now, in order to do that, we need to create a new workspace, right? There's nothing here. You can see there's a lot of space here, right? There's nothing going on. So what we're going to do is we're going to create a new workspace. We can do that by clicking right here on this button, New Workspace, or I can come up here in the menu bar and click Workspace, New Workspace. Again, I could use either one. I'm going to select this button right here, and then I get this Select Workspace Type dialog box. I want to create a C++ workspace. It's really important that we choose C++ here, and I'll select OK. Now it's going to ask me, where do you want to store this workspace? I'm just going to put it right in my user directory's documents directory or documents folder. And what's my workspace name? I'm just going to call it First Workspace. Here it shows you the complete path to where this file first workspace.workspace is going to be stored. If you want to put it somewhere else, you can just click these three buttons and choose whatever folder you like. I would encourage you to select that little checkbox down here. That way it creates the workspace in a separate directory. That way when we create multiple workspaces, they'll be nicely organized. Now, word of warning, do not use spaces, special characters. In other words, don't use spaces like this here. Don't use special characters like pluses and ampersands and all kinds of weird things. And don't use any international characters either. Those will cause all kinds of build issues. Keep the naming really, really straightforward with everything we do in CodeLight. Also, if your username, you can see my username right here is my first name and last name. If your username has spaces or if it has special characters or international characters, then put your workspace somewhere else. Create a new folder somewhere that doesn't have that and just store it somewhere else or off your root directory. We're good to go here. We're going to create the workspace. Now, when I click OK, you're going to see this workspace, first workspace appear right up here in the workspace view up in the top left. So I'm going to click OK. And here's my workspace. You can see it right there, first workspace. You can see this whole area here on the right has been cleared out. In and of itself, the workspace really doesn't do much for us. It's really a container or a holder for projects. So what we need to do now is to create our first project. And we can do that by selecting the workspace and then right-clicking on it and selecting New Project. Okay, so I'll do that again. We're going to right-click on the workspace and then select New Project. And now we're going to get a new project wizard. And this is really important that we get this right. There's a lot of settings here, and depending on how we fill them out, our projects may or may not build. So I'll go through this really slowly and carefully. This is the path to our workspace, and it's asking us for a new project name right here. So I'm just going to call this Project 1. Again, no spaces, no special characters, no international characters. Make sure that this checkbox is checked. Create the project in its own folder under that workspace. That keeps them nicely organized. The category, we're going to select console.
The next option here is the type. For type, we want to actually select simple executable GCC. This is really important because we're going to be using the C compiler. We're writing C programs, so we want to use GCC for type. The compiler, we want to make sure we select GCC. Again, C programs, very important. For the debugger, we want to select the LLDB debugger. Because we're on a Mac, we use a different debugger than the normal GDB. And then for the build system, we want to make sure we select default. That's really, really important. It's probably the most important step here for the build system. So again, make sure you understand all these settings. Make sure they look like this. If you have to pause the video, make sure that they're all this. Again, I'll go through it again. First workspace is the name. Create the project in its own folder. The category is console. Type is simple executable GCC. Compiler is GCC. The debugger is LLDB debugger. And the build system is default. And just to emphasize too, the name, it's really important not to have any spaces in the name, any special characters. And that's really important because I often see a lot of questions in the Q&A about, hey, my project didn't work. It's because you put in a special character here. At this point, I'm going to go ahead and select OK. When I select OK, you'll notice that my project was created here, right under my first workspace. We have the first workspace project name. We can actually select these arrows to actually see there's a source file folder underneath, and then there's a main.c. Now, we don't actually see anything over here yet because we haven't selected main.c. But if we double click on main.c, you'll see that the editor comes up, and we see some C code in here. Now, the font's a little small, so I'm going to make it a little bit bigger. You don't necessarily have to do this. But if we go ahead and we actually select, we can go right to settings, colors and fonts, and we can just change it to be a little bit larger. We're going to go ahead and change this to 18, probably be a good size, just so you guys can see it, and just hit OK and apply. And you should also notice in this editor that whenever you don't have anything saved, you'll see the red. So if you actually try to edit this file, you put a thing, you see the red there on the side. That means the file's not saved. Normally you could go up to File and you could say Save File, but the Save File is grayed out. It's a bug in CodeLight. So you can still do the Command S So if you just hit your Windows key or Command S, it will save it and you'll see it go to green. And that's how you can edit. So you can always see whether or not your file's up to date with the latest code changes that you've made by hitting Control S or Windows key S to save. If you're on your Mac, Command S, and that will save the file and it will go back to being green. So I'm just going to go ahead and modify this. Just again, you can see the change from red to green whenever you type in once you save the actual file. And so we're good. Our code looks pretty good. It's a simple C program. Again, we'll explain all this code in later lectures. But at this point, we're almost ready to compile one of the program. But first, we have to modify the project settings. So we can actually go to the first workspace right here, highlight it on the left side, and we can right-click and we can actually go to the project settings right at the bottom here. I actually made a mistake there. That should be Project 1, not Workspace 1. I named my project wrong. So make sure you select your project and then go to Settings. Project should be Project 1. Mine says Workspace 1. And here you'll see there's General Compiler Linker Settings on the right. The general settings are pretty much filled in for you. You don't have to change anything here. Everything is set from when we set the compiler and build settings earlier. You do want to select the compiler option, and you want to go down to the C compiler options. You want to make sure you can see if you select that, there'll be a ... Once you select the ... you can actually see some of the options. We want to make sure, basically we want to, and you'll see that the options are added to the command line. We want to enable all warnings, W-all. That's actually not checked, that's a bug. And then we also just want to make sure, again, this is a C program. We want to make sure we optimize for debugging. We produce debugging information. We should be good. We might want to say enable C99, so we want to check that one too. So again, there's only 4 checks here, I think. Enable C99. We want to make sure the -W all for all warnings are shown. We want to make sure that optimize for debugging is shown and that we produce debugging information -G. And that's all down there. So at this point we can just say OK, followed by OK again. Again, a real simple application here. So we can actually build and compile this by going up to the build menu option, and we can actually say build and run project. And you may ask yourself, the settings we just applied, we're actually going to, you don't have to do those settings for every single project. We're going to actually, in a couple of videos, walk through a way to create a template for all your projects so you don't have to upload those settings. But we are going to build here, so let's go ahead and go to build and run project. And if there's no errors, I didn't make any typos, we should see the project was built successfully and it's actually run. So you see this little codelight.exe shell come up, some last login information, but what you really see here that's important is the program that was run, which just displayed output called hello testing to the screen. And so we were able to compile and run successfully. So now we can just hit any key to close. So what you'll see here is there's a couple important tabs here at the bottom. First one is output. And the output tab down here really just shows you what the program did when it ran. So it tells you where it's running from, and it tells you that it executed the shell command to the codelight exec shell command and that the program exited. Sometimes this is important if you're running from a different directory and so forth. The other tab that's really important is the build. The build is really the tab that's really showing you the commands that were run to run and execute the program. So here you see the GCC command to compile it. -C is the flag for compiling. And then -G are some of the settings that we set earlier, right? -G is producing debug information, optimization, using C99 standard and so forth. Then it's doing the linking and all the stuff. And then we actually run it. We would run the debugger using G++. But you'll see there's no errors and no warnings, so we are successfully able to run that. This screen is really important. A lot of times you can copy paste the screen in the Q&A and I can diagnose a problem if you have this information. So build and output are really important. Now, if you were to build this program and you actually had a compile error, so let's say we removed the semicolon and you'll see the red, it turned red there because I haven't saved it. So now if I save that, it will hit green. But now when I go up to build and I say build and run, I'm actually going to have an error, right? It's going to say, it actually pops up with a little pop-up box here. Confirm, build ended with errors, continue, and we're going to say no, because we weren't able to build. And then you'll see in the build output tab here that there's a little red error that basically says we're missing a semicolon. You can actually select this, and it will bring you up to an arrow up here telling you where the error is. So here you could actually add the semicolon to fix your problem and then save it again. And then you could build and run it, and you would build it successfully and it would run.
All right, so you could rebuild your project and you would see there's no errors, and then you could run it as well after that. So you notice the build, the run, all that can be in separate steps, or it can be in the same step. Now, other common errors that may be in here for your first C program, a lot of times you'll see forgetting a bracket. You may not have a bracket, so you have to make sure your brackets line up. Sometimes you forget a left paren or a right paren. It's very, very specific. Compilers are very specific in syntax. You got to pay attention to all the details, all the syntax. You can actually have other issues if you misspelled the header file, maybe stdio, things like that. So you have to make sure everything's okay, and then always save once you're done making your changes and rebuild the compiler to get rid of your errors. One other thing I want to mention is you saw the previous terminal coming up earlier. I don't really like that terminal that much. There's a lot of information in it. So you can actually change the terminal that gets shown when you run the program. You can just go up to CodeLight, menu option, you can go to your preferences, and then at the very bottom you can go to terminal here. And by default it's just going to say terminal. You can actually select the CodeLight terminal. I like this one a little bit better. It has less information in it. And there are some issues when you run the other terminal where a lot of the terminal windows show up. So I'm going to go ahead and select the CodeLight terminal under the terminal menu option and say apply, and then hit OK. And now when I build and I run this, you're going to see it comes up in a slightly different terminal. And this purple bluish type terminal. You can then say OK so that it can allow it. And then it will run, and you can see it says hello testing, and you can any key to continue. There's less information in there. It's a little bit nicer, I think. So this is one option. You can see if you want to change the terminal, and then hit any key to exit that terminal window. Okay, so that about does it. We were able to write our own code here, just a little program, build and run it. We change the terminal. If you have any errors at all in this program, it's really important that you take the build output from the build tab here, and you can kind of post that in the forum if you had any issues, and I can help solve them. But this is basically it, right? Setting up your environment in CodeLight so that you can run a C program using the C compiler and everything. You'll notice that CodeLight restart is needed because I did change the terminal. But that's about it. If you have any questions, please post in the forum. Thank you.
Hello everyone. In this video, I'll be installing the C++ compiler along with the build tools that we'll need to build C++ programs on Linux. The distribution that I'm using is Ubuntu 22.04, which is jammy. There are a lot of different Linux distributions out there, so depending on which one you're on, you can check out the different options here for Ubuntu, Fedora, and so forth. As I said, I'm on Ubuntu. So open up your favorite browser and head over to codelight.org. And then once you get there, select Docs and Getting Started. And then right where it says Prepare Your Environment, select Linux. And there's basically one command we're going to run, which is pretty straightforward. Once you get to the Linux section, there's a lot of information here, right? Depending on whether you want to install Rust and Python and Brew and so forth. I'm not going to do any of that. I'm just going to install the essentials, which gives us everything we need. And you can see this box right here that says Install the Essentials. So what you can do is hover over this box and click that little icon right there. That's going to copy this information to the clipboard, and that's what we're going to execute in a terminal now. I'm done with this for now. I'm just going to minimize it. I'm going to open up a terminal. All right, so there's my terminal. Now at this point, all I really want to do is paste what I just copied into the terminal and execute it. It's as simple as that. So I'm going to right click right here, paste, click the right arrow key and press enter. It's going to ask you for your password. And that's it. Some of these tools might already be installed depending on the type of distribution you installed originally. So it says, do you want to continue? Yes, I do want to continue. And there it goes. It's going to do its thing when it's finished. And again, how long it takes really depends on what's already on your system. So it may take a little bit longer. I've already got most of this stuff on my system, so we're good. Let me clear this screen.
So I can go ahead and I can type in which GCC, which is the compiler we're going to use for C. And you'll see that it has user bin GCC. That's where it's installed. You can also type in GCC -- version. And you'll see that I have 7.5.0.
This may be different for you, it may be an up-to-date version. It really doesn't matter what version it is. It should be good to compile C programs. So now you know that you have the compiler installed.
All right, so the next step is to install CodeLight. And then once we install CodeLight, we can configure CodeLight to work with the compiler we just installed, and we should be good to go. So head over to codelight.org again, and in the docs section, you'll see this downloads link right here. So I'm going to select that, and I'm going to click latest. I've got the information here how to install for Mac, Windows, Linux, and this is the one we're interested in right here, the Ubuntu area. Now, it's all going to be terminal driven, so I'm going to make some room here for my terminal. And really what I want to is have access to these so I can copy and paste them. Okay, so let me open the terminal again. And I'm going to move the terminal just over here, just so we can get it just slightly out of the way. Perfect. All right, so what we're going to do is we're just going to go through this and basically copy these commands into the terminal and execute them. So the first thing we need to do is we need to set the public key. So again, I'm going to click on this little icon right here, then come over to my terminal, paste, press the right arrow just to make sure that that's unhighlighted, and press enter. It's going to ask you for your password again. Notice the warning that it's deprecated. Don't worry about it. That's a normal warning. All right, we're done with that.
Now, if you got any error here where you weren't able to fetch the certificate, it's a general error or something like that, you may have to actually issue the sudo apt install CH certificates command. And this will install the certificates, and then you can execute that command again to fetch. So you just do apt install CH certificates, and then after that you can do the actual fetch keys, and it should be able to grab them from there.
Then I'm going to come down here. And depending on which distribution you have, and again, there's a lot of Linux distributions out there. I'm using Jammy, which is 22.04. If you're using these other releases, you can use these lines here. So basically what I'm doing is I'm going to execute this command because it's already my Jammy command right here. But if you've got one of these, you can just replace this part with whatever distribution you have, whether it's Bullseye or Kinetic or whatever else you have. So I'm just going to copy this. If you're a Linux user, you probably know exactly what you're doing. So let me right click on here and paste it. Press the right arrow again, press enter. And it'll just be a second. Okay, I'm done. I'm going to clear this terminal just to make a little room here. All right, so I'm going to scroll up here, just a couple of more commands to run. I'm just going to type these in. The first one is sudo apt update. Sudo apt update. Press enter. Okay, that's done. I'll clear it once more. Okay, so now what we want to do is we want to install the latest version, which we know is 17. Don't do this right here for now. Just come right down here and type this one right here. I'll click the icon and paste it just to make it easier. Okay, clear it once more. And now here we're going to execute this command, except we're going to use the 17 instead of the 14 because we know that that's the latest. So let me paste that. And I'm going to just change that 4 to a 7, just like that, 17.0 star. And that will install CodeLight and all the other dependencies that it might have. So this one might take a little while, but once we're done, we've got CodeLight installed. And the next step is to actually run CodeLight and configure it to work with the compiler. Okay, so we're done with that. So let's now open up CodeLight and configure it to work with the compiler. Hello, everybody. So we're back. Let's configure CodeLight to work with the compiler. Obviously, at this point, we've already installed the compiler and we've installed CodeLight. So first step is to open CodeLight. So you can come down to your applications. And if you move over to the next screen here, you'll see CodeLight right here. If you don't see it there and you've got a lot of applications, just type CODEL or something like that, and we'll find CodeLight. Then we want to run this. You can see it's opening up. And the first time that you run CodeLight, you're going to get this setup wizard. If you don't get the setup wizard, you can find the setup wizard under help and you can run it manually. So I'm going to select next. I'm going to select my default profile, which is C, C++ development, and click next. Now we want to set up our compiler. So we're going to hit the scan button and it should find the compiler that we just installed. So I'm going to click scan and there it is. It's called GCC. That's the name that we're going to be using for the compiler on Linux. So we just select next and it will set up the compiler for us. Customize the colors. You can use the light theme or the dark theme. Totally up to you. I'm just going to stick to this default. Click next. White space and indentation. I'm going to keep all these defaults and click finish. At this point, we are done. It's going to close and open up again automatically. Okay, so at this point, we've got a couple of areas. We've got this area over here on the left, which is the workspace view. This is where we're going to store all our workspaces and projects. We've got this area here, which right now is just an area for 4 big buttons. This is going to be our editor. This is where we're going to be able to enter and type in our code. And then down here, you can see the local workspaces. Since this is the first time I've run this, I haven't opened any workspaces, but once you start creating workspaces, they'll show up here and you can choose one of your recently opened ones, which is kind of nice. Okay, so our first order of business is to create a new workspace. So like with many modern user interfaces, there's usually 3 or 4 or 5 ways to do the same thing. In this case, I could just click here on this big button, create a new workspace. I can come up to workspace, new workspace, and there's probably other ways to do it as well. I'm just going to click this big button that says create a new workspace. Once I do that, you need to select the type of workspace. It's going to always be a C++ workspace for us and click OK. Now, what's the workspace path? I'm going to store this not in documents. I'm going to create a new folder right off of my home directory, and I'm just going to call it workspaces. And that's where I'm going to save all of my workspaces. So now in order to create a new folder, you can come up here and you can do this through the command line on your terminal as well, but I'm just going to do it with the interface. I'm going to select this guy and just type workspaces and create it. And you can see that it now shows up right where you expect it. So I want to choose that workspaces and click open. And now what is my workspace name? Well, this one is called workspace 1 or section 1 or section 2, whatever you want to call it. If you're working through the course, you could call it section 3, section 4, section 5, and create all your projects for that specific section of the course, or you can organize in whatever way makes sense to you. Be sure that you've checked create the workspace under a separate directory. That way it'll keep your workspaces nicely organized. And I'll click OK. And now you can see over here in the workspace view that it's created that workspace. Now we want to create a project. So again, select the workspace and you can come up here to File, Create. I'm just going to right click on the workspace and create a new project. Now we've got a bunch of options here to set up, which are pretty straightforward. The first one is, what is the name of the project? Well, I'm going to call this one Project 1, or again, whatever you want. Something that's very important. Do not use shared drives here. Do not use spaces anywhere. For example, don't say Project 1. Do not use special characters. Don't do any of that. Don't use international characters. Just use simple words with no punctuation, no spaces, and no special characters. This is one of the biggest reasons for builds to fail. So again, keep the names really, really simple. So Project 1, make sure this is checked. Create the project in its own folder. The category is a console application. That's an application that runs in the terminal.
The type is going to be simple executable GCC because we're writing C applications. So simple executable GCC. The compiler is going to be GCC 11, the one that you just installed or whatever version it is, GCC. The debugger is going to be the GNU GDB debugger. And the build system is going to be default. And default, that's really important. Now you make sure you select your build system for default. So go ahead and click OK. So we'll see here that we now have a Project 1 folder under the Workspace 1 folder. We can maximize that and we'll see a source directory. And then we'll see main.c. All C programs end in the .c extension. So we can double click this and you'll notice that the editor now brings up the main.c program with some code inside of it. This code is automatically generated by CodeLite. You don't have to understand this code right now. Again, I know there's going to probably a lot of questions about this. We're going to go through all the details. This is later. Right now, we're trying to get our environment set up to be able to build, run our programs. So this code is really important. You see some curly braces, things like that. This is our source code. What you will notice is if you edit this source code, so say we change hello world to hello testing, what you'll notice is this becomes red, and that means that the file is not saved. So you can always save your text, save your source code by hit Control S, and then you'll see that go away. Or you can go up and you hit File, and you can say Save File. So now we have to actually just check the project settings to make sure they're okay. We can highlight our project right here on the left-hand side. We can either go ahead and hit this wrench icon to go to the settings, or we can right-click and we can go down to the settings this way. Either way is fine. So once we hit the wrench, you'll see that the project settings come up. And you'll notice a lot of this is filled in for us. It's the compiler we chose before and some other important things. We can keep those as the default. We want to go to the compiler settings, and we want to go to the C compiler options right here. And you'll see there's already some options that are selected for us. The GDORF 2, that's for debugging. The -O is for optimization. The -W all is turning all the warnings on. Now we can hit the ... on the right-hand side and just see if there's any other options that we want to enable. I don't think really the only maybe interesting one, enable the C99 features. And you'll see that it's added down below on the command line, so you see exactly what we talked about earlier. And then you see standard C99. That's probably the only one we're going to need. Everything else is good. The debugging, if anything's missing from down here, you could just go up ahead and check it. And so then we can hit OK. We want to make sure that our linker also has some options. There's a ... there if you select it. After you select the text field, if you hit the ... you can basically just say static linking. We just want to say -static and then hit OK. And those are all the settings we need to apply. The debugger should already be set for you, but if it's not, we do want to make sure that we select the debugger, which is GDD debugger, which is in your user folder. So you can usually go down to user bin and try to find GDB. If you just scroll down right here, GDB, that's a debugger we want to use. So we can just point our debugger path here to GDB, make sure everything else is set okay, and we can hit apply, and then we can hit OK. And at this point we want to actually be able to build and run our program. So we can build and compile by, again, selecting the project. You can right click and you can say build, or you can actually go up to the menu option and you can say rebuild project, build project. Either one will work. So once you hit build project, you'll see that there's some output that comes down on the bottom under the build tab. And what you see is basically the commands and the options that we just applied in our project settings. Right? You see the GDORF 2 for debugging, standard C99, dash warnings all, and so forth. You see that -static option for linking. And you also see, most importantly, that there's no errors. No errors, no warnings. Now, if you were missing a semicolon, or if you were missing a bracket or something like that, and you tried to build, you would see that there's an error. And you'd have to go and you'd have to fix that error. We'll talk again about syntax for C and a lot of other important options in coding in later lectures. But you should be able to build successfully by just the templated code that already comes up. Right? And you should see the output that I just showed you, right? Build project, successfully, 0 errors. Now you can actually run your program. Again, we can go back up to the build menu option. We can say run. And once we hit run, it's going to come up and it's going to say, do you want to build again? And so forth. We just built, so we can basically say execute. We don't need to build again, so we can just say execute. And then that's going to bring up our terminal, right, with the output. Hello testing. So we're able to run our program successfully. It says hit any key to continue for the terminal to go down. So we can just go ahead and do that. And so we're good to go. Again, you got to watch out for some errors, common errors that you may see if main is misspelled or missing a bracket. But at this point, we compiled, we were able to run our program successfully. So our environment is pretty solid. You will notice the two most important windows here at the bottom, the build and the output. The output kind of just tells you what's going on in what was currently executing. The build is really the most important thing because it has all your compiler output, and if you have any errors, it will be listed there. In the next video, we're going to show you how to set up an actual template so you don't have to provide all the settings that you do for every single project. You basically can inherit project settings, and you don't have to do the standard C99 and so forth with the static linking. We're really close to starting to write some code, so we're moving right along. If you have any questions, please post them in the forum. Thank you.
Hello everyone, in this video I'm going to create a default project template that we can use whenever we need to create a new project. That way we don't have to go through the steps of setting up compilers and all kinds of stuff. So I'll show you how that's done, and we'll create a couple of projects on the way. I closed the workspace that we had earlier in the previous video, so I'm going to create a brand new workspace. So I'm going to select New, Create Workspace, select C++. Give the workspace a name. And again, I'm in the workspaces directory right off of my home folder. And I'm just going to call this workspace. Let's call this workspace 2. Okay. Make sure that this is checked down here to create the workspace under a separate directory. I'm going to click OK. Now, I know I've done this before, but it's good to see it a couple of times, and that way you get the hang of it. Now that the workspace has been created, I want to create a project. So I'm going to select New, New Project. And we'll call this Project 1.
So we want to change this to Project 1. And that is a different Project 1 because it's under Workspaces 2 folder. You'll notice it filled in some information for us, right? Which is pretty cool. Category is the console. The type is the simple executable GCC, compiler GCC in whatever version you may have installed. The GNU GDB debugger, and then the build system, which is really important, which is default. And so we can go ahead and click OK. So now you'll see our project 1 is created. We want to, again, set the project settings. So we can highlight that. We can hit the wrench. And you can see that it has some of the compiler settings that we had before. We just want to add the ones that we added before, right? So under compiler, we want to go to C compiler settings, and we just want to make sure we select C99. And then we hit OK. We also want to make sure for the linker that we add the linker options for static. And for the static linking, you actually don't need to use the static linking on a Mac OS. For a Mac OS, you would just leave that blank. It can cause some build errors. So again, we hit OK, and that's all we need to add. So we can say OK again. And so now we can see our project 1. We can see again under the source directory that we have main.c, and we have our C code. Right? And whenever we edit C code, if we want to change this and say just default project, all right, we can hit Control S so we can save, and you'll see this go to the save option. You'll see that we have our main.c here. We can have many projects in here. You'll see that project 1 is bold. CodeLight does allow us to have many projects per workspace, and you would just see the current active project would be bold. And so we can go up just like we did before. We can go to build. We can say build project or rebuild project. And you'll notice there's no errors. Again, if you had any errors, you'd have to fix them. And then we can actually run the project by going to build and run. And again, we can just say execute. And this will bring up the terminal, which says default project. Hit any key to continue. Now at this point, what we want to do is we want to basically use these project settings for our other projects. Basically, it will allow us, so every time we create a new project, we don't have to go through those steps to add C99, to add the static linking option. We can just basically inherit a project settings just like this one. So how do we do that? We can actually select the project. We can right click and we can say save as template. Again, project name, select it and say save as template. And this will come up and it will say the project name 1. Probably a better name for this would be just maybe my template. And be very careful with the name. Again, I've been emphasizing this, but don't put a space in here. Don't put apostrophe, no special characters. Typically you just use this code convention with lowercase and uppercase, but no space or anything like that. Now for the project category, you can kind of really select anything. It's just going to be where it saves it. You can select console, whatever. I'm going to actually put this in user templates, and then for a description, I'm just going to say, my default template. You can put whatever you want in here, just so you remember it when you load it up. So now I can go ahead and select OK. And that essentially saved a template that we can use later when we create new projects. So let's, at this point, go ahead and create a new project. If we select the workspace, again, we can right click and we can say new project. And now the key here is in order to use the template, what you want to do is you want to change the category that you select. For category, you want to select user templates. And once you select user templates, it then asks you for the type. And for the type, you can select what you just created, right? I named it my template. So now I select my template, and this is going to use all the settings for our previous project, project 1, right? The standard C99 and the static linking option if you're on a Linux or Windows operating system. So now we select OK, and what you'll notice is, and I forgot to rename the project. This time we named it Workspace 2 for the project. That should have been Project 1. What you'll notice is this is not highlighted. This Project 1 is still highlighted, so that means it's the active project. You would have to actually select this Workspace 2 folder, and you would have to say, set this as the active project, make active. You can also double click to make it the active project, but you'll see that the bolding goes for that project. Now you can build, compile, and run that project. You can see that it also created a main.c file with the default code and so forth. It actually put default project in there. And we can actually fix the name if you highlight Workspace 2 and you right click, you can actually change the name again by just saying rename project. So we could then say, project 2 if we made a mistake there, and we'll update. But again, whatever is highlighted in bold, that'll be the project that actually gets compiled and run. And so this allows us to have many projects, and projects are just C binaries. They're C programs, C executables, and so you can work on many C programs at any given time. And if we check the settings for project 2, again, if we just select the wrench, you'll notice that we have the static for the linking option, and the compiler added the C99. So we're reusing the project settings from project 1. And we can do this for any new project that we add. We can just select user templates, and we can select the name of the template that created, in my case, my project, and we can always inherit those project settings so we don't always have to add them manually for every new project that we create. And there we go. We can create many projects like I mentioned and just double click them, and it will compile and build different projects. Right? So if we want to build project 2, we built it, we can then run it. And we're, again, just an easy way to avoid those manual configuration changes to create many projects with the same types of settings. And so on to the next video. Thank you. Hello and welcome back. In this video, we're going to talk about using the command line interface. The command line interface is basically a way to compile and run your C programs without using an integrated development environment. Right? Up until this point, we've gone through the CodeLite lectures and we've talked about integrated development environments, and those are, you have to set them up and configure it up. You can actually compile and run your C programs using a simple text editor. It's important to note that this is not a word processor. Microsoft Word is not. You cannot use that. You cannot use AppleTalk. Those editors actually are not simple, and they add a lot of extra code, and they're not text documents. So by simple text editor, depending on what platform you're on, it's something like WordPad or Notepad or VI or some simple editor. And you can basically write your code, your C code in this editor and compile it from the terminal. And so as I mentioned, it's basically a terminal window, command prompt if you're in DOS, or it's usually referred to as the command terminal. If you're in Linux and a Mac, it's usually referred to as like a terminal window. So all you need really is an installed C compiler, and you can issue C commands from this terminal window to compile, and then you can execute the executable, run the executable by just typing the name of the executable to run the program. And so what you'll notice, there's no need for any IDE. None of that overhead with an IDE. And so it makes it very simple and very efficient. It takes practice because you have to kind of know some of the commands for the compiler, especially if you want to have more enhanced project settings, and then linking if you want to do everything on a separate step. So it can become a little bit more cumbersome, but with practice, it's very simple and very efficient. And you get better as you gain more experience. And so it can be used in place of an IDE. And so in the next few videos, I'm going to go through each platform. I'm going to go through Unix, Linux, Ubuntu, and show you how you can compile from the command line from a terminal with a simple editor, a C program, the same with Windows, and the same with Mac OS. Thank you. Hello and welcome back. In this video, I'm going to show you how you can compile and run a C program via the Cygwin terminal on Windows. So our best option here is to compile and run through the Cygwin terminal, not the command prompt, because we're using Cygwin as our compiler. So in Windows, if you go down and you go into the search bar here, you can type in Cygwin, and you should see a Cygwin 64 terminal option come up. You can also, if you bring up Explorer, you can go to your Cygwin path, by going to your C programs, wherever you installed it. I installed it in C Cygwin 64, and then you can go into bin, and you can see the terminal in there as well. But once you bring up the terminal, you should see a little sort of command prompt type thing come up. So you just type Cygwin 64. And so you'll see this little terminal window show up with a prompt. And what you'll notice, it does have a path and so forth. But the $sign is where your prompt is. Now you can issue certain commands, Linux type commands, in order to navigate and see yourself around here in this environment. The basic ones are CD, which is a change directory, and then ls, which lists comments. So if we type in ls right here, we can see, I'll make this full screen, we can see everything that is under our certain path, wherever the default is. So right now I'm in the Cygwin C users jfedin directory. So if I go back to Windows Explorer and I go to the actual Cygwin directory, you'll notice that the directory structure has a home directory in it. And this is usually for a particular user that you've created. Usually by default it will create whatever you created, and it will be like, so mine is jfedin, home jfedin. Now I would suggest you probably just put all your C source code files in C jfedin, because it looks like a Linux environment with all these different directories, binary, dev, etc, and so forth. So home is your user environment, and so mine is jfedin, and inside there is where I'm going to put my C source code files. And so if I'm back in the Cygwin prompt window, all I need to do is type in cd/home/jfedin, and that will get me to my root directory where I want to start saving my C code. Now I'm going to create a directory using the make dir command, and I'm just going to call this projects, just to put in, organize things better. And then I'm going to navigate inside there using saying cd projects. And at this point you can use any C editor that doesn't have like rich text format, anything that has like a text, plain text saved. So things like Notepad, WordPad, we'll save things as RTF, so you don't want to use WordPad. Notepad, Notepad++ is another good one to use. I'll just go through Notepad just because it's a popular one. So if I go and I type in Notepad, it comes with Windows. Again, I usually use Notepad++. We'll just go through Notepad. You can use any text editor that saves things as text files. So if I bring up Notepad, hopefully you're familiar with this, but it's a simple text editor. Let's make the preferences a little bit bigger for our text. Make the font a little bit bigger so we can see what's going on. We'll say 16. And so now we just want to save this to our home jfedin projects directory. So if we go into File and we say Save As, we can just navigate to that directory where we installed Cygwin. Right, so again, it should be in C, Cygwin 64, Home, and then the username, jfedin, and then Projects. So here I'm just going to create a file, and I'm just going to say All Files as my type, and I'm going to just call this hello world.c, and I'm going to hit Save. And so now if we go back to the Cygwin terminal and we issue the ls command, you'll see there's a file there saved called hello world.c. And we can actually look at the content of that by saying more command hello world.c, and that tells us there's nothing inside there yet. So the cd and the make dir command and the ls command are really the only three commands you need to get going in order to just navigate around and see where some of your source code is. So now I can go back to Notepad and I can start writing my C code. Now I know you're probably going to have a lot of questions at this point. What is this code? That's not important right now, right? We're just trying to set up the environment so that we can run and compile our C codes. In this case, specifically from the terminal. We don't have to use an IDE. So I'm just going to create some C code here. Include is including a standard IO .header file inside the angle brackets. I'm going to say int main. This all has to be spelled completely correctly. I'll say void. I'll use the left curly brace, and I'll have the right curly brace. The one thing you'll notice is in the IDE, a lot of this code completion will happen for you. It will automatically add brackets. It may correct misspellings and so forth. And it will also usually highlight the syntax in different colors. So there are some advantages of IDEs. Now you have to make sure everything is spelled correctly. Lowercase I, main, or this is not going to compile correctly, just like in our previous videos. Here I'm just going to say printf. I'm going to say hello world inside double quotes. Make a space. Say \n for a line feed, and the double quote, and the right parentheses, add a semicolon. This is C code. It has to be exact. Can't misspell main. Can't misspell standard IO. Use the brackets. Double check this. Use the pound. Make sure you pause this. Double check it. Now we can hit File. We can hit Save. And again, we can double check that everything's saved by just using the more command, and now you see content for that file. Now we're going to use the GCC command to compile our source code. Now, before we checked if GCC was installed, you can actually type in which GC. It will tell you where the path is. You can type in GCC --version. We'll show you the version of GCC that you're using. And this is a command that's going to compile your C source code. Now, I'm only going to show you the basics of the GCC command. It can definitely get more complicated if you're doing different settings, preferences, and so forth. I want to get you up and started just so you can compile and run a C program. So in order to run a simple C program, you can just say GCC, the name of the source file, which in this case is hello world.c. You have to make sure you're in the right directory of the source file, and then you can just hit enter. And if there was no errors in your code, you'll see the prompt come back immediately and the $sign or whatever the prompt is. If you type in ls, what you'll notice is there's a new file that was created called a.exe. That's the program that was created since there were no compile errors. In order to execute this program, you can just say /a.exe, and this will run your program. And you'll notice when I type that and enter it, it says hello world, which is the output of the source code. Now, if I had an error in my source code, so let's say I go back, I forget a semicolon, right? Or I misspell main, or I forget a curly brace, whatever the case may be. If this is now saved and I hit Control S to save, I go back and I recompile, type in GCC hello world.c. What you'll notice is there's an error. I'm missing a semicolon. And no program should have been generated. You may still have the old one in there, a.exe, but no program was generated because the compilation and the build failed. So we would have to go back, add the semicolon, save the file, recompile, and now we can actually, and you can actually see that the time a.exe was just generated. And then we can run the code again, a.exe. Now those are very basic compilation commands, basically just GCC with the source name. You'll notice it created a default name for your binary, your executable a.exe. Now if you wanted to change the name of the a.exe to be something meaningful, you can actually say GCC, name of the file, hello world.c, and we could say -o, and then we can change the name of our binaries. We can do something meaningful, like maybe say my program. And again, if there are no compile errors and you hit enter and you do an ls, you're going to see that there's a new executable called myprogram.exe, and then we can execute that. myprogram.exe. And again, GCC gets much more complicated with options to the command line. If you type in GCC --help, you can see some of those options. The real important ones I already mentioned, the -o. The -c will just do a compile but not link. So you if you don't leave that by default, it will do compilation and linking in one step. For now, the -o is really the main one that you want to focus on. Again, you can get a little more complicated if you do GCC. You can type in the --std for the version, and you can say something like C99, and then the name of the source file. If you want to use a specific version of C, and this one actually says, so I must have typed in something wrong. This may be C. It's a lowercase c, not an uppercase C. Right? So there's a lot of different command line options that you can send, but that's for another time. That's for more advanced options when you compile. This will get you up and running if you don't like an IDE and you just want to compile from the command line. Very simple to do in Windows. You go to the Cygwin terminal, you navigate to the right directory, you create a simple C source file with a C extension and a simple editor like WordPad or Notepad++. You save the content of that file, you issue the GCC command, which creates a binary, and you run that program by just saying // the name of the program. Now, if you have any questions on this, please post them in the Q&A. Thanks for listening. Hello and welcome back. In this video, I'm going to walk you through on how to use the command line interface, the terminal, on a Mac operating system to compile and run your C programs. So the first thing you need to do inside your Mac OS is you need to bring up a terminal window. And you can do this in a couple different ways. You can go to the Finder, bring up the Finder and go to Applications, and go down to Utilities, and select Terminal right there. Or if you have it on your desktop already in your window right here, you can just select the terminal window right down in the bottom there. Once you select terminal, this is your command line interface essentially. This is where you can type in commands and run and build your C programs. And it also, there's a lot of other Linux, Unix commands, Mac OS commands. The Mac OS operating system underneath the hood is Linux-like, but it's not exactly Linux. And so what you'll see when you bring up the terminal is you'll see the name of your computer typically, and then also maybe a path and a prompt. And the prompt is where you can actually type in your commands. I'm not going to go through an exhaustive tutorial on all the commands in the Mac terminal, but the basic commands that you should understand are CD, which is change directory. It allows you to navigate to different folders. You just type in CD and then the name. You can also use the make dir command to create new directories. And you can use the ls command to list the contents of a directory. So by default, depending on where you brought up the terminal, your path may be in right at the top level. So here I'm in my Jason's desktop directory. If you want to create a directory to store all of your C programs, you can just use the make dir command and then create a directory right at the top level here. So maybe I'll just create a directory called projects. And once I created that projects directory, I can navigate to that directory by typing in CD, change directory, and then projects. And you can hit the tab button to complete names. And if you hit enter there and you issue the ls command, you'll see you're inside your projects directory. And so at this point, you can actually bring up a simple text editor, start writing some C code, and then come back to the terminal and issue commands to compile and run that code. Now, on the Mac OS, I'm not a Mac OS expert. I typically don't use a Mac OS too much. But there is a simple text editor that you can use. If you go to the applications, this might not be the best one. There are many text editors you can probably download. But one that comes with the Mac OS is if you go under applications, you'll see one named Text Edit. And so you can create your C programs in this simple editor by double-clicking Text Edit. And it is just a simple editor, right? There's not much going on here. It just allows you to write some of your C code. And so once you're inside Text Edit, by default they're going to save files in the rich text format. You want to change that because you only want to change save files in the C extension. So you can go up to the Text Edit and you can go up to Preferences, and under the New Document tab you can just say the format. You can say plain text because you don't want any extra stuff saved with this. And again, there are many editors available on Mac OS. You know, you can use something much easier than probably Text Edit, but this is the basic one that comes with the operating system. So now I just want to go up and I want to say under Text Edit, I want to say File, I want to say Save, and I want to navigate to wherever I created my projects directory, usually in the middle. You can go to the username and you'll see everything listed there, and then you can go to Projects. Then you want to go up to the Save As text field and you just want to say, let's name this Hello World.c. And you want to make sure that it says plain text encoding. You may have to restart Text Edit if you just change the preferences like I showed you so that this comes up. But you just want to make sure that you say Unicode UTF-8 and then you can hit Save, and it should have saved Hello World.c. You can navigate back to your terminal, and if you issue the ls command, you'll see that there's a file named Hello World.c now. So now we've saved our file in the right location. Now we can actually start writing some code and saving it in order to compile it. So the nice thing about IDEs is they'll bring up some templated code for you. You don't type everything in. Now I'm going to write some C code, and this code is going to look unfamiliar to you. Right? It's not important at this point. It's just, again, we're trying to set up our environment so that we can run and compile a C program from the command line interface in the Mac OS. So I'm going to type in some C code, #include. Let's make this text a little bit bigger so you can see it. So we can go up to text edit, and we can go to preferences, and we can go to the plain text font. Let's just make it something we can see. We'll make it 18. Type include. Standard IO.h, and then we'll just say int main, and some things may be automatically capitalized for you. Again, might not be the best text editor. We can come back and correct these. We had the curly braces, and then we can just say printf hello world \n for a line feed, and then end it with a semicolon. Then we got to make sure that int is lowercase. And then we can go ahead up and we can say file, save. Again, this is just a simple C editor for source code. Text edit may be not the best one, but this is one I'm familiar with. So now we go back to the terminal, and if we issue the ls command, we see hello world.c. Let's make this a little bigger. And we can now actually see the content of that text file by just typing in something like more and then the name of the file. And you can see that what's inside there, standard IO, int main, and so forth. So we're able to save our C source code to a text file. Now we want to compile it. If you remember from previous classes when we installed the C compiler is named GCC. If you type which GCC, you can see where the path is. If you type in GCC -- version, you can see the GCC version. But the command to actually compile is just GCC. And so if we clear this out and we say GCC, and we're currently in our projects directory, and we type in the name of the C source file, which is hello world, and we can actually complete that using tab completion, and we hit enter, you'll see that it just went back to the command prompt. And that usually means there's no errors. But actually, after issuing the GCC command, that should generate a binary program, an executable. So if we type in ls, we can see there's something named a.out. That's our program that was created by default with the default GCC command. We can run our program by doing // and say a.out, and that will run the hello world program. And you see as output hello world. Now the GCC command can get much more complicated. We can change the name of the executable. We can do all sorts of things. I'm not going to discuss all the compiler command line options in this lecture. That's going to be in the advanced C class. We're just going to go over the basics. Now, if you type in GCC -- help, this can give you some additional information on some of the compiler commands. The really important compiler commands, the ones that you'll probably use a little bit more, are the -C and the -O, which you'd have to actually, maybe maximize your window to see them because it looks like they're higher up. But GCC -C and O are really the main ones. If you type in GCC -C, that will compile a single source file. I don't recommend it because then you have to actually link and so forth. A really good one is, as you noticed, a.out is by default the name of the program. That's not a really good name. So you can say GCC and then the name of your source file, hello world.c, and then -O. -O will change the name of the program from a.out, and you can name it whatever you want. Let's name ours my program. And so if we compile and we have no errors, now what you see generated is my program. And it's a little more meaningful name. You can then do a // on my program. And that will run it, the program. Now, if you have errors in your code, so for example, let's go back to text edit, and let's say we have an error. Let's say we forgot a semicolon, or we changed the name of main to misspelled it, or the int was a capital I, or standard IO wasn't saved correctly. Say we save that. Now when you compile with the basic GCC command, GCC hello world.c, what you see is we have an error. And so we would have to go back, fix that error in the text editor, and then rebuild it and resave it, right? Because we're missing a semicolon here. So if we go back we add the semicolon, we save it, and we compile it again, we don't have that error and we can actually run it. And we have no errors, and then we can actually run our a.out program because we didn't name it there. And we can hit the up arrow key to go to previous commands, and we'll execute our program. So this was just some basics on how you can compile and edit using a simple text editor a C program using the terminal. Again, it can get more complicated. These are just the basics. If you don't like the overhead of an IDE, this is always a good option. Thank you. Hello and welcome back. In this video, I'm going to walk you through how you can compile and run your C programs using a simple text editor through the command line interface on Ubuntu. So here we have our Ubuntu operating system. Remember, to start programs and to start different terminals, you can actually select the ... and you can come up here and type in search, and you can say terminal. That's one way to start it. If you don't go to the search option, you can actually just come up here and right click on the window and you can say open in terminal, and that will bring up a terminal as well. Now this is your command line interface. This is the terminal. This is where you type in commands to run your C programs essentially. And you'll notice when it first comes up, it's going to come up with specific font and your directory structure wherever you're logged in. So this comes up on the desktop, right? And so you can issue simple commands like cd to change directories. This is not going to be an exhaustive tutorial on all the commands in Linux to create directories and navigate to directories. I mean, you only need to know a few. A cd will change directories. Make dir will create directories. And then ls will list directories. Those are really the main Linux commands you need to understand. So for example, if we're in our default directory and we want to create a directory maybe just to store our C code, and maybe we call it a project, we can say make dir project. And then we can do ls, and that will show us all of the different directories under our desktop here, default directory. And then to navigate inside there, we can say cd project. And we get the tab button for tab completion. And so once we're in a directory where we're going to start editing our code, we have to bring up a simple text editor. And Linux does have a lot of various text editors that are available. There are old school ones called VI. You'll see me using this quite a bit. But it has kind of some commands that are a little tricky to insert and add tabs. So if you type in VI and we could say main.c or whatever, it will create a file called main.c in the VI editor. And it looks a little weird. If you're familiar with VI commands, it's not too hard to use, but it's not the most intuitive. You have to select I to insert, and then you can start writing your code and things like that. And then you have to hit the colon or the escape key to go back to the commands, and then hit colon and Q to quit. So VI is a little bit harder to use, and so it's a little bit more complex. The editor that I would suggest using is probably something like gedit. That's a pretty simple one to use on Linux. There's a lot of different ones. And again, if you go to the show applications, you can type in gedit, and this will bring up a gedit text editor. And it's a pretty simple text editor. And so you run that, and it will bring up the gedit text editor. You can also, incidentally, bring it up from the command line, right? You can say gedit, and you can do the ampersand so that you still have the prompt. And that will also bring up a gedit editor. And this will bring up the editor in that directory project. And so what you can do here is it's very easy interface to use to start creating your text, your C source code. And so what you can do is you can open an existing file if you already had one, or you can hit the plus to create a new document. And here you can say it will add tabs. Right, so we have a document right here, doesn't have anything in it, but we can save it anywhere we want. And so I just created a directory under my desktop project, so I can select desktop and say project, and I'm going to put my file in there. And I'm going to name it, I'm just going to name it Hello World. Let's see, you put it right up here in the name. Hello World.c. And I'm going to hit save. And then you can actually see that this file is now saved inside that directory by typing the ls command. And you see hello world.c. So now we can go back to our editor, and you'll see it still listed on the left-hand side, and we can actually start writing our source code. And again, we haven't really gotten there yet where we understand all this source code, but we're going to. We're going to get there. I know you're going to have a lot of questions about that. But the source code right now, we're trying to set up our environment. We're making sure we can compile and run. And in this case, we're compiling and running from a terminal. So the source code is just a standard C template for a Hello World application. We do the pound include. We basically use standard IO, so we can use some of the printf functions. You can manually type this in, and then we can just say int main. Make sure you spell main correctly, and we could have put a void in there, and then a left curly brace, and then a right curly brace. And you'll notice that this simple text editor doesn't do a lot of the nice things that the IDE does for you, right? It doesn't do any of this code completion or add templated code for you. It doesn't add brackets. Everything has to be done manually. And so here we're just going to create our main function, and we're going to do a printf, and we're going to say hello world inside double quotes, and we're going to put a line feed in there, end it with a double quote, right parentheses, and a semicolon. And at this point we want to save it, so we can either hit Control S to save it, and now you see some syntax highlighting happen. The int is in green, the void is in green. We can also just hit save. Right? And so here we just created a simple C program, right? And this should look familiar from the previous videos. It's not an IDE, it's not in CodeLight or anything like that. It's in your own editor, a simple gedit. Right? It doesn't have any of the overhead of projects or settings or anything like that. It just has the templated code. So now if you go back to the terminal, and again, if you type in ls, you see that hello world.c exists. We can actually see the contents of that to see if it was saved correctly by typing in the more command and then the name of the file, hello world. And you'll see the source in there. And at this point, we've actually created the C source code, but we haven't compiled it yet. We haven't built it. So we want to build it, and then we want to run it. Right? And we talked in previous videos about how we installed the GCC compiler. And so if you type in which GCC, you'll see the path to that GCC compiler. You can type in GCC -- version. You see the version of the compiler you're using. And so in order to compile this, you have to use that command, the GCC command. Now, the GCC command can definitely get more complicated. There's a lot of options to it. There's all sorts of different things. At the very basic level, you can compile a C source code by just typing in GCC and then the name of the file. In this case, hello world.c. And you can always hit the tab button for tab completion, so you don't have to type all of it in. But if you just type in GCC hello world.c with no options, no flags, it's going to try to compile your source code. And so you can hit enter, and if there's no errors, you'll see just the next prompt. Now, if you actually had an error, so let's go back to our text editor. Say we were missing a semicolon, any other common errors. Say we misspelled main, we misspelled standard io.h, we didn't have a curly brace, beginning or ending, whatever the error may be. Once we save that, and if we execute the command again, you'll see now it says there's an error, right? You're missing a semicolon essentially. So you'd have to go back and edit it, add that semicolon, save it, and then compile again. Right? And again, this is very simple GCC command. It can get a lot more complicated. Right? So you can actually see a lot of the various options for GCC by typing in GCC -- help. And this gives you a list of all the different commands you can execute with C. So the common ones are the -C, the -O for linking. Again, I talk more about compile options in my advanced C course. We're just trying to compile basics here. So if we type in GCC and we have no errors on our file, you'll just see a command prompt that's returned. Now you can actually, and what you'll see as well is if you do an ls, now you'll see a file that's created called a.out. This is actually your binary executable file. And so you can actually run your program now by just typing /a.out. And this will run your program. If you hit enter, you see the output hello world. And so that's how you can compile and run a simple C program. Now it can definitely get more advanced where you can have different compiler options. You can change the name of the binary to something meaningful. You can actually, instead of hitting the // to execute the executable, so you could do something like GCC, and then you can have the name of the file hello world, and then -O to change the name of the executable. So in this case, maybe we'll name it something like my program. And that will compile the code. and it will change the name of the binary, the program that you want to run. You can ls, and you'll see now there's my program. In order to run that, you do a ./ and you say my program. But again, we're sticking to the basics. I'm showing you how to compile a basic C program using a simple text editor and then issuing the GCC command in one line to compile the program, link it in one line, and create the executable program that you can then run from the terminal. So there's a lot to cover here. Make sure you pause the video, go back. But the gist of it is you can use a simple text editor, write a simple C program, right? No IDE here. Make sure it's saved. Go back. Confirm that it's saved, your source code. Compile it using GCC. If you need help, use the -- help option. But basically creates a binary, and you can run C programs from the terminal. Thanks. And if you have any questions, please post in the forum. Hello and welcome back. In this lecture, I'm going to actually provide you with another option of how you can write and compile your C programs, mainly using an online C editor compiler. This is useful if you don't have your computer, or if you're in an environment where you only have access to a web browser and you want to write some code. You don't have your own computer set up with your IDE, or you don't have access to a command line interface. You just have a browser, and there's many online C compilers that are online in a browser. So I'm just going to bring up my Chrome web browser and show you a couple that are available. There are a lot of different ones out there. You can essentially Google just online C compiler to find out many of the ones that are out there. I'm just going to show you a few. Again, the whole idea is that on a server somewhere, there's a way to edit and compile and run your C code just online through a browser. One of the more popular ones, one of the first ones you'll see is this one here, which is the online GDB beta. If you look right here on the link is www.onlinegdb.com/online_C_compiler. Again, if you do a Google search for online C compiler, usually this is the first one that comes up. You can select that link. It's a pretty basic interface. Again, you have run and debug. You can actually debug, stop, share. It actually comes up with the code template initially with the main and the print hello world. You can also pass command line arguments into your program. So it has some nice features here. The interactive console can allow you to actually ask the user for input as well, and it will come down here. But the basic program, all you need to do is, you can write and code and edit it here in this editor. And then when you're ready to use it, you can just say run. And this will actually compile the program down below. It will tell you if you have any errors, and then it will do the output. So if you had an error here, and it automatically saves for you as well, and you hit run, you'll see the errors listed below as well. So it's a nice little online compiler that you can use if you don't like the IDE, or if you don't have access to the IDE. Again, interactive, and allows you to pass command line arguments, and again, it allows you to run the debugger. We'll talk about the debugger in much later sections, but this is just an introduction to some online compilers. So you can check that one out. Another one that's commonly used, although sometimes it has some performance issues, is the Tutorials Point online C compiler. This one you can grab through the Coding Ground online C compiler. So if you just go to tutorialspoint.com/compile_C_online.php. Again, a similar interface here, except now you have the editor on the left-hand side and then the terminal, the output on the right-hand side. So you can write your code, you can select execute, and you'll see the output on the right-hand side. Now this one doesn't have a debugger. This is a little bit more limited, but it will show you errors if you have errors, things like that. And it allows you to run basic C programs. You can also get input from the terminal by, if you want to get input, you would enter the input over here. Pretty nice interface, pretty easy to use. Sometimes I've seen this one have some performance problems. With all the online C compilers, you're always going to have a limited number of features. I don't actually know how long this C source code is saved or cached in your browser, so you may want to copy it. If you do write a program, copy it and save it somewhere else, because online I'm not sure. Another one that's used, I think it was the second link here at the current time of this video, is this one by Program IZ. This one is C Online Compiler at programiz.com/c-programming/online-compiler. Again, more of the same, right? Source code here, output on the right, you run it, you see the output and so forth. Not sure if this was an interactive. Last one I want to show you really quickly is a CS50 IDE compiler. And so if you go to the online C compiler, you type in CS50 IDE. I've used this for different things. Mainly the nice thing is it has a Linux terminal. So if you type in CS50 IDE in Google, you'll see this come up with the link. Now, initially, when you go to the CS50 IDE, at least at the time of this recording, which is ide.cs50.io, you'll see that the old way of doing things is deprecated. So you want to click this link, code.cs50.io. You want to go to code spaces. The only prerequisite for using this online IDE is that you have a GitHub account. So you actually have to sign up for GitHub, have a username and password. But once you select that link, and once you're logged into GitHub, it will take you to this Visual Studio Code for CS50, and you can just say log in, because you have to log in to GitHub if you're not already logged in. Once you log in, it will ask you to authorize CS50 IDE to just do some things. If you're comfortable with this, you can say authorize CS50 IDE, and then you'll be redirected to the authorized application. It may take a few minutes to, build and set up your code space initially. And so once everything is loaded, what you end up seeing is this type of interface. And it looks like an IDE, right? So this is why this one's a little bit more robust. So you can go up here and you can make sure you select new file, not new folder, new file. And you can name it hello world.c. And you'll see that file being created, and then the editor's on the right. So then you can actually start writing some source code for a standard C file. And then in order to run that code, you just hit the run, and you'll see errors and so forth down in here. You can also interact with the Linux terminal by issuing commands here. You can see hello world.c was actually created here. So if I just take a copy and paste and take some code, it has line numbers, which is nice. You can run it and run and debug, right? And it kind of has this Visual Studio interface. So if you don't want to actually run it over there, you can run it in the terminal through the command line interface, like I showed you before. This is running in debug, but it's a nice little interface here. I usually just go to the terminal and I'll actually just type in commands to execute, but this is another option to run and write your code. Now, just remember that with all of these online C compilers, is they are somewhat limited on features. They use the GCC compiler, a variation of it, but they may not support all the features in the class. So if you're doing advanced C programming and you're doing things like sockets and you're doing things like threads, these online C compilers typically won't work for that. But they are a nice third option if you're on the run and you want to write some C code, you don't have your laptop, and you don't have an IDE, and you don't have any kind of terminal in play, you don't have Cygwin installed or whatever. These online C compilers are a nice alternative. Thank you. Hello and welcome back. In this video, I'm going to go through an overview of the CodeLight IDE graphical interface. The IDE stands for Integrated Development Environment. And IDEs basically are nice tools that allow you to compile, edit, and run your C programs in a nice, easy manner. So you can click on menu options to compile, menu options to build and run, and they're really, really nice and easy to use. Now, the CodeLight IDE is kind of a simpler IDE compared to other IDEs. If you ever used Xcode or Visual Studio Code or even Eclipse, they're usually a little more complicated. This is a lightweight IDE with minimal features and minimal graphical interface components. So during this video, I want to kind of go through this interface to show you some of the nice tips and tricks and how you can actually use the IDE. When you first start CodeLight, this is the interface you're going to see. This is the default interface. CodeLight refers to this as the default perspective. So what we see is basically three areas here that are divided. On the left-hand side, we have, and these are usually referred to as panes, we have this workspace pane. And then in the middle here, we have our editor pane. This is where we edit our source code. We also have a recently opened workspaces that comes up by default, so you can quickly access a previous workspace that you opened or created. And then at the bottom, we have our build and our output windows. This is our output pane, typically the build pane where you see compilation going on and so forth. So this should look somewhat familiar from previous videos. We especially know how the workspace pane looks like. Right now it's empty, right? You see a bunch of tabs inside there. We'll kind of cover those. But we have no workspace. So let's go out and just open up one of our previous workspaces or create a new one, right? And you see a lot of symbols here on the left as well. You can pretty much get to everything through the menu options at the top, but you can always go to File, New, and you can say New Workspace, or you can pick a previously recent workspace as well. We know how to create new workspaces from previous videos, but usually you want to select C++, right? We can put it wherever we want to in any directory that we like by going to the directory structure. We can just name it whatever we want. Again, we'll just name it Workspace 1 or Workspace 2 since we already have one. And then you say, okay, now you can actually see our Workspace 2 here in our simple view. And then we can also add a new project by just going to New Project, right, and just naming this Project 2. And we can use, remember, templates from previous videos, all our default information from set our project settings for previously as well. So we just said, okay, now we have a workspace and a project. So now we see that it actually created that main.c file, right? And then that comes up in the editor view. Right? And so we have this tree-like structure for our workspace projects. Remember, we can create multiple projects. We can click on the workspace, we can right-click, and we can say new project. We could also go up to File and select new project. You know, we could, again, we'll create another project just to show you that there can be multiple projects in a single workspace. Again, keep all the defaults, say OK, and now we have multiple projects. And it's very important to know that the bold ones is the active project. So that will always be the one that builds and compiles. And anytime you do any actions in a project, it's the bold one, the active project, that's going to get actions on. You can also make another project active by just double clicking it, or you can select it and set it as active by clicking Make Active. A couple things to note here, especially in the editor. You can see we have line numbers listed. Line numbers are always useful because the compiler, whenever there's errors, will tell you the line number, and so you can easily reference the line number to fix errors. It's also a nice way to just see what's going on in terms of when I write code in the class, I can always refer to line numbers. But not everybody likes the line numbers. You can always turn off the line numbers by just going to the Settings, Preferences, and if you go to the editor, you can turn on and off the line numbers. So right under Guides, it says Line Numbers. You can uncheck Display Line Numbers if that's your preference. Another nice preference that you can use is, again, if you go to Settings, Preferences, and you go to Folding, you can actually show the folding margin, and it will actually add a triangle-like thing to wherever you have brackets. And so when you click that, you can see that it basically hides this function. So it's useful when you have a lot of code and you want to get rid of some different functions. You don't want to have too much code showing. So you can always add that code folding for easier editing and kind of just showing these lines. Another thing to notice in the editor is the syntax highlighting. You have green for header files, purple for some of the different data types, and printf has the green inside double quotes, return is a certain color. You can always change these if you go to Settings and you go to Colors and Fonts, and you can start modifying the appearance of the different syntax highlighting and also the different kind of themes of your CodeLight appearance. Right? We can have a dark theme and so forth, but you can mess around with this. I would suggest just leaving these as defaults for the syntax highlighting. And so if you actually select the Customize Colors per Language, you can select that and you can actually see the different options for different languages. Right? So even though we're doing C, you can actually select C++ and mess around with different styles for different keywords and global settings and everything like that. So it's an option if you want it. Again, I usually just keep it as the default. So if we look down below at the output pane, there's a lot of different tabs here, different windows that you can see. Real important ones are the build and the output. But there are a lot of other ones that you typically don't really need to see. If you select one of those tabs, you can right click and you can say hide, and it will no longer show. You can also go to the dot on the right hand side and you can kind of see which current one you're on. And then also look at the different hidden tabs. It's a way to manage a bit easier what all these different tabs are showing up. Again, most of them you don't really care too much about. Search and replace is also usually useful to see as well. So you can manage that. Now up top here, you can slide your window back and down depending on how you want to see it. There are a lot of different tabs available in the workspace view. We're really only interested in workspace, explorer, and maybe tabs. These other ones we don't really use too much. Tab groups and help. So you can get rid of those by selecting one of those, right clicking and saying hide, and that will show that it's not showed anymore. Same with CMake, help, usually hide. Just again, we're limited on real estate, so we may want to customize according to your preferences what you want to show and what you don't want to show. We've seen some of these options already in the workspace view, and we can always go up to view as well, and we can restore layouts if you ever mess up or make changes that you don't like and you want to restore the default perspective. You can also take the workspace view and move it around if you want it at the bottom. So if you just select the title tab here, you can move it down on the bottom if you like it at the bottom. If you want it up on the right hand side, we can move it over there, or the bottom right hand side. And so those are the main things I kind of wanted to show you, but obviously there are a lot of different options, right? There's a lot of different shortcuts. So if you have a tab on the left here, you can create new files, right, by hitting the plus, right? And usually if you just hover over them, they'll highlight open file, backward, build the active project. So there's shortcuts here on the left that you can have access to. We already showed you with the wrench, goes to the project settings. This will take you to the active project, taking in the home. Right? You can select the drop down if you want to build different types of binaries, either for release where you don't have debugging information. You can open up the workspace configuration manager. The explorer and the tabs just allow you to navigate. You can look at different folders here, see different views. You can always close the workspace. You can also have a lot of menu options up top. Right? A lot of these are self-explanatory. Again, creating new projects, creating new empty files, opening existing ones, saving. Right? Pretty intuitive, I think. Editing, copy and pasting. Right? You can turn on different options for matching braces. Code completion, usually you need a plugin for that. View's pretty good to use because you can hide the different windows that you want for your particular layouts. Right? You can show white space, so you can actually see it in here. White space is sometimes useful when you're using tabs. Display end of line. You can show the navigation bar, the debugger pane that's used for the debugger. Again, another window. Usually that will come up automatically when you're in debug view or debugging a project. We'll go through, and a lot of these options that we talk about right now, we'll actually go through as the course progresses when I show you things. You can actually change the toolbar to put it on the top, right? And you have to reload CodeLight for that whenever you move that around. The toolbar is nice because it has those shortcuts, right, for building and even in debug mode and so forth if you're showing a debugger window. So view is a nice thing that you can play around with to, again, get whatever layout you want. Search is obviously, you can search all your different files. You see the output in the bottom in the search. You can also do an edit and replace, which is also very useful, especially when you have big projects. Workspace menu option allows you to, again, reload open workspaces, create new projects, select the active project. Build is your build menu option. We've already covered this, how you can basically compile your source code and you can run your source code, rebuilding everything, build and run in one particular selection. We can clean a workspace, which will delete all intermediate files, all .os, all libraries. Debugger is the view that you can see when you run your code in debug mode, right? And again, we'll talk about this more in a subsequent video. There's a lot of different plugins you can use for CodeLight. Really, the only real important ones are usually some for the code completion. You'd have to do some additional research on this if you wanted to look at any of these different ones. And then settings is obviously very important because you can actually check your build settings, your preferences in terms of the editor. Right? We talked a little bit about this, but you can kind of go through all of these to see how you have different preferences for different editing preferences, colors and fonts. And then the build settings was always important because you can select your build and have all your paths. Again, we've kind of talked about that already. And then help is basically how you can get updates, run the setup wizard and so forth. So a lot of different options in this IDE, mainly just personal preference type operations and also shortcuts to common features that you usually perform, like building and compiling. And again, as I mentioned, in upcoming videos, we'll go through some of these a little bit more in detail when we need to use them. Right now, the basic default perspective is usually meets everyone's needs, and you can manage your different projects in your workspaces. You have your editor and you have your output windows for building and compiling. Thank you. Hello and welcome back. In this video, we're going to create our first C program. And so you're probably familiar with this view. This is CodeLight. We have a couple projects in this workspace from previous videos, Project 2, Project 3. We want to create a new project, and we should know how to do this. At this point, we can just go to File, New Project, or we can select the workspace, right-click, and say New Project. This will bring up our new project wizard. I'm going to use the previous template that we created from a previous video. And so I'm just going to name this project, our first project. How about our first program? That's even better. And in the category, I'm going to actually select our user templates. And for the type, I'm going to select my template. I'm going to hit OK. And you'll notice that it now created our first program folder, but it's not highlighted bold. It's not bold. We have to make that bold, meaning our active project, because that means whenever we edit it or compile it, it will actually compile this project. So we're going to go ahead and we're going to double click that to make it bold. So we select main.c and we're going to close that other file, and you'll see that we have our templated Hello World program from our previous project settings. We're going to go ahead and delete this because it's always a good idea to write code from scratch anyways, because then you understand what you're doing and it's good practice for you guys to undertake. So at this point, we're going to start writing our code, and we're going to start off by including a standard IO header file. And these concepts we'll explain in even more detail, but this pound symbol is basically a preprocessor defined that says we want to include some other code somewhere built from the C standard library. We can also include our own header files later, but right now we just say include. We say standard io.h. You see the syntax highlighting happening, and we just say include. And then the next line of code we want to write is we want to write our main function. Our main function is our entry point to the program. This is the function that gets executed when we run our program, run our executable. Now, the main function has a lot of different variations. We're just going to create it with an int data type. And again, it's highlighted in purple. And then we just say main, and then we can just have empty parentheses. And then you'll notice when you type in a parentheses, that it's red because there's no ending right parentheses. So left parentheses starts a function, prototype function definition, and then a right parentheses will end it. Well, this function doesn't take any parameters, so we're just going to keep it empty. Now, incidentally, C also allows you to put void in there, which is a special keyword, but we're just going to make it empty for now. And then we're going to actually create our function, and all functions start with the left curly brace. So we're going to have a left curly brace, and again, that's red because in order to end the function, we have to have a right curly brace. And a left curly brace begins the function block. Basically, anything in between the left function and left curly brace and the right curly brace is code inside of a function. And again, these terms may not be completely understandable, function, things like that. We're just writing our first program that will demonstrate some understanding of the syntax, and then you'll have a challenge and so forth. So whenever you have a red curly brace, you have to have an ending curly brace. Now, incidentally, the IDE will add it for you when you hit the return after adding that left one. And so what I'd like to do now is I'd like to write some code that will basically ask the user to enter in their favorite number, and then I'll just print out their favorite number. And again, some of this information will be detailed as far as syntax in later videos. But we want to get our first program written, and we want to be able to compile it. And so at this point, we're just going to basically create a variable that stores information, and it's going to store our favorite number, so we want to have it of type int, and we're just going to name it my favorite number. And we're going to initialize it to 0. We're going to assign some data to it. And we'll talk about data types and variables, and again, more of these concepts in future videos. We always want to use good naming conventions for variables that are stored, our data. And then we're just going to ask the user to enter some information. So we're going to use a function called scanf for this. And again, inside double quotes, we're going to just put our data type specifier, %d, and a backslash, or in an ending quote. And then we're going to store that data inside of a variable called myFavoriteNumber. And so you should be typing along with me to just see how we can write code and get input from the user and so forth. There will be, again, another video that specifically explains how to get input. So we're going to also ask the user to enter a number. So we want to display some output to the screen. So we're going to do something like, please enter your favorite number. Right, and then add a line feed for backslash n. You'll notice everything is enclosed in double quotes. And then we do a semicolon to end that statement. And you'll also notice that other statements in C, such as the include directive, don't have a semicolon. Functions don't have a semicolon. So then we ask the user to enter a number, and then we're going to just print out and tell them what their number is. So we're going to say print out you entered number, and we're going to use format specifier, again, explain later, backslash n for line feed, and then we're going to display the value of the variable, which is my favorite number. And then we're going to end our parentheses and add our semicolon. The main understanding of this code here is that we have a lot of code completion for us with parentheses, ending parentheses, and so forth, and also ending quotes, double quotes. So the IDE does a lot of nice things for you. And then we have the syntax highlighting. Again, this is kind of just for getting you familiar with some of the syntax for C. And then because we have an int, we just want to basically say return 0, meaning we don't have any errors. Right? And so then we can save our code. We can hit Control S. And what you can actually do is, since our first program is in bold, that means we can actually compile this. Right? And we can right click and we can actually say compile. And then you'll see output in the build window that's whether or not it was successfully compiling with no errors. Okay, and so we just wrote our first program that did something very simple, asking the user for their favorite number, getting that input, and then displaying the output. And again, a lot of these concepts, getting input, displaying output, format specifiers, functions, those are all going to be later defined. The purpose of this video is to just write some code and be a little bit familiar with some of the syntax and be able to compile that code. And so we didn't have any errors. So in the next lecture, I'm going to actually show you how you can build, right? We already talked about C programs and how there's many steps to create a binary and executable program, right? One is compiling, one is linking. Up to this point, we've only compiled. Now we have to actually build our entire project so that it links and creates our program executable. So we'll see you in the next lecture. Thank you. Hello and welcome. In this video, I'm going to show you how to build and run the program from the previous video. So if you recall, we had a little program that basically asked the user to enter their favorite number and then printed out that favorite number. So from past videos, you should understand that there are many steps to create a program that you can run. Right? You have to compile, you have to link, and then you have to create that binary. And so up to this point, we were able to compile successfully. We don't see any errors. Now we need to basically take all of the external dependencies for this program, right? Standard IO header file and any other libraries provided by the C programming language. We have to take all of that, which can be many .o files, and take all of that external code to create one single executable. Right? So here we have our source code. You'll see we kind of have the source code that's kind of bunched up together. You can actually make this code a little bit more readable by adding some new lines. You know, something like this. It just makes it a little bit more readable. Now, as I mentioned, we've already compiled it. Just to refresh your memory, you can compile a source file in many different ways. You can right-click on the source file and say compile. Or you can actually select that source file, go up to build, and you can say compile current file. If we select our project, you'll see many different options related to building. You see build, rebuild, clean, stop build. Let's talk about clean first. Clean is going to basically wipe out any .o files that you had. So remember beforehand in previous videos that a C program when it gets compiled, you're compiling each source file. And a program may consist of many source files, main.c, any other files as well. There are programs that contain thousands and thousands of C source files. Once you compile all those C files, it creates all the .o files. And then you take those .o files and you link them together to create one single executable. Now, when you select the project setting, the project itself, and you say clean, what you're doing is you're basically deleting all those .o files. You're deleting any extra artifacts, you're deleting the program executable, and you're starting from scratch. You're essentially getting a clean workspace that you can then recompile, rebuild, relink, and recreate a program itself. Typically, you want to use clean if you're running into errors and maybe you just want to recompile every source file. Because typically when you run a C compiler, if the code doesn't change and you try to compile that code, it usually doesn't recompile it. And so if you just are running into problems, you have a lot of source files, you're seeing errors that don't make sense, it may be good to start from a clean state, go to clean, clean everything out. You say clean, and it will show you exactly that it's basically removing everything from your build debug folder. Again, all those .os, the executable, you're starting from scratch. It's a nice way to resolve any kind of dependencies or any kind of issues with not recompiling the whole project. It's, again, to start from scratch. So after running clean, we don't have anything compiled or anything built. And we could go through and we can compile individual files by saying compile and click on each file if you have many source files. But that's not really a great way to get to the final executable. Typically what will happen is you want to make sure you have your apt project and you'll typically just say build. And that will go through all of the source code in your project and build all of the files. Right? So when you hit build, you'll see it go through and grab all of the source files and rebuild. Right? And same thing as if you right click and you say rebuild, this will not rebuild all the files, it'll only rebuild the files that have changed. Right? And so you can say build, which makes it a little bit easier than just compiling every source file. The build will actually, again, compile all the source files, but also link them. So you can kind of see that in the output, right? If you go to the build output window, you can see that we're first issuing a GCC command, -c, which is the flag for compiling on main.c. We then pass in parameters for 64 architecture, optimization, some debugging, standard C99, warnings for all warnings, and then we do the -o to link to the main.c.o file. We're basically going to also include some include directories. And then in the next step, right, we issue the -o to do our linking to every external dependency. In this case, we don't really have many. We just have basically we're linking statically with the -l, and we're basically building this object list.txt. The big important thing here is it's actually creating an executable named ourfirstprogram.exe. And so building does both steps of a C program, right? It compiles it and links it and creates the executable. And so it just makes things easier by building as opposed to compiling everything at first. Now, you may want to compile individual files just to maybe see what's going on to make sure your source code is correct and you're not ready for linking. Right? You may have 5 files in here. You select each one. You want to say, okay, I just wrote some code. Let's compile it, make sure it's all good to go. And then I'll go and audit the next file, compile that, and then eventually you build everything. Now that we have an actual program executable that's created, we can actually run our program. And so you want to make sure that you have your program, your project as the active project and have it highlighted. And then you can go up to build and you can simply say run. Now, when you select run, you'll probably get this pop-up that says, do you want to build again and execute? Now, you've already built, so you don't really need to. You can just say execute. You can select the checkbox to make sure this doesn't always come up. And when you run, it doesn't always rebuild. It's up to you. It takes up some CPU processing time to rebuild everything, but you're probably not worried about that. So you can always say build and execute and not have a pop up, or you can always just execute. Now, if we select execute, it's going to take that executable and it's going to run. And what you'll notice is it's asking you to enter your favorite number, the user. And so you can just put in a number, 45, hit the enter button on the keyboard, and then it will just display you entered number 45. Right? Again, a very simple program, asks for input, displays output, and then you can hit any key to continue, to close that window. Now, if we go back to our workspace view, or workspace window, or workspace pane, whatever you want to call it, you notice we have 3 projects, right? Our first program is highlighted. That's the active project. The other projects still have their source files in them, right? Main.c, right? And our other projects, they're pretty much templated hello world code. But what you don't see is you don't see any of the object files, the .o files. You don't see the executable file, anything like that. Now, you can actually view those by clicking on the Explorer tab. And you can actually specify a folder to open. And usually this should be the root folder of where you're creating all your workspaces. Right, so I typically put them, I think I put them in Documents inside of, right inside Documents, I have my workspaces. You'll see that it does have a lot of stuff in here, so usually you want to put that local. But you'll see that you do have Workspace 1 and Workspace 2, and you'll see that that workspace has the .codelight file. Actually, it'd probably be better to open the exact workspace files, right? Because that's really only what we're interested in. Workspace 2 is what we're interested in. So let's say select folder Workspace 2, and then let's go ahead and close our existing documents. So we can go ahead and we can just say close. So now we have Workspace 2, and now we can actually see all of our executables for all of our projects and all of our .o files. And so you notice there's a CodeLight folder in there. That CodeLight directory just contains, some of the preferences for the workspace and so forth. We have our build debug folder. This contains our binary directory, which contains our executable. And you'll notice that we also have an our first program directory. And that's inside build debug because that workspace, that project has been built. And you'll see in there we have our object files and any other dependencies that are built, this object list. We actually have our first program project, right? And that contains our source file and any other make files and so forth. And you see the same thing for the other projects. And then at the very bottom, you see compile commands.json. This is usually used for code completion. You see a make file, and then you see a workspace file. But the Explorer tab helps us see our entire workspace layout. All of our projects, everything that's been built, all the project settings files and all the project source files, and then also any dependencies on code completion files and so forth for the workspace itself. And so we talked about clean, right? How clean can actually delete everything, all the object files and the executable. So if we go back to workspace view and we highlight our first program project, when we right click and we say clean, that's going to delete all of those. So now if you go back to your Explorer tab and you go to the build debug, you still see everything in there because it hasn't been refreshed. So you can actually refresh this view. So I'm going to right click on our workspace and I'm going to say refresh. The build debug folder is still there. It usually gets deleted, but there's nothing inside of it, right? You might have a bin. Again, usually that gets cleaned up, depends on the permissions, but you don't have any .o files. You don't have your executable after doing it clean. Now again, if we go back to workspace, you can see this little drop-down menu that tells you what to build, whether you're building for debug or whether you're building for release. When you build for debug, it includes debugging information in the program executable itself. That usually happens when you're developing your code. You want debug information in case you need to run the debugger and so forth. That's not always good to do when you're releasing a program out into the field or to a customer into production mode. So you can change the release to release when you're building and you want to distribute this program somewhere. And so then when you build it, what you'll notice is if you go to the Explorer tab, you'll see, again, do a refresh, you'll see a build release folder. And this will lack the debugging information, essentially. So you won't have to worry about, basically, if you have debugging information, you can generate a core file, and you can have hackers that can kind of get information about your source code. So you only build for debug mode when you're developing, and you would change it to build release mode when you're maybe releasing your program out to a customer. Again, it depends if you're working somewhere or if you're working for an employee, if you're actually delivering some code somewhere. Usually you don't really modify anything in the Explorer tab. It just gives you a view of what's built and your executables and so forth. Again, I mentioned you see some helper files. You can look at some of these things. Some of these things will be auto-generated. You can see a make file in here. And this is actually a makefile that can be generated depending on your project settings. This is a makefile for the entire workspace. You can look at, specific programs and see some of the makefiles that are generated. Again, but usually you don't want to mess with any of this stuff. This just, again, provides a makefile to compile. Sometimes when you have errors, you can look at the makefile to see exactly what's going on. Maybe something wasn't generated correctly. CodeLight sometimes has some bugs depending on what make system you use. Again, we usually go with the Unix file make system for if you're on Windows. And then if you're on Linux or Mac OS, you just go with default. So that's basically it, right? You can close these files, but you kind of see what's going on in the Explorer and the Workspace views. Now, in the Workspace view, again, if you select a project, you can also say stop build. So sometimes compiling and building your executable can take a long time. I mean, if you have thousands of files, you could be building for 30 minutes. So stop build just allows you to stop building anything, compiling and linking anything, any of the projects. Again, useful for when you have a long compilation process. But you typically don't see that in some of the code we're going to be writing for our class. The other thing that might be nice is if you highlight the workspace view, you can actually build all the projects in one shot. You can say build workspace or clean workspace and delete all the dependencies for all the projects. But if you say build workspace, that will build all the projects regardless if it's active. And that's what you see in the output window, right? We're building project 3, we're building project 2, and we're building our first program. And so again, just a quick rundown of how you can actually build and run your code from the active project, some of the settings, and how you can see your Explorer tab. Thank you. Hello and welcome. In this video, I want to explain to you what compiler errors are. Up to this point, right, we've written some code and we've noticed that in the build output window, we issue a compile command. And we know when we have errors, right? Usually there's a nice description that says there's an error in your code. But what exactly does that mean? So when you write code for programming languages are very, very strict. Right? They have rules. And you have to follow those rules in order to get a program executable. Right? A compiler will actually check the syntax of the code, and if it's correct, and if there's no semantic errors, it will generate from the source code machine language type code, and you can run a program. And so you have to follow these rules, and they're very detailed rules, and so you have to be very detail oriented. So compiler errors can come in two forms. They can come in the form of a syntax error or a semantic error. A syntax error is when you have something wrong with the structure of the code. You're not following the rules of the language in terms of its syntax, right? You're not putting parentheses in the right correct space. You're not adding all of your statements with a semicolon. You're not, you're misspelling keywords. These are all common examples. A semicolon is a really common one when you're first starting off. So if you declare a variable and you assign it to 5, but you don't have that semicolon at the end, that's a syntax error. Something's wrong with that structure. The same as if you were to use a printf statement and you say a printf statement inside double quotes, but you forget the ending double quote. That's a syntax error. And so something is wrong with that structure. And the compiler will typically, when it scans your source code and it finds this error, it will usually give a descriptive error meaning that can point you in the right direction. It also usually gives the line number, and we've seen that in previous videos. The other type of error that the compiler can catch is a semantic error. It doesn't always catch semantics errors if they're logic errors, but semantic usually means something is wrong with the meaning, the intent of the program. So for example, if you were to add two variables, A and B, but those variables were of different types and it didn't make sense. Right? It doesn't make sense to add A and B. The compiler can sometimes catch these semantic errors. Other semantic errors have to do with logic, and we're going to discuss those, and the compiler doesn't always find those. Right? The structure was correct, and everything was fine with the structure, but logically something was incorrect. There's an error in the logic of the code. So when you think of semantic errors, what the compiler can catch, it's more has to do with type catching and things that you're not supposed to do with different rules of language concerning like variable types. And so now let's take a look in CodeLight to see some common examples of some syntax and semantic errors in the C programming language. So here we are in CodeLight. with a simple hello world type application. This is code that's generated for you from your project settings if you saved it as a template. Very simple code, right? And when you compile this file, it will tell you whether or not you have errors in syntax, right? You can right click again and you can say compile. And right now we don't have any errors, right? But syntactically, we're following all the rules. But the syntax includes, again, all the structure of the code. So if you don't have a semicolon, or if you don't have a pound symbol before an include, and you try to compile it, you're going to see that there's an error. And usually the error, compiler error, has some kind of meaning. Now, as you write more and more code and you get more and more practice, these compilers aren't going to be so obtuse. They're not going to be so non-descriptive. You're going to kind of be familiar with it. Like, for example, this error says we have an error on line 1, right? And so it's nice. You can double click this. It will go to that error, but it says expected equals, semicolon. It doesn't really tell you what is wrong. Through programming practice, you'll realize, oh, I forgot the pound symbol. So some compiler errors aren't as descriptive as you'd like if you're new to programming. So you add that pound symbol, you recompile, and you're good to go. If you misspelled standard IO, sometimes it won't be able to find it. So you save it and you recompile, and you see an error that says a little more descriptive, right? No such file or directory, stdio.h. That kind of tells you like, oh, maybe you misspelled it. So misspellings are common errors. Not putting things in the proper perspective in terms of mismatched parentheses. You forget a parentheses. Again, you recompile. Let's see what that error looks like. Again, that's not super descriptive. It's saying, there's basically a parentheses before the ending curly brace, because it doesn't know. It thinks maybe that this right parentheses is going to end somewhere down in here. It can't always tell you exactly what's going on. So parentheses and missing curly braces sometimes aren't as descriptive. But if you have something like a missing semicolon, that's pretty straightforward. That compile error tells you exactly what's going on. Expected semicolon before the return. Kind of even points you to where you're supposed to put that semicolon. So you can double click that, put a semicolon. Right, if you're missing a double quote and you recompile, right, you see now something that says basically missing terminating double quote. And again, it kind of points you to where the first quote happens. And it gives you multiple errors, right? Even though you only really have one. So you add that double quote and you're good to go. Now this main is saying you need to return an int. What if you actually tried to return something like inside a double quotes? Right? Again, you're not following that structure of the language, and it tells you basically you're returning a character pointer from a function type. Again, these compile errors may not make sense to you right now, but as you write more and more code, they will make more sense. But it's all about following that structure. Now, if you try to do things that make sense syntactically, but the meaning is not correct. So, for example, say we do a printf, and then we try to do a arithmetic operation like dividing by 8 or dividing by 7. Right? We save it and we compile it, and now we see more of a semantic error where we have a division symbol after the double quotes, where it was actually expecting a semicolon. C mainly will find syntax errors. Semantic errors, the meaning of the code, usually have to do with logic, not found as much. The semantic errors happen more in language like C++ when you're using objects. So be on the lookout for syntax errors from the compiler, common things, misspelling, misuse of keywords, not ending your parentheses when you're starting them, blocks of code when you don't have the ending and beginning block, and you can have multiple errors, right? So say we have hello world, we're missing a semicolon, we're returning a string, we're missing a bracket, and we build it. And this is a rather small program, but when we try to compile it, now we're seeing multiple errors, right? 2 errors. And it's kind of tricky, like where do I start? Usually what you'll do is you'll fix the first error, because sometimes one error can cause more errors. So you always want to look at the compiler error at the very top and fix that one first. So you want to fix the one on line 5. Right? And then you may want to fix, and then recompile, and then maybe fix the one on line 6 after that. And now it says, oh, JSON. So now you can say return 0. But always fix that first error before you fix the subsequent errors, because one can be causing the other one. And by the way, we're always going to have errors in our code. Even the most seasoned programmers are going to have syntax errors. And so it's common to have errors. What's really important is understanding the messages that are coming from the compiler to tell you how to correct them. And again, that will come in practice. We'll talk more about compilers, common compilers in future videos, but just try to make sure you're following structure of the language as you learn it. This syntactic languages. And so in the next few lectures, we'll talk about how we can have different types of errors. I mentioned logic errors. We'll also talk a little bit about warnings. We'll also talk about linker errors and runtime errors. Thank you. Hello and welcome. In this video, we're going to talk about compiler warnings. And big tip, do not ignore compiler warnings. A lot of times you'll see them in the build output window, and some new programmers will just ignore them. You do not want to ignore them. Basically, warnings by the compiler are telling you that there's an issue with your code that could lead to a potential problem. The code is syntactically correct. The compiler is able to generate object code, able to generate your program, but it's not perfect code and there could be issues with the code. It's only a warning, again, because syntactically it's correct and you can generate that machine code. So for example, if we create a variable called total, and then we try to display the value of that variable total, we'll get a warning in the build output window saying total is used, but it's uninitialized. And what that means is basically saying total doesn't have a value associated with it. It's in memory somewhere and it doesn't have a value, so when you try to display that value, it could display anything. And so again, it's syntactically correct, but it doesn't really, you have to initialize your variable, so the compiler tells you. And so you don't want to ignore compiler warnings. In fact, most programmers will treat warnings as errors, and they will fix all their warnings. Now, we actually turn on the compiler warnings for all warnings, because there's different categories of warnings that you could turn on, turn off. We use the -w all compiler flag, so the all warnings are displayed, and you really should fix all of your warnings. So let's look at an example in CodeLight. So here's our hello world example. Let's actually just do what we just did in the slide and create a variable total and don't assign any value to it, and then try to print it out. And so if we say total is, and we try to print it out, and then we try to compile it, you'll see that we get a warning, right? Basically saying total is used uninitialized. We can still run the program. If we go up to build, we can run it because again, it's able to generate the code, it's just a warning. And what we see is it says total is 0. And that can actually be any number because it hasn't been initialized. In C programming, you always want to initialize all of your variables so that they actually contain some valid value. A lot of times in C, the actual memory that a variable stores, it will be inherited from a previous program. So if you don't initialize your variable, it could be anything. In this case, when we ran, it happened to be 0, but we just kind of got lucky. Right? It could be any value. So you always want to fix those warnings. Now, if we go back to our Hello World application, let's go to project 3 and make that the active project. If we have a Hello World type application, in here we'll create an actual variable, again, total. We'll initialize it, so we won't have the initialization warning. And we'll actually try to compile this. And in this case, when we compile, we see another type of warning, right? Unused variable. So this is saying we created a variable, but we never used it. We never displayed it. We never used it for computation or arithmetic or anything like that. So why did we create it? Why are you creating a variable that you never use? It's sort of wasteful code, dead code. So you should delete it, right? Because we have an unused variable. And so we can remove the initialization and still not use it, right? So if we actually have something like this and we save it, and again we compile it, you're going to see unused variable. So the unused variable warning takes precedence over the initialization warning. We never used it. So we're going to see a lot of warnings in your code as we go through and we learn about if statements, while loops, all the different concepts of C. We'll talk about some of those warnings in later lectures, but really what you want to learn from this lecture is that warnings are a big deal. You don't want to ignore warnings. In fact, you should have a policy that whenever you see a warning, your goal is to fix it. Do not ignore warnings. Thank you.
In this video, we'll talk about linker errors and why they can happen. Linker errors occur when the linker is trying to put all the pieces of a program together to create an executable, and one or more pieces are missing. Typically, this can happen when an object file or libraries can't be found by the linker. Fixing linker errors can be tricky. Sometimes it's just a matter of getting the paths correct so that the linker knows where the missing pieces are. Let's head over to CodeLight, and we'll force a program to have a linker error so you can see what the error message looks like.
Now in the example code here, please ignore the syntax. This is actually C++ code, but it's still relevant to linker errors. Don't worry about the IO stream. Don't worry about the std cout. The main idea here is that linker errors are the same in C and C++, and the coding example here is just trying to demonstrate, again, a linker error.
So I'm in CodeLight, and I've created a project called linker error based on the template that we use. So all I've got is a main CPP file that says hello world. Now we're going to force a linker error here. This is not something you want to do normally, but I want to do it to show you what the error looks like. So what I'm going to say is I'm going to say extern int C, or let's just say X. And I'll explain all this to you in just a second. And then in the body of the main, I want to try to use that X right there. It's just an integer, and let's say I want to print it out. I just want to print out X. Simple as that. I'm going to save this. Now you'll see if I compile this program, you'll see what happens. I'm going to right click, compile. I get a clean compile. There's nothing wrong with the program. Okay. But when I try to build and run it, you can see the linker error. This is classic linker error, undefined reference to something. In this case, it just happens to be X. Also, you'll notice that the linker returned 1 here. LD returns 1, which is the exit status. So something was wrong with the link. Obviously, the compile was fine because we got no compiler errors. We do that again. There's the compile, no errors, no warnings. So let me explain to you what's going on here. Let me grab my stylus here real quick. And what's going on here is I've got my main CPP file here, and it's going to be compiled to main.o, let's say, or main.object. In here, we have a reference to an X. You can see it right there. You can see it right there. So in here, I've got a reference to an X, which I'm going to use. Now, we also have our IO stream libraries. So the linker needs to grab those libraries, and I'll just type IO stream here so you'll know what I'm talking about. The linker needs to put these two together to create my main.exe. Or in this case, I believe it would be linkererror.exe, but you know what I mean. So the compile is fine. We've created our object file. This library exists. The problem is that I've told the compiler here that this X is not in me. It's somewhere else. It's defined by somebody else. Well, obviously it isn't defined by someone else because that kind of forced the issue here. So now the linker needs to resolve that X. It's saying, okay, where do I get that value to print? Because that's what you asked me to do right here, right? I wanted to print the value of X. Where is X? It can't find it. That's the linker error. That's exactly what's going on. And let me build this again so you can see the error message one more time. Let's build it and run it. And there's the error message. It's saying undefined reference to X. You can see exactly what's going on. It can't find X. Now, this is not a compiler error. This is a linker error. That's really important to understand. Linker errors are tricky to fix. A lot of times the files that you need to link are missing. They're in the wrong places. You don't have to worry about that using CodeLight. In this course, we're going to basically do everything ourselves. But if you're using libraries from third parties, this is the kind of thing we'll talk about in a more intermediate or advanced course. But I just wanted to show you linker errors in case you do come up with one. Post it in the forum and we'll work through it together. In this video, we'll talk about runtime errors and why they can happen. As the name suggests, runtime errors are errors that happen when the program is executing. These types of errors can be difficult to predict when we're writing our program. These errors include divide by zero errors, file not found errors, out of memory errors, and many, many more. Some runtime errors can cause your program to crash. We'll see examples of runtime errors later in this course when we work with files. In this video, we'll talk about logic errors and why they can happen. Logic errors are errors or bugs in your code that cause your program to run incorrectly. Logic errors are mistakes made by a programmer. Sometimes the mistakes are careless, other times the mistakes are because the programmers have incomplete or incorrect information. Other times mistakes occur when one programmer modifies another programmer's code to fix or add something, and they introduce an error as they do this. There are many, many causes for logic errors. It doesn't matter what the cause is, though. They need to be corrected. We need to test our code and debug it to find and correct errors. Suppose we have a program that determines if a person can vote in an election, and you must be 18 years old or older to vote. We haven't talked about if statements yet in this class, but they're very intuitive, and I'm sure you'll follow this little piece of code. First, we test to see if the age is greater than 18. If it is, then we execute the code that's inside those curly braces. Do you see the error? It's pretty easy to see it here because the code is isolated, and I told you there was an error. However, in reality, there's much more code typically involved, and this may just be a small part of a much larger program. The problem in this code is that the test condition should be greater than or equal to 18, or greater than 17. Either one will work. As it's written now, 18-year-olds would not be able to vote. We'll talk about testing throughout the course in the context of some best practices. Well, that wraps up this section. If you have any questions, please post them to the course forum.
Hello and welcome. Welcome to another exciting lecture, and in this lecture it's going to be our first challenge. So if you remember from previous lectures, I mentioned that I'm going to provide slides to you to help you learn the concepts. I'm also going to do demonstrations, which I've done both so far. But in order for you guys to learn the material, you have to have some kind of self-assessment. And so I'm going to be giving you guys challenges, essentially homework assignments where you can complete the homework assignments to see how well you're learning. And so in this lecture, this is going to be your first challenge. Very exciting. Our first challenge, our first assignment, more or less. And so what I'd like to describe to you is what the challenge is. What are the requirements? And what this challenge is going to include is it's going to be writing your first program. So what we're going to do is you're going to write a C program that displays your first name as output. That's the requirements. That's what I want you to do. And so in order to complete this task and complete this challenge, you're going to need to do the following things. You're going to first have to create a project in CodeLite. And I've demonstrated how you can do that, so you should be able to do that. You're going to use the IDE to perform the tasks that you do in every C program. Edit, compile, and run. And then test your code. Right? So the first step is creating that project. You can use the lecture that I provided earlier if you need to go through those steps again. As part of creating a project, we know that it generates a file for you. I don't want that file generated for you because it's going to do all the work for you. So after you create the project, make sure you go into your project inside your project window, your management window, and make sure you delete the main.c file that was generated. You can right click on it and say remove. After you've created your project, the next step would be to create a new C source file. And we know that all C source files end in the .c extension. You should create the C source file in the project that you created, and you should name the source file test. Once you've created the source file, then you're going to have to edit it. You're going to have to actually put some code in there. The code that you put in there is not important. That's not what we're trying to learn in this phase. What you're trying to learn is how to create a program and how to compile it and run it. Writing the code doesn't matter right at this point. So what I want you to do is I want you to copy the source code that I've provided right here. And it looks a little weird, right? You see this pound, and then it says include, and there's an int, and it says main, and then there's these squiggly brackets and all this. None of that's really important. Copy and paste this. The line that is important is the printf, and that's the line you're going to need to modify to display your name. But I've started it for you. I said, hi, my name is. So copy and paste this code into your test.c file. After you've copied and pasted that code in this test.c file, you're going to need to modify the line so that when the program runs, it displays the right output. And so you're going to need to modify that printf line. Basically, just add your name where the dots are. And that will be part of editing the source code. After you successfully added the source code, then you want to compile and link it. And this, again, was explained in another lecture, so this should be pretty straightforward. There's menu options to build. So you want to compile and link, and then you want to analyze the build output window. This step, again, is just going to your menu option and building. And what this will do is it will issue the GCC command to compile, and it will set the test.c files in an import, and it will also generate any object files, and then it will link all those object files to create a program. If you have any errors when you compile and link, you'll see them in the build window. That means you'll have to go back and edit your source code to fix those errors. Now, if you copy the source code exactly how it is on the slide, you'll be fine. One of the things you're going to notice with programming is the detail matters. Make sure you copy the source code exactly how it is. Everything matters. Okay, so if you're missing a semicolon or anything like that, it can cause your program not to compile. Now, if you were successful in compiling and linking the source code, then you want to run the program. You want to execute it. And again, this is just another menu option in the IDE. Once you run the program, it's gonna actually display a new console. It's going to display the DOS prompt, that little black window. And you need to analyze the output to confirm that it's correct. If it doesn't display your name, then you're going to have to repeat this process. You're going to have to go and edit the source code, recompile, which will link, and then run. And this is the process that you're always going to employ when creating a program. Editing, compiling, linking, and running. And then testing and debugging. Testing the code, making sure it does what it's supposed to do. And if it doesn't, fixing the errors. So this is your challenge. I'm going to provide a solution to this in the next lecture. But go ahead and do this on your own. Again, it's important to do it on your own so that you learn from it. All right, just watching the lecture, you may have missed some steps. If you go and do this on your own, it's going to be like the back of your hand the next time you need to write another program. So good luck, and I hope you guys succeed. Thank you. Hello and welcome back. In this lecture, I want to provide a solution to your first challenge. So this is very exciting. Remember that we had our first challenge, and our challenge was to write a C program that displays your first name as output. And so you're going to write and run your first C program. You're going to need to follow all the steps that you do when compiling and editing and so forth. So here's our solution. I'm going to go ahead and select CodeLight because CodeLight is the IDE that we're going to use in this class to compile and run our C programs. So the first thing we need to do is we need to create a new workspace. So I'm going to go up to File and I'm going to say New Workspace. And I'm going to select C++ as the workspace type. Again, we're doing C programs, but C++ is fine. So we go ahead and OK. And then we have to place our workspace in a particular directory. We're going to keep it in Documents for now. And we're just going to name our workspace Workspace. And then we're going to hit OK. At this point, we now have a new workspace. The next step is to create a project. So to create a project, again, we can either highlight the workspace, right-click, and say New Project, or we can go up to File and say New Project. We're going to go ahead and say New Project. And you'll remember this from previous videos. This is basically our settings for our project that we can set up. You should probably get a meaningful name. We're just going to call it Test Project, Challenge Number 1, whatever you want to call it. We're going to create this project in the folder. We're going to use our template that we created previously under User Templates. And we're going to say for the type, we're going to say My Template, and then hit OK. And everything else can stay the same. At this point, you should see your source file, which is main.c, created with a hello world type application. Now, according to the instructions from the challenge, we're going to go ahead and delete this file because we want to actually write our own code. We don't want to just have everything created for us. And this is usually common practice that happens. So we're going to say remove, and we're going to remove main.c, and we're going to say go ahead, yes. Now we can create a new source file by selecting the source tab, right-clicking, and saying add a new file. Once we say add a new file, we can name this. I think I told you to name it test, and you want to make sure it has the C extension, so test.c. And so we go ahead and we say OK. And at this point, you'll see there's a test.c file under the test project, and it also is empty. So now we can start adding our code. I then told you that you should just basically copy some source code that I provided for you. which is what I'm going to do now. This source code you don't need to fully understand yet. I'll explain some of it in the next lecture, some of the basics. But basically, it contains a basic example of a C program. There is something here on line 5. Line 5 is doing the main work. It's actually outputting data to the screen using a printf function. I gave you instructions that you should modify this to print your name. So here in the dots, you would actually type your name. I'm going to type Jason. You then have to make sure the file is saved. So I'm going to hit Control S, or I'm going to go up to File, and I'm going to say Save All Files. Once it's saved, you then want to follow the process of compilation, linking, and running. In order to compile this code, we have to go up to the Build menu option, and we have to say Build. That will issue the compilation command. When we say that, you'll see, when we execute that, you'll see in the build.log window, you'll see that it compiled and it also linked. You know that it compiled because it uses -c, uses the test.c file as input, and then the -o is doing the linking. It's linking all those object files. And there were no errors, and that's what you want to see if you write code. You don't want to see any errors in compilation. If there were an error there, you'd have to go back and you have to edit this source code. I also demonstrated that. Once the compilation and the linking is successful, you then want to run your program. So you go back up to Build option and you say Run. And then this will actually run your program. It will bring up the DOS prompt window, and you see the output here, which says, "Hi, my name is Jason." And that means the program was run correctly with the correct output. I analyzed the window and I verified that it's correct. And so now I'm done. If that was incorrect, I'd have to go back and edit my source file, and I'd have to fix it. And that would be part of debugging, which we haven't talked about exactly yet, but everything worked successfully. So we completed our first challenge. I'm going to include this source code so that you can just download it. Thank you. Hello and welcome. In this lecture, I want to basically highlight some of the concepts for a C program. I want to describe the structure of a C program. Now, we're going to talk about the details of all the syntax and so forth in other lectures, but I want to describe at least some of the things you saw in your challenge, just some of the highlights. Again, we're going to go through other concepts in more detail, and so you remember this. This looks familiar. I just wanted to show you a little bit about the structure of this code. We'll talk about include statements and so forth, but one of the important things to understand in this program right here is this is kind of the basic structure for all C programs. The first thing you should notice here is this code on line 3, which is called main. It says main there, and it has 2 parentheses. Those 2 parentheses are signifying that it's a function. Now, we don't know what a function is yet, but basically a function contains code inside of it. And so I want to describe to you that the main function is part of all C programs. It's the entry point to the program. This is what gets invoked when you run the program. Everything inside line 4 to line 7 will be executed. Okay, and so this main function is a special function in C that gets invoked when you execute the program. And you know it's a function because it has parentheses. And functions is just a way to organize your code. The things that you should notice here is on lines 4, you have a squiggly bracket, a left squiggly bracket, and on line 7, you have a right squiggly bracket. This defines the starting of the function, and then on line 7, the ending of the function. This is referred to as a block of code. So lines 5 and 6 is the block of code inside the function main. And again, I want to reiterate, main is a special function in C that gets invoked when you run the program. So there should be at least one main in all C programs, and only one main. Now, I'm going to show you how to structure the program with other functions, but this is a basic program, so it contains our main function, and this gets invoked. And then in lines 5 and 6, this is the body, this is the block of code for the function main. And you'll notice 4 and 7 start and end those functions. So what I'm trying to tell you here is blocks of codes and this idea of functions. These are all part of a structure of a C program. Other things to notice here is C programs are case sensitivity matters. So whether you use uppercase or lowercase, it's going to make a difference. So if I were to change this I in int to an uppercase I, it's not going to compile because that's an error. And when I said earlier that you have to pay attention to the details, I meant it. Every little detail in a program can cause a problem or cause an error. So case sensitivity matters. Uppercase, lowercase. It makes a difference. The other important thing to notice here is, and the uppercase and lowercase, by the way, are distinct. It doesn't, and also here when we edit our source code, it doesn't matter where you start typing your line. You can type it at the beginning. You can put everything on the same line if you want, some of it. However, I will explain that it makes it easier to read if you do some kind of structure to it. But you can do that if you want to. The other thing that's important to note here that's not a specific concept is that all the statements are ending in a semicolon. So that's a syntax detail that you have to understand. Now, lines 3 and 4 and line 1, those aren't statements of code. 3 is defining a function, 4 is specifying the start of the function, 1 is doing something different. It's including some library that you want to use in your code. But lines 5 and 6 have semicolons because those are statements. And we'll talk about statements and so forth, but you do want to recognize that a semicolon is also important. All right, and other concepts that I'm going to explain, I'll explain line 1, I'll explain functions in a much more detail. I'll explain why there's an int on line 3. But really what I wanted to point out here is the structure of blocks of code and functions. And this idea of the main function being the entry point of the C program. So this simple C program is, you're going to see very similar things in all programs. You're going to see that main routine, and you're going to see brackets for functions. And that's really how programs are going to be organized. Now, this function may call other functions. That's a whole other ballpark. But again, I want to emphasize here the idea of blocks of code inside functions, and also this idea of the main routine, and then the semicolons that end. Now, the other thing here that you'll notice is I did indent certain pieces of code. And we'll probably talk about this more when we talk about quality of code, but you want to make your code readable. And what readable code means is, if I were to just write my code like this, and I would have placed things on the same line, it makes it a lot harder to read, doesn't it? You see how that's a lot more difficult to follow? But when I add new lines, and I add indentation after each line of code, it makes it easier to read. You can easily identify that lines 5 and 6 are inside of a block of code because it has the brackets. And they're specifically inside of a function called main. So the use of indentation, spacing new lines in meaningful names, will make your code more readable. That's the other takeaway for your first program. I mentioned the main takeaways for the structure of a program, and readability is another important one. But this is just describing, again, the structure of a C program that you'll see in all C programs. In the next few lectures, we're going to talk about some of the basics of C. I'm going to describe to you this idea of the include statement, this concept of displaying output using a printf, the idea of returning data from the main. All these nice little concepts that are sort of really common for programs. They're not a specific category. They're really just fundamentals. And we'll be describing that in the next few lectures. Oh, and one other thing, just to give you a little heads up, this is going to be discussed in more detail, but other things that you may notice that sometimes students ask about is what's going on with this integer, right? And when we talk about functions, we'll talk about how you can return data from a function, but this basically just means you have to have a return. And this is saying that the main function is going to return a number. And what this usually represents is whether or not there was an error in the program. So when you return 0, it means that there was no error in the program. If you return an error code like 44, that might represent an error in the program. But again, we'll talk about that more functions, but be understanding of this keyword int. And you won't always see the int there. There are times when you'll see a void keyword there. And again, that's okay as well. That just means that the main function doesn't return any data. You might get a compiler warning for that, but typically you'll see int. But int just means it's returning something. Sometimes in the main you'll see this keyword named void. And this just means that the main program doesn't accept any parameters or any data. Again, these are terms we use when we talk about functions. But when you see these things, don't worry about too much right now. They'll be explained when we talk about functions. But you do see void. Void is just another way to say no data. It's not required. It's pretty much the same with empty parentheses. Now, because the main is a keyword, you can't declare variables named main. That will give you an error, things like that. Just a couple gotchas that you want to be familiar with. Again, it's questions I get often. Why is there an int there for the main function? Why is sometimes I see a void? Why do we return data? Why do we return a 0? That's why, for error codes. Thank you. Hello and welcome back. We're starting a new section, and in this section I want to talk about some of the basic concepts in C. I want to describe some of the things that we had in our example or our first challenge, our main program here. So I have this challenge up, you probably remember it. It has a number of different statements in lines of code. I'm going to try to cover some of the concepts here. I'm going to go back and forth to this example. The first thing I want to discuss is the concept of a comment. So we'll come back to this in a second. I want to go to some slides at this point. So comments are used in a program to document a program and to enhance its readability. I told you why it's important to have your program be readable, because you're going to be maintaining the code and you need to be able to look at it and understand what it's doing. So with comments, it can help quite a bit in this concept of readability. Comments are there to remind you or someone else reading your code what the program is doing or what a particular line of code is doing. So comments are there for your benefit. Comments are ignored by the compiler. Okay, so it doesn't matter if you follow the syntax of comments, the compiler is not going to throw any errors, whatever is inside the comment. So again, they're very useful and you want to use them in your programs. And they're a basic concept of all programming languages. And so there's nothing new really here to see. Again, you may, as a programmer, write some code, come back to it in 6 months, and you may not remember why you wrote the code the way you did. You may not understand the functionality. You may not understand the logic. By providing a comment in the code, it can save a significant amount of time that you waste on relearning things, especially relearning that code. Or imagine that you wrote some code and it's a large program, there's many programmers working on it, and somebody else needs to look at that code. If there's comments in there describing what the code is doing, then that other person is going to be able to understand that code much quicker. It's going to be more readable. So again, comments help the readability. Either they help the readability of the programmer who wrote the code, or they help the readability of somebody else that's looking at code. You can easily look at that source code and then quickly understand what the code is doing. And so you want to provide comments in your code. The syntax for providing comments in your code is there's 2 ways you can provide comments in your code. And again, this is very, very similar to Java, very similar to many languages. But in C, you can either have multi-line comments or single comments. If you use 2 characters, the / followed by the asterisk, this will signify a multi-line comment, a comment that spans many lines. And the / marks the beginning of that comment. And when you have these multi-line comments, because they have a starting comment, you have to have something that says it's ending. So to end the comments, you put the characters * asterisk / at the end, without any spaces in between. And so then anything in between the / and the ending * is considered a comment. Everything in blue that. And that way you can span multiple lines. The other way that you can add a comment to your C program is you can use single line comments. Single line comments are just 2 /. Anything after the 2 / on that line is ignored by the compiler and considered a comment. Anything after that is not a comment. It's a new line of code. So it really depends on the comment that you're providing whether or not you want to use multi-line comments or single line comments. And I'm going to show you how you can add those to your code in a second. Now, as far as styling goes, whether you use multi-line comments or single line comments, you're probably going to use both depending on what you're trying to do or how many lines you have to describe or how big your comment is. In this example, we're using a multi-line comment here, and this would typically go at the top of the file. It's describing who wrote the file, the author of the file, and then a copyright. You can also provide comments that stand out if something really, really important in your code is happening by providing many asterisks. And so the second example here where it says this is a very important comment is really stands out because of all those asterisks. So it's kind of a different style than the heading comment at the top in the first example. Now, the last example here, which is just a single line comment, it's at the end of a line of code, and it basically just tells you what a single line is doing. So you see these different styling of multi-line versus single line comments. Here's a common example that you would see in a program. This is a program that contains C code. You don't know really what the heck this is doing, but you could look at the comments and sort of identify what's going on. So there's a comment at the top that says this program adds 2 integer values and displays the results. It's telling you the purpose of the program, what it's doing. And then you see some single line comments. And how do you know they're single line comments? Because they have 2 forward slashes. So you see a single line comment that says declaring variables. You see another one that says assign values and calculate their sum. And then you see one that says display the result. Each single line comment is describing each single groups of code, telling you what they're doing. And so you can quickly look at this code and understand what the code's doing by looking at the comments. It makes the program more readable. Readability is an advantage because it makes the code easier to maintain. All right, so it's important to use comments, and this is a quick example of adding comments to some code. Now, how often should we utilize comments? There is the concept of having too many comments. You don't want to have your code that has a comment for every single line. That actually decreases the readability of the code because it's just overflowing. It's actually making it harder to read because it's just overwhelming. So you don't want to put a comment for every single line of code. You have to choose your comments wisely and use them intelligently. So usually it's a good, and this will come with practice, when to add comments, when not to add comments, where to put the comments. Typically, I'll have comments at the top of my source file with a standard information like the author, the purpose, the description, the date created. I'll have comments then interspersed throughout my code describing some lines of code where the logic is a little more complicated. I won't technically, or I won't always include comments for just declaring variables because it's kind of obvious. I may not include comments for certain function descriptions because the description itself might be more meaningful. It all depends, and it comes with practice. But whenever you do add comments, it's traditionally a good idea to add those comments when you're writing the code. One, because if you do it then, you'll have the program commented and you won't forget to do it. It's also easier to document the program while you actually understand what it's doing, while you're writing the code. It's still fresh in your mind. You don't have to come back a month later and say, what did I mean here? And now I have to add a comment. So add the comments while you're writing the code. And the comments can also help when you're trying to find and fix your errors during the debugging phase. If there are logic errors, you can look at the comments and you can kind of isolate, oh, well, this is the error that happened. This comment kind of lines up with that functionality. I bet you the error is in this group of code. So it helps you isolate errors in debugging. A comment can help you read through the program, but it can also point the way to the source of a logic mistake. So comments are important. Now, the other argument when providing comments is, again, there's this big debate with programmers. How many comments do you provide? And there is there's a nice book out there called Clean Code, which talks about writing quality code. Believe it or not, code can be good code, or there can be good code or bad code, and that's referred to as the quality of the code. You want to write high quality code. We'll talk about this throughout the course, but a lot of students that learn new languages think, as long as the output matches what I need, it doesn't matter how I write the code. That's not true. Because again, remember that maintenance phase. Remember that the product or the program that you release is going to be out in the field maybe for a number of years. And so if you want to find existing bugs or add new features, it's important that the code is have a high quality, easier to maintain, very loosely coupled, highly cohesive. And we'll talk about these concepts as we go through. We're going to be writing high quality code throughout the class. One of the ways to write high quality code is providing comments, but also providing self-documenting comments. And what this means is really using meaningful names. And this is what that Clean Code book talks about. When you create a variable, use a meaningful name. So when you look at the variable, you know exactly what it's being used for. Then you don't need to provide a comment. If you have a function that adds two numbers, name the function add two numbers. Then do you need a comment to say what is that function doing? No, because the name is telling you what it's doing. So meaningful names is a good way to provide self-documenting comments. Let's go back to our example from our challenge and show you how. I want to show you exactly how you can add comments and where you add them in. And you'll notice that the compiler is going to ignore these comments. So in our first example here, which is a basic program, I'll typically add multi-line comments at the top of the file before any lines of code. And remember that we can add those multi-line comments by just providing a slash star asterisk to start the comment, and then anything in between the comment will be the comment. Anything in between the star and the asterisk. And you'll notice when I do that slash star that everything turns gray, because that's telling me that I don't have my ending comment right now. So you have to add that star / to end the comment, and you'll see that the colors now change. This is why I like to use an IDE, because it tells you a lot with this color coordinated formatting. So anything between the slash star is the starting of a multi-line comment. Anything in the before the star forward is the description of, or the end of the multi-line comment. And I'll usually put at the top of the file something like author, and I'll put my name, and then I'll put maybe a purpose. This is usually good practice. And I'll put something like, this program prints out my name to the screen. And then I'll usually provide a date of when it was created, whatever the date is. And that's an example of multi-line comment at the top. And then I'll provide comments throughout the code, usually as single line comments or multi-line comments. It just depends how much comments there are. So maybe we're not familiar with this code, and I could say, 2 / is a single line comment, and I can say this code is displaying my name. And again, when I provide these / or these multi-line comments, the compiler ignores them. Basically, you can put anything you want inside there and it doesn't matter. There's no syntax that you have to follow. There's nothing. It is ignoring everything that is colored gray here that is considered a comment. So comments are a basic fundamental thing of every program. I wanted to describe them early on because I'll be utilizing them and you should be adding them as you're writing your code. Also with comments within the IDE, there are times when you're compiling your code and it's all failing. And so there are times when you may want to comment everything or comment blocks of code to try to debug your problem, try to isolate your error. You can highlight multi-lines of code, and then you can go up to the edit in the menu and you could say comment or uncomment. If you say comment, it's going to comment all of that code that you highlighted. And then you can recompile and maybe you don't have a compiler anymore. It's a way of isolating errors either at runtime or compile time. So the IDE has some nice tools that allow you to comment multiple lines automatically by highlighting and toggling. Hello and welcome. In this lecture I want to talk about the preprocessor. We briefly discussed this concept in earlier lectures, mainly just citing it as an advantage. The main reason I want to talk about it a little right now, early in class, is because it's being used in every single program. And I want to talk about the include directive, which is a preprocessor command. So if I want to talk about that, I first have to describe the preprocessor in general. This is going to be a high-level description. As we go through class, we'll talk about more of the preprocessor in terms of its different directives and so on. But to just understand the basics, this preprocessor is a unique feature of C. It's not found in many other languages. And it's very advantageous, and you should try to understand it, and we should try to use it as much as possible. It basically allows for programs to be easier to develop by the developer. It makes programs easier to read. It makes them easier to modify, and it makes them easier to port. So it allows for a lot of advantages. And so to have a description, understand what it is in an early learning of C is important. It's part of the C compilation process, but it's recognized as special statements. And just like it says preprocessor in the name, it implies that something's going on before you process the code. So it analyzes certain statements in your code before it actually analyzes the program itself. It does things before it compiles, essentially. So it's telling your compiler that, hey, before you actually convert any of this code, before you generate the object files, before you generate and do all the linking and generate the executable, first do this. Okay, and so because you do this stuff before you compile, you can optimize things and you can make things a lot easier. Now, you'll often have these preprocessor commands at the very top of your source code, but they can be anywhere. They can be anywhere interspersed throughout your code. One of the big ones that we're going to talk about is the include. So the way that you can identify preprocessor statements in your source code is they have a pound sign before them. So they have that number pound sign. And that has to be the first non-space character on the line in order to be a preprocessor command, also known as a preprocessor directive. Now, as I mentioned, our first challenge actually used a preprocessor directive. It was the include directive. We know it's a preprocessor directive because we saw the pound symbol. We don't exactly know what the include does. We'll talk about that in another lecture, but it is a preprocessor command. It is a preprocessor directive. And again, because it's used so widely, basically in every program, because every program is going to have an include, I wanted to talk about it early on. But it doesn't just mean that there's an include. The preprocessor can do many, many other things and have other commands. Some of the things we'll talk about as we go through this course concerning the preprocessor are things like being able to create constants. Constants is a concept where it's a variable essentially that never changes its value. It's data that never changes. That's how you can think about it, because we haven't even talked about variables yet. But you can create constants in the preprocessor, and this optimizes your code, makes it more efficient and runs faster. There's also this concept of a macro, which is an entire another topic in and of itself, but a macro is another preprocessor directive. And the way that you can create the macros is you can use the define statement. And so we'll talk about the define, we'll talk about creating constants, but you should be familiar with this preprocessor concept and utilizing these different things like include, define, constant. Include, we'll talk about specifically in the next lecture, but a benefit of this is that you can create your own library files. And we talked about what a library is, right? A library is just reusing existing code. So it's code that you don't have to write. The C programming languages comes with its own standard library that does many things for you, like display output to the console, read and write files, handle streams, all sorts of different things. Again, similar, if you're familiar with Java, similar to importing Java APIs, application programming interfaces. Other examples of a preprocessor directive would be conditional things like the if-def, the end-if, the else, or the if not defined statements. And we'll talk about those in more detail as well. But all of these preprocessor directives help with the efficiency of the code. And they run before the compiler actually runs. It's run before any code is generated, any object files or executable files. But we'll cover all this in much more details in future lectures. I wanted to give you a little taste of it beforehand because we need to understand it before we can understand what we're doing with the include statement, which is what we're going to talk about next. Thank you. Hello and welcome. In this lecture, I want to talk about the include statement. And so again, from our first challenge, our first exposure to C code, a C program, you should have noticed this include statement. It's on line 8 here in this example, and this is our example challenge project, basic C program. You see it's include. And now, because we've learned about the preprocessor, we know that it's a preprocessor directive because we have that pound symbol. Anything that starts with the pound symbol before any other spaces is a preprocessor command, a preprocessor directive. And so we know line 8, include, special keyword with the pound symbol is a preprocessor directive. I now want to explain to you what exactly this is doing. What does this mean? Again, this is a basic concept in C that we need to talk about very early on because every C program has it. It's very similar if you're familiar with Java with the import statement. But we're going to describe this in detail now in some slides, but you'll see this in all of your C programs. So the include statement is a preprocessor directive because of that pound symbol. We know that. And we call it a statement as opposed to a directive for no real reason, just because it's common to use that term in programming language. But it is a directive technically. And again, the example in our program was including this something in these angle brackets. So we see this include keyword, and then we see this stdio.h. And so this is an example, and this is the one that we used in our first challenge. It is not strictly part of the executable program. However, the program won't work without it. We know it's a preprocessor directive. It doesn't really do much as far as how the program works. It's just telling the compiler before it runs, hey, we're doing something here with this include. And so if you don't have it there, the compiler is going to complain and throw errors. So you need it. The pound symbol indicates that it's a preprocessing directive. We talked about that, which is an instruction your compiler to do something before compiling the source code. There are many, many preprocessing directives, and we gave some examples in our preprocessing lecture. We talked about constants, defined statements. We talked about if and else and so forth, the conditional preprocessing directives. But this is one of the most really commonly used ones, the include. And so, again, these directives can be anywhere in your source code, but they're usually at the top. In the include specifically, this include preprocessor directive is very similar to the import statement in Java, if you're familiar with that. But what does that mean? So in the above example here with the include pound symbol stud stdio.h, this is telling your compiler to include some of your program contents of the file with that name. So there's a file name that exists somewhere called stdio.h. And what the directive is saying is, my current program that contains the directive needs some of the contents inside this file in order to compile. So specifically, the include directive is going to have file names that end in .h. These are called header files. They're called header files because they're usually included at the top of the source file. It's one of the first things you do is you include all your header files. And again, this preprocessor directive is saying, I want some of the code, some of the contents inside that file. It's not a C file. We know that files that end in a .c are C source files. So the .h has to be something else. And it is. It's a header file. And it has that .h extension. So let's talk about what a header file is. Header files define information about some of the functions that are provided by that file. And I'll give you an example of some of the content in a header file. But first off, they're defining some information about some source code. And specifically for our example with that included stdio.h, this is including a C standard library header. So remember I told you about libraries. Libraries are just additional functionality that's already written for you in C that you can include in your program so you don't have to rewrite it. So again, examples of libraries are, reading and writing to the console, displaying output, reading and writing files, all sorts of different things, doing networking code, many, many different libraries out there. But stdio.h is a C standard library. What that means is it comes with the C programming language. And it provides functionality for displaying output, among many, many other things. So stdio.h, it's a header file. It defines some functionality that the compiler needs to understand before it can actually use it. So specifically, stdio.h contains information about printf. And so we're going to talk about printf in the next lecture, which helps us display output. But printf is a function that's in the stdio.h header file. And it also contains many other functions. stdio is short for standard input output. So this library is contains functionality for dealing with input and output. And so this is the concept of using a meaningful name. We don't want to call that library JSON or JSON.h because that's not meaningful. We use std.h because it's saying standard IO, standard input and output. And we know that that library contains all sorts of functionality for input and output. Specifically, the functionality that we want to use in our challenge program, our example first program, is we want to use this function called printf, which allows us to display output to the console. And so by including this stdio.h in our source code, we're saying in order to compile, in order to use this functionality, this printf, we need to include this file. So header files are going to specify information that the compiler uses to integrate and utilize any reuse code, any functions within a program. So you're going to either use many, many different standard library header files, and there's many out there. stdio.h is just one. There's again header files that define functionality or function prototypes for networking code, socket code. Again, we're going to go through a lot of them. Strings for complete words and things like that. But in addition to the C standard library and in the different libraries that come with the C programming language, you can also create your own header files, and you will be creating your own header files because header files allow for software reuse. They allow you to reuse functionality written in C. So somewhere the designers of C wrote all this C code that reads and writes data and handles input and output. They don't want this new C programmer to have to write their own, so they're going to write it for you and they're going to say you can use it. And the way that you use it is you include the header file. And so you as your own developer, you may write some code in a big, large program, thousands of files that you want to be used in other files. And so you'll write your own header files. And the header files, again, are going to define function prototypes, different constants, all sorts of different things that are going to help another file that can use your program. It will help compile your program. So it's a software reuse technique essentially. So we're going to include this standard io.header file in a program whenever we need to use the printf function from the standard library. It's required. If you didn't include it, it will not compile. So whenever you're using certain functionality, you have to use the include. The syntax, as far as header files go, they are case sensitive. Case sensitivity means uppercase or lowercase. It matters whether you do one or the other. So you should always write them in lowercase. Your header files should be in lowercase, because otherwise certain systems may interpret them as different, have a different meaning. There's two ways to include header files in a program. You can use angle brackets, such as #include JSON.h in angle brackets. And what this usually means is it's telling the preprocessor to look for a file in some kind of system directory. It's usually a standard library that comes with the C programming language. You can also use double quotes. Double quotes usually means it's a user-defined header file. It's one that you created as a developer that didn't come with the C programming language, but you want to have that header there because you want to reuse some code. So it's also going to say look in the current directory. Every C compiler that conforms to the C11 standard will have a set of standard header files supplied with it. These are just header files that represent libraries. C functionality that comes with the language. You can also, when you do use the include directive, it's common practice to use the other preprocessor directives if not defined and define, so that you don't include the file more than once. This is for efficiency. So if your program is using printf, for example, displaying output to the screen, you want to tell your program, hey, I need to include this additional functionality in the standard library. You don't want to tell it to include it more than once because the preprocessor will do many things that it doesn't need to do. So typically you'll use if not defined. So you'll see some of this in some of the examples that I provide where I wrap the includes in these if not defines and define statements. Here's an example of a header file and its contents. You may have some header file has some comments in it. It could have other things in it. It mainly has function prototypes in it, but it can have constants. It can have type defs. These are some concepts that we don't understand yet, but I'm just trying to illustrate, trying to help you understand that it contains many different things. But again, for our standard library inclusion, standard io.h, there's something in there called printf that defines the printf function so that when we link, we can find the implementation code for that. So here are some function prototypes. Function prototypes are just names of functions. We know what a function is, hopefully by now. It's just a way of grouping code together. We'll talk about functions in much more detail later. So a header file can include many different things. It can include defined directives, constants, structure declarations. This is, again, kind of a way to group different variables, group different data. Type def statements have to do with data types. We'll talk more about that. But function prototypes are really the important one. They're telling you how functions are defined so the compiler can generate the code it needs to. Executable code, remember, goes in a source code file. A source code file ends in the .c extension. Executable code normally doesn't go in a header file. There are some exceptions when you want to do things inline, which is, again, an efficiency thing where you can put source code in header files. But typically a .h file, a header file, is not going to contain implementation code. It's going to contain lines of code for just definitions. All right, there's not going to be any logic in there. There's just going to be definitions. This function exists. That function exists. These constants exist. These different structures exist. They don't say how this code is doing what it's doing. It's just telling you that it's there. It's needed by the compiler to generate the linking. Okay, so you're going to create your own header files. You're going to use system header files for additional functionality. It's a concept that you need to understand before you move on with writing C programs, because you're going to see this include directive in all programs. And it's just telling the program again that we're including an additional code somewhere. We're including additional definition code so that we can now invoke these different functions in this different code in our C program. So I hope that makes sense. It's not a real complicated concept. We're including additional code. It's pretty intuitive, but we'll go through it and we'll provide more examples as we go. Thank you. Hello and welcome. In this lecture, I want to talk about how you can display output to the screen. So here I have our example program that we started out with, and our first challenge was to display output to the screen. And so after you look at this code, you probably noticed on line 13, which is our printf, this is the code that's actually displaying the output. And again, this is a basic concept of C that needs to be addressed very early on because you often need to display output to the screen. So let's talk about displaying output to the screen using this printf function. Displaying output. So again, I just mentioned this. You should have noticed that printf line in our example program, our first challenge. It's included the word printf. And you probably thought to yourself, well, what does this mean? What does this do? Well, now I want to explain it. It basically displays output to the screen. It's a standard library function. And what are standard library functions? We talked about this quite a bit, but it's a function that comes with the C programming language that you can utilize to display output. You would not want to write your own code to display output to users because it's a very common thing that you do in your program. So you wouldn't want to have to write that every time. So what you do is you use that include directive. You include the standard library header, which defines that printf function, which allows you to display output to the screen. Printf specifically is going to output information to the command line. The command line is also referred to as the console or the terminal. But by default, it's actually displaying the information to the standard output stream, which is the command line by default. That's why you see it there. So you'll see it in when we run our programs, and we saw that little black box, the DOS command prompt, the command line. That's where we saw our output, because that's where printf is directing it. Where it's saying display this output on the console. The information displayed is based on what appears between the parentheses of the function itself in the double quotes. So everything inside those double quotes is going to display. Now the printf function itself can get much more complicated using format specifiers, which we're going to discuss later. But basic information is you just print out words and text. And anything in between those double quotes is going to be displayed to the output. The other important thing to notice here, and I mentioned in a previous lecture, is it's a statement, so it's going to end in a semicolon. The semicolon tells the compiler, we're done, we're printing this information, now we're completed printing that information. So the function itself, it's probably one of the most common used functions in C, because you often need to display output. It will be the function that we use most in this class, because you can use it for many, many things. Now, so far in our example first program, we just displayed some text, some output to the screen. But it's very easy, it's very convenient to also display program results, besides just text inside quotes. You can also display values of variables and the results of computations. So what this means is it can be used for debugging. It can be used as a technique to display values of variables in your program while it's running. You can also use it to see where you are in your code as you're executing. And this is one of the reasons I wanted to cover it so early, because we're going to use it as a debugging technique so we can see what's going on in our program as it's running. And we're going to use it to display just regular words and results of programs. So it's very, very useful to understand how to display output to the console using this printf function. Again, the basic way to use it is just include everything in the double quotes, but we'll provide many examples of this. I just wanted to tell you, hey, this printf, this is what it's doing. It's displaying output to the screen, and we're going to be using it quite a bit, especially for debugging. Thank you. Hello and welcome. In this lecture I want to talk about reading input from the keyboard. This is a basic concept that I wanted you guys to learn early because it's very valuable and a lot of programs take input. So I provided this early on. Some of the concepts are not going to be completely clear, but we'll definitely learn these concepts in other sections as we go through. But it's important to learn this very early. And it's very similar to the printf function. So we've discussed output. We know how to format output using printf. We now have to learn a little bit about input, getting input from the user essentially. It's very useful to ask the user to enter data into a program. We talked about command line arguments, entering data via that way. That's one way to do it. Another way is to ask the user directly so that they can type something in the keyboard. So you get the input from the keyboard, but it gets displayed. You enter the input via the terminal, the console. That's how you enter the input. The C library contains several input functions. We're going to use scanf. That's the most generic function. It's very useful. It provides the most different formats that you can enter. So you can enter text and then it will get converted to the different formats. So scanf reads the input from the standard input stream. That's standard in. Scanf can actually be used for reading from files as well, if the input stream is a file. But we're not going to worry about any of that for now. We're just going to use it to read input from the keyboard. Okay, and so standard in by default is the keyboard. Standard in is a stream. Streams in C, there's three different streams: the error stream, standard in, and standard output. Standard in by default is the keyboard. So we're going to keep it that way. And using scanf, it's going to read from standard in, and then based on what you enter, or how you want to store the data, I should say, it's going to convert what you entered, because what you enter is going to be text. It's going to convert that text to the format that you provided. So it's going to use format specifiers, just like the printf function. So the format can be a sequence of characters, which is called a string. We haven't studied that in a lot of detail yet, but again, we will when we talk about data types. And then also, you can specify other data types that we're going to talk about, such as integers, numbers, basically. So you can read numbers, you can read strings, you can read numbers that contain decimals, single individual characters, all this nice stuff. If the standard is input from the keyboard, which is default, what's going to happen is as you type in text via the keyboard, it's going to take that text, put it into the C program, and it's going to convert that text. And text is things like letters, digits, and punctuation. So even though you're typing in a number, it's still text because it's coming from the keyboard. So if you enter the integer 2014, which is a number, and you type essentially what's happening is you're typing characters 2, 0, 1, and 4. And what will happen is it will send that input to the C program. And if you want to store that data as a number, then you're going to have to convert that data. And so you have to specify the format specifier how you want to convert it, just like you do in the printf. Remember, like with printf, you used %d to print an integer. You would convert the text to an integer using %d as well for scanf if you wanted to convert the string to a number. And that's what we're going to do for basics early on. We're just going to use numbers because we know numbers so far and we haven't really learned about strings yet. So we're going to mainly use numbers when we input. So scanf, it's very similar to printf, but instead it is a little different in certain arguments that it takes. It still uses a control string followed by a list of arguments. So there's going to be something in those double quotes. The double quotes typically will only contain one thing, and it will be the format specifier, how you're going to convert the data. So the control string indicates the destination data types for the input stream of characters. It's that format specifier. %d, %c, %s, %f for float, and so forth. The printf function uses variable names, constants, and expressions in its arguments, right? Because we learned that. You have something in double quotes, and then inside the double quotes, you use format specifiers, and then after the commas, you can print out variables, or you can even print out expressions. Expressions we'll talk about in more detail as well. Something that essentially returns a value. Most common type of expression is an arithmetic expression. The scanf function is different because instead of actually displaying variables, it's going to use variables that are pointed to. But luckily, pointers is a big concept in C. You don't have to know anything about pointers in order to understand and use the scanf function. So don't worry about that. All right. All you have to do is you have to remember 3 rules about the scanf function in order to use it. It's going to return the number of items that it successfully reads. So this is, if it reads 1 variable, 2 variable, 3 variables, it will return that. If you use scanf to read a value for one of the basic variable types that we're going to discuss, such as the int, the float, the double, then all you have to do is the variable name as the argument has to be preceded with an ampersand. Right? You don't even need to know why that is right now, but just do it. Any of the basic data types. Ampersand is address, and because scanf takes a pointer, you have to dereference, you have to pass in the address. The third thing that you have to remember for scanf, if you use scanf to read a string, which is a sequence of characters, into a character array, you don't have to use the ampersand. So basically, scanf takes 2 arguments, which I'm going to show you an example. The first argument is going to be how to convert the data that you type in. And if you store that data in int, you use format specifier %d. If you want to store it in a string, which we haven't learned about yet, you use %s. And then the second argument is, and it could be many arguments depending on how many format specifiers you use, because just like printf, would be the actual variable, the variable name. And if the variable is everything but a string, you just use the ampersand. Otherwise, you don't use the ampersand. Scanf function also uses whitespace to decide how to divide the input into separate fields. And whitespace includes new lines, tabs, and spaces. And again, I'll go through an example to show you what that means. Because just like printf can display many, many variables, depending on how many format specifiers you have inside the single quotes, same thing with scanf. If scanf has multiple things inside the double quotes, it will read multiple inputs. And the inputs are going to be divided by new lines. So again, scanf, if you want to try to understand what scanf is, it's the opposite of printf, right? Printf is going to convert integers, floating point numbers, characters, strings, all these different data types, and it's going to convert it to text so that you can see it output. And it's going to be displayed on the screen. Scanf is the opposite. It's going to take as input text and convert it to any of the different data types like ints, floats, and doubles. So let's look at an example. This is an example. This is an example of a simple program. We know what the main routine is. We know what the include directive is. We haven't learned about characters and integers yet, but basically at the very top of that main function, we're creating 2 variables because we need to store the data. And we're going to talk about variables in much more detail. But just like the printf function, again, you're just doing the opposite. So here we're displaying output to the screen saying enter a value. Scanf inside the double quotes has format specifiers to read in the input. And so you have to specify the data that's going to be read in. Here it says %s, %d. What that means is we're reading in a string, then we're reading in an int. And you'll notice that the string doesn't have the ampersand in the scanf after the first comma. And after the second comma, we have an ampersand because that's an integer. We're reading in a number. And then the printf is displaying output. So it's saying you entered in this string in this integer, just like we know what printf does. And then the main function returns a 0. All right, so let's go through this example in a second in code blocks, but let's just, again, reiterate a couple concepts. When a program uses scanf to gather input from the keyboard, it waits for you to input some text. So the program is actually going to pause until you enter the data. And then once you enter some text, and if you enter some white space, if you're entering in multiple things, then the program proceeds and reads the input. Once you actually hit the enter button, you have to hit the enter button. Again, scanf expects input in the exact same format that you provided. So if you say %s and %d, that means you have to provide a string followed by a space, any number of spaces, followed by an integer, a number, and a word. Right? String is a word, integer is a number. So let's go through this example line by line in code blocks. Okay, so here we have our main function. And again, it's important to be able to enter data into a program. So just like the printf, it's going to be very similar. And we don't have to understand all of this code. And we'll even get rid of the parameters that are being passed. It's a simple main function. We don't have to understand all this code. We don't even have to understand what variables are at this point. But variables will store data. In the example, we're creating a string array of 100. And with a semicolon, and then we're also just going to create an integer. Just like in printf, we have an integer, but we're using a string. I just want to demonstrate different inputs. Then, usually before you call the scanf function to get input from the keyboard, you're always going to tell the user something. You want to tell them what to enter. So printf, remember, displays data to the screen. We're just going to say enter a value. And they're going to actually enter a couple. And then we end it with a semicolon. We have to tell the user to enter something. Now here's where we use the scanf function. We say scanf, and then inside the parentheses, the first argument inside the double quotes is going to be data that we're going to read. So in this example, let's just say we're only going to read one input, %d, which is an int. And then we're going to store that data in a variable because we want to look at it, and it's going to be I. Now we have to specify the ampersand before that because remember this little trick with pointers. You don't have to know why, it's just the address. So that scanf on line 17 is going to actually read data from the keyboard until the user hits the enter button. And then that data is going to be stored in a variable called I. So now we just want to print what we entered. So here we're just going to say, we're going to add a line feed so it's readable. So we're going to use our escape sequence \n, and we're going to say you entered %d, and we're going to display the value of the variable. And we're also going to put a line feed after. So the value of the variable that we want to display is I. We're going to end it with a semicolon, and then that's our program. So again, printing output, asking for a value, reading input line 17, specifying that the data that we're reading is an integer, storing it in I using an ampersand, and then printing out what we just entered. So let's build this, and let's run it. And you'll see the program starts and then it pauses because it wants you to enter a value. It says enter a value. So at this point, I have to enter a number that it can convert to a string, right? Because that's what's happening. So here, I'm just going to say 56, right? And then I'm going to hit enter. It ran twice because of my virus scanner. So just, I'm going to say 56 and then enter. And then it prints out I entered 56. So I was able to enter information, number, and it stored it in a variable. Now, as just like printf, you can actually have them enter multiple things and store in multiple variables. So here, after they enter an integer, I'm going to say another percent format specifier, %s, which means I want them to enter a string, which is just a word. So here, remember, if it's a word, I don't have to provide the ampersand, so I'm just going to say stir. I want to store that data in the variable store. And again, we'll learn about variables. And then I'm going to just print it out. And I added another variable, so you know that printf, and I'll just put colons before it. You also have to specify the format that you're printing. So there, %s. So hopefully that's clear. I'm now going to read in two inputs separated by spaces, store them in two variables, I and stir, and then display them. So now if we build and we run, the program is, I guess, my virus. I just have to hit return because I have to hit enter twice. My virus scanner, I don't know why it's running twice. So here I'm going to enter a number 22. I'm going to hit space and then I'm going to enter my name. And then I'm going to hit return. When I do that, the program is going to unpause and it's going to display the number I entered and then the string. So it displays 22 in JSON. So this is how you can get input from the user. Simple, 4 or 5 lines of code. One other quick thing I want to show you is how you can read in a double. So later on in the lessons, you're going to be shown how to read in a float, and that's usually using a format specifier %f. But if you want to read in double, it's actually a little different. You use %lf. So kind of keep this in the back of your mind. If I create a variable named double x, and then I use scanf to read that in, I need to read it in using %lf. That's the format specifier you want to use. And then again, just like the other ones, you would use the ampersand for address and say x. And so this is how you can specifically read in a double. And that's different than reading in a float. So keep this in the back of your mind. When you go to run this, you'll notice it works pretty straightforward. And you can run read input using reading a double. So you just go ahead and run that. And so it's going to ask for a double. I didn't really do much. And this double would be like 77.8. And then we'll read it in and store it. It's pretty straightforward. So the scanf is very useful, as I mentioned. Other things with the scanf you'll notice as you go through the course is that scanf sometimes doesn't work that well. You can use fgetS for other things. The main issue with scanf is when you read in you're only reading in until you see a space. And so if you try to use scanf, you try to call it multiple times in a function with other combinations, it may not work very well, because what's happening is it's going to, when you hit the return button on the keyboard, it's going to not read that return button because it only reads up into a word. And so it's not going to get the line feed. So the next time you use scanf, it's going to immediately skip that line and it's going to read in the line feed. So this is a problem you'll see if you write multiple scanfs in a single program, one after another. You'll notice that the other scanfs aren't executing because they're reading in the line feed. A very easy way to get around that is right after you do a scanf, you just call get char, and then you call another scanf. But that's more of a concept to talk about later. This was just to show you when you read in a double using scanf, make sure you use %lf. And again, this is useful because some of our challenges will want you to get input from the user. And in order to do useful things and learn different concepts, we should be able to get input from the user. So I hope this helped. And again, don't worry about some of these concepts that you're not fully understanding, things like variables and strings. We're going to discuss all that in a lot of detail. Thank you. Hello and welcome. In this lecture, I'd like to talk about the concept of variables and data types. All right, so you should remember that a program needs to store the instructions of its program and the data that it acts upon while your computer is executing that program. So I want to just reiterate to you the concept of memory. Right? We talked about this in an earlier lecture, but I'm kind of just summarizing here why memory is important and what it is, because it's directly related to variables. So you should understand this concept of memory, right? Understand what the difference is between memory and a hard drive. Okay, but we know that memory is used by programs. When a program has to send instructions to the CPU, it's going to use memory, and when it also stores data, it's going to use memory. And a program will definitely do both of these in order to be useful. This is called RAM, random access memory. Programs store data in RAM, and they will for variables and data. They will also use hard drives. The difference between storing data in RAM versus a hard drive is when you store it in RAM, the data is going to go away when the computer is turned off or when the program exits. Now, if you want to store persistent data, you would store it on a hard drive. Programs still may use data on the hard drive, but only usually for external data, persistent data, data that's retrieved somewhere. All variables and all data in the program itself is stored in memory. Okay, so memory is, you can just kind of think of it as this ordered sequence of boxes. I was going to try to find a good illustration for this to help you. We'll go over this in a lot more detail when we talk about pointers, because then you really have to understand and visualize how memory is stored. But if you think of memory as just, it's an external hardware configuration or hardware type, and it's just a little stick of memory that you can put in your motherboard. And if you think of it visually, conceptually, it's just a sequence of boxes. Each box is full will be represented by the number 1, and when it's empty, it will be represented by the number 0. And it stores binary digits. They're zeros or ones, which represent true or false values. And each box is called a bit. So bits in memory are then grouped into a sets of 8, which is a byte. So you've probably heard these terms, bit and byte. They're important when they're related to memory because it determines the size of the data. So each byte has been labeled with a number that represents an address. If you have data stored somewhere in hardware, you have to know how to access it. And just like a street address where you live, you need to know how to get access to that memory through some kind of label. So all memory bits and bytes have 8 bytes have an address. So 8 bytes represents an address in memory, and it uniquely references that byte. So that's how you can access the data, and that's how you kind of want to visualize it. So again, memory consists of a large number of bits that are in groups of 8 called bytes, and each byte has a unique address. And your program will access that data usually through an identifier, but it can also use hexadecimal addresses. And when you have memory for a program, memories that use programs and memories that are on your motherboard, it will increase the efficiency of your programs if you have more memory and the memory is faster. The buses are faster. You can access the memory quicker. So 16 gigs of RAM, you probably heard terms like that. That's the higher amount of RAM means that programs can store more memory and access it quicker. And remember, programs use memory because it's just faster. If you have to store something on a hard drive, it would be much longer to access. And remember, we are executing a billion instructions per second, remember, by the CPU. So that's a lot of data that you may need to access. So how does this all relate? Well, it directly relates to this concept of a variable. And so a program is only going to be powerful if it can manipulate data. It's going to send instructions to the computer, but it needs to manipulate data. So in order to understand the different data types that you can use and how to create and name variables, you need to understand this concept of memory. Okay? And when you're writing a program, for it to be powerful, you have to then understand the concept of variables, how to create them, name them, and also this idea of a data type. Constants are types of data that do not change. They're always the same. They retain their values throughout the life of the program. So as long as that program is running, that data is always the same. Variables are the exact opposite. They're types of data that may change, and that's why it's called a variable. So values can change throughout the lifetime of the program, different values for that variable. And variables and constants are stored in memory with an address. However, it would be really, really hard to access that memory and memorize all the hexadecimal addresses. So it's a lot easier to create variables that have meaningful names. So you can give variable names that represent the memory locations, that represent the addresses. And that way you can access them and modify that data much easier. So for example, assume you want to store two values, 10 and 20, in your program. And at a later stage, you want to use these two values. What you would do with this data is you would first create two variables with meaningful names. Probably something like, depending on what the 10 and the 20 represented, but it might represent, ages. So you would say age 1 equals 10, age 2 equals 20. You always want to use meaningful names. And then you can store the value. So you create the variables with names. Then you assign data to those variables, the 10 and the 20. And I'm going to show you how to do that. Then later in your program, you can access those variables by their name to read the data. And you can also modify them later in the program to change it, as long as it's not a constant. So as far as naming variables, there are rules in the C programming language for what you can name it. In C, all names, variable names, must begin with a letter or an underscore. And then they can be followed by any combination of letters, upper or lowercase, underscores, or digits 0 to 9. So for example, I could create a variable called Jason. My flag, I, J5x7, my underscore data, another, or underscore another variable. These are all variables that start with either a letter or an underscore, and then whatever's following them is fine as long as they're uppercase letters, underscores, or digits. Here are some examples of invalid variable names. You would not be able to create variables with these names. The compiler would give you an error. If you said temp $value, the compiler would give you an error because the $sign is not a valid character, so you can't use the $sign. My space flag, that would give you an error because there's a space. 3JSON, that's an error because you started a variable with a number. Can't do that in C. And remember, the compiler checks these rules, so they'll tell you if you're wrong. Int is actually an error too. It looks normal. It looks okay because it starts with an alphanumeric character. The problem here is it's a keyword. All programming languages have certain words that have special meaning that you cannot use for names. And int is a specific data type for the C programming language, so you cannot use that as a variable name. So these are some examples of variable names that are not good. I mentioned earlier that when you do create variable names, you want to make sure they're meaningful. We talked about comments already and the importance of comments for self-documentation and understanding the code. Meaningful names are the exact same thing. If you have meaningful names in your code, it can increase the readability of the program. It's much easier to follow, and it also helps in the debug and documentation process. So use meaningful names, and we'll be doing that throughout all the examples that we go through. So once we name the variables and we have a variable, well, what about the data that's associated with that variable. That's referred to as a data type. So some types of data in programs can be numbers, letters, or words, right? We just talked about how you can have 10 and 20 as values. And you can also have alphanumeric or strings or characters. So the computer, depending on that type of data, needs a way to identify it so that it can do certain things. It really just affects the size of the data in memory, how it's stored. So a data type represents a type of the data which you can process using your program. Examples of types of data I mentioned, numbers, letters, and words. Those are represented by specific keywords in the programming language. So examples of keywords in C that represent data types are ints, floats, and doubles. And we're going to talk about these specific data types and what they mean in another lecture. But data types are important because you have to specify the data of the variable when you create it. And the data types are going to correspond to the byte sizes, depending on the operating system, the architecture of your program. So again, it all has to do with size and how this stuff is stored in memory. The program needs to know, do I need to allocate 8 bytes, 4 bytes, 6 bytes? And it all depends on the data that's being stored. And the way that the program knows how to do that is you specify a data type. There's also this idea, or maybe you've heard of this term called primitive data types. These are types that are not objects and they store all sorts of data. In C, all we have is primitive data types because we have no objects. So everything is a primitive data type in C. Now, if we want to actually start using variables in our program, we first have to declare them. Declaring a variable means that you specify the type of the variable followed by the variable name. So you use the data type followed by the name. And this tells the compiler how a particular variable will be used by the program, and it will also understand how much data to store in memory, whether it's 8 bytes, 4 bytes, and so forth. So for example, there's a reserved order keyword in C named int. That's used to declare a data type of type integer. And so if you wanted to create that in your program, you'd first have to identify the data type, the keyword, which is int. Then you'd have to have the name of your variable. That's also referred to as an identifier. And then at the end, you'd have to have a semicolon, because remember in C, all semicolons end all statements. So the actual syntax looks like is like type specifier or data type specified after with variable name followed by the semicolon. You can also declare more than one variable on a single line by using a comma, or you can declare variables on separate lines. It all depends, but there is syntax for comma separated variables. And C requires you to specify all program variables be declared before they're used. So declaration is basically just telling your program, this is what I have. It's not telling you how you're using it. It's just saying, this is what I have in my program. I have a variable named int. I have a variable that's going to store a decimal number. Things like that. So here's an example. We have the type of the data, which is int, and then the variable name, and here it's just x, and then we have a semicolon. Another example, if you wanted to create multiple variables on the same line, you can separate them by commas. So in this example, we have 3 variables of type int named x, y, and z. And so we're going to, and this is called declaring variables. We haven't assigned any data to the variables. We just said this is the variable that exists. And what will happen in the program is the program will create those 3 variables in memory, but there's no values for them yet. You can assign a variable a value by using an equal operator. And we're going to talk about this in more detail when we talk about operators. But this is pretty simple, and you should understand it. Assigning a variable to a value, you just use equals and then the actual literal constant of the type. So in this case, x is an integer, decimal, so we assign it 112, and then we have the semicolon. That's assigning a value. And closely related to assigning a value is initializing the variable. Initializing the variable is basically having an initial value for that variable. And it's important to initialize your variables because if they don't have any data, any values associated with them, it could cause problems in your program. So you want to get in the habit of initialization. And initialization can be done as part of the declaration. Doesn't have to be. Basically what happens is when you declare the variable and you say, hey, this is my variable name, this is my type of variable, you can then immediately have the equals operators and then the value of the variable followed by a semicolon. Like, for example, int x equals 21. In that case, you're declaring a variable named x of type int, and you're also assigning it a value of 21, initializing it a first value. And that's initialization. Another example, int y equals 32, z equals 14. We can do it on the same line, initialize two variables of the same type. Int xz equals 94 is okay to do by the compiler, but in this case, you're not actually initializing both variables. Only z will be initialized. X is not initialized. So z is going to be equal to 94. X is not going to have a value. So that's important. And we're going to be declaring and initialized variables all throughout our code. So let me just go and we'll bring up a simple project in code blocks, and I can show you how you basically can declare these variables, just like these examples. So here we are in code blocks. This should look familiar from our previous example programs. We have some comments at the top from lines 1 through 6. They're multi-line comments. We have our include directive on line 8 saying we're going to use standard library. And then we have our entry point to the program, our main routine on line 10. And we're not doing anything in our program. Now, again, for a program to be interesting to do anything of substance, you're going to want to create and use variables. And there's all sorts of different ways. Right now, we don't really know all the data types, so we can't really create many different types of data. We've really just had that int example. But again, just to reiterate, all you need to do is you have to specify the data type. We know int, so you type in int. And actually, with the IntelliSense in this nice integrated development environment, it displays all the other things that you can define with int. It actually completes I. If you were to type an F, you would see maybe other things completed, like a float is another data type that we'll talk about. But again, to declare a variable, you just say the data type, a valid name. Remember, valid names start with alphanumeric characters or underscores. Can't start them with digits. So here I could just say int Jason. And then I have a semicolon to end the declaration. And that's how you declare a variable. Now, if I want to initialize that variable, which you should do, during the declaration, you just use the equals operator and you specify the right type of data. So int is a decimal, so I have to say a number. I can't put a word in here because I didn't specify a word. I specified a number, and that would give a compiler error. But all you have to do is specify based on the type of data and then a semicolon. Remember, semicolons end the statements. And that's initializing and declaring a variable on the same line. You could also assign values to variables later in your program. So I could just declare it, and I could actually initialize it. Let's say it's equal to 5. And then I could overwrite it in another line. I could say Jason equals 8. I want to change the variable because variables can change values. Here we're assigning data using the equals operator, and you'll notice that there's no data type on line 14. All we have to do to access that variable is specify the name to modify it. We'll talk more about the equals operator when we talk about operators. But this is the basics for variables. They represent data in your program stored in memory, accessed via variables using these naming conventions, and initialized and declared in your program with data types and assigned values. Thank you. Hello and welcome. In this lecture, I want to describe some of the data types that I mentioned in our last lecture. Data types, remember, they're important because you have to provide this when you declare a variable. And they tell the actual compiler how much memory you want to create. So it's specific to size as well. So the compiler needs this information. But let's talk about the ones that are supported by the C programming language. So we know, up until this point, we know that C has many different types of variables that have different types of data. Right? We know that from creating and initializing variables. You can have types that store integers, numbers essentially. You can have types that store non-integer numeric values, things like scientific notation, or things like what we'll talk about Booleans, which is true and false values. And then you also have data that needs to be stored, such as characters, either a single character or many characters, which is referred to as a string. But we know that we have these different types of data. Again, for a C program to be powerful, it's going to need to manipulate data, and it's going to need to manipulate all different types of data. So some of the examples that C supports, the basic data types, there are many data types in C, but the basic ones that we're going to talk about today in this lecture are the int. And remember, these data types are special keywords. So when you say int in a C program, the compiler is going to know that, oh, this is a data type. So we want to talk about int, float, double, char, or char, and bool. underscore bool. These are the main ones that you're going to use, and then there's different variations off of those depending, again, on the type of data you want to store and how big the data is. So the difference between these types is the amount of memory. That's all the data types in specifying the data types is about. It's about the memory that needs to be allocated. And it varies depending on what type of architecture you have. But the memory and the amount is going to determine the range of the values that can be stored. So the amount of storage that is allocated to store a particular type of data is important to the compiler. It all depends on the computer you're running, and this is referred to as machine dependent. So if I run a C program on a Linux system with different hardware versus a Windows system with certain hardware, an integer may be 4 bytes in memory, or it may be 8 bytes. Again, it depends. So it's dependent on the machine you're running at, how much memory is allocated depending on the data that you want to store. So, you know, an integer might take up 32 bits, which is 4 bytes. Or it might take up 8. So first let's talk about the int. This is one of the most widely used data types. It's a data type that can store integral values, values that do not contain decimal places, whole numbers. This is when you would identify this data type when you create a variable int to store a number. You can also put a minus sign preceding the data type in the variable, and that indicates that the value is negative. So if you have a minus sign preceding the actual literal. So what I'm talking about here is when you create the variable and assign it data. If you put a negative number, a value, it's a negative number. So ints can store negative numbers is basically what this is saying. It's also a signed integer. We'll talk more about what that means. But a signed integer just means that it can be either positive, negative, or 0. And that's why you can put a minus in front of it. If an integer is preceded by a 0 and the letter x, so here we're talking about constants. Here we're talking about when you assign data to an int. I'm trying to describe to you the type of data that can be stored in here. And so when you assign data, we know how to assign data to variables because we learned that earlier. We just define the data type and then we assign it using the equals operator. Now you can assign values to ints. You can either assign numbers, which is the most intuitive and easy way to do it, like 15. But you can also assign hexadecimal numbers. The computer and the programming language allows that. If you want to assign a hexadecimal number to a variable that stores an integer, you just put the 0 and the x before. And that tells the compiler that this is a hexadecimal number. Hexadecimal numbers is base 16, so you can store letters A through F. So hexadecimal looks like 0xFFEFOD. So you may see this occasionally in your program where somebody's assigning a hexadecimal number, and you're probably thinking to yourself, well, an int only stores a whole number, but it can also store different representations. And so this is one with 0x preceding it. The values 158, negative 10, and 0 are all the valid examples of constants that you can assign to integers, integer variables. There's no embedded spaces are permitted between the digits. Right? And if you try to assign a value larger than 999, you can't use commas. So don't try to assign a value to a variable like named x with 12 comma 1000. You have to 12 comma 000. You have to do 12,000. Float, another really important data type, one of the basic data types. This is a variable that can store data for floating point numbers, which means numbers that contain decimal places. So values like 3 dot, 125.8, and negative .001 are all valid examples of data that can be assigned to variables of type float. There are also floating point constants in C. This can be represented, expressed in scientific notation. So for example, if you have 1.7 e to the 4, that's a floating point value, and it's expressed in the notation, scientific notation, and represents the value 1.7 times 10 to the power of 4. So that's 17 times 10,000, which would be 170,000. A double, very, very similar to the float. It stores decimal numbers, decimal places. The only difference is it's larger, so you can store larger numbers. And again, so that would mean that it collects more data in memory. So you want to use a double whenever the float is not sufficient. It's too small. So a float, I think, stores like, say a float stores, depending on your architecture, say a float stores 8 bytes. that means it can store values from like negative 32,000 to a positive 32,000. If you try to represent that same data in memory using a double, you can then store even higher numbers, right? So you want to use basically twice as many significant digits, going as long, millions and millions and trillions, whatever, much bigger than a float. So most computers represent a double value using 64 bits, which is 8 bytes. Doubles are usually, or floats are usually 4. Doubles are 8. I might have misspoke there. And that just means you can store more data. And the way that you would create the variable is you would say double keyword before naming the variable. All floating point constants are taken as double values by the C compiler. So that's by default. If you specifically want to make something a float, you just add an F2 at the end of it when you assign it. So to explicitly express a float constant, just put that F there, 12.f. Underscore bool. This is a data type that can be used to store just the values 0 and 1. You'll often hear this term Boolean expression. In bool, it all means true or false. It's a yes or no, 0 or 1. So it's indicated for binary choices, essentially. And we're going to talk a lot about Booleans and Boolean expressions when we talk about decision statements. Boolean variables are used in programs that need to indicate a Boolean condition, a true or false type of answer. So for example, a variable of this type might be used to indicate whether all the data has been read from a file. Yes or no. Has all the data been read from a file? If it's 0, yes, or 0 false, 1 yes, which we'll talk about now. So 0 is used to indicate a false value. 1 indicates a true value. So even though it's true false values, the way that the data is stored in memory is 0 or 1 as a numeric. But the numerics mean that 0 means false, 1 equals true. So if you were to print out Booleans, you would see values 0 and 1 printed out, not true and false. But they mean true or false. They only can have 2 values. So here's an example with some data. Let's go ahead and put this in code blocks and see how we do it. So here again, we have our basic program and we have our main routine. We know how to declare variables where we have to provide the data type. Now we know how to declare more than one. Before, we only declared an int. Now we can actually declare something like a float. And you just use the float keyword. And IntelliSense will help you. And then you follow the naming conventions. Let's just say, again, JSON. And then we can assign it a value. Floats consist of decimal places. So we could say, 23.22. And that contains a float, and we assign it. So we're initializing and creating a data type, a variable of type float that contains value 23.33. And you notice the semicolon at the end there. We can do the same for double. We have to come up with another name. We could say JSON2. We want to have meaningful names, though. We know that. Here, it would just be a larger number. So it'd be like, so many. And we could also express this with scientific notation if we wanted. We could put an E here, plus 11. But that big, large number would not be able to be stored in a float, and that's why we'd use a double. We can create a bool, underscore capital B, or capital B, and then an OOL. Oops. And here, just, bool variable. Usually you want a camel case. And then here we could just say true, even though it doesn't necessarily contain that when you print it out, or we could set it to 1. And then you always want to compile and run your command. The bool type also usually has been aliased to other names, so you don't always have to just use underscore bool. It depends on the compiler you're using. This actually compiled fine. It just says I'm unusing variables, which gives warnings. The other important thing about bool is, remember, C has different standards. The C89 standard means you have to use underscore bool, like we've learned, right? Underscore and bool with a capital B and so forth. With C99 standard, it allows you to use the true false values in the bool data type. So you don't have to use underscore bool and then create a variable, my Boolean and then set it equal to 1 or 0. 1 true, 0 false. You don't have to do that with C99. Underscore bool is only in the C89 standard. So if you're using the C99 compiler, you can actually use the bool data type. All you have to do is you have to say include, and then you can say include standard bool.h. And this is going to have a macro that allows you to use different data type, the traditional bool data type. So when you include standard bool.h, you can now say, instead of underscore bool, you can just say bool, right? And it's going to recognize that as a data type. Instead of saying 1 or 0, you can say true, right? Or you can say bool, another boolean, and you can say false. So if you don't like using underscore bool for your data type, which again is not what most languages use, they usually just use something like bool or boolean, include standard bool.h and specify bool, and then you can use the true and false keywords in the bool data type. So other data types, you may ask yourself the question, well, hey, why do I need more data types? I pretty much talked about numbers. Why do I need to represent numbers in different ways? So we still haven't talked about characters, which we're going to talk about, and there's some other data types. But as far as numerics goes, we've talked about numerics being decimals or non-decimals, ints, doubles, and floats. And you would say that probably is enough. And typically the int is enough. All you need is an int. You'll use an int quite a bit. But C is a flexible language, and as one of its advantages, there are many other data types where you can represent other integer types. And it gives some flexibility to the programmer. Depending on the use case, depending on the data, it allows it to be even more precise. So this is one of the ways that C can become even more efficient. If you have something very, very specific, you can specify a specific data type as part as an integral or an integer, and it will make the program run quicker. So it gives the programmer options, flexibility with additional data types. Integer types can vary in ranges, and in whether negative numbers can be used. So some of the data types I'm going to talk about in terms of integers, but these also apply to floats and doubles, are some keywords that you can assign to the int already, but it's not always required. So you can basically have more specified versions of ints, more specified versions of floats or doubles. Or you can use these keywords by themselves. So for example, you could say short int. That's a data type. And I'm going to tell you what that means. Or long int, or unsigned int, or short double, or long double. These are all additional data types with these three adjectives. But you also don't need to use the int, float, or doubles with them. You could just say short, or you could just say long. Or just, and that will provide specific data that you can store. But this is all about being more precise and making the program more efficient. Again, you'll probably just use int, double, and float for the most part. But when you start getting more advanced C, you're going to start using short, long, and unsigned along with the int, double, and float. So for example, type short int or short, just short by itself. Like I said, you could use both. It uses less storage than an int. So it can save space. So if you're writing a program that needs a lot of memory and you need the program to be efficient and not use a lot of memory, you can create shorts. So it allows that flexibility. It makes your code more efficient if you use a short as opposed to an int. You don't have to use a short, but it will use less memory. And the same goes for longs. They use more memory, and it's actually larger data. So a long int is going to use more storage than an int, allowing you to store larger integer values. Or you say long float. Or you can just say long by itself, and that will be a larger integer value that you can store. You might ask yourself, well, why not use a double? Because a double, remember, has decimal spots. So you may want to store an int that's just a really large int. You can use long. So a type long int, another type, or long may use more storage than a long. And again, it all depends on the computer platform you're using and the architecture. You can assign values, use all these different types. A lot of them have different letters that you can append. So for example, here, if you're assigning a long constant value, you just put the capital L or the lowercase l at the end of it. And that will assign that value as a long. Same goes if you're doing some of the shorts, you can also apply suffixes at the end to make sure that the compiler explicitly knows what you're dealing with. So type specifiers can also be applied to doubles, as I mentioned. These shorts and longs, you can say long double. And here we create a long double called US Deficit 2017. You can, for the long doubles, you can use the capital L, as I mentioned, or lowercase l, same way you would with the ints. As far as the other data types besides short and long that we talked about, concerning unsigned, you can set the prefix unsigned to ints, doubles, or floats, and this is used for only variables that have non-negative values. So remember that an int can store not negative numbers. You just say minus. If you don't want a int to store a negative number, you can declare it as an unsigned int, or just unsigned, and that will make sure that everything assigned to that is positive. Now, that's how it works in theory. Some compilers don't enforce it. But if you were to create an unsigned int and you tried to assign a negative number, the compiler should complain. So unsigned int counter, for example. And again, this allows the accuracy of the integer variable to be extended to only allow positive values. So it's making your program more efficient by using all of these different data types, these more specified data types for these. Also, there's the signed data type that can be applied to ints, floats, and doubles, or shorts, signed short, signed int. It can be used with any of the types to make it more explicit, the intent. Signed shorts, signed ints, signed shorts, short ints, shorts, they're all the same. Signed means that it can be negative and positive. So these are just the basic data types that I wanted to talk about. These are the ones you're going to use most of the time, along with a couple more that I'm going to talk about in the next lecture. You usually don't have to get into using shorts and unsigns and longs unless you are more advanced C and you're trying to make your program more efficient. But all these data types, they're provided right before the variable name when you declare the variable. And then when you assign data to these variables of these different types, you can use suffixes like capital L or lowercase l to have explicit intent. Thank you. Hello and welcome. Let's continue our discussion on data types and talk about a couple more. In this lecture, we're going to talk about the enum data type and the char data type. So enums. Enums are a data type that allows the programmer to define a variable and specify the valid values that could be stored into that variable. So an enum is very powerful. It's actually specifying a data type. It is the keyword enum, but you can basically have your own data type that includes certain values only. So for example, you could create a variable named myColor, and if it's a certain enum type, you can set it so that it only includes or only can be assigned values of primary colors, such as red, yellow, or blue. And then no other values can be assigned to it. The compiler will give you an error. And so it's sort of like a data type that you can specify that you can create, but so you're going to have to define the data type, and then you're going to have to create variables of that type. So an enum is the keyword. So the first thing you have to do if you want to use this enum data type is you have to define that enum type and give it a name, just an identifier, just like a variable name. And the way that you do it is you're going to use the enum keyword. And then after the enum keyword, you're going to provide a name, like an identifier. And then after the identifier, you're going to put all of the list of valid values inside curly braces. And you're basically saying that this enum can only be of these values. And then when you want to use the enum later, you create a variable of that type enum. So let's see this in action. Here, I'm defining an enum type called primary color. So I have the enum keyword, and then I have my name of my enum, which is primary color, and then I'm defining all the valued values for that type. And you'll see that they're enclosed inside curly braces, the left curly brace and the right curly brace. In this case, we have a type of enum named primary color that can only hold values of red, yellow, and blue. And it can't store anything else. If you try to assign a value to primary color, or if you try to use the primary color data type and you try to assign a variable value to something else, it won't work. So this is just how we define it. We first have to define the enum. We then have to use it. Again, definition is just saying this is what it is. And so what we're saying here is we have a primary color, and what it can be is red, yellow, and blue. So variables that are declared to be primary color type can only be assigned the values red, yellow, and blue inside the program. No other values will work. So again, the first step defining it, the second step is using it. So after we've defined it, we can then declare a variable of this type, primary color. And the way that we declare the variable now is we still use the enum keyword. We then actually have the name of the enum that we specified when we defined it. And then at the very end, we follow that with a variable list. So here's an example is we have enum. We use the enum keyword. We have the name of the enum that we want to use, which is the one we just created called primary color. And then we just have names. So here we have two enums of type primary color, my color and Greg's color. So again, this is where we're using the enum. We've already defined what the enum can be, just red, yellow, or blue. And now we're saying we have two variables named my color and Greg's color that can only contain one of those three values. Can't contain anything else. So here we're declaring a variable of primary color. And again, this is defining two variables, my color and Greg's color, to be of type primary color, which is an enum type. The only permissible values that can be assigned to these variables, these two variables, are red, yellow, and blue. So we could say my color equals red, and that's perfectly valid. We could not say my color equals green. That wouldn't work because those values aren't valid for that enum type. We couldn't say my color equals Jason because my color can only contain the three values of the primary color enum type. So this is a very powerful data type because you're essentially defining your own data types that can contain only certain values. Another example here would be if we created an enum that is of type month. And here we're saying that month can only be equal to January, February, March, April, May, June, July, August, September, October, November, December. Again, this is the definition. This is where we're saying what the valid values are. If we were to go and use month, we would create a variable called enum month and then whatever name you want to give it. And then we can assign to that name any of these valid months, January through December. And that is how you use an enum. Now, under the hood, as far as how enums are implemented in the C programming language, is they're really represented by numbers. So the compiler actually treats enumeration identifiers as integer constants. So the first name in the list that you define, if you were to try to print out the value, it'd be a 0. All this is saying again is how are they defined if you were to display the output? What are the actual values? So what this means is if we have enum month this month, we created a new variable of type enum month, and then we say this month equals to February, this month is actually going to be equal to an integer. But we can still compare it and use it to compare it against February. But if you were to print out this month to the console, this month would actually be an integer value corresponding to when it was defined in the list. So in this case, February would be 1, because this month enum, the second one is in the list is February, right? So if we go back, if you remember, when we defined it, the second one is February. And you should notice that it's 1 even though it's the second one, because what that means is the list starts at 0. So January would be 0, February would be 1, March would be 2, and so forth. And this is important because you can then compare it against ints as well as comparing against actual values like February. Now, if you want to have a specific integer value associated with the enumeration identifier, you can explicitly assign something using the assignment operator when you actually define the type. So, for example, here, if we define a new enum of type direction, and we're saying that the valid values for direction are up, down, left, and right, you'll see that the third value left actually has an equals. That's saying that left is going to be equal to 10. So in this case, our enum type direction is defined with the values up, down, left, and right. Those are the only valid values that you can assign variables of this type. Up is going to be equal to 0 because it's the first element in the list definition. 1 is going to be equal to down because it's the second element. Again, it starts at 0. 10 is going to be equal to left. It's not going to be equal to 2 because we explicitly assigned it to equal to 10. So left is going to be 10 because that's what we put in our definition. And then right is going to be equal to 11 because it's going to be the one next after it. It's the next one. So if we had another value in there, it would be 12. So you can explicitly assign values if you want to. But again, what this is important is because when you do comparisons or if you print out the values, you just have to know that the enums are actually represented as integers inside the system. But you can still actually use February, March, January when you assign to your enum. When you actually compare those values against another value, you can use January, February, March. It still allows you to use those nice names. So we're going to have a nice little assignment or challenge on enums so you can become a little more familiar with it. But the point here is how can you create an enum type, and then how can you create variables of that type and assign values. And again, it's nice because you can control what's being assigned. If you don't want direction to be assigned, right corner, you just define up, down, left, and right. Another important data type that I want to discuss is a char or a char, depending on how you pronounce it. We've talked mainly about numeric data types. We now talked about the enum. Char represents a single character, such as the letter A, the digit character 6, or a semicolon. And what you see here is these single quotes. The reason we know they're characters, even though one is a number, is because it's in single quotes. So anything inside single quotes in a program is referred to as a character data type. And typically the characters will be alphanumeric characters like A, B, C, D, E, F, G, but they can still be actual numbers or other characters on the keyboard. And you can also declare character variables to be unsigned. Unsigned just means that they can't be negative, so it doesn't really make a lot of sense. But what it's telling the compiler when you have an unsigned character is that it's only a positive number, because remember, characters can also be represented as numbers in the ASCII table, and we're going to talk about that in a second. But we'll talk about, you also don't want to confuse the character data type with character strings. A character data type is just a single character inside single quotes. We have a whole other section where we're going to talk about strings. This would be a sequence of characters, a number of characters. So don't get character or char confused with character string or string. If you want to declare a character and use it, you can simply specify the data type char or char and then the identifier. So in this example, we have char broiled. That's declaring a variable named broiled of type char. When we assign to that variable, we put the value inside single quotes. So broiled equals T is perfectly fine. If we try to say broiled equals T and T is not inside quotes, that's not okay because T is a variable. And that would not be valid unless T is also of type char. Here we have broiled equals double quotes T. Again, that's not valid because double quotes in C means it's a string, which we'll talk more about, but that's not valid. So if you omit those single quotes, the compiler is just going to think that T is the name of a variable, and it's not going to work. If you use double quotes, it's going to think you're using a string, as I mentioned. You can also use numerical codes to assign values for characters, and it will just use the ASCII table. So the ASCII table is how characters are represented as numbers in the computer. So there's this whole table, and basically if you assign a number to a character type, it's going to think you're assigning an ASCII value. So what it's going to do, if you assign 65 to grade, it's going to look 65 up in the ASCII table, and it's going to be the equivalent of whatever character that is. And you'd have to look in the ASCII table to see what that character is, but I know B is like 48. Again, this is the way the computer represents certain characters, by numbers. So you can't assign numbers to characters. They're just going to be converted to single characters based on what they are in the ASCII table. Escape characters. This is a specific term that you're going to hear about where basically it's a special character that represents an action in the C programming language. So for example, you can have a special character that represents a backspace, or a special character that represents the new line, or a special character that represents the terminal bell ring. And you can represent these actions by using basically a an awkward symbol like a character inside single quotes. And I'm going to give you some examples. These are also called escape sequences. These are special characters that represent actions. So escape sequences are also enclosed in single quotes when they're assigned to a character variable. You often see these escape sequences inside of strings as well to represent an action. So for example, here we have character X equals single quote \n. And you'll notice a lot of the escape characters start with a backslash. But \n is a single character, and it looks kind of strange. What it represents in the program is it represents a new line. So if you were to try to print out that character as output, it wouldn't actually print out \n. It would print out a new line. You would see a new line printed out. So char x will represent this character, and if you were to print variable x, it would just advance to the next line. And there's a number of different escape sequences. Here's a nice little table I took from C Primer Plus book that represent all the escape characters that you can use that represent actions. So we mentioned the \n, that's a new line. \r is a carriage return. \v is a vertical tab. \t I think is a horizontal tab. So let me give you some examples of this and also give you some examples of an enum inside of our nice code blocks editor. So here we have our familiar program with our main method. And an enum, again, an enum is nice because you can decide what values are assigned to it. But there's two steps when you create an enum. You have to define the type, and then you have to create the variable of that type. And you use the enum keyword for both. So if I want to create a new type enum, and I want to name have this enum equal to some values, for example, I could create an enum of type, let's say, enum type gender. We say enum gender, and then all we do is we use the squiggly bracket, not to be confused with the square brackets, squiggly bracket, and we then define the list of values that gender can be. Basically, it can just be a male, and then we separate it with commas, and then a female. And then we end it with a semicolon. And what this is saying is we have a new type called gender. It's of type enum, and the only values that can be assigned to variables of this type is male and female. If we want to use this enum, we can create a new variable. We just have to say enum, the name of the type, gender, and then we can just say my gender. Right? And that's how we're declaring the variable. We declare variable my gender, but we haven't assigned or initialized any values. The only values that we can assign to it are male affirmatives. So we could say my gender equals male. And that's valid. And if we were to go and compile, this would be fine. There's no errors. And if we tried to assign something else, like let's just say we want to assign it a string. Let's try saying we want to assign it a number, 44. Now if we try to build this, you'll see that it built okay without an error because it was an int. But if we try to put it in a string or something, it would be more valuable. It's going to say incompatible types when assigning. So there's an error there. It's probably hard to see. But basically, we're not allowed to assign it a string here because it's not the right type. 44, you can only assign it male or female. And then again, if we were to try to see what this represented in terms of integers, so we can say male. We can then actually compare it to other variables. So we could create another enum gender type of another gender. And you always want to use good naming conventions here. Make sure we spell correctly. This one we can say female. God. And then we can actually say, create a Boolean value to see true or false. We could say bool is male. And we could say that's going to be equal to male equals female. I'm sorry, not male equals female, but my gender equals another gender. And this would actually return false because my gender is not equal to another gender. My gender is equal to male, another gender is equal to female, and is male would be set to a false value or a 0 value. We can also, though, actually see the values of enums by printing them out. And what we'll notice is that if we were to actually print out the value of the enum gender, which we haven't learned how to print out variables yet, but we can do something like printf, we would notice that gender, my gender, is actually going to be equal to 0 because that's the first in the list. Another gender is going to be equal to 1. So that's pretty neat. I also wanted to talk a little bit about chars in our examples. Remember, we can create chars, single characters, with variable names. We just use the char type, and then we say something like char my character. And we can equal to anything in single quotes. It can be J, F, whatever. We can even assign it variables, which will represent ASCII numbers in the table. But what this is nice is you can assign it escape characters, which represent specific actions, like a \n. And if we were to try to use this or print it out, it would print a new line feed. So we could do a printf, and we could say printf. We'd have to do something like %C, which we're going to talk about in our next lecture, and then print out my character. And that would actually display to the screen a new line, just a line feed. All right, so if we were to build this, and we were to run it, what we'd actually see as output is just a new line. So you kind of see it up there. There's a new line there. So it's a specific action. You're not printing out any output. But we'll go through more examples of this. What I was trying to demonstrate here is this nice concept of an enum and characters and escape sequences, escape characters. A great way to learn a lot of this stuff is to just play around, type code inside the IDE and see what it does. But to supplement this, I'll provide some challenges to help also with your assessment. Hope this helped. Thank you. Hello and welcome. In this lecture, I want to walk you through another challenge. I want to help you guys learn all about enums. So let's take a look at a challenge for enums. So in this challenge, I want you to create a C program that defines an enum type and uses that type to display the values of some variables. Remember, enums are awesome because enums can actually, you can create your own type and you can say this type is only going to have these certain values that can be assigned to it. We had examples for month, where month only had values of January through December. We had an example of a gender, where you could only assign variables of the type enum gender, male or female. Same type of idea. But in this code, we want the program to create an enum type named company. And for this enum type, the only valid values are Google, Facebook, Xerox, Yahoo, eBay, Microsoft. All caps. And also, the order is important because they represent integers. So it should be the same order as well. Google should be first, Facebook second, and so forth. Xerox is kind of out of place there, but that's okay. So we're going to create this enum type because that's the first thing you do with enums. You create the type, and then you use the type. After we've created the enum type called company, we then want to actually create the 3 variables of this type. And we want to assign these 3 variables values of Xerox, Google, and eBay. And then the last thing this program should do is just display the output. It's a simple program. It's just demonstrating enums. So what we need to do here is we need to use the printf function, display output. We should display the value of those 3 variables that we created. And we should also use a new line so that it's easy to read. Essentially, the output would be, if we printed out Xerox, Google, and eBay variables, would be something like 204. Now, you could actually put something before those integers so they're meaningful, something like the value of Xerox is 2. The value of Google is 0. The value of eBay is 4. Now, why are those values 204? Because those are integers. Remember, enums are represented as integers in C. Those are the integers of the order of the declarations in the list. So Xerox is 2. Right? Google is 0. Remember that Google was the first one in the list, and the list starts at 0. So Google 0, Facebook 1, Xerox 2, Yahoo 3, eBay 4, Microsoft 5. And that's why it prints out 204. Those are the requirements. That's what I want you to try to accomplish. So some hints. You're going to have to first define that enum type and its values. So what you're going to need to do is use that enum keyword. You're going to need to use the brackets, right? The squiggly brackets for the valid values. You're going to have to declare and initialize 3 variables. The way that you declare an enum type is just use the enum followed by the name. And then you can assign values using the equals operator. And then you need to use printf to display the value of the enum variables. We're getting pretty good at the printf, so this shouldn't be too bad. We'll need to use a format specifier. Since the enums are ints, we can just use %d. We'll also want to add an escape sequence to make the output more readable, \n. And that's it. That's what I want you to try to accomplish. You'll learn a lot from this little exercise, mainly all about enums. Thank you. Hello and welcome. In this video, I'd like to demonstrate the solution to our exercise for using enum types. So I'm going to go ahead. You remember this solution? It basically, you create an enum named company, you define some values for it, and you print them out. So I'm going to run code blocks. I'm going to create a new project. I'm going to name this project enum example because that's a good one for it. It's going to go up to File, say New Project. We should be getting pretty good at this by now. Selecting console application, C, and we're going to name this enum example, and it's going to put everything in our usual spot. I'm going to hit next and finish. And this will create our main.c file, which is good. It will get us started. We'll just delete some of the data. Again, we can add comments at the top for the author and the source. We should be doing that for good practice. For demonstration purposes and just efficiency, I'm going to leave that blank, but you should be adding comments throughout your source code. All right, so the requirements for this challenge were to basically create an enum that was named company. And then the company can only have valid values of Google, Facebook, Xerox, Yahoo, eBay, and Microsoft. And then create 3 variables and assign them some values, and then print those values out. So if we want to create an enum type, we have to use the enum keyword. So we say enum. And then we want to specify the name of the enum. In this case, we're going to name it company. And to specify valid values of this enum type, we have to use the squiggly bracket, which is right above the semicolon on the keyboard. And then we can just type in our names. Here I'm going to say Google. I'm going to put everything in all caps just because it's easier to see. Facebook is going to be our second one. Xerox our third, Yahoo our fourth, eBay, and then Microsoft. And that's it. This is how you can create a new enum type named company, and these are the only values that can be applied for this enum. So any variables that you create of this type cannot contain other values. And so the first part of enums is defining them, defining what they are, and then using them. In line 6, we're defining it. We're saying company can only have values of Google, Facebook, Xerox, Yahoo, eBay, and Microsoft. The next part of the assignment was to create some variables. 3 variables that had values of Xerox, Google, and eBay in them. To create an enum variable of type company, you just have to say enum, the name of the type, which is company, and then the name of the variable. Here we can just say, let's name it Xerox. And we're going to initialize that declaration on the same line. So we're going to use the equals operator, and we're going to just say that's equal to Xerox. So remember, the name company, it cannot be assigned any value. If I were to just do this and build it, it would compile good because we're able to actually assign that variable. But if I tried assigning something else, like my name, you would get a compiler error. Because that's not valid. My build message here is saying incompatible types when initializing type enum company with a character. So there's an error and I won't be able to run that. So the compiler actually protects you from what you can assign the enum. So again, we're just going to say Xerox. We don't have to put that in double quotes. We don't have to do anything because it's a actual value. We want to create a couple more, one for Google and one for eBay. So here I'm going to say company Google. I'm going to assign that all caps Google. And I actually made a mistake here. It has to be all caps. Luckily, I never saved it and compiled it. And then the third one I'm going to create is called eBay. All lowercase is the name of the variable. The value of that variable is going to be enum value eBay. And what you should be doing when you're writing this code in all of the actual examples that I've been providing, you should write small chunks. Write a couple lines, compile, test. Do not write a lot of code and run it. And some of the examples that I go through here, demonstrations, I'm compiling at the end for efficiency's sake. But as a new developer and a new programmer, you should be compiling after a few lines of code and testing. So after I created my enum type on line 6, I should compile and test that. Not much you can test, but you can at least compile it. Lines 8, 9, and 10, I should compile and run. So forth. Now after we created the enums, we can then actually print out their values. We know how to print out values by using the printf function. Anything inside the double quotes for the printf will be displayed as output. So I'm just going to say the value of Xerox is, put a colon in there. I need to use a format specifier. Remember that enums are actual integers under the hood. So we can do a %d here. And then we do a comma for our mapping. So after the comma would go the variable name. Here we'd have to actually provide the variable name, which is Xerox. And then we want to do the same for the other ones. Now, the thing that I forgot here on line 12 is we want to make sure the format's easily to read, so I want to add a new line. So I'm going to say \n. This is an escape sequence, a special character interpreted by the printf. So we're also going to do a printf, and we're going to say the value of Google is, we're going to say %d \n, whoops, \n. And here we're going to print out the value of Google variable, which is all lowercase Google. And then lastly, we're going to print out the value of eBay. And this is also going to be an integer, %d, with a line feed, even though I don't need it because there's nothing after this. Good practice. We use the comma for the argument, and then we say eBay variable. And we end all those statements with a semicolon. And that's it. So now we should compile and run. And the expected output here is going to be integers represented to the order of these values in the list. So as you notice that the list is defined on line 6. The list is Google, Facebook, Xerox, Yahoo, eBay, Microsoft. In the C code, in the C compiler, those are represented as integers. So Google is 0, Facebook is 1, Xerox is 2. So what I should see as output here is I should see as output 2, 0, and then eBay, which is 4. So let's see if that matches. Let's go ahead and build. I have no warnings, no errors. Let's go ahead and run it. And what I see is the value of Xerox is 2, the value of Google is 0, and the value of eBay is 4. So it looks correct. Pretty neat. Now remember from some of the lectures, you can actually change the value of the integers when you define the enum, you set an assignment. So if I actually wanted to change the order, I could say Yahoo equals 10, and then that would mean eBay would be 11 and Microsoft would be 12. So let's go ahead and save that. Now the output should be Xerox is still going to be equal to 2. Google is going to be 0, but eBay is going to be 11. So we run it again, and we should see that 2, 0, 11. So you can change those integer values if you wanted to for some reason. Otherwise, it's going to be the order that they were defined in the list. Okay. And again, we can play around with this. We could actually create other variables to see if Xerox is equal to Google and so forth. Enums are really cool, and you'll probably end up using them quite a bit. They can restrict what is valid for a variable, which is nice because it provides some kind of validation. Really easy to use, and it's also very easy to read. It makes your code more readable. Now we have a Xerox variable, and the actual value is Xerox. So we can actually provide other conditional statements and things, and it makes the code easier to read. So this was a quick little exercise that helps you understand enums, basically how to define an enum type, and then how to use that type. Also, we covered printf again. We covered print format specifiers. We covered escape sequences, and pretty good example. I'll provide this example as a zip file so you can download it. Hello and welcome back. In this lecture I want to talk about format specifiers. So this is in the section for variables and data types, and the reason is it's very important to be able to display the value of variables as output, and format specifiers basically help you do that. So I want to run through some examples of showing how you can display the value of variables, and we're going to use format specifiers to specify the type of data that we want to display. So format specifiers are used when displaying variables as output. You can also use them for converting data, but we're just going to talk about using them as output for now. They specify the type of the data of the variable that you want to display. So for example, if you declare an integer named sum and it's equal to 89 and you want to display that variable sum, what you would do is you would use the printf function, and it looks kind of weird, right? The thing that you should really notice in this printf is there's a % symbol there. And the way that you know, the way that you're going to be able to identify a format specifier is through that % symbol. So format specifiers are exactly what the name implies, in that they specify the format of data and how the format should be, basically how something should be formatted or displayed. So in this example, printf is a function that we've been using to display output. We know how to do this because we had a couple, many different examples and a challenge. Printf is a function, right? A function, again, we haven't talked about functions in detail, but a general concept of a function just means that it's a group of code. It's a way of organizing things, like an algorithm could be inside of a function. Function has specific syntax in C, in that you see parentheses with it. So we know the main function is the way that you enter a program. So we're familiar with at least one function called the main. We've also been learning about printf because that's one of the functions that you use to display output to the console. So it's important to understand those two basic functions. We don't have to understand everything about functions up to this point. We just need to know that a function can be invoked or called to do something. And in this case, we're using the printf function to display output. And we're telling it what to display based on what's inside these parentheses. All right, so printf is a function. It can display the output of variables. Up to this point, if we wanted to display something using printf, we just enclosed it in double quotes and we saw text go out to the screen. But what happens when you want to print out a variable? Well, when you want to print out a variable, you have to specify the type of the data for that variable that you want to print. The printf function needs that information. So if you look at printf and you're trying to analyze it, you don't know anything about functions yet. Things that should stick out to you are that, hey, it has a left parentheses and a right parentheses. There's a comma in there. There's quotations in there. And the comma, first of all, you're going to know it's a function because of the parentheses. And inside those parentheses are what's called function arguments. It's data that you're passing to the function that can be used. And again, it's not real important that you understand all of this, but it is arguments, and the arguments are separated by comma. So the first argument for the printf function is everything inside those double quotes. The second argument would be that variable sum. And so the first argument there represents what you want to be displayed as output. Everything in the double quotes. And up to this point, we were able to display text. But that %d symbol and that \n, we know the \n is an escape sequence. So if we try to print that out, that's just going to print out a line feed. But what does the %d do? Well, the %d is basically saying when you see the % symbol, don't actually print out %. Print out what's the next argument. So %d is going to actually be interpolated or mapped to the variable sum. Okay? So along with the display of the character string, the sum is, right after displaying the sum is, %d is going to be mapped to the variable that you want to display as well. And then \n is going to be interpreted as a line feed. So this is going to display the sum is, the value of sum, and then a line feed. Now the % symbol tells you that it's a format specifier. The d is telling you that it's an integer. And depending on the type of that data, what's after the % symbol is going to change. Okay, so that's what's going on with the printf function. The % character is what's important in terms of the format specifier. It's a special character recognized by the printf function, and what immediately follows that % symbol is going to identify the type of the data that we want to print. The type of the data that we want to print is just going to be a single character, like this is D. The data that we're going to actually print is after the comma. And so you can put many, many different % symbols in there to print many different types of data. And we'll go through some examples. So here's an example where we're creating some variables of different types. We're creating an integer variable, a float variable, double variable, and a character variable. And we're assigning all these different data values to them. We then want to display these actual variables values. And so what you should see here in these printf examples are after the percent symbol, there's different letters. We have %I, %F, %E, %G, and %C. Again, those letters identify data types. %I is going to represent an integer. %D also represents an integer. %F represents a float. %E is actually going to represent a double. %G is going to represent a double as well, just a different format. %C is going to represent a character variable. And then Boolean values, remember we mentioned that Boolean values are true or false, 0 or 1, so you could use a %I there as well. So let's go through this example in code blocks. So here's our familiar example, our main function, our main program. And I'm just going to copy and paste in the values that we had for our little program that had different data types. Just give me 1 second. So this is the example from the slide. Again, I have pretty big font here, so hopefully everyone can see it. All we're doing in this example is we're declaring some variables of different data types. So on line 12, we're declaring a variable named int, of type int named integer variable, integer var, and we're assigning it 100. So we're initializing and declaring variables. We have an int. On line 13, we have a float. Line 14, we have a double. Line 15, we have a character. We know that it's a character because it's inside a single quote. And then our Boolean, which we can just use underscore bool, again, is what was defined in the C99 standard, but we can just use bool. I think that would be better. And then we can set that to 0. The printf function, remember, that's displaying the output. And the first argument inside the double quotes is going to be what's displayed to the screen. The second argument is going to be mapped to what's the format specifier, %I. And then the \n is just printing new lines because that's an escape sequence. So if I were to run this code, first I need to compile. And let's see, it looks like we have an extra character somewhere. Probably with my cutting and pasting. Whoops. Just want to make sure I don't have anything here. This is basically, this error is saying there's an extra character somewhere I'm trying to figure out. Hidden somewhere. There we go. These spaces are creating problems with my cut and paste. And the way that we know there's no errors is because now we see it's highlighted. When you're in code blocks, one of the ways that you can identify errors is this color coding. It will tell you. So if you see things that aren't highlighted, it's usually a good indication that something weird is going on. So now we save it, we build it. We do have a unnamed type bool. So we're just going to use underscore bool for now. And we still have some bad characters here, and we know that because the printf is actually not. Let's see. Again, I should have copied and pasted this. I copied and pasted this from the PowerPoint slides, and it basically added all these weird characters. So now I have to make sure they're not there. And now we have no errors. Not sure why I wasn't able to use bool. This might. Oh, because it's a C++. So bool is actually for C, not defined as an alias, I think, until the C11 standard. So let's just continue. Well, you have to use underscore bool. All right, so let's run this thing. And what we'll notice as output is it's going to be displaying the output. So you'll notice again, try to look at this both for the output, that it's displaying integer value, so it displays whatever in the quotes, right? And then %I gets mapped to whatever the value is of integer var, which is 100. So %F is going to get mapped to floating var and vice versa. So what you see output is integer var equals 100, floating var equals 331.79, so forth, double var and double var. And you'll notice the format's a little different depending on the specifier you provide. You also notice bool var is equal to 0 because bool is a actual integer. And other things that you should notice is the floating var is actually printed out as 331.790009, but we assigned it 331.79. And the reason it's displayed with more precision is because of the specifier f, and depending on what machine you're in, because it's machine independent, it may display differently. And so this is just an example of how you can use format specifiers. And also, if you wanted to print more than one variable on the same line, so we could actually put what else we want in here, anything else inside in here, and then we could do another thing, %d, or let's print out the floating var. We could do %f, and then all we need to do if we want to print out two variables, we add another comma, and we say floating var. So you see what I did here? Is I wanted to print out two variables on one statement, one print statement. So I added another format specifier, and then I just added another comma to specify the variable that I want to print. So you can put as many format specifiers in between the double quotes, and those are going to get mapped to whatever after the commas for each variable. Again, I wanted to talk about format specifiers because we're going to be printing out data for debugging. It's important to know how to print out variables. And there are all sorts of different format specifiers in the C programming language. I want to provide you with a little illustration of some of the ones you're basically going to use depending on the data type. But format specifiers can get even more complicated. You could put a % here and say 2 dot, and this will print it to 2 decimal points. There's all sorts of nice things you can do with format specifiers to format your data, but we're just going to talk about the basics. Basically, how you use the format specifier to specify the type of data that's going to be outputted, and then put the variable after with the commas. Okay, so you can play around with this. Again, we'll have an activity or a little challenge to help understand this. But this program just demonstrated some declaration, initialization of variables, and then using format specifiers to display them. So let's go back to the slides and summarize some of these different format specifiers that are available in C. Let's look at one more example related to format specifiers, which is the width specifier. So the width specifier is where you have a number after the % symbol that specifies the minimum field width to be printed if the characters are less than the size of the width that remain in the space. So it really just has to do with precision. So this will make more sense if I show you an actual example. So this has to do with really floating point numbers and whole numbers. So let's say we have a float called x, and this is going to be equal to 3.9998 or 399, a bunch of different decimals. We can print the width of this by specifying how far or how precise the number is. So what we can do is we can say printf, and if we want to print %x, we usually use something like %f, and then we want to print out our float. But what we want to do instead is we want to specify, so it would look like something like this, as opposed to %f, you can actually say % dot, and then you can say something like .2. And what this is going to do, it's only going to print out 3.99 because the dot and then the number specifies the width of the floating point number. So let's go ahead and build this. And then when we run it, we can say, and we want to make sure this is X, we want to make sure that it only prints out to 2 precision. So when we run this, you'll see that it just prints out 4.00. So it rounds it. But again, %2 is the specifier. Now you can change this. If you don't want to use 2, you can say 5. And that will print up everything, and it will round it. So let's actually do 9.3. And it will print out 5 precision. So now when we run this, you'll see that it prints out 3.93232. So there's 5 decimal points. And so you can use the width operator for how you want to provide it. So in this summary slide, it actually tells you the format specifiers that you would use for printf in the third column here, printf chars. So if you want to print out a character, use %c. If you want to print out a bool, use %i or %u. And that will print out 0 or 1. There's also examples of what represents these data types. Short int would be %hi, %hx, and so forth. The ones that you're probably going to use a lot, int for %i or %d. %d works with int and is usually used depending on the standard. %F, you get a use associated with that for floats. Doubles, %F, %E, %G. Each one is going to determine the precision. Long double, %LF. Another real popular one is %S for strings, but we haven't talked about strings yet, which are just a sequence of characters. But again, all these different format specifiers can be included to convert data as well as displaying data as output. And we'll be doing a lot of this in many examples. Thank you. Hello and welcome. We have another challenge for you. This challenge assignment is going to test your ability, your understanding of data types and variables, more or less. So what I would like you to do is I want you to write a program that will display the perimeter and the area of a rectangle. And so the actual requirements for this are you're going to need to create 4 variables of type double. You're going to need to create a variable to store the width of the rectangle, a variable to store the height of the rectangle, a variable to store the perimeter of the rectangle, and a variable to store the area of the rectangle. All right, so we should understand how to create variables and then also how to initialize and assign variables by now using the assignment operator. But the first thing we need to do is create the variables. So you need to have 4 variables of type double. You're going to need to create a C project, which we'll get to in a second. But also the program needs to perform some calculations. We have not actually learned how to do calculations yet because we haven't talked about operators. So I'm going to give this code to you. It's pretty simple to create calculations in a C program. You just use operators like mathematical operators. So for example, in C, if you want to add 2 variables together, you use a plus. If you want to multiply 2 variables against one another, you use a asterisk. And so to calculate the perimeter of a rectangle, you have to actually add the height and the width and then multiply that by 2. It's very easy to do. Like I said, I'll give you this code. The main focus of this challenge is for you to understand how to create variables, how to use them, and how to define data types. Area is also going to need to include a calculation. Here, you're just going to multiply the width times the height using the asterisk. I didn't want to just create a simple challenge that didn't make sense, so I wanted to make it more relatable. And so I thought a rectangle, perimeter, and area, yeah, that's pretty good. It has some calculations in it, but you won't have to worry about that. So also, what you need as the output for this program is you're going to display the height, the width, and the parameter variables in the correct format. And so the other thing that you're going to learn through this challenge is how to use the printf function to display the value of variables. So you're going to need to understand format specifiers. You're going to need to understand an escape sequence for the \n. So you print out line feeds. So the first display should be the perimeter. The second display should be the area with the height and the width as well. Okay, so for some tips for this assignment or hints, you're going to need to create a project in code blocks. You should use a meaningful name for this project. Since this project is, in this program is basically creating the perimeter and area of a rectangle, you could name the project rectangle. That's really the simplest thing. When you create the project in code blocks, remember that by default, the code blocks is automatically going to create a C source file for you. It's going to be named main.c. You can go ahead and use that for this project. You don't need to delete it. In our first challenge, we deleted it because I wanted to make sure you know how to create your own C source files. But in this case, use the advantage of them already creating it for you. So main.c is just going to be an empty template with a main function in it. Remember, the main function is the entry point. After you have the main.c file, you're going to need to edit it. And as I mentioned, you need to create some variables. And the variables have to be of type double. So you should at least create a couple variables for height and width of type double. And you should initialize them. Initialize means that you set an initial value to them. You can initialize things using the equals operator. You end it with a semicolon. You'll want to initialize this to something, anything you want, something useful. We're not getting input from the user for this program, but you could, if you wanted to, if you felt comfortable, you could pass in command line arguments, but I didn't think that you guys are ready for that yet. So you can just hard code the variables to anything, 50, 100, 23.5, 92.7. Remember, they're doubles, so they can contain decimals. But you can just hard code these variables to a particular value. And they should be something other than 0, else you won't see decent output. As far as the other variables, the perimeter and area values, those are going to be calculated. So you don't want to assign any data to them hard-coded. You can just initialize them to 0.0. And then later in the program, you can assign values to them based on your calculations. So here's the code that you would use for the perimeter calculation and the area calculation. If you created two variables of type double named perimeter and area, all you would need to do is say equals to calculate the perimeter 2.0 times height plus width inside parentheses ending with a semicolon. To calculate the area, you would just assign area variable using the equals symbol, equals operator, width, and then the asterisk for times, and then height, and then the semicolon. So you can copy and paste the perimeter and area things right here in your program after you've declared and initialized all your variables. This is really the only logic of the program. Just do a couple calculations. After we've done those calculations, you then want to display the value of the two perimeters, or two variables, perimeter and area, and also height and width you should display as well. So you're going to need to use the printf function, and you're going to have to use the correct format specifier to display the required output. Format specifier for doubles, I mentioned, is %f, so you want to use that. You can play around with it as well and use like %f2 to see how the precision changes for the number of decimal points. If you're, and again, use meaningful names for everything. After you're done doing that, you should compile and link and then test, run the program. Okay, and again, play around with this program, try different things, try changing variables, data types, try printing out different variables using different data type format specifiers. If you're feeling really, really ambitious, add command line arguments to the program, and the command line arguments could be the width and the height. Read those in from the main function and use those to do your calculations for perimeter and area. And again, in our previous thing where I gave you the code width and height, I'm assuming that you created two variables called height and width, all lowercase, or else this code won't work. And those are common names for those for this actual functionality. So that's about it. Again, I'll provide another demonstration of how you complete this program along with the source code. So good luck. And lastly, also don't forget to analyze the output to confirm it's correct. If it's incorrect, you have to go back, do your editing, do your saving, and doing your rebuilding. Hello and welcome. In this video, I want to provide a demonstration of the solution to our previous challenge. Basically a solution to a program written in C that will print the perimeter and area of a rectangle. So I'm going to start code blocks up, and I'm going to first create a new project. I'm going to get a meaningful name. I think I'm going to name it rectangle, and it's going to be put inside of our regular directory path. I can create a new project by just going up to File, New, Project. I'm going to select a console application. That means it's just output to the console, to the screen. It's not a graphical application or anything. I'm going to hit Go. I'm going to select C, standard stuff. I'm going to name this project Rectangle. It's going to create a project file for me. It's going to put it in my usual download area. I'm going to hit Next, and I'm going to create debug and release configurations. And I'm going to say Finish. This is going to auto-generate a C source file for me called main.c. I'm going to go ahead and use this. All this does is put templated code in there to print out some information. I don't need to do that. I am going to keep the two standard includes. I could add comments at the top of the file. This is good practice. For this demonstration, I'm not necessarily going to do it. But if I want to add a multi-line comment, I would just put in, my author, typical things, author. And I'll do it, I guess, for learning purposes here. Author, purpose. This program is going to calculate the area of a rectangle. And then I could put in the date as well. But I want to end that multi-line comment with an asterisk /. You'll see my two include directives here on lines 5 and 6. I'm including the standard IO for input-output because I want to use the printf function. Standard libraries also includes because it has other important stuff in there, but we may not use it. So this program is going to calculate the area. And I mentioned in the requirements that we need to create some variables. In order to create variables, we have to specify the data type, and we also specify the name of the variable. And then we also may want to initialize them. we need to create variables for the width and the height, and they should be of type double. So the way that we do that is we just say double. That's a data type. We say name of our variable. We want to get a meaningful name, so we're just going to say double width for our first one. And we're going to initialize that to some value, anything we want. We're going to say 32.5, 32.3. We're going to end it with a semicolon. We're going to create another variable for the height. Here we're going to set another value to it. The way that we can assign values to variables is using this equals operator. That's assigning a value to a variable. Here we'll just say 15.2 or 3. Now remember, we could create these variables on the same line actually, but we can't initialize them on the same line. I could put a comma here and say height, but they won't be initialized both to that value. I would have to initialize them on another line. So I'm just going to create both variables on separate lines and assign them, initialize them on the same line as well. You know, I could override these later and actually assign different values if I wanted. But I created my two variables. I also have to create variables for my perimeter and area. Now I don't know what these are going to be equal to yet because they're going to be calculated. So I'm just going to create these and I'm going to initialize them to 0. And we could say 0.0 since it's a double. The same with the area. I'm going to also initialize this to 0.0. It's always good habit to initialize all of your variables. Now that we have our variables, we have to actually do our calculations. We haven't learned fully how to use operators yet, but it's very easy to do mathematical equations operators in a program. You use the traditional operators that you would use in any math class. In this case, I want to assign values to perimeter for a calculation. So I'm going to say perimeter, and I'm going to assign it using the equal symbol, and I'm just going to say the perimeter is going to be equal to 2.0 times, using the asterisk, and then in parentheses, because I want to have precedence, I'm just going to say height plus width. And then I'm going to end that statement with a semicolon. That's assigning new data to our perimeter variable. Mainly 32.3 times 32.3 plus 15.3 times 2. And I'm going to assign area equal to the width times the height. That's how you calculate the area of a rectangle. Use the asterisk for multiplication, and you just specify the variable names. So width and height are variables that we want to multiply. The last thing I want to do in my program is I want to display this output to see if it's correct. I can use the printf function to display output. And when I want to display the value of variables, I have to provide format specifiers. But remember, the printf function first takes this first argument. Anything inside double quotes will be displayed to the screen. So here I just want to say, and we could print out all three variables, or we could just print out the perimeter. Let's say perimeter is, and then after the is, I want to print out the value of the variable, so I have to use a format specifier. We can use a format specifier by doing a percent symbol. After the percent, we have to specify the type of the data. Here we're displaying doubles, which are floats, so we can say %f. And then the data that we want to display has to be separated by a comma, and then the name. Here we just want to display the perimeter. And I have trouble spelling perimeter. Then we want to end it with a semicolon. We also want to display the area, so we're going to use printf again. Inside here, we're just going to say area is, and again, we're going to say %f for a variable, and then we're going to have the comma, and we're going to say area. And this is basically the program. Now, you'll definitely want to make changes, do different things. And the last line here, we're returning 0. We'll explain that later when we talk about functions. But for now, just know it's standard. So now I'm going to hit Control S, or I'm going to save all. I'm going to go up and build this. Hopefully there will be no compile errors. There isn't. Now I'm going to run it. The one thing that I didn't add were line feeds, so it's going to be difficult to read this. So let me use an escape sequence to say \n. After I print out perimeter is, I want to add a line feed. Remember, escape sequences are actions that are interpreted by the compiler to do something, and they're represented through these weird character sequences. In this case, \n represents a line feed. \t would represent a tab. So let's resave it, build it again, and this time let's run it, and the output should be formatted a bit better. So when we run it, what we're going to see here is perimeter is 95.20000, area is 494.19000. And that's these two calculations. And it looks correct because 2 times 32 plus 15.3, that would be 2 times 47.6, which is 95.2. So that's correct. Width times height would be 32.3 times 15.3. I can't do that in my head. But if I put out a calculator, I'm sure it'd be 494.19000. You also notice they're printed on separate lines because we use the \n, and they're formatted nicely. Now, say I want to print out more than one value of a variable. Say I want to print out width and height. I can say perimeter is, and I can actually add more format specifiers. I can actually say, let's first say width is, and then add a format specifier for the width, and then put a comma, and then say height is, and then put a format specifier. So for each %f, we have to have a comma outside of the double quotes to represent that variable. So the first %f is going to be a width, so that has to be my first one. The second one is going to be the height. The third one is going to be perimeter. So hopefully this makes sense. See what I did here? I'm printing out multiple variables on a single printf. And so you can put multiple %. They just get mapped to whatever the commas are. So %f is going to be mapped to width, the first %f. The second %f is going to be mapped to height. The third one is going to be mapped to perimeter. And now again, I save this and I build it. And for output, we should now see, in addition to perimeter being displayed, also the width and the height. So when I run this, we'll see that the width is displayed as 32.3000, height is 15.3000, perimeter is 95.2. So we printed 3 variables. Maybe we want to get rid of some of those zeros. We could actually add in %2, .2 I think it is, .2, %.2f to format it to 2 decimal spots. Let's see if this will work. I always forget the syntax. This might be incorrect actually. Let's see. So let's see what this does. The height and the width, I want it to be more precise. Compiled, so let's see if it runs. And when I run it, it actually displays 32.30, 15.30, because I specified %2.2f. That's only displaying it to 2 decimal points. So you can play around with these format specifiers. And this is the basics, right? We created some variables. We defined the data types for those variables. We assigned data values to them using the equal symbol. Did some calculations and displayed the output. Now, if we were getting really ambitious, we could actually, instead of hard coding these to 32.3, we could add in some parameters to our int and pass data. And then, we'd have to do something like this. And we'd have to actually assign what was ever passed in. We'd actually convert it to a double, and it would be we'd have to do something like this actually. Convert it to a double first. But this is kind of getting more advanced for what we're learning here. But this would actually take in 2 parameters and assign them. So it'd be a little different. We'd have to then select our project, and we'd have to set the program arguments. Here we could just specify them being as like 44 and 28. Now let's see what happens here. Now when we build and we run, it should use 44 and 28 as for our calculations. And it does use 44 and 28, and it does a different calculation there. But that's getting ahead of ourselves. Let's just not use program arguments, but you can verify that's how to do it, and just assign hard-coded values to whatever we want again. And I'll provide this source and zip file to you so you can take a look at the source code if you're confused. We should also probably be providing single line comments in here. We could say something like declaring variables. Again, comments are nice because they help document the code. We could say performing perimeter calculation, and then the last one could be displaying output. Again, a lot of this is intuitive, but if somebody's completely new, they might get confused, so you provide the comments. So a lot of things that, again, we focused on here. Hopefully this helped with your understanding of variables, data types, using printf to display variables, format specifiers, and escape sequences. Thank you. Hello and welcome back. In this lecture I want to talk about command line arguments. The reason I included this information in the variables and data types section is because command line arguments are a way to pass data into your program. So it's sort of like passing a variable into your program, and it's very useful and you often do it. So I wanted to cover this real quick. So command line arguments. Basically, there are times when a program is developed that requires the user to enter a small amount of information at the terminal. Okay, so just like this implies, command line arguments are essentially program arguments. It's how you can pass data to a program. So when you ask a user or a program needs data that's dynamic, that's entered by the user, there's a number of different ways you can pass this data in. You can either ask the user for it, or you can pass it as a program, right? And the reason you'd want to do this is because, again, you might need the user to enter a number that indicates the triangular number that you want to have calculated. Or the user has to enter a word that you want to look up in a dictionary. Not all data is static or doesn't change. Some data you need to ask the user to input. And so, like I said, you could do this one of two ways. You can either request the data from the user, and we're going to talk about that in upcoming lectures, or you can supply the information to the program at the time the program is executed. And this is what is referred to as command line arguments. Passing data to your program via the command line when the program is run. And so we already know that every C program has a main function. This is a special function. It's basically the entry point of the program. It's also special because it can be used to get command line arguments. So when the main is called by the runtime systems, two arguments are actually passed to this function. Command line arguments. The two arguments are, the first one is the argument count. How much data is being passed to the program. It's an integer value. It specifies the number of arguments typed at the command line. The second argument, which is represented by argv for argument vector, is an array of character pointers. Now, you may ask yourself, what's an array? We don't know what an array is yet, but again, it's important to understand how you can pass in command line arguments. You can just think of an array as many different variables for now. So first argument, argc for the argument count. Second argument is a vector. Remember, arguments are how you can pass in data to a function. That's all it is. It's really not even that complicated. So the main function, you can pass the main function some data when you run the program. That data can be specified when you run the program at the command line. So remember, when you run a program, you either double click on it if it's an executable, or if you're on Linux or Windows, you run it by doing a /a.out. Well, when you do that, you can actually pass in things after the program. So you could say program.exe and then put parameters after that, data after that. And I'm going to show you how to do that. So again, the first entry in the array is a pointer to the name of the program that is executing. And then everything after that would be the arguments, and I'll demonstrate this. So here's an example. This is the main function, and it has two arguments, or two parameters, really. We'll talk about the difference between parameters and arguments as well. But you see it says int argc and then char, and there's a star asterisk argv. Again, don't worry about that. Basically, everything after the comma would be some data that you're passing to the program. And the argc would be the number of the data. Right, so let's go through an example. That's the best way to learn this. Okay, so here's our example. If we want to pass in data to our program via the command line, we have to have parameters in our main. Up until this point, main has just been empty with two empty parentheses. So the first thing we have to do is just have to say argc. Argc, it can actually be any name, but argc represents the argument counts. And then char star argv. And again, don't worry about the syntax for now. But we do have to add those two first. And so I'm going to create some variables here that demonstrate data being passed. And so because the data is being passed, I need to store it somewhere. So I'm going to create a variable of type int, just that is number of arguments. And this is going to be equal to argc. Argc is just the variable that's passed in. And I'll show you what this represents. I'm going to create another variable that just represents our argument. And this is going to be equal to argv0. Again, don't worry about the argv0 syntax. What this line of code is doing on line 13 is it's setting argument 1 variable equal to the program name. And then if we do another one, we say character star argument 2, and we're going to set that equal to argv sub 1. And then we're just going to print out this data. So we're going to say print out number of arguments, and we want to print out the value of a variable, so we have to use a format specifier. We're going to say %d, and then after the comma, we're going to say number of arguments, because this is a variable that we want to display. And then we have another print statement that's going to print out argument 1. And this is going to represent the program name. And again, we have to have a % symbol, so we're going to say %s because this is a string. Again, not important to understand at this point. We just, oftentimes, when you demonstrate code examples, you want to print out the value of variables. And so these printf statements on 16 and 17 are printing out the value of the variables that are passed to main, which are command line arguments. That's why I'm displaying it. And then the last one I want to display is our second argument. And this is the command line argument, in addition to the program name. So this would be argument 2 that we're going to display. And then we're going to return 0. So it's a very simple program in terms of it doesn't have a lot of functionality. It just basically gets data from the function that's passed in and displays that data. So when I said you can pass data to a program, again, remember that when you execute this program, we're just double-clicking on a menu option. But what's really going on is you're executing a command. Either double-click or executing exe, or in Linux or Unix, you're doing a.out. And so when you execute the program, you can actually pass data to it. Right? So since we're not actually executing the command, we're doing the menu, we have to pass the data via the integrated development environment. And luckily, CodeBlocks has a nice way of doing that. To pass data as a command line argument to a program, all you have to do is go to your project, highlight it, go up to the menu option that says project, and then go to set programs arguments. And see here, a window will pop up, and here basically you can just say your arguments. And you can put in as many as you want in here. Let's start, I'm just going to print my name, Jason. I'm going to pass that argument, that data, into my program when the program is run. And I'm going to say OK. So I'm going to go ahead and compile this. And when I run it, what do you think the value of number of arguments is going to be? Well, remember that there's one argument that's passed, which is the program name, and then I'm passing in Jason. So this should be equal to 2, the number 2. Argument 1 is going to be the program name, so this should be the program name, whatever I named it. And I can't remember if this will generate a test or not. And then argument 2 should be Jason, because that's what I am passing in. So now if I run it, let's see what happens. We say run. And my stupid virus protector, you'll see that number of arguments is 2. Argument 1 is the program name, which is, and it's very hard to read the format because there's no new lines. So let's start this over and actually add some new lines. How can we add new lines to be printed? We can just use an escape sequence, which is a \n. So let's add a \n after the %d for the first print statement and a \n after the next one. So it's more readable as output. And now let's save that. Let's build it again. And let's run it and see what the output is this time. Hopefully it'll be easier to read. Now when we execute it, you'll see that there's separate lines. Much easier to read. Number of arguments gets displayed as 2. Because as I mentioned, the first argument is the program name. The second argument is what I passed in. And argument 1 is actually displayed as the name of the program, which is my entire directory structure, and then test.exe. And argument 2 is Jason, because that's what I set in the IDE. Now, I can go and I can modify the program arguments by going to the project menu option and saying, make sure project, go to set program arguments, and I can change this. Now, when I change this, if I change it to something else, or I'll just say something. Now when I run it, the data that's going to be passed to the program is going to be something different. It's going to be, and actually all you have to do is run it. You don't have to recompile. Now it's just something that's displayed. And so this is a way that you can pass data to a program without asking for it from the user specifically. You just type it in the IDE and pass it to the program. And you can pass many, many arguments. You don't just have to pass that one. If you wanted to pass more, you would just, again, go to set program arguments and either separate it by new lines. Of course, if you wanted to use them, you would have to access them in the array, but you can pass in many. Okay, so this is useful to pass data to a program without asking the user to type something in the keyboard. If you didn't do it this way, the program would pause and it would say, hey, user, please enter something. And then the user would enter something, and then you'd have to save it in a variable, and then you'd have to continue executing. This way, you don't have to ask the user for anything. You just pass it in as part of the program. So this is what command line arguments are. Don't worry about these other concepts like arrays. You see the asterisk for pointers. Don't worry about that. Again, this is just displaying the command line arguments. And the way that you access them is through these parameters in the function. But again, the main point is this is how you can do it. And it's useful. It will be useful for other programs and is associated with variables. Thank you. Hello and welcome back. We're into a new section. In this section, we're going to talk about operators. So I wanted to just give you a quick overview of a couple terms and tell you what operators are. And then we're going to dive right into a lot of examples and of the different operators. So operators use functions that use a symbolic name, and they perform all sorts of different actions in the program itself. The most common types of things you do is you perform mathematical or logical functions. So you do arithmetic type stuff, 5 plus 9, 3 plus 8, or you compare things like is this number variable greater than this variable? All right, and instead of actually calling a specific routine like a printf or a scanf, you don't call a function, you just use a symbol. You just use like a character, like the less than symbol or the plus symbol. Those are called operators. So operators are predefined in C, just like most other languages have this concept of operators. And most operators tend to be combined with the infix style. And all that means is that the operators in between the data. Right? So I mentioned that operators can perform mathematical functions, just 5 plus 8. Plus is in the middle between 5 and 8. And that's referred to as infix style. You can actually do like plus 5, 8. That's considered prefix style. And then postfix style would be the operator is after the arguments. So 5, 8 plus, for example. But we're most familiar with how you do math in high school and everywhere else. The actual operator goes in between the arguments, which is referred to as the operand. So operators and operands, you want to think of those two terms. Operator is the actual symbol, and operand are the arguments to the symbol that are usually on the left and the right hand side. But again, it depends on the actual operator. So we're going to talk about logical operators. These are sometimes called a Boolean operator because they return true or false values. And we know what a Boolean is, Boolean variable at least. So it's an operator that returns a Boolean result, true or false, that's based on the Boolean result of one or two other expressions. And so we've also been hearing this term expression a lot, so I wanted to formally define that as well. We'll do that in a second. And how it's a little bit different than a statement. Another example of an operator would be arithmetic operators, as I mentioned. Plus, minus, two operands on the left and the right hand side. You perform some kind of calculation. Other operators can include assignment, where you're assigning data. And we've done this in previous challenges and in previous lectures. And this is kind of the most common thing. That's the equals operator. And then there's things like relational operators, which are really comparison operators, less than, greater than, not equal. That's used with the exclamation point. And then bitwise operators, where you can perform operations on bits. And we'll talk about that as well. This is just designed to give you a little introduction to what an operator is and how it can be very useful. Now, in order to really use operators, you have to understand a couple different terms. I've been using these terms kind of casually, expressions and statements, but I haven't formally defined them. And it's important to know the difference because if you read any kind of, or learn about anything in programming, you're going to hear these two terms. And you may have been brushing them off and maybe you kind of understand what they are, but you should know there are specific differences. Usually you can identify the differences. For the most part, statements end in semicolons, expressions don't, and expressions return values. Statements don't necessarily. But let's go through a formal definition. Statements are the basic programming steps of C. Most statements are constructed from expressions, so you kind of see a combination. You may see an expression inside of a statement. And I'll give an example of that. So an expression consists of a combination of operators and operands. And now that we know what an operator is formally, and we know what an operand is just the arguments to the operator, together that makes an expression. We can now actually say what an expression is. Operands are what an operator operates on. I mentioned that. They're the arguments. Operands can be constants, variables, or combinations of the two. So it can be 5 plus 8. It can be variable x plus y, or it can be variable x plus 8. Every expression has a value, and expressions generally return values. So here are some examples of expressions. -6, minus. Minus is an actual operator in C. It's a unary operator, single operator with a single argument. And then 4 plus 21, where the operator is plus, and it's in between two constants. This is an expression. And then another expression that's a little more complicated, many operators, the star for multiplication, the plus for addition, and then the / for division. And then you see an assignment, which is Q equals 5 times 2. That's where you have an expression 5 times 2. On the right-hand side, you have a variable on the left-hand side. Together, those make up a statement. Another one is x equals plus plus q %3. We'll talk about those. Plus plus is an incrementation operator. Percent is a modulus operator for remainder. And then a comparison operator, q is greater than 3. A variable q is greater than 3. But these are examples of expressions. Now, statements, we've mentioned that they're the building blocks of a program, but there's different types of statements. We've already learned how to declare variables. That's actually a statement. That's a declaration statement. So a program is going to use a series of statements with special syntax ending with a semicolon. Those are referred to as simple statements. Statements that are single lines that end with a semicolon. Right? You can also have compound statements, which I'll tell you in a second. But a statement is essentially instruction to the computer. So a declaration statement, data type followed by variable name, and then a semicolon. That's an example. An assignment statement, Jason equals 5. It uses the assignment operator. It's not an expression. It's just Jason equals 5. A function call statement, where you call a function printf. That's the one function we know. And we call it, say, Jason, pass it. Structured statement, we haven't learned this syntax yet, or this keyword while, but this is a loop where it has a single statement on a single line ending with a semicolon. A return statement is when we return data from a function. Again, we don't fully understand what this means, but you see it ends in a semicolon. These are different types of statements. So C considers any expression to be a statement if you append a semicolon. So that's why some of this looks a little tricky, right? When you see Jason equals 5, you might have thought initially, well, that's an expression because it has the assignment operator. But because it has a semicolon, it's actually referred to as a statement. Again, not necessarily super important to know, but you probably see these terms all over the place, and you're going to be just asking yourself, what expression? Why do they keep saying expression? So expression statements that end in semicolon are assignment or are statements themselves, or referred to as expression statements. So in C, it's perfectly legal to just have a number in the semicolon, even though it doesn't do anything and is wasteful. But it is okay. And same as 3 minus 4, semicolon. That's an expression normally, but it ends in a semicolon, so it's an expression statement, but you're not doing anything with it. You're not assigning it, but it is perfectly valid, but no reason to do those two examples. Compound statements, a little different than a single statement where you just have a semicolon at the end. These are usually inside blocks of code. And I tried to tell you what a block of code is previously, where you have the brackets, but this is where you just have multiple statements, and then they group them together by basically braces. And that's referred to as a block. So an example of that would be something like this. Int index equals 0, that's a single statement. Ends in a semicolon. Well, while printf, while index is less than 0, this is a while loop. You don't have to understand what that means. But what you should notice here is these braces. A starting braces on the left, and left braces to start, and ending braces on the right, or at the end, which is a right braces. That looks kind of like the main function, right? Where the main routine has a left and right braces. And I mentioned that's a block of code. So a block of code is just multiple statements. But that's referred to as a compound statement as well. And we'll be talking about blocks and how you can use these braces for while statements, looping, and if conditionals, and so forth. But again, a quick overview. we're now going to go into some examples of specific operators that are supported and how to use them. Thank you. Hello, welcome back. In this lecture, we're going to discuss some of the basic operators supported by the C programming language. So operators, again, just special symbols for functions. You're performing some kind of operation. So we're going to discuss basically in this lecture 4 different types of operators: the arithmetic, logical, assignment, and relational operators. And then we're going to discuss in another lecture the bitwise operators, and then a couple other special operators that don't really look like they be an operator, but they are. The size of operator and the casting operator. So an arithmetic operator is probably the most common sense one, the one that you're probably most familiar with. It's a mathematical function. It takes 2 operands and performs a calculation on them. It's infix, so it's the operators in between the operands. A logical operator, sometimes called a Boolean operator, is an operator that returns a Boolean result. True or false value, that's what a Boolean is. So it's really just a conditional operator. It's based on the Boolean result of one or more or 2 other expressions. One or two other expressions. An assignment operator just sets variables equal to values. It assigns the value of the expression at its right to the variable at its left. So it's a right operand and a left operand. Again, it's infix. And then a relational operator will compare variables against each other. So this is kind of comparable type operator, less than and greater than. But let's go over each one of them because there's many of the different operators. C supports a super rich set. So the first ones are these arithmetic operators in C. Okay, these are the mathematical functions. So here's a little table that I found online from tutorials, the tutorials points website, which is nice. And this summarizes all of the arithmetic operators in C that are supported. So the basic ones, just like in math, there's nothing really new here. On the left-hand side of the table is the operator, and the middle is a description of what it does, and then on the right is an example. Right, so plus, the plus symbol, that's going to add 2 operands. It's infix, it's in between the 2 operands. So what you would do is you could either add variables, you could add a combination of constants in a variable, or just constants. In this one, we're saying a plus b equals 30. But the actual operator and operands are just a plus b. And then that would be the example. Minus subtracts 2 operands, a minus b. So a minus b could actually be equal to something like a negative 10 if a is equal to 20 and b is equal to 10, or b is equal to a negative 10. Is that right? 20 minus negative 10, yeah. Asterisk is for multiplication. Again, infix in between operators, in between operands. Division is the /. Percent is modulus operator. This is the remainder operator. So if you were to say like a variable percent %a, what is that going to be equal? If b was equal to 20, a was equal to 12, the modulus operator would return 8, because that's the remainder of 20 divided by 12. Plus and minus, these are specific incrementation and decrementation operators. They're still referred to as arithmetic operators, but you typically only see them, you'll see them mostly in loops when you repeat code, but not always. I mean, in this example here, you're incrementing a variable by 1, or by a specific value if you're doing something else. But so if you do a plus plus, it's just whatever a was. If it was 5, it's now going to be equal to 6. And then there's a decrement operator, which decreases the integer value by 1. So a minus minus. And the plus plus and the minus minus, you should notice, are after the variable. This is referred to as postfix. And what this means is if that variable is in an expression, it's actually not going to be assigned the extra 1 until after that statement. If it's prefix, it'll be assigned before it. So let's go through some examples of these arithmetic operators and code blocks so that they make a little more sense. So here's code blocks. Here's our main routine. We're familiar with this by now. I'm just going to create a couple variables and do some operations on them and then print them out. And I'm just going to create integers. There's going to be, and it doesn't matter though. You could create floats to do calculations or doubles, but we'll just make it basic. We'll say a is equal to 33. We'll create another variable of type integer, and we're going to assign that to 15. So we're doing a declaration and an assignment on a single statement, and then we're just going to have a result variable, and this is going to be initialized to 0. So here we can start performing calculations. We can say C and we can do assignments. We haven't learned about assignments specifically, formally, but we know what assignments are. Assignments are taking data and putting that data in that variable. So C equals is taking whatever is on the right-hand side and putting the result into that variable. So if we say A plus B, again, this just looks like a normal mathematical routine. And it is. It would just be 33 plus 15, and what would be the value of C? 48. And so you could just print out the values, right? You could just say C is %D, using our format specifier, and just printing out C. And then maybe we could do a line feed. And that would just add two numbers. It's it's that basic. It's that simple. We're just displaying it. So when we run this program, we're going to see the addition of 33 plus 15. This is still running an old one. Make sure we recompile this, save it, save build, and then save run. Let's make sure that we don't have anything up because it's still, yep. Because I have an undeclared identifier. I have a compiler error. I said C instead of result. Didn't make sense. Sorry about that. Now when I build and I run, it's going to run my new program. Make sure. Oh, we still have an error. Result set. No, let's see. We're still using C. Wow, a little careless. There we go. Now I don't think we'll have any errors. Now we build. No errors, so now I can run it. And you'll see that when I run it, after my virus scanner, it says C is 48. So you can play around with these. I mean, these are basic, right? So A plus B, you can do the minus. You can do the asterisk for multiplication. And then you can do the division for /. And then the % symbol, which is modulus. So this is interesting because, 33 divided by 15 would be 2 with a remainder of 3. So result is going to be 3 in this case. Let's just make sure, though. Save this and make sure we close our execution. And when we run it, we can see that we have C is equal to 3 because that's the remainder. Otherwise, it's pretty basic. The important ones with the plus plus are that to understand the prefix and the postfix. So if I were to say, and this is more relevant when you actually do it in a single statement, printf. So let's say I print out A++. What that's going to print out is 34 because you're going to increment A by 1 and then print it out. But you're going to do it in the single statement. You're going to do it in the same line because it's afterwards. So actually what's going to be displayed here is it's only going to display 33. It's not going to actually increment A until the next line of code. So if we run this, you'll see it just prints out 33. Right? Now, that's the difference between doing a plus plus A. If you do a plus plus A, which is the same thing, you're going to increment by 1. Difference here, though, is you're going to increment it by 1 and then before the statement is executed. So here now, we'll notice that we just have a couple warnings, no errors. And when we run it, now you'll see the answer is 34 because it's actually incremented before the statement is executed. And that's important to know between plus plus variable name versus variable name plus plus. That's just referred to as prefix and postfix. Right? The same would happen for the minus minus. So keep those in mind for your unary. These are also unary operators because they only have one operand. The other ones are binary operators because they have an operator in between the operands. But understand the minus minus versus the plus plus, and then also understand if you place it before the variable or after the variable, when it's going to actually increment or decrement. And again, all it is if it's after the variable, it increments or decrements right there before it executes the line of code. If it's before the variable, it's going to execute the line of code, and then after that's executed, the statement, it's then going to either increment or decrement. But play around with this. Open up a window, do a bunch of different arithmetic expressions, and see how it all works. Now let's talk about some of the other types of operators. The next group of operators are referred to as logical operators. Right? And we defined what this means is it basically is conditional type operators They return Boolean results, true or false values. So the symbols that represent logical operators are the ampersand, ampersand, the two parallel bars, and the exclamation point. The ampersand, ampersand is called a logical AND operator. And it says it's also an infix operator that takes two operands, one on the left, one on the side. Basically, if each operand is non-zero, then the condition becomes true. And so non-zero means 1, which means true. So if A is true and B is true, then the answer would be true. If A is false and B is true, the answer is false. If A is false and B is false, the answer is true. Right? Or false, because they have to both be true. Sorry, I was getting confused with the or and other ones. So again, we'll do some examples of that. And then parallel bars are the logical OR operator. Again, this should be similar to your math class, so I don't want to spend too much time on it. But if any of the two operands is non-zero, if either one is true, then it's true. So if A is true and B is false, it's true. And that's, remember, these are expressions that return values. So the return would be, if A is true and B is false, the return would be true. And then the logical NOT operator, which is the exclamation point, this just reverses the logical state of its operand. So if the condition is true, it then is going to return false. So if you say not A with the exclamation point and A was true, A is false. If you put the not outside of parentheses, whatever A and B evaluated to, it's now going to evaluate to the opposite. So let's again look at some examples and code blocks. Okay, here's code blocks, and again, I'm going to create a couple of variables to demonstrate logical operators. Again, I'll just create some integers. We'll say A equals 12, and then B equals 20, and then int. Actually, what will be better is we'll create a, because I don't want to utilize conditions. So we'll just create a underscore bool, and we'll assign that. I will say that will be result, and we'll initially not assign that to anything. And then we're going to just print out some data. So we want to see what the values are of these expressions returned if we use the logical operators. So in here, I'm going to print out %d, which is an integer, because remember, Boolean expressions are just integers. Boolean variables are integers. So if the Boolean value is 1, then that means it's true. If it's anything else, it's non-zero. Or if it's 0, it's false. Anything else, usually 1, it's true. So I'm just going to print out the result. And then I'm going to assign some data to it. So if I say result equals A and B, now that's not going to make any sense because these are numbers. So let's initialize A equal to true, and again use Booleans. And here we'll say this is true, and this is true. Right? And when we use the ampersands, this is saying A and B both have to be true in order for the return to be true. So results should print out 1 because 1 represents true. So let's build this and make sure that we have to use the right namespace. So we're just going to represent 1 for true and 1 because we don't do in the right include right now, so that's no big deal. So now when we run, it should report true, 1. And it does, 1. Now if I change any of these to not true, if I say 0, then the result is going to be false because A and B both have to be true in order for the result to be true. Right? So if I build this and I run it, you're going to see that the result is 0 because it's false. So either one, if I changed A or B to 0, which means false, the result would be false because both A and B have to be true. Now if I say A parallel bar, which is or A or B, only one of them has to be true in order for the result to be true. So in this case, result should be 1. So let's build this and run it. And now we have a value of 1. 1. So only one of them has to be true. So now if I make them both false, and this is going to be much more applicable when we talk about if statements and conditionals and making decisions, but I am demonstrating Boolean logic here. Now both are false, so this should return 0, which is false, and it does. 0. So pretty neat. And then the last one is just the not symbol, which is the exclamation point, which just does the inverse. So if I say not A, if A is equal to 0, A is now going to be equal to 1, or result will be. And result is going to be equal to 1, which it is. So those are the 3 logical operators. Again, they'll be used in usually decision statements. Let's now move on and talk about another set of operators. Now here are the assignment operators. We're pretty familiar with at least the simple assignment operator, which is the equal symbol. The equal symbol assigns data, and that's pretty basic. C equals A plus B. C is going to be the result of A plus B. Now there's these compound type of operators where you can do plus equals, or minus equals, or star equals. Plus equals is where you add and the assignment operator. So it adds the right operand to the left operand, and then it assigns the results to the left operand. So you could say C plus equals A, and that's the same as saying C equals C plus A. Minus equals the exact same thing, except you're subtracting, and then you're assigning. So you subtract the right operand from the left operand and then assign the data. So if you say C minus equals A, it's really C equals C minus A. It's kind of a shorthand notation, these plus equals and minus equals. You can write things a little faster because you do 2 operations essentially in one single statement. And then multiply is the same thing, star equals, multiply and assign. So C star equals A is equivalent to C equals C times A. It's pretty straightforward, I think. The other assignment operators are similar, except you're using division. So division equals is divide and then assign. Percent is do the modulus and then assign the result. So those are pretty straightforward. And then we have some other ones which we're going to talk about in another lecture in more detail. So I'm not going to touch them on here because they're really completely different. They're called bitwise operators, which is left. And all I'm saying here is that for those bitwise operators that we're going to talk about, you can also assign them in single statements. So shifting, doing a left shift and a right shift, and assigning, you can just do less than equals and write that right greater than equals. And then again, the ampersand, the caret, and the parallel bar are all related to doing things on bits. So we'll come back to that, but they are part of the assignment operators. So the assignment operator is just pretty easy, right? Assigning data, and then if you want to actually do expressions, a couple expressions, then assign it, you do the combination ones. The relational operators are comparison operators. They compare 2 values. So this is important. Equals equals will compare the value of 2 variables. And if they're the same, it's going to return true, because it's going to return a Boolean expression, true or false, or a Boolean value. Exclamation point equals is checking if the values of 2 operands are equal or not. Right? So A is not equal to B is how you want to read that. If A is true and B is true, then that's going to return false because they're equal. So A would have to be false or B would have to be true, or vice versa, and that would return true. The greater than symbol is checking whether or not A is greater than B. Less than symbol, A is less than B. Greater than equals, A is greater than or equal, and less than equal. So again, this is all basic math stuff. I'm not going to go through examples in the IDE because this is pretty straightforward. Comparison operators, just like in math, greater than equals, and so forth. So hopefully we have a good handle on the basic operators, arithmetic, logic, assignment, and relational. Used quite a bit, so you need to understand them. Hopefully it's not too difficult or confusing. You're going to use a lot of this in if statements and decision statements, so we'll be providing a ton more examples on these. Thank you. Hello and welcome. We got another challenge for you. So we talked about operators in pretty good detail. Now I want you to make sure you understand these by giving you a challenge, trying to use some of these concepts that we've learned about. So I want you to write a program, and I want you to create a C program that basically does some conversion, converting number of minutes to days and years. Now this program doesn't necessarily seem that useful. You might never, I don't know why you'd ever do that, but it will force you to use some of the operators, mainly the arithmetic operators, and get you acquainted with those. So that's why I'm giving you this challenge. This is a very, very simple program. It should ask the user to enter the number of minutes via the terminal. So this is also your first challenge where you're going to use the scanf function. I want you to actually ask the user to enter number of minutes. They're going to enter the number of minutes, and then you're going to provide as output the equivalent of those minutes in years and days. Now it gets tricky because these are all going to be doubles. So the conversions are going to actually, or the results are going to be decimal numbers, right? Where you have floating point numbers that are, because a lot of times you might enter 50 minutes. Well, how is 50 minutes equivalent in years and days? Well, it's 0.0000 or something, right? Because years and days are much larger than minutes. So it's not a necessarily useful program. It's not a necessarily complex program. You're going to just do some calculations. But again, it's going to get you familiar with the basics of operators, mainly arithmetic operators, and also allow you to perform a calculation. And then the other good thing here to learn is the scanf, fscanf. So you're going to need to create some variables to store. They all should be type double because this is going to be a very precise program. Minutes can actually be an integer if you want, but the rest should really be doubles. You see here that minutes needs to be a variable. That's what you're going to do your scanf function, what you read in from the keyboard. Minutes in year, this is necessary because this is how you're going to do your conversion. So you need the minutes in year. And the reason the minutes in year, you can use the minutes in the year to actually calculate the number of years, right? Because the user is just going to enter the minutes. You need to know how many minutes are in a year to display the number of years, right? So I would expect you to have a variable called minutes in year. That would be something like the number of minutes in an hour, which is 60, times the number of hours in a day, which is 24, times the number of days in a year, which is 365. If you do 60 times 24 times 365, that's going to give you the minutes in the year. You can then use the minutes in year and divide it by the total number by the minutes entered by the user, and that will give you the number of years, right? So it's a little more complicated than you think. Again, you're going to need to figure out this calculation. I'm not going to give you any hints on the exact calculation. I probably gave you too much already. But what I expect to see as output is this conversion, right? So you need to perform a calculation using all the arithmetic operators. You have to figure out the conversions. I'm going to provide a nice demonstration of how I'm going to implement this, but I would expect something very similar, creating some variables, using the actual scanf function to read an input into a variable, and then assigning those variables some calculations using, basically I think you'll need to use the division, multiplication operators, as well as the modulus operator for days, I would think. Good luck. Thank you. Hello and welcome. In this demonstration, I want to provide a solution for our last challenge. So I want to provide a solution to our C program that is taking a number of minutes and converting it to what that representation is in days and how many years that is. Again, not necessarily a practical program, but it will demonstrate a few key concepts that you guys can learn, mainly using arithmetic operators, getting input from the keyboard. And also, you do have to use the cast operator for this, which I might not have mentioned in the challenge, but hopefully you guys figured this out, because when you do the, maybe you don't need to use the cast operator. You shouldn't need to. Initially, I was thinking a solution needed a modulus operator, but if you do a modulus, it only takes a two ints, I think. So anyways, let's get started. Let's start up Cold Blocks. And let's create a project, go through the basic stuff that we're pretty good at by this point. So I'm not going to go into it in detail. You can just watch. But I'm going to create a new project, and it's going to be a console project, and definitely going to be C. And what I'm going to name this one is, again, you always want to get good, meaningful names. I'm going to say minutes conversion. So it's like a minutes conversion app. All right, and now I'm just going to modify our main.c file. So let's get rid of this, and we're going to keep the include statements, and like always, you want to add comments. Make sure you add the comments. Just because I don't do it doesn't mean you shouldn't do it. It's standard practice. It's just for efficiency and time purposes. I leave it out. So let's. What I like to do at the very top of the program is declare my variables that I need to use, and then initialize them. So let's start off that way. I'm going to create an integer variable for the minutes the user is going to enter. And I'm just going to call that minutes entered. I'll initialize it to 0. I'm going to create a double for years. This actually could be a long as well, depending on how much calculation you want to do, because you could actually get into a pretty big decimal point number. So long might even be a better option. But I'm just going to use a double for now. Initialize that to 0.0. And days, and I'm going to equal to that 0.0. And now I want to get input from the user. In order to get input from the user, the first thing you do is you have to tell the user to enter the input. So I'm going to just display some output saying, please enter the number of minutes. And then it's going to put a colon there and a space and end it with a semicolon. Next is I'm going to actually get the input. Right? And here's where you'd probably say get input from user as a comment. How do we get input from the user? We use the scanf function. So remember this from a while back? Just say scanf. It's similar to the printf. And the first parameter, though, argument, is the type of data that you want to read in to convert. Remember, everything is read in as a string or text. So you have to convert it to how you're going to store it. So you put it in double quotes just like the printf. You use a format specifier. Here I'm going to just say I want to store it as a decimal. So I'm going to say D, an integer. Not a decimal, an integer, sorry. And then the next argument is what variable you're going to store it in. I'm going to store it in minutes entered. Now remember that scanf, and I actually just have scan there, scanf, for every single data type except a string, you have to provide the ampersand, the address of operator. So we have to provide that. We're reading in a number, so we have to do the ampersand. Remember that from the lecture? Then I want to add this with a semicolon. And at this point, you should probably test. Make sure you can get input from the user, and you probably just have a printf to display what you entered. But since I know that this is correct, I'm going to move on. I'm going to need to do a calculation on line 15. Mainly, I want to store the minutes in years. Okay? So what I'm going to do is create another variable that I forgot about, which will store the minutes in year. Because this is going to make it easier. So here I'm just going to say minutes in year. You'll notice that the convention I'm using here for naming variables is camel case. It's where you have lowercase for the first word, and then every word after that you uppercase the first character. I didn't explain that earlier, so I thought I'd mention it. So yeah, the first calculation, I want to set my minutes in year, because this is how I'm going to calculate my years. So minutes in year is actually going to be equal to, and I like to use parentheses just to organize so everything's clear, it makes it more readable. It's going to be 60, because 60 is the number of minutes in an hour, and I'm going to multiply by that by number of hours in a day, which is 24, and I'm going to multiply that by the number of days in a year, which is 365, and so this calculation is going to give me how many minutes are in a single year. And I can now use this to calculate my years. So here on the next line I can say years equal. So we're using assignment operators here, the equals. And then what we're doing in those parentheses on line 16 is we're using the asterisk, which is a multiplication. Right? So pretty neat. Years is just going to be equal to, and again I want to use parentheses, the minutes entered, which was done by the user, divided by the minutes in the year. Right? So if you entered 5,000 minutes and there's 20,000 minutes in a year, 5,000 divided by 20,000 is going to give you how many years there are, which would be 0 point something. To calculate the days, here I'm just going to say minutes entered divided by 60, and 60.0, because there's what? There's 60 minutes in an hour, right? And then once I have the hours, I can then divide that by the number of days, which is 24.0. And I could have put this in another calculation if I wanted to, but again, I want to make sure that we do this in the correct order. So first, I'm going to divide minutes entered divided by 60. You don't have to worry about this actually, because we're doing division here, so the associativity will be left to right, and I actually don't need these parentheses. But I always like adding parentheses because it makes things more readable. So let's add that last one. That's kind of redundant. I don't even need one here, so let's just leave it out. Only the first ones. And this should display our days. Now that I've done my calculations and used some of the operators, I want to do a printf to just print out my data. Here I'm going to say print out the minutes first. %d minutes is approximately %f years and %f days. Right? And then I'm going to add a line feed. Oops. So what this is doing is we're using printf to display output of variables, and the % symbols, remember, are markup specifiers. The first thing I want to print out is minutes, so I have to put minutes after my first comma, minutes entered. The second one is the years, so I want to say years because that's %f years. And the third is days, something like that. And that should be it. I should now compile and run, and this should do my conversion for me. So let's go ahead and build. I got no warnings, no errors. Let's run. And I'm not even sure how many minutes are in a year, so I'm not sure how to test this, but let's just put in 5,000 minutes to start with. When I run the program, it asks me to enter the number of minutes. I'm going to put 5,000. And if you didn't put in a number, you might have a crash because you're converting it to a number in your scanf function. I hit return. This says 5,000 minutes is approximately 0.009513 years and 3.472222 days, which seems to make sense because what, 60 minutes in an hour times 24, that's going to be roughly 2,400 or so for one day. So 2,400 and 2,400, 4,800, or no, 60 times 24 is going to be roughly 1,200. So 1,200 goes into 5,000. How many times for each day? Probably about 3.4, around there. So roughly, this looks to be correct. So you can run this multiple times, put in some big numbers. What you're going to notice, though, we're only storing doubles here. So if you run it and you try to put in a too big of a number, say like 600 billion or something, you may get incorrect. Yeah, so you may have incorrections here. So this is showing you the data types problems. So I'm storing in an int. Int is only 8 bytes. I entered this huge number. That can't be stored in it. So when I go to print it out, it's printing out a completely different number, 184.298.154. That's because what I'm entering is bigger than an int. So you may want to consider, if you want this program to be even more precise and you want to enter larger numbers, to change some of the data types. Change the ints to doubles, or even the doubles to longs. Right? So this is saying 350 years and 127,000 days or so. So a nice little conversion app that, again, tries to provide you with some understanding of, data types as well as operators. We could have a lot of different conversion apps. Another nice app that you want to write for more practice would be a Fahrenheit to Celsius app. Write an app that allows the user to enter Fahrenheit and then convert that to Celsius. I mean, there's many, many different scenarios you come up, but this will force you to use the operators. And we could also even do a casting here if we wanted to. If we didn't like that the days was too precise, and maybe we want to change the double to an int, and we want to make it a little less precise, we could actually say cast this to an int by just providing the parentheses and then doing an int. And this would actually take that number for days, and if it's decimal, 3.549 or something, it would convert it to 3. Maybe that would be better for the user. Up to you. But let's keep it for now as a double. But that's how you learn. You play around with the program, try different scenarios, try different input, make sure that everything's correct. Thank you. Hello and welcome. Let's talk about bitwise operators. We showed you a little glimpse of this in the previous lecture when we talked about assignment operators, because assignment operators have all these compound assignments where you can perform an operation like an addition and then also assign. You can do the same things with these type of operators. But let's go into these in more detail and exactly tell you what they are. So C offers bitwise logical operators and shift operators. Those terms might be completely clueless on. They look like logical operators, but they're quite different. They don't do any kind of Boolean evaluations. They don't evaluate to true or false. They're not. They kind of look like the ampersand, the two ors, but they're not doing any kind of Boolean evaluation. What they're doing is they're operating on bits inside integer values. And so you may ask yourself, why the heck would you ever want to do this? Well, it's not used in most programs. It's more of an advanced technique. Even though this is a beginner class, they are part of the operators, and operators are a beginner concept. So I'm going to address them, but we're going to not necessarily focus on them a ton. I'll give you some examples, show you how you can use them, but you're not going to be an expert in this after this lecture. But the way that they're useful and why you'd actually want to use them is because you can store quite a bit of data. So there's bitwise operands called and, ampersand, and the bitwise or, which is an or, just a single parallel bar. Try not to get these confused again with the logical operators. Logical operators have two of them. Ampersand, which is an and. The bitwise operators just have a single. So just an ampersand or just an or. And so what they're going to do is they're going to test and they're going to set individual bits inside of an integer variable. What is a bit? Right? We know a bit is a way to measure data. But a bit is essentially just a 0 or 1 value. And 8 of those make up a byte, right? So a bit is a 0 or 1. And what you can do is an integer, remember, depending on the system you're running, could be 8 bytes. And so you could turn on and off each bit. And when I say turn on or off, I'm saying you can either have them be equal to 1 or 0. And then you can use those bits to tell you something. So you can store a lot of data by having bits represent some kind of data. And that's why one of the reasons why the computer uses bits and 1 and 0s and binary numbers to do operations, because you can store a lot of data. Now, exactly what this means is, here's an example, okay? You could use a single integer variable. Again, an integer is a number. An integer represents 4 to 8 bytes, depending on what system you're running. That means if there's 4 bytes, that means there's 32 bits. There's 32 zeros or 1 values. All right, so you can use all those bits to represent something. So, for example, if you want to store individual characters of a person, you could just have 1 bit tell you whether or not the person is male or female by saying 1 is equal to male, 0 is equal to female. You just either turn it on or turn it off. Then you could use 3 bits to specify whether the person can speak French, German, or Italian. So the 1 bit could represent French. If it's not 1, 0, then that means they don't speak French. If German is 0, that means they don't speak German. If it's 1, it means they do speak German. So by turning off and on these bits, setting them 1 to 0, you can represent a lot of data. You could have another bit to record whether the person's salary is $50,000 or more. If it's 1, it's true. Yes, it is. 0, false. So basically, we just specified here, it actually says 4, but we actually specified 5 bits of data. Only 5 out of whether or not we have 32 or if we have 64 bits, but we only used 5 and we're able to represent whether or not a person is female or male, whether or not they speak French, German, or Italian, or all 3, or one or the other, and whether or not they're making more than $50,000. We can represent all that data in our bits. And these is where the bitwise operators come in handy. Now that we know how we can use bits to store a lot of different data, let's talk about those binary numbers. We know that a binary number is just a number that includes 1s and 0s, and that's why it's advantageous to use bit operators in an integer. The number can be of any length. The following are examples of binary numbers, right? Just 0s and 1s. So you've seen this: 0, 1, 0, 1, 0, 1, 1, 0, 1, 0, 1, 0. And remember that a byte is 8 bits. An integer is usually 4 bytes on most platforms. It depends on the architecture, but mostly 32 bits. So you have 32 values that you can store with 1s and 0s to indicate on or off. Binary numbers, again, every binary number has a corresponding decimal value, so you need to understand how to convert binary to decimal. Examples here, 1 is equal to 1, 1 0 is 2, 1 1 is 3. These are simple conversions. Again, usually they have more bits. 1 0 1 0 1 1 1. The way that you want to convert the binaries numbers to a decimal number is you want to look at each position in the byte with the bit, corresponding bit, and then use the power of 2. So for each digit, you multiply the digit by its position value using the power of 2, and then you add up the entire project to get the final result. So position values in a binary number are the powers of 2. So the first position would be the value 2, 0, which in other words would be 1. All right. And then the second position would be the value of 2 to the first power, which is 2. 2 to the 2 would be 4. 2 to the 3 would be 8. 2 to the 4 would be 16. And you keep doing that over and over again. And so it's easier to understand if you see a nice example. And so here we have a binary number of 0, 1, 1, 0, 1, 0, 0, 1. The decimal equivalent of that is 105. The way that you convert it is you start on the right-hand side for each bit, and you multiply to the power of 2 depending on if the bit is 0 or 1. So if we start all the way to the right, we have 1, so we say 1 times 1, and we keep that 1. Then the next one, the second position, is 0 times 2, 0. And then 0 times 4, 1 times 8, 0 times 16, 1 times 32, 1 times 64, and 0 times 28. And you add all those up, and you get the result of 105. That's one way to convert it. You can actually convert it left to right as well by multiplying by 2 and then adding 1 or adding 0 depending on what the next bit is. So for example, you can also, if you go left to right, you can say you start off with 1 because 0 doesn't matter. So the second bit going from the left to right, you have 1. The third bit you have 1 times 2 plus 1, so you have 3. Then again, you multiply by 2, so you say 3 times 2 plus 0, which is 6. 6 times 2 plus 1, which is 13. 13 times 2 is 26. 26 times 2 is 52 times 2, which is 104 plus 1. So again, multiply by 2 and then add 1. Another example, again, the right to left is usually a little bit easier. Here's 1 0 0 1 1 1 0 0. And that converts to 156 because you say, again, 0 times 1, 0 times 2, 1 times 4, 1 times 8, 1 times 16, and so forth. And then you add all of them together, which is 4, 8, 12, 16, 28 plus 128 is 156. And again, if you go left to right, you multiply by 2, add 1. So we start off at 1, say 1, 2, 4, 9, 4 times 2 plus 1, 9 times 2 is 18 plus 1 is 19 times 2. 38 plus 1 is 39 times 2, which is 78 times 2, which is 156. So this is a quick demonstration of how you can convert binary to decimal. Now, converting decimal to binary, I usually just use a conversion on the web if you're really interested in that. But you can take these binary numbers and then perform bitwise operators. So let's take a look at the bitwise operators. So the bitwise operators are summarized here. And again, another nice table I got online, but they look similar to logical operators, but again, don't confuse them. So the ampersand by itself is a binary AND operator. And so what this is doing is it's copying a bit to the result if it exists in both operands. So if both of them are true, then it's going to copy a bit. So if A and B is equal to 12, you're going to have a binary representation of 0, 0, 0, 0, 1, 1, 0, 0. So A and B would be that number. We'll go through some examples. A binary OR copies a bit if it exists in either operand. Okay, so A or B will copy a bit if it exists in either operand. So if either operand is equal to 1, it will copy a bit. And then the binary XOR, this is the exclusive OR. This will copy the bit if it is set in one operand but not both. So if you have a true but only one true, and you use the caret to represent this on your keyboard, then it's going to set, it's going to copy a bit and it's going to say it's true. Binary one's complement. So again, we're getting the binary data here because we're talking about bits. So hopefully 1's complement operator is unary and has the effect of flipping the bits, basically just negating them, taking the amount off. So an example here was if you say tilde A, you're applying the 1's complement operator. And if it's equal to negative 61, it will be 1100001, right? So if you were to actually convert that binary number to decimal, which is negative number, and the first number is the sign. So 1 tells you that it's a sign, and then you say 1, 2, 4, 8, 16, 33, 33, and then 61. So that's how it would be represented. So I'll go through more concrete examples of this, but basically, if you have a binary number, A is initially a binary number that's 00111100, which is 60, and you supply the flipping, basically, it's going to then turn into negative 61, which is 110000000011. Right? So these are the results of variables that are actually set. So if, again, I'm assuming that A has certain binary representation and B has a certain binary representation. So if A is equal to, again, 60 and B is equal to 13, then the result of ANDing them together, doing a bitwise AND, is going to be 00001100, which is 12. Again, I'll go through these examples, but this is trying to provide a little description of these different binary operators. The greater than symbol is going to, the less than symbol is going to shift bits to the left. So the left operand value is moved left by the number of bits specified by the right operand. So if you do something like A less than 2, and A is actually equal to, some binary number, for example, like 00111100, you're going to shift the bytes by 2. So you're going to take off the zeros and it's going to become 1111, and those zeros are going to go to the end. And the same with the right shift operator, you're just shifting them to the right as opposed to the left. Here you use the greater than symbols. And so I'm going to go through these in a second. The other important thing to understand with the bitwise operators is how do you evaluate these A and B values, right? So what does a 1 and a 1 evaluate to? A 1, if it's an ampersand. If it's an OR, 1 and a 1 evaluates to a 1 as well. But a 1 and a 0, if you're using an ampersand, doing an AND, that evaluates to 0, false, right? So I just wanted to provide a little truth table here that shows you the values when you do and use an AND, an OR an exclusive OR. So here, if you have P0 and Q0, which means they're both false, and you apply an AND, it's going to be false because they both have to be true for that to be true. And that's what you see in row 3. If they're both true, then P and Q is going to be evaluated to 1, true. If they're not both true, it's always false. P or Q, only one of them needs to be true. So that's why you see rows 1 and rows 2 equal to 1 and row 3 equal to 1. The only time it's false is when they're both false. And then the exclusive OR is at least one of them is true and only one. Right? So if P is false and Q is true, it will return 1, true. And if P is true and Q is false, it will return 1. So this gives you an idea of how it's evaluated. Again, a lot of math stuff, but when we talk about binary digits, that's what we're talking about. So let's look at some examples, concrete examples in code blocks. Hopefully this will help a bit. Okay, so here's our function. I'm going to create a couple more variables. I'm going to make sure that they're unsigned, even though that's by default. So if I say unsigned int A and assign it to 60, that's actually going to be represented in binary as 0011 and then 1100. If I create another unsigned variable and I say int B and I assign that the value of 13, that's going to actually be represented as in binary as 00001101. You can do the conversions there. But what I want to demonstrate here is that when you set these binary numbers up, you can turn off the bits by using the different bitwise operands. Okay, so now then I'm going to just create a int result, and I'm going to say that's going to be equal to 0. Z is going to hold the result of the bitwise operation. So now if I say C equals A and I apply the bitwise amperand and A and B, now what that should do is if A is equal to 1 and B is equal to 1 that bit's going to be turned on, right? So what would you expect the result of this be? Well, you look at the first bit of A and you look at the first bit of B, and they're both 0. So the result is going to be 0, because if you do a true, an A and a B, they both have to be true in order to be 1. So the next one is also going to be 0. The next one is 1 and 0, the third bit. So that's still 0, 1 and 0, still 0. And then now we have a 1 and a 1. So now we finally have a true. We have another 1 and a 1. We have a true. And then 0 and 0 is going to be 0. And then a 0 and 1 is going to be 0. So the result, if I were to try to print out C, it's going to print out the value in decimal format. If I were to do something like that, the result is it's going to print out the decimal equivalent of that binary number, which would be the equivalent of 0000. And this is all converting binary to decimal, so you need to understand how to do that to understand this example. But 00001100 is actually 137. That's the value is actually is 12. 13612. So this would print out 12. Right? If I were to print out C, or result would be better. So if I run this, you're going to see that the value is 12. It actually turned off and on all the bits based on the ampersand comparison. So now I say run. We see that the value is indeed 12. Because it's turning off and on the bits, and it's going to actually be represented as 0001100, which is the value 12, because we're printing out its decimal. If I were to change this, and I want to now do an OR, and I'm still doing the OR, and the OR, remember, is the parallel bar right next to the enter. Now I'm only going to turn on bits if either one is true. So 00, both of those are false. Again, I'm comparing up here, right? I'm comparing these bits for 60 and 13. 60 is represented as binary 0011, 1100. 13 is represented as binary 0000, 1101. Each one of those numbers represents a bit. So the first bit in 60 is 0, the first bit in 13 is 0. And if I OR those together, 0 and 0, I'm still going to get 0. So that's the first result of the first bit. Second bit, 0, 0 again. Third bit is 1 for 60, and it's 0 for 13. Now, all that means is I have to have 1 true, so that's going to be a 1. Same goes for bit number 4 in 16, 13, so now I have a 1 again. And then a 1 and a 1, they're both true. So again, 1. All I need is 1 true. Another 1. Both false, so that's not going to be true. 0, remember, is not true. 1 is true. And 0, 1, 1. So now I have 0, 0, 1, 1, 1, 1, 0, 1. And the value of that in decimal, if I were to print it out, is again, you have to understand how to convert binary to decimal, but it basically goes 1, 3. I'm trying to add these up, these bits as I go. 1, 3, 7, 15, 30, 61. So this is going to print out 61. Oops. End this program and rebuild it, and we're going to see a value of 61. And we do. So that's bitwise operators, and again, it's a more kind of advanced for advanced programs, but it's a nice way to represent a lot of data by using ampersands and so forth, by turning on and turning off bits, essentially. So if you didn't, you could play around with this. You could do the exclusive OR, which is the caret, right? The caret is above the 6, number 6 on the keyboard. You would see a different result. If you would add the tilde, that's just going to basically turn everything off. So for A, and A is equal to 60, 00111100, it's now going to be equal to 11000011. Another really cool thing you can do with the binary operators is shifting, right? Shifting left and right. There's a couple key things you know when you need to shift left or right. First of all, we know that an unsigned int means that can only be positive. It can't be negative. So if you're storing a negative value in there, the compiler will convert it and it'll be longer, it'll take up a lot of size. So remember, unsigned ints mean that you can only have positive values. Signed integers mean that they can be unsigned or negative or positive. But if you want to shift, remember, in order to shift to the left, So now if we say result equals, and let's say we want to shift A, let's say by 2, right? The other important thing you want to know is when you have the integers, integers are, remember, they're 4 bytes on most platforms. It depends. You can get the size by doing the size of operator. So really, the integer is really 32 bits. So really the number is something like this 16, something like that. What is that? 4, 8, 12, 16, 20, 24. So you probably do something like that and something like that, right? That's really the number. I only showed the last 8 bits because the rest were zeros. But if you look at this as a 32-bit integer, which is 4 bytes, this is what it looks like in binary. 4 zeros, 4 zeros, 4 zeros, 4 zeros, 4 zeros, 4 zeros, and then the 0, 0, 1, 1, 1, 1, 0, 0. And so you kind of got to know the size when you do the shifting to left to right, because if you shift more than 2, it's not going to be clear. You don't have any, it doesn't drop off or anything like that. So again, let me just make sure 4, 8, 12, 16, 20, 24, 28, 32, right? And the same would go for 13. So if you were to shift to the left, A greater than 2, what you're end up going to have is these ones are going to shift to the left too. So what the result is going to be, still all those preceding zeros, but then you're going to have 1, 1, 1, 1, 0, 0, 0, 0, right? And that is going to be equal to 240, right? And if I do a quick conversion, I do it in my head by saying 1, 3, 7, 15, 30, 60, 120, 240. But we can convert that, we can confirm that by building and running. I want to make sure we spelled this unsigned correctly. And you'll see that the result is 240. And we see the result is 240. All right, so now if you want to actually shift to by more than 2, say you want to shift by 4, this is when it becomes important to understand that it's a 32-bit number. Right, so here you would actually have to use some of those zeros. So if you want to shift by 4, really what you would have is you would just have something like that. And then, if you want to group them by 4, you'd have something like, like that. Right? And so the result here would be, again, if I do this in my head, you have 1, 3, 7, 15, 30, 60, 120, 240, 480, and then 960. Hopefully I did that right. Again, when we run this and we say 960. So that's shifting to the left. If you want to shift to the right, use the greater than symbols. So shifting to the right, binary right shift operator, you do the greater than. Binary left shift operator, you do the less than. So here, if you're going to shift to the right, you want to move to the right 4. And what happens if you have the end here, so if you have your original 60, you try to go 4, you're going to have digits that just get dropped off, right? So instead of having, these last 4, which originally, again, we have 60, so we have 0, 0, 0, 1, 1, 1, 1, 0, 0, we have to move over 4. So we're going to end up losing 2 bits because they're just going to drop off, and what we're going to end up with is something like this, 0, 0. And so this would just be equal to 3. Something like that. So you actually lose bits because you're shifting to the right too much. Let's see if we can run this. And you have the result of 3. So you have to be careful when you shift left and to the right. Make sure you use those 32-bit bits, 4 bytes, again, depending on your system. It's a quick summary of bitwise operators. You would also need to, when you get more advanced, you'd have to understand how you can actually check if a particular bit is 1 or 0. It's pretty simple. You just do an AND on it, but you do have to write a little bit more code. This lecture was not intended to be an exhaustive look at bitwise operators. I wanted to give you an overview, give you a good head start on it, but in order to understand these operators more, you're going to have to study quite a bit more and use them and practice them. So I hope this was helpful. Again, it can get a little confusing, so you want to follow and you want to play around with it. But again, what's the best way to learn? Write some code, learn some examples. Thank you. Hello and welcome. In this lecture, I want to talk about a couple operators that are a little bit strange in the sense that you wouldn't necessarily think they're operators, because all the operators we learned up to this point really just point to, sort of using the symbol to do calculations on numbers. And these operators actually sort of look like functions. So let's talk about the cast in the size of operator. In order to first talk about the cast operator, I have to tell you a little bit about type conversions, how data is being converted. We learned all about data types and different data types out there. But if you're actually trying to assign data to different types, there's some implicit conversions that go on in the C programming language. So conversion of data between different types can happen automatically, and this is referred to as implicit conversion, by the language or explicitly by the program, by the programmer. The programmer itself, the developer, can do something. They can use a cast operator essentially to do a conversion. The data that's being converted implicitly is really important because you have to understand this, because most C programs that you're going to develop, in order to effectively develop them, you have to understand these rules for these conversions. Because you're going to often have integers and floating point numbers, decimal numbers and whole numbers, and you're going to be using them, intermixing them kind of sometimes. And when you do, you have to know how things are being converted. Now, you should try to avoid that as much as you can by using the cast operator. But when you don't use the cast operator, understand what's going on. And what's going on here, when you assign data to different types, floats and doubles, the data is either going to be truncated or it's going to be promoted. These are two terms that you're going to hear. Truncated means it becomes less precise, and promoted means it becomes more precise. So try not to mix these types, but they may be useful. The main thing to understand is we know from earlier lectures that C is very flexible. And that's a conscious decision by the designers of the language when they wanted to have it flexible, but again, as a trade-off, as this additional freedom is given to you, you can abuse it. And so don't abuse this idea of mixing types. Try to use the same types when you can, integers with integers, floats with floats, but when you can't, either understand the implicit conversions or do the explicit conversions using the cast operator. So again, another issue or another concept where C is flexible, but you shouldn't abuse it. So whenever a floating point value is assigned to an integer variable in C, so you have int x, float y, x equals y. The decimal portion of the number is going to get truncated. So if you have a number, int x equals 0, float f equals 12.125, and you assign f to x, the value of x is going to be 12. You're going to lose that precision. The value is going to get truncated because you're assigning a float to an int only knows how to store a whole number. So it's automatically going to get converted by the programming language, by the compiler, to 12. Only the int portion is going to be stored. Now, if you assign an integer variable to a floating point variable, which is the opposite, it doesn't cause any change in the value of the number. The value is converted by the system and stored in the floating point variable. So that you don't really have to worry about assigning it into a float. If you assign 12 to a float, it's still going to be 12, just 12.0. When you perform arithmetic on integers, and so this is different than just assigning values, assigning it into a float or a float to an int. This is when you have an expression, you're doing some addition, some subtraction, whatever the case may be. When you're doing a subtraction or an addition, you have two operands. And so one operand can be an int, one operand can be a float. You have to know how that what conversion is happening. So if you have two operands in an expression and they're both integers, then any decimal portion resulting from a division operation is discarded. Right? So if you have an integer x, it's 20. You have an integer y, it's 12. And you do 20 divided by 12, you're not going to get 1 point something. You're just going to get 1. It's going to discard all the result and put it in an int. Because again, an int only stores a whole number, right? So two numbers are ints and they're doing division. You're not going to get a floating point number. You're not going to get a decimal number. Now, if one operand is an int and the other is a float, then the operation is going to be performed as a floating point operation. So if you have float f is 20.0, float a is 10.0, or 10, just an int, then if you do a division there, or 12, I'm sorry, that'd be more applicable, then the result is going to do a floating point number, and the result is going to be 1.8888 or whatever it is, whatever the case may be. Right, you're not assigning this data to anything. This is an expression. What is it going to return? So 2 ints in a division, it's going to be a whole number. An int and a double or float, it's always going to be a float. It's always going to be a decimal floating point operation. And this is the implicit conversion. That's really what you need to understand what's going on and done for you by the program if you don't do anything. However, you should try to do some explicit conversions, which is you can do with the cast operator. And this is just referred to as casting more or less. And you see casting in many languages when you want to convert. And all it is you're doing an explicit conversion. You're saying what you want the data to be. So you want to do this if you can, because otherwise code or data might get demoted. It might get lost. All right? If you do 2 ints and you're doing division and they're not divided equally, you're going to lose all that data. So it's possible for you to demand the precise type conversion that you want by explicitly specifying it. This is called a cast, and it consists of preceding the quantity with the name of the desired type in parentheses. All right, so parentheses and type name constitute the cast operator. You do a left parentheses, and then you specify the data type, and then a right parentheses. And that's going to convert whatever is to the right of it, whatever the expression is to the right of it, or even if it's just a single variable, it's going to convert that to whatever inside the parentheses. So the actual type is desired, such as a long, it's substituted for that word type. So the type cast operator has a higher precedence than all arithmetic operators, except the unary minus and unary plus. We haven't learned about precedence yet. We're going to in the next lecture. Precedence is basically what happens, the order of the operations that are performed. So we'll provide some examples of that. All you have to understand at this point is that the typecast operator takes precedence over every other operator, except 2, unary minus and unary plus. So here, example, we have a number 21.51, and we have the cast operator, because we know it's a cast operator because it's in parentheses, and it has a type. And what we're basically saying is, take 21.51, convert it to an int. If you take a floating point number, convert it to int, it just becomes the int, the whole number, 21. Same it's doing on the right-hand side is converting 26.99 to an int. So what would actually happen here if you did this expression in a statement, it would evaluate as 21 plus 26. It would truncate the data from 0.51 to a whole number, and the same as 0.99. And so that's the cast operator. Anything inside parentheses that contains a data type. You'll see this a lot. If you were to say 21 plus 26 and you cast it in the floats, it would just add a .0. Usually, you don't cast to a more precise type because you're not going to get more precise. You cast from more precise type to a less precise. So more of like a float to an int. So you'll see this throughout some programs occasionally when you're using different types. You should try to avoid using different types if you're doing arithmetic, but if you do, you'll see this. The size of operator, another operator that's kind of strange, not similar to a lot of the other ones. And this actually looks just like a function. But the size of is an operator. It performs an action. It's not doing anything function oriented. What it's doing is it's telling you how many bytes are occupied in memory by a given type. So it looks like a function because it takes an argument. And we're going to give an example of that, but it's just going to return the number of bytes in memory. Remember that depending on the system that you're running, the platform that you're running, the operating system, the architecture of the computer, the hardware, different data types are going to be represented in memory with different sizes. For example, an int might be 4 bytes on one system, 8 in another. So what you can do is you can use the size of operator as a special keyword, an operator in C, and you can pass in a data type and it will tell you how many bytes it's using in memory. So size of is actually an operator. It's not a function. It's evaluated at compile time and not at runtime unless a variable length array is used in its argument. And so we'll mention that. This is basically saying that if you have a variable that's inside of the size of an array, it's not going to be resolved at compile time, at runtime. So not that important to know. The argument to the size of operator can be a variable, an array name, the name of a basic data type like int float, the name of a derived data type, anything, or an expression. So you could say size of x plus y. And that's basically just going to say the size of x plus the size of y. Or the resulting number, right? If x is an int, y is an int, and it's size of 16, it would say this is an int, 4 bytes. If one was an int, one was a float, and the result was floating point arithmetic, then it'd be, float is 8 bytes or something. But you can use it for many things, and you should use it for many things. Size of int, for example, will result in the number of bytes occupied by a variable of type int. So this would return 4 or 8 depending on your system. You can also apply the size of operator to an expression. As I mentioned, the result is the size of the value that results from your expression. So if two ints together, it's still going to be an int. So it's still going to be a size. But you'll see the size of operator also being used when we talk about pointers. I wanted to talk about this now because it's an operator, but we're going to provide many more examples of this and casting throughout the class as we talk about more concepts. Specifically, the size of operator comes into play a lot more when we talk about pointers, because when you're calculating how much memory to allocate, which is what pointers are, you use size of because you want to be precise. But you can use it for other things as well. So use the size of operator whenever possible to avoid having to calculate in hardcode sizes into your program. Hardcode sizes, magic numbers, are not a good thing because, again, if you're on a different system, if you were to hardcode 4 on one system for an int, on the other system it might be an 8. So use size of as much as you can, and we'll see this come into much more relatability when we talk about pointers. Other operators that are a little strange are the asterisk operator. This is, you may have said to yourself, asterisk, we've already talked about this with multiplication. But that asterisk takes two operands, one on the left, one on the right. If you apply the asterisk operator to a variable and you just say star variable name with only one argument to the right, it represents something else. It actually represents a pointer. It's dereferencing a pointer. And again, I'm not going to harp on this now because we're going to go through this when we talk about pointers. But if you see something like star A, don't freak out. That's actually valid. That's doing the asterisk, the pointer operator. You may also see the question mark colon. This is an operator that's used for decision making. If the condition is true, if the thing to the left of the true is true, then the value to the right after the colon is evaluated and so forth. Otherwise, it's a shorthand notation for an if-else statement. It's a ternary operator, it's called. But again, I don't want to really discuss these in a lot of detail now because we're going to talk about these when we talk about our specific subjects. We'll talk about the ternary operator when we talk about decision statements. We'll talk about the asterisk operator, unary, when we talk about pointers. But if you see this right now, and I wanted to mention now because they are technically operators, but we'll understand their use cases when we talk about those concepts. Thank you. Hello. I want to provide another challenge for you for this operator section. Mainly, I want to demonstrate the use of the size of operator. So let's start in describing the requirements. In this challenge, I want you to create a C program that displays the byte sizes of basic data types supported in C. Right. So the reason this challenge is kind of cool is because I keep mentioning, but maybe it hasn't stuck in your head that depending on the actual system you're running on, whether you're a different operating system or different architecture hardware-wise, you may have different memory sizes for the various data types. Int may be 4 and it may be 8. Doubles may be 8 or 16 or whatever the case may be. And it's very important to understand that. And if you start hard coding numbers, it's going to cause problems in your program. So you want to use the size of operator. Now you don't necessarily have to worry if your program is running on a certain system. It's always going to work the same. Okay, so this challenge kind of demonstrates that. It forces you to use size of. Now we're going to be using size of operator a lot more when we talk about pointers, but this will get you a little challenge. It'll get your hands a little dirty with this operator and also get you more familiar with some format specifiers related to this operator. So again, depending on the system you're running, the output might be different for this program. But you're to write a program that displays some basic data type sizes. It's pretty simple. Shouldn't take you that long. But what I want you to do is use the printf function to display the byte size of the following types: int, char, char, long, 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 double, long, double. And the usefulness of this program will be to run it on multiple actual computers to see the differences. But when you print out this data, you can use the %ZD format. This is, I think, supported in C99, so you should be good. But this format specifier will help format each size and print it out correctly. Other than that, this function or this program is really just going to use the size of operator and demonstrate how sizes vary for memory for different data types. Again, the key will be to test this on more than one computer to see the differences. But this program should not take you that long. You don't even actually have to create variables if you're clever. You can just use the printf statements themselves and see. This is more for your knowledge on the size of operator. In addition to these challenges, definitely do more challenges on using the operators for converting different types. You know, there can be all sorts of conversion. I mentioned the Fahrenheit to Celsius, but you could come up with conversions for converting any type of data set. Or just go into your math book and look for different equations and try writing programs for them. That will also help you get familiar with some of the different operators in C and how they're supported and how they're used. But good luck on this one. Again, it shouldn't take you long. I'll provide a quick solution in the next lecture, show you how to do this, but pretty straightforward, just using the size of operator. Hello and welcome. In this demonstration, I want to provide a solution to a quick little program that will use the size of operator to tell us how big our memory is for certain data types. Let's bring up code blocks. And we're going to do very familiar steps here with creating a project. And we're going to get a meaningful name. Let's call this project size of example. So let's see, size of example. And I selected the wrong thing. Let's go back. Thought something was a little strange there. Okay, and this is going to be pretty easy, really. It's just going to be using printf statements to display certain data types. So I'm just going to not even create any variables. I'm just going to print out some data. So here I'm going to say variables of type char occupy percent. And I was going to use a certain data type. I think it was ZF, but let's try using ZD. This is a nice format specifier. It was added in C99, I believe. ZD, and then all we have to do is use size of, and again, it looks like a function, but it's not, and then say char for character. And then I'm just going to copy this and paste it, because I'm going to do similar things. I'm going to not do a char, but I'm going to do short on the second one. I'm going to do an int. And a long, double, or let's do a float, double, let's try long double. And then all we have to do is modify the size of parameters to take the corresponding types. We'll be using this as well when we talk about memory and pointers. But this helps just to understand different data types. And you'll see that you can actually pass in space, long, size of. That's probably why it's not a function, because you can't have spaces in function parameters. But remember, the size of also takes, it can take variables, expressions, all sorts of things. And when it does that, it actually determines the size of at runtime as opposed to compile time. And long double. Let's save that. Build. No errors. You might not understand. It looks like it doesn't understand the Z format. I think it's because it might not be in. So instead, let's change these to %use. For unsigned. All right, now let's build. All right, now we have no warnings. Typically when you're in build, you don't want to have any warnings as well. Warnings in the compiler are exactly what they say. They're warnings, so you'll still compile successfully, but a warning usually indicates a problem. So you want to clean up your warnings. And so I had a warning saying that a format specifier wasn't allowed, %Z. So I changed it and now I have no warnings. Try to clean up your warnings as much as possible because they can. The reason there are warnings is because they can cause problems. And one thing I did forget here that I just noticed is it's formatted incorrectly because I didn't add my escape character for line feeds. So it makes it very difficult to read. So let's add our \n after our %u. All right. Now this looks a little bit easier to read. Okay, so now it says variables of type char occupy 1. And I probably should have put bytes after this. The format's not good. Variables of type short occupy 2 bytes. Int 4 bytes, long 4 bytes, long 8 bytes, float 4 bytes, double 8 bytes, long double 12. It's pretty neat. You run this on many different platforms and you'll see those things change. So an easy program to write, but again, demonstrating some neat concepts. So you can go ahead, you can download this. If you have any trouble, try running it on different platforms. But this is all I wanted to demonstrate, just a little show of the different data type sizes. So on to the next section. Thank you. Hello and welcome. Now that we've talked about all the main operators, the fundamental ones, the weird ones, we have to talk about this little concept of operator precedence. So this comes into play basically when, how do you evaluate the order of these operators? So operator precedence determines the grouping of the terms in an expression and decides how an expression is evaluated. Now you really don't need to understand any of this if you use parentheses, which we'll get to in a second, but you have to understand this concept because it's part of the language. It's part of understanding the language. So precedence is going to dictate the order of evaluation when two operators share an operand. And this is going to become clear with an example. So, for example, the multiplication operator has a higher precedence than the additional operator. Certain operators are going to have different order of evaluations, right? So if you were to do a compound statement where you're performing many different calculations, for example, 7 plus 3 times 2, right? This can have multiple results. You have the addition and you're doing the multiplication. You need to understand, do I need to do the addition first or should I do the multiplication first? Because depending on what you do first changes the result. So for example, this x equals 7 plus 3 times 2, the result can either be 13 or 20 depending on the order of when you evaluate each operand. So the order of the executing the various operations can make a huge difference, and this is why you need to understand precedence. C provides specific rules for choosing what to do first. In this case, do I do the multiplication or the plus? Well, C is going to tell you what's going to happen. Now, ideally, if you wrap those in parentheses, you wouldn't have to, you would be telling it what to do. You would be making that decision. But if you don't put that in parentheses, the programming language is going to make the decision for you. So in C, multiplication is going to have a higher precedence than the addition operator. So what's going to happen is the result is going to be 13. Right? Now, you could either say 7 plus 3, which is 10, and then multiply it by 2. The result would be 20. Or you can do 7 plus 3 times 2, which is 7 plus 6, which is 13. So that's how you can have different values. That's ambiguous, right? Do you do the plus first, or do you do the multiplication first? Luckily, again, that's decided by the language. But you can see how there's two different results. 7 plus 3 times 2, or 7 plus 3 times 2. You see the pause there. Now C is going to do the latter. It's going to do the multiplication first because that has higher precedence. So it's going to do 3 times 2, which is 6, and then it's going to add the 7. So the result of X is going to be 13 because the star asterisk has higher precedence than the addition. All right? And so there are rules for every single operator. Which operator has precedence over the other? There's a precedence level. And multiplication and division have higher precedence than addition and subtraction. So they're performed first, for example. So whenever you include, now you can avoid all of this precedence and having the language decide for you if you provide parentheses. Parentheses will always group the expressions at the highest precedence. So if I say 7 plus 3 and I enclose that in parentheses, it's always going to do the addition first. If I say 3 times 2 and I enclose that in parentheses, it's always going to do the multiplication and then add whatever outside of the parentheses. So you should really just be using parentheses. Always use parentheses. Otherwise, the language is going to decide for you, and you're going to have to memorize all the precedence levels, which is hard to do, as I'm going to show you in the next table. There's a lot of different operators, and you have to know precedence for all these different operators. So it can become very, very confusing. This is similar to, either you let the language do an implicit conversion for you, or you do it with an explicit conversion with a cast operator. Same type of idea here. Just use parentheses. So if we look at this table, which we'll look at in a second, I guess, because I first want to talk about associativity. Associativity is related to precedence because what happens if 2 operators have the same precedence? Then how do you figure out the order? Well, then you apply associativity. So whenever operators have the same precedence level, then you apply additional rules. So associativity is basically whether or not you start on the left-hand side and go to the right, or right to the left. So if you share an operand and they're both executed in the same order, you're going to execute them in the order of the statement based on the associativity rule. So for most operators, the order is from left to right. So let me show you an example. If you say 1 equals 2 is not equal to 3, the equals and the not equals operators, exclamation point equals, have the same precedence. So in this case, we have an ambiguity. We have a problem. We don't know what to evaluate first. We don't know if we need to do 1 equals true, 2, or 2 is not equal to 3. Right? And it matters, right? Because you're doing a Boolean expression. This is a Boolean expression here. So it's got to return a true or false. So what you would do here is you would apply associativity. The associativity of both the equals and the not equals is left to right. So you're going to first do 1 equals 2. That's going to be false. And then you're going to say false, which is not equal to 3. Right? Which it isn't. So 1 equals 2, and then that's not equal to 3. So the result is going to be false. So the expression on the left is executed first and moves toward the right. So how you want to think of that is basically it's equal to these parentheses. First you're going to evaluate 1 is equal to 2. And then if that evaluates true or false, you're then going to say is that equal to 3. Right? And this is confusing because it doesn't have true or false values. But 1 equals, remember, that's the comparison operator. That's not the assignment operator. And we're not using variables here, so it's even more confusing. But if you were to put these numbers in variables, you would just be saying like if x equals y, so if x was 1 and y was 2, that would evaluate to false, because they're both not equal. And then if 3 was another variable, z, which is equal to 3, you'll say does x equals y is false, z is equal to 3, so false is not equal to 3, so it would be false. So 1 equals true executes first, resulting in 0, false. Then 0 is not equal to 3, executes resulting into 1, true. So I said false initially, but obviously 0 is not equal to 3, which the whole thing would evaluate to false. The whole thing would evaluate to true, I'm sorry, because 0 is not equal to 3. So 0 not equal to 3, I was saying is false because they're not equals, but that means that it's actually evaluates to true. So pretty neat there. Now, here's our table that says all of the precedence and associativity rules, and it's very hard to memorize this. So again, what do? You use parentheses. But here is the table. The highest precedence level is at the top, so the postfix operators have the highest preference level. And if you're using any of those in the same expression, then you read left to right. So the postfix operators, things like the parentheses are the highest precedence. So every time you enclose something in parentheses, that's going to take effect. But you have the brackets, and then you have postfix operators. We haven't talked about a couple pointer stuff, which is this dash greater than. Won't worry about that for now. But we do know now about plus plus and minus minus, which are postfix. Those have the highest highest precedence. Unary operators, things like the plus, minus, the exclamation point for not, the tilde for the bitwise, the plus, plus, and the minus, minus. And then the casting operator is referred to as a unary operator because it only has one operand. And then the asterisk operator is the pointer operator. The ampersand is the bitwise, and the size of. Those have the next highest precedence. But here, you're actually reading right to left to evaluation if you have two on the same line, same statement. And then again, we just go in orders. You have to know this order and memorize it. So pretty tough to do. But I did want to show it to you. Did just want to have a little illustration. It showed some of the tables and shows you there's a lot of operators, right? And so there's a lot of precedence levels, and there's the associativity for the most part, like we said earlier, is left to right. You only have the associativity of right to left for the unary operators. So the bitwise operators follow towards the bottom, all left to right. Conditional ternary operators right to left. Assignment operators are always at the bottom. That's always evaluated last. And it's always, and then if they're equals, other ones on there, you evaluate right to left. And then comma is also referred to as an operator. That's left to right. Another concept though, precedence and associativity that we're not going to really address without these other examples, we're going to end up using the parentheses all the time. And that's what you want to do. But again, if you want to fully understand the language, you want to understand these concepts. That's why I tell it to you. You know, no one can actually claim they know a language if they don't know some of the details like this. But use parentheses as much as you can. Thank you. Hello and welcome. We're starting a new section, and we're going to start talking about control flow. Control flow basically deals with conditional statements, if statements, and making decisions in your program, as well as repeating code, which is loops. So this is an important section. These are fundamental programming techniques used in most languages. We're going to talk about how they're specific to C. But to give you an overview, before we start talking about syntax and diverting into examples, I want to tell you what control flow means in terms of a program. So the statements inside your source files are generally executed from top to bottom in the order they appear. That's called sequential. Right? You have all these statements. We've learned about expressions inside the statements or outside, but you go from the beginning to the end. That's what we've learned so far. We've never jumped around. We've never done anything where we repeated stuff automatically, beginning to end. Control flow statements, however, will break up this flow of execution by adding things like decision making, asking questions essentially, repeating code, looping, and branching. This enables your program to conditionally execute particular blocks of code. So it's not going to just be start at the top of the main function, go to the bottom. You now may be going back and forth. You may be branching out, or you may be jumping in and out of blocks of code. So the code in the program is going to become a little more complicated. So things that we're talking about in terms of control flow, decision-making statements. This is where you ask a question, essentially, and then you receive an answer, a true or false answer. Things that are supported in C are the if decision statement, and then you have if else, and then you also have a switch statement and a go-to statement. These are all kind of decision-making statements. Go-to I put in here because it exists in C. You're probably not going to want to use it. I'll briefly talk about it. It's really just something that the programmer will hard code to a label. We also have looping statements that are supported in the C language. The for keyword, the while keyword, and the do while keyword. Those are the three types of loops. Loops will repeat code. And then branching statements are similar. They're usually used inside of a loop or inside of a decision. These are things like the break, continue, and return. So we're going to try to focus in this section, have specific lectures for decision versus looping, and then also talk about break and continue a bit. Again, a very important lecture. So decision making, what does this really mean inside of a program? Again, up till now, we've basically created variables, declared them, performed calculations, but we never really made any specific logic decisions. So a decision making concept is it will require that the programmer specify one or more conditions to be evaluated or tested by the program. What is essentially happening is you're asking a question inside the program. That's the kind of logic. And if the condition or the answer to that question is true, then you're going to execute some code, some statements. If the answer to that question is false, then you may execute other statements, or you may not do anything at all. So here's our little data flow diagram that shows you the concept of decision making in a program. You have this condition. Depending on the answer to that condition, whether it's true or false, you're going to either execute code or not execute code. It depends. It gets a little more complicated. But this is the basic structure of how you can make decisions in your program. And so what this means is, inside your source code, you may be skipping some code, depending on the answer to a question, depending on whether or not it's true or false. So the statements that are supported by C are the if statement. The if statement has a special keyword called if. We're going to talk about this in detail and give examples. But this statement is going to ask the question essentially. Inside the parentheses is going to be a Boolean expression. We know what Boolean expressions are. They're basically they can return a true or false value, a statement that returns a true or false value except in its expression. And it can have more than one or more statements inside the body of the if statement. You also have an if else. So this is an if statement that can be followed by an optional else. If it's true, do this. If it's false, do something else. And then we have nested if statements. This is when you have an if statement inside another if statement. So you may be asking multiple questions. And again, this is going to be detailed with specific examples and syntax. I'm just trying to give an overview at this point. As far as repeating code goes, which is again another control flow mechanism, because you're no longer again going sequentially, right? With repeating code, you're going to be executing the same code a number of times. So there may be a situation when you need to execute a block of code several number of times. The statements are executed sequentially. The first statement in a function is executed first, followed by the second, and so on. It all depends. This is kind of the block of the code of the loop body. So a loop statement allows us to execute a statement or a group of statements multiple times without having to actually have each statement repeated that many times. Loop control statements change execution from its normal sequence. When execution leaves the scope, all the automatic objects that were created in that scope are destroyed. Okay, so that's like when you, this is talking about scope with relation to variables, and basically saying that when you're in the body of a loop and you have local variables, you're not going to be able to access them outside of the loop. A loop becomes an infinite loop if a condition never becomes false, and that means that the loop will just your program will hang because you'll be executing code over and over and over, and you'll never actually exit. Sometimes you will need to do that actually. When you're monitoring something or you're listening for something. And the way to actually implement that in C is you would use a for loop most likely, but you could use a while loop as well. We'll talk about infinite loops and why you may need them and what that means in a later lecture. So the actual data flow of a loop looks something like this. You check a condition, and if the condition is true, you execute some code, and then you keep doing it over and over and over and over again until the condition evaluates to false. Once the condition evaluates to false, you exit the loop. The loops that are supported in C are the while loop, the for loop, and the do while loop. Special keywords. The while loop is repeats a statement or a group of statements while a given condition is true. So the condition is right at the top in the while parentheses. Condition is test at the top before it executes the loop body. Even though there's 3 different types of loops that are supported, you may use one more than the other. They're really only different. The while and the for loops are pretty much the same. They just have different syntax, and you can do more things differently. The do while loop is different because you actually have the test at the bottom, so you're always guaranteed to execute the loop at least once, the body of the loop. But again, we'll talk about this stuff. For loop, special keyword, executes a sequence of statements multiple times. It just has basically easier syntax. You can initialize the loop control variable and the conditions all in one statement. And then the do while loop, as I said, is a little different because it's a post-test loop, an exit control loop, which means that you're always guaranteed to enter the body of the loop at least once. And we'll also talk about nested loops. This is, again, just a loop inside of a loop, just like a nested for if statement is an if statement inside of an if statement. Same applies to loops. And we'll see how this is sometimes required and can complicate things. but it's essential for programming. Nice quick overview of the different control flow mechanisms, high level, and then some of the keywords that are supported by C to actually implement this. Now let's move on and give some examples and start talking about decision making. Hello and welcome. In this lecture I want to talk about decision making, specifically if statements. So the C programming language provides a general decision making capability in the form of an if statement. We know what statements are up to this point, so now we're just going to add a keyword in front of it and also put it inside parentheses. So what it looks like is something like this. If keyword, and then inside the left and right parentheses, you have something called an expression. We know what expressions are and the difference between statements. That expression has to evaluate to true or false. And then you have a program statement. And so this is the most simple kind of if statement. So if you say if expression and then the program statement, you could actually substitute that with some pseudocode, something like, if it is not raining, then I will go swimming. And if you translate that pseudocode into C, pseudocode is like not real syntax. It's a way of describing something in code in the English language. And so if we say an if statement in C, all you would do is you would put the condition inside the parentheses, it is not raining, and then after the if statement, either a single statement or multiple statements. If you have multiple statements, you would put them inside curly braces. But in this case, we have one statement, so inside the body of the if statement is I will go swimming. So it has to not be raining in order to execute I will go swimming. This is why it's in the control flow. You're not actually always executing I will go swimming. It depends on the condition and if it's true or false. So you may be skipping over code in this case. So you don't have a sequential process. So the if statement is used to stipulate the execution of a program statement based upon a specified condition, a decision-making capability. So you're only going to go swimming if it's not raining. You're only going to execute the code in the body of the if statement if it's not raining. The curly brackets are required for compound statements inside the if block. So for example, if you were to say, if it's not raining, I will go swimming, or before you go swimming, you will put on your bathing suit, you will get dressed, and then you will go swimming, then you'd have to put those curly braces in there. And again, we'll have specific examples that show that. But the curly braces aren't required if you only have a single statement. They're optional. You can provide them or not. I usually provide the curly braces in all my if statements just for consistency. Here's an example of a common if statement in the C programming language. In this case, we're declaring two variables, one named score and one named big. Score is 95, big is 90. Here we have an if statement, just a simple statement in the body, and it has no brackets. And basically we're saying if score is greater than big, score is 95, so if 95 is greater than 90, it's a Boolean expression. It's going to evaluate to true in this case, so what's going to be displayed to the screen is jackpot. And then we have that same example, except we use the curly braces because we have more than one statement in the body of the if statement. So in the bottom example, if score is greater than big, we have a left curly brace to start the block of the if statement, and we have an ending brace to end the block of the if statement. That's referred to the body of the if statement. And so in this case, we have two statements. We're going to first increment the score by 1, and then we're going to display you win. So notice the difference here. Brackets versus non-brackets. You can still put the brackets in a single statement. They're optional. But if you have multiple statements, the brackets are required. The left bracket signifies the starting of the block. The right bracket signifies the ending of the block. If statements are pretty simple when they're just a single if. If keyword, parentheses, left and right, inside the parentheses in an expression. And when if statements get more complicated, those expressions can become multiple expressions. So you can start using some of the logical operators we learned about in terms of we can use the and or the or. So if score is greater than big and something else is required. So we can have multiple questions in a single if statement, or we can break them down. But this is a basic if statement example. Again, syntax pretty basic. You don't see any semicolons at the end of the if statement. They're only at the end of the printfs. Right? So you just have the ending and starting brackets. Now, you can also add an else clause to your if statement. This is supported by C. So you can extend it a bit with a small addition that allows you to have a lot more flexibility. So, for example, If we were to say, if the rain today is worse than the rain yesterday, I will take my umbrella. Else, if it's not raining as bad as yesterday, I'm going to take my jacket. So the else is saying what happens when the question to the answer is false. So else, I will take my jacket, then I will go to work. So this is exactly the kind of decision making the if-else statement provides. Do something when it's true, also do something when it's false. So you have the if keyword, and then inside the parentheses you have your Boolean expression, something that evaluates to true or false. Then you have your statement that gets executed, statement 1 if it's true. Else, you use the else keyword. It's optional. You don't always need to provide the else. Only if you want to do something if the Boolean expression is false. You say statement 2. And again, in this case, we don't have any brackets inside the body of the if block or the else block because we only have single statements. If we have more than one statement inside either one of those bodies, we have to provide a bracket for starting and ending. So here's an example of an else statement with an if. In this case, we're going to determine if a number is even or odd. Okay, so we have our main function. That's where we enter. And we create a couple variables. One is called number to test. One is called remainder. They're both of type int. We're declaring them on the same line by separating with commas. We didn't initialize them yet. On the next line of code, we're going to print out some output to ask the user to enter some information. We then use the scanf function. We're reading in an integer so we can do %i or %d. And we're not reading a string or any words, so we're going to put the ampersand in front of the variable where we're going to store the data. So the user is going to enter something, a number to test, and then we're going to also get the remainder of whatever they entered by 2, because that will tell us whether or not something is even or odd. If you can divide a number by 2 and the remainder is 0, that means it's an even number. Otherwise, it's odd. The important part of this program is the bottom, where we're using the condition. Up until this point, every single line has been executed. But when we have an if statement and a condition inside the parentheses, if the remainder equals 0, and you'll notice that you always have to use the equals for comparison. You don't use equals. Remember, equals is for assignment, assigning data to a value. Equals is for comparing numbers. We're comparing a remainder variable to 0. And if it's 0, we're going to print out even. Else, the else keyword is on that next line, we're going to print out odd. You'll notice there's no brackets in the if or the else because there's only single statements. Let's run this and see how it works in code blocks. Well, here's our program. It's described as I just mentioned it, the exact same way. We're just going to print out even or odd. So let's go ahead and build this. And we want to make sure we don't have any errors. We have a couple extra line feeds here. All right, now when we run this program, we're just going to basically be able to have output for even or odd. It's going to ask us a number to be tested. I'm going to enter 33, which is odd. It's going to say the number is odd. So it's a pretty simple program. The important thing here is that you're not executing certain code. You're either going to execute line 19 if the remainder is equal to 0. If it's not, you're going to execute line 21. And the brackets, again, are optional. You can put those in there, and the IDE will do some automatic completion for you, which is pretty nice. But again, I usually like to add them because they are easy. And it makes code even more readable. It depends on your formatting style. You can actually, some people like to have the bracket on the beginning of the else statement like this. Some like to have it on the other line. Depends on how your format. And actually this can be done for you automatically in the IDE by formatting the code. But this works the same way, and it's almost even more clear to easier to read. And if you ever have to add more statements, you easily add them, and you don't have to worry about adding the brackets. So I get in the habit of adding the brackets. Again, the other important thing here is this equals. You can't do equals. If you were to do equals and run the program, you would see there's a big difference. So a very simple if-else statement, very, very useful. You're only going to execute line 19 if the remainder is odd. Otherwise, you're going to execute line 22. Let's talk a bit more about an else-if statement. So you can also have an else-if. So we've learned about if, we've learned about else. You can handle additional complex decision making by adding an if statement to your else clause. So it's like asking an additional question. You're not actually going to execute something if the condition in the original if is false. You're going to ask another question. So you say if expression 1, you have some code that's going to execute if it's true. Otherwise, you say if after it, which is perfectly legal. This is an if statement inside of an else statement. Then you execute program 2, else you execute something else. All right, so this extends the if statement from a 2-valued logic decision to a 3-valued logic decision. Here you're asking 2 questions, and if the question to the first answer is true, you execute program statement 1. Then you ask your second question only if the first question was true, or if the first question was false. And if that's true, then you execute some code, else you execute something else. So you have 3 branches here essentially, 3 separate lines of code that may be executed or may not be executed. Program statement 1, program statement 2, or program statement 3. You can rewrite this code to use an else if. Right now the if is on the separate line, but you can actually just do something like this. If expression 1, do something, else if. You don't have to put it on a separate line. It can be a single line, and then you can have an else outside of that. The only thing tricky about this is that else clause is going to get executed. And this is the same thing, right? So this else clause is going to get executed for all 3. So it's a little confusing in the first example because it looks like the second else is only being executed if the other if is false, but it's really being executed if the first expression is false as well. If you would have brackets in there, you could have actually nest those if statements, and the outer, the last else, would only execute based on the question of the second if answer. But we'll get into nesting when we talk about nested if statements and nested loops. Nested if statements are just putting an if side in an if, and you have to be careful where your else clause is, because the else has to be corresponding to the last if statement. Here's another example where we're going to actually try to implement the sign function. We're going to return either -1, 0, or 1. So this is a 3-tiered evaluation here. What this program is doing in the main routine is we're creating a couple variables of type int, number and sign. We're having the user enter a number, and we're storing it in the number variable. And if the number is less than 0, the sign is going to be equal to -1. Else, if the number is equal to 0, it's going to be 0. Otherwise, if both of those are false, its sign is going to be equal to 1, meaning it's positive. So this is an example of how the else if can be very useful. And you can have multiple else ifs. We only see one there, but we could have 100 if we wanted. Else if number is equal to 2, else if number is equal to 3, else if number is equal to 4. And you can also, you see the brackets aren't used here, but the brackets would be used if you had multiple statements inside the body. And when you use if statements, you should also notice that you're going to be using a lot of logical operators and comparison operators and relational operators. So you're using the less than symbol here. You may use the logical operators, remember, are the ampersands, 2 of them for and or. And relational operators are where you're comparing values. So when you're doing things like less than or less than equal or greater than, those are used quite a bit when you're using numbers in your if statement expressions. When you use the ampersand, you're actually asking multiple questions. If this is true and this is true, or if this is true or. It's a way of reducing other else if statements as well. So you could rewrite this code right here if number is less than 0, and also if you wanted to have the sign, well, you couldn't actually the way it is now, but if you could put an ampersand in there, you could say if number is less than 0 and it's equal to 0, then the sign is -1 and 0. I mean, you can't do that specifically, but you can see how you could add multiple questions here. So we're going to have a specific challenge where we're going to write a program that uses if statements. These are some good examples. You'll want to put these examples inside your IDE and see what happens. But the else if is, again, a way to ask multiple questions. Nested if else statement. Nested if else statements means you can use one if or an else if statement inside another if or an else if statement. So that's why it's referred to as nesting. You can use multiple things inside, and you can keep doing that over and over and over. There's no limit on the number of nesting that you have in C. So the syntax looks something like this. If a Boolean expression is equal to true, then inside that, and when you do nesting, usually you want to use the brackets, even though you don't have to for single statements because it makes it much more readable. So if the Boolean expression is 1 is true, Then inside there, you say if Boolean expression 2 is true. You would not actually execute if Boolean expression 2 unless Boolean expression 1 was true. Okay? And then inside the body of the Boolean expression 2, you would execute code if that's true. So an example of a nested if statement would look something like this. If game is over equals 0, and then inside there, if player to move equals you, then you have a print. The key here, noticing there's no brackets, and it's a little harder to follow. The only way you follow this is through the indentation, which is another thing you want to do when you write if statements in blocks of code. You always want to indent the block because it makes it easier to read. Imagine if this did not have the indentation, how harder it would be to match up the else and the ifs. So use indentation, but also probably use brackets. Brackets even help even more to make it even more readable. And remember, readability is a big deal, right? Because readability helps you find and fix your errors much quicker. So in this case, we're only going to execute your move printed out to the screen if player to move is equal to you and game over is equal to 0. We're going to only execute my move displayed to the screen if game is equal to 0, but player to move is not equal to you. And then lastly, we're going to only execute the game is over if the game is over not equal to 0. So if we have three conditions here, or for printing out three different statements. All right. And you could actually write if the game is over equals 0 and ampersand the player to move equals you. All right. But the problem with that would be your else my move might not be right because you still have to compare player to move. So there are times when you can use the ampersands to simplify code. There are times when you cannot. In this case, you can't because the first else is inside the nested if. So nesting is quite applicable and you will use it. So get familiar with it. Again, the syntax for the if statement is very straightforward. The Boolean expression inside, and then you use brackets for single statements. Otherwise, you use brackets. You don't use brackets for single statements. Otherwise, you use brackets. There's also a third type of way to ask questions in your program. This is called the conditional operator. And we talked about it when we talked about operators, but it needs a little bit more understanding. So the conditional operator is a very unique operator. It's unlike all the other operators in C. Most of the operators in C are either unary or binary. Unary means that the operators take a single argument or a single operand. Binary means they have operands on both sides. So the plus operator is a binary operator because you do 5 plus 3, 2 operands. The negative is a unary operator because you say like -3. Well, there's a third option. There's a ternary operator which takes 3 operands. And this is the conditional operator. You have two symbols that are used to denote this operator, this conditional operator. It's the question mark and the colon. And it really is equivalent to an if-else statement. The way that it looks is the first operand is placed before the question mark. That would be the Boolean, that would be the condition, the Boolean expression in the earlier examples. And then the second thing between the question mark and the colon would be basically the body of the if statement if the if statement was true. And then the colon is the third, and that would be if the condition evaluates to false, you would be executing that body of code. So that's like the body of the else statement. So this ternary operator is nothing more than an if-else statement, just shorthand notation. You can write it much quicker. The difference here also is there's no brackets, so you can only have single expressions or single statements inside the body of the after the question mark or after the colon. So if the conditional operator evaluates to one of two expressions, depending on whether the logical expression evaluates true, depending on whether condition is true. If the condition is true, expression 1 is evaluated. If the condition is false, expression 2 is evaluated. So again, it looks just like and behaves just like an if-else statement. Also notice how the operator is arranged in relation to the operands. The question mark character follows the logical expression condition. The right of the question mark are the two operands, expression 1 and expression 2. They represent the choices. The value that results from the operation will be the value of the expression 1 if the condition evaluates to true, and then the value of expression 2 if it's false. So exactly what I said, if, else. Let's look at an example. So this looks kind of funny to read, right? But what this is saying is if x equals to y is greater than 7, so what this is doing is it's doing an assignment. X equals y. So if x is 5 and y is 9, it's going to say if x is greater than 9, it's going to then set it's then going to set the number to 25x. Otherwise, it's going to set x to 50. So it's a little confusing to read it first. What this results in is x being set to 25 if y is greater than 7, or to 50 otherwise. So it's an easy way to do an assignment of the expression. X equals y is greater than 7. If y is greater than 7, x equals 25, otherwise 50. That's why the x equals there is important. So the ternary operator and the conditions are on the right-hand side of the assignment. And this is typically how you use it. You say x equals the result of that ternary operator. So the entire ternary operator is y greater than 7. So it's just saying if y is greater than 7, 25, otherwise 50. And then you assign that to x. And this is typically how you use it. It's the same as saying, using an if statement. If y is greater than 7, x equals 25, else x equals 50. But it's much less code, right? The limitation of this conditional operator is you can only have two variables written using the conditional operator, a maximum or minimum. You can't just do a ton of them. So it's a little limiting. It's usually used for assignment. So quite a long lecture, a lot of different examples. This will be more applicable when we do our challenge. But if statements are going to be used a ton, and they're really, really easy to learn. You're going to, before you know it, you're going to be knowing the syntax like the back of your hand. Parentheses, brackets, if-else keywords, and then occasionally you're going to use this conditional operator. Again, that's maybe as you become more advanced in C, you'll start realizing, wow, this if statement's taken me a long time to write. Maybe I can write it in a single line using the conditional operator with my question mark and my colon. Again, very useful for assigning variables based on conditions. Thank you. Hello and welcome. Now that we've finished our lectures on decisions, the if statement and the switch statement, I want to provide you with a little assignment, a little challenge. So in this challenge, you're going to create a C program that calculates your weekly pay. This program should ask the user to enter the number of hours worked in a week via the keyboard. The program should display as output the gross pay, the taxes, and the net pay. So the following basic assumptions should be made. The pay rate is going to be $12 an hour. Overtime is any time you have more than 40 hours, you're going to get paid time and a half. The tax rate is going to depend on how much money you make. For the first $300 that you make, it's going to be 15%. For the second $150, $300 to $450, it's going to be 20%. And for anything above $450, you're going to be provided at the tax rate of 25%. So the first thing you should notice is you're going to have to write a lot of decisions. And the whole purpose of this assignment is to get you familiar with the if-else statements. Okay, so what I'm expecting for this assignment is for you to first, you're going to need an if-else statement to calculate the overtime. Right, so overtime is anything in excess of 40 hours. So you're going to have to see if there's overtime. So you're going to have to say if the number of hours entered is greater than 40, then they're going to get paid $18 an hour. Okay. Now, you want to make sure that they only get paid for the hours after 40. All right, so if you enter 45 as the number of hours worked, you're going to get paid $12 an hour for those first 40 hours. And then for the other 5 hours, you're going to make $18 an hour. So you have to keep that in mind. And then with the tax rates, you're going to have if statements, because depending on whether or not they made more than $300 or made more than $450, you're going to have additional tax rates. So if the user entered 45, and that means you have to calculate overtime pay. What will end up happening for 45 hours, I think roughly the pay will be, let's see, $12 an hour times 40 is $480. And then for those 5 extra hours, you're going to get paid $18 an hour. That's $90. So 480 plus 90 is 570. So you should display for the gross pay 570. That would be an example run. $570 for gross pay. Now the taxes are going to be calculated different for that entire 570. So for the first 300 that you make, you're going to have a tax rate of 15%. So you want to tax 15% of 300. And then from 300 to 450, which is $150, that's going to be taxed at 20% rate, only the 150. And then if you make more than that, whatever is made more than that, you're going to tax at a rate of 25%. So don't confuse these tax rates. The tax rates are different for each amount you make, not for total. So if you made $800, that doesn't mean you pay 25% in taxes. It means you paid $300 of that $800 as 15%, $150 of that $800 as 20%, and then $350 of the remaining is 25%. And that will force you to write if-else statements. So I wanted to make that clear as far as the output and what we're looking for. So go over this. The requirements are pretty basic. You're going to have to enter something via the keyboard for a number of hours. First thing you want to do is you want to organize your program. You want to constantly test. And you want to use meaningful names. And for the if statements, you want to indent. You want to indent all of your blocks so it makes it easier to read. You should have noticed in all my lectures, all my examples, I was indenting code. Get in the habit of indenting blocks and adding new lines for readability. But you can kind of group this program into the problem-solving aspect. First thing I would do is I would get the user to enter the number in, and I would test it and make sure that's working. The next thing I would do is I would just figure out the gross pay. So the gross pay would basically just include figuring out the overtime if it's more than 40. When I'm done with gross pay, I would test it like crazy, make sure it works. Then I would move on to taxes, and I would test the taxes. And then once I'm done with taxes, I would figure out the net pay. And the net pay is going to be the easiest part because it's just going to be the gross pay minus the taxes. But I hope at the end of this exercise, you're going to become pretty adept at if statements. You'll at least understand the basics, understand the else, understand when you need to add brackets, and understand how to make your code more readable by indenting and using good variable names. So good luck. Thank you. Hello and welcome. I would like to provide you with a solution to our challenge on calculating the weekly pay. So I'm going to provide a nice demonstration here. Let's bring up code blocks and let's close our project that we currently have open and open up and create a new project for this application. So I'm going to create a console application. It's going to be in C, and I'm going to name this calculate pay, calculate weekly pay. And so I'm going to have my main.c file, which is going to give me some nice starting point. But there's a couple things I'm going to do in this solution that may be a little different, but it's going to introduce you to a couple concepts. We'll talk about them, but we're going to be using a lot of constants in this program, mainly for our pay rate and our tax rates. So I'm going to use something that we haven't seen yet, which is called the define. It's a preprocessor directive to create constants. And so the way that we know it's preprocessor directive is we have the pound symbol. So I'm just going to say pound define. And this is a way to create constants. I'm going to create 5 constants for all of our data in this program. We have a pay rate, which is 12.00. So the way the define works is use the define keyword followed after the pound. And then usually you'll provide a name. Usually it's all caps. That's standard convention. And then a space and then the value. No equals assignment here. And this is creating a constant variable essentially. So we're going to create one for pay rate, tax rate for 300. Actually, we'll say tax rate for 150 or for 300 and under. And that's going to be a tax rate of 0.15. You'll notice that the data that you assign can be floating points, integers. You can even assign strings. Doesn't matter the type of the data here. Tax rate for 150 can be 0.20. And I usually do the defines outside of the main at the top of the file. And also don't forget to add your comments at the top and throughout the source code. And then I'm going to create a last tax rate for the rest, which is 0.25. The last thing I want to do is I'm going to create a constant for my overtime. Just going to call it overtime and say 40. This will just represent when we want to check for greater than 40. It's never a good idea to have magic numbers inside variables because now if anything changed, say the overtime changed to 45, I only have to change it in one spot, right at the top. And my program is going to work the exact same. If I didn't have this constant in this, and I used a magic number in my comparisons or my variables, I'd have to change it everywhere I'm using 40. So get in the habit of using constants and not using something called magic numbers. I also like to declare my variables right at the top of the main. If they're local, these are local variables to our main function. So I want to put a comment declaring variables. The variables I need that are locally, I'm going to create an integer for hours. I'm going to initialize that to 0. The hours is going to be entered by the user. And then I'm going to create some doubles that are going to be displayed as output. Mainly the gross pay, which I'll initialize to 0.0 because it's a double. And then taxes, I'm going to also initialize to 0.0. Ending with a semicolon, don't forget the semicolons, and then the net pay. Because these are my 3 outputs that I want. So I'm going to create my 3 outputs at the top along with my input hours. First thing I want to do is I want to get my input, so I'm going to tell the user to enter something. I'm going to say enter, say please enter the number of hours worked this week. Put a colon, a little space, and a semicolon. Then I'm going to use my scanf function. Getting the input. I'm just going to say scanf. I want to read an integer, so I'm going to say %d. I'm going to put a comma, and I'm going to do hours, and then because it's not a string or characters, I have to put the ampersand in front of it and end it with a semicolon. That's going to read in. And at this point, what I should do is I should test. Work in small chunks and test constantly. If I keep writing code, try to compile, I could have a problem anywhere. Work in small areas. But I know this works, so I'm going to move on to demonstrate how to do this. Like I said, the first thing I'm going to do is I'm going to calculate the gross pay. In the logic here, we'll need an if statement. Basically, if the hours is greater than 40, we want to have an overtime rate. So what I'm going to do is I'm going to say if the hours are less than or equal to 40. Then all I have to do is create my calculation very easily because it's just rate of pay times hours. Right? So we have our if keyword on line 24 and we have our hours. We're doing comparison. We're using a relational operator, less than equals. If hours is less than or equal to 4, we're not going to use a bracket because we're going to have to use a single statement. We're just going to say gross pay, we're going to set a variable, is going to be equal to hours times our constant, pay rate. And that's it. Now, if it's greater than or equal to 40, we want to do something else. So if that condition evaluates to false, we want to have an else. And this is where we use the else. The else is going to have multiple lines in its block. So I'm going to use a bracket. It's going to start on line 27 with the starting bracket, 29 with the ending. Mismatching your brackets or not having brackets are a common error that your compiler may find. So make sure you match those brackets. The IDE is very helpful because it highlights them. You can also, if you have multiple brackets, you can always go to if you go to the bottom bracket, it will highlight telling you where the starting bracket was. So in this type, if it's greater than 40, first I want to set my gross pay equal to 40 times the pay rate. Because those first 40 hours are going to be $12 an hour. And then everything after that is going to be more. So I'm going to create a local variable called overtime pay. And I'm going to set that equal to the hours minus 40. So if I typed in 40, it'd be 5 here. And then once I have those hours, I want to multiply that from the pay rate, which is $12 an hour. But I want to add 1.5 of that, which would be $18 an hour. And then I end it with a semicolon. At this point, my overtime pay is going to be 5 times 18, $90 if I typed in 45 as a user. And then the first 40 hours are just going to be 40 times 12, which is, what do we say, 570. If we did 40 times 12 would be 480. Now, the last thing we have to do is we have to add the gross pay to the overtime pay. So I probably could have used a better name than gross pay because we don't have our gross pay yet. But I'm going to use a nice little operator, our assignment operator plus equals, which is going to do our overtime pay. What this is saying is gross pay equals gross pay plus overtime pay. But we're doing it in shorthand notation. So now we have our gross pay and we're done for gross pay. So we would go ahead and test this, print out the gross pay, and make sure it's correct. But since I know this works, I'm going to move on to the next step. The next step is to calculate the taxes. Right, so to calculate the taxes, remember we have to do certain things for how much, depending on how much money you made. So we're going to have to look at the gross pay. And so if the gross pay is less than or equal to 300, we're going to do something. If the gross pay is between 300 and 450, we're going to do something. And if it's greater than 450, we're going to do something else. We will have a little duplicate code here. It's okay for now because we're just demonstrating if statements. You might be able to write this a little cleaner. But what I'm going to do is I'm going to say, first check the first condition where if the gross pay is less than or equal to 300. And in that case, it's very easy to calculate the taxes. The taxes are just going to be gross pay times the tax rate for 300. The tax rate for 300, remember, is anything from 300 and other is taxed at, what, 15%, I think it was. Yeah, 15%. So that's all we have to do if you made less than or equal to 300. And again, the other thing you should notice here is the indentation. Whenever you have blocks of code, and even though I only have a single statement, I'm going to put a bracket there. And then I indent my blocks. It makes it much easier to read. Don't forget about indentation in new lines. And typically here you want to have spaces as opposed to tabs, but that's another discussion. Now, it can also be something else. So on line 34, we ask the question, if the gross pay is less than or equal to 300, do something on line 36. We use the if keyword, we put the condition, Boolean expression, inside parentheses. But what if it's not 300 or less? Then we want to do something else. Specifically, if the gross pay is greater than 300, and so here I'm using a logical operator, ampersand, ampersand, where I'm asking essentially two questions. If the gross pay is greater than 300 and the gross pay is less than or equal to 450, then I want to do something else. Right? So what's this saying is if my gross pay is anywhere between 300 and 450. Now, if it's between 300 and 450, I first want to calculate my taxes just like I did before, except for the first 300, I want to multiply it by the tax rate for 300. Because the first 300 are taxed at that rate. For the other amount, I want to do the tax rate at 150, which is 20%. So first I have to find out how much we made over 300. But I can actually do this in one line. I'm going to do the taxes plus equals, so this is saying taxes equal taxes, which are 300 times the tax rate 300 already, taxes plus something. And when I want to add to that first taxes on line 40 that was calculated, I want to add the additional amount, and it would be the gross pay minus 300, so however amount I'm over 300, and I've already determined that I'm not above 450, so gross pay minus 300 times the tax rate for 150. Okay, so see what I did there? If I made anywhere amount of money between 300 and 450 on line 38, then I want to get the taxes for the first 300, which is 300 times the tax rate 300. And I want to add that to however much my gross pay was over 300 times that tax rate for 150. So now we've met two conditions. The last condition we want to check is if we made more than 450. So basically we can just have an else if gross pay is greater than 450, or really just an else. But for clarity's sake, I'm going to put the else if in there, and I'm going to say else gross pay is greater than 450. I don't really need to do this because I can just have an else without an if. But I want to demonstrate the else if. In this case, I do want to calculate the taxes for the first 300, so I can copy code here. I also want to calculate the taxes for the 150, so I'm going to do a plus equals for the next 150, so 300 to 450. So this will be 150 times tax rate 150. And then the last thing I want to do is I want to tax the rest at a certain rate. So here I'm going to say taxes plus equal. Again, plus equals is taxes, taxes plus. And here I'm going to say gross pay minus 450, because I don't want to apply the taxes to the entire pay, just what's above 450. And I want to multiply that by tax rate equals rest, which is our constant variable we defined above. And that's it. I'm done calculating the taxes. And again, you would test this after each step and make sure it's correct. Compile and test. But you'll notice the indentation. This is easy to read. I'm doing comments, all of that. Last thing I want to do is calculate the net pay. this is going to be simple because the net pay is just going to be equal to the gross pay minus the taxes. Very simple. And then I want to display my output. And remember, the assignment requirements were to display the gross pay, the taxes, and the net pay. So we can use printf here. And I'm just going to copy and paste this in for efficiency's sake so we don't take up too much time. Sometimes students get mad when I copy and paste and they say, you're not supposed to copy and paste in programming. Well, that's true to a degree. If you copy and paste something and you fully understand that code, it's more efficient. The problem with copying and pasting is a lot of developers copy and paste and they have no clue how that code works. And then they're just hoping it works. But in this case, I know how the printf statements work, and I just want to show you what's happening here. So I don't have to waste time typing in at the keyboard. So on line 54, we're going to display the gross pay. It's a float. We know how to display the value of variables. And the only thing peculiar in that is I'm formatting the output to 2 decimal spots. So you should notice the %.2f. And then the \n is a line feed for an escape sequence. So I'm formatting everything to 2 decimal spots because when we display money, we have cents and we don't have a percentage of cents. And then I've displayed the taxes, same format, and the net pay. So pretty nice there. And again, what you should notice in this program is the indentation. It's very easy to read. I'm using constant variables at the top. I'm initializing my variables, why I declare them. Everything's nice and neat. I'm providing comments. I'm writing a bunch of if-else statements. Hopefully this was all clear. The logic is not too tough to follow, but you do have the source code with you because you can download it, so you can analyze this more. But let's see what happens when we build and compile. Let's make sure nothing's wrong. When I build, it says I have a warning, unused. I also have, it looks like here, I have missing something. Expected a semicolon before a bracket. That doesn't make sense. So I think what I'm missing here is, well, I can't have an else. It has to be else if. Doesn't make sense. I forgot the if. So else if. See what happens there is I had an else and then below that I had an else if. That doesn't make sense. You can't have an else and then an else if. So now let's see what happens here. Okay, now I get 0 errors and 0 warnings. Let's run this. And my virus scanner. When I run this, first thing it's going to do is it's going to say, please enter the number of hours worked this week. I'm going to put in something higher than 45 so it demonstrates overtime. I'll say 45 or higher than 40. 45, and it says I made $570, which is right because everything for up to $40 is $12 an hour, which is we calculated to be 480. And then the 5 hours are $18 an hour, which is 90. 90 plus 480 is 570. The taxes this week were $105 and the net pay was $465. Nice even numbers. You can go through those calculations to make sure they're correct. You can try running this many times and seeing different data output. Let's run it with something less than 40. Let's just say 30 hours this week. I'm not going to get any overtime pay. It's just going to be a straight 30 times 12, which is 360. I'm going to be taxed for the first 300, I'm going to be taxed at a rate of 15%. And that's going to be what? That's going to be $45. And then for the $60, I'm going to be taxed at a rate of 20%, and that's going to be $12. So 45 plus 12, 57. That looks correct. And the net pay this week is 303, 360 minus 57. So it looks to be working pretty good. You'll want to test this more with earnings greater than 450. The other important thing in testing is you want to test all the boundaries. You don't just want to provide one test. Say, oh, everything works. You want to provide good cases and bad cases. So in this case, this example, we have many different cases for this program. We have a case where when you make more than 40 hours, so you have overtime pay. We have a case when your earnings is 300 or less, a case when your earnings is 300 to 450, and a case when your earnings is greater than 450. So for this program, you should at least run 4 test cases, or 5 test cases probably. It depends because you really want to calculate the overtime as well. You could probably get away with 4 cases. because you probably make less than $300 less than overtime pay. But what you really want to test is overtime and then the 3 tax rates. I hope this was helpful. I hope you fully understand what I demonstrated. I hope you understand all the stuff with the if statements and how I make my code readable and use meaningful names. Thank you. Hello and welcome. In this lecture, I want to talk about the switch statement. It's sort of an alternative to an if statement, but usually used only in specific situations. But it has some nice, cool syntax for doing some repetition in your if statement. So the conditional operator and the if-then-else statements make it easy to write programs that choose between 2 alternatives. Right? It's very easy to ask questions and make decisions. However, many times, a program needs to choose one of several alternatives. And this would essentially being the if, else if, else if, else if, else if, right? It gets kind of messy because you can obviously implement this with the if statement when you have several alternatives, but you could have 100 else ifs. So it's tedious, it's prone to errors, and it's really just a pain in the butt. It's like writing a bunch of boilerplate code. So the alternative to this syntax, and everything you can do in the switch, you can do in an if, but it's cleaner and it's easier to weigh, and it's a lot more efficient actually too. So when the value of a variable is successfully compared against different values, use the switch statement. And what this means, if you have an if statement and then you have an else if, else if, else if, else if, else if, else if, use the switch statement. Now, if those Boolean expressions are a little more complicated, you can't use a switch statement. You can only use a switch statement when you're comparing against a value, like a constant. The expression cannot be that complicated. But it is much more convenient and very efficient to use the switch statement. And most languages have this construct as well. In C, it's very nice. The one thing you notice is a lot of languages will build based off of C. So you may be, if you've programmed before, you're going to see and be familiar with a lot of these constructs because they originally came out in C or B, the language before. So here's the syntax of a switch statement. You have the switch keyword, and then inside the switch you have these left and right parentheses, which is the expression. So it looks just like the if statement at the beginning, except instead of the if keyword you have the switch keyword. You then have the left bracket. The left bracket's required. That left bracket starts the body of the switch. And you see the ending right bracket at the very bottom. That ends the body of the switch. The other thing that's important here is these keywords case. Case is actually like the if statement itself. So switch is actually going to be looking at an expression, not whether or not it's necessarily true or false. The switch could be just looking at a variable or something. And then it's going to evaluate that variable in the case statements. So if value 1 equals expression, if value n equals expression. But you can kind of look at this as like the switch being at the top level and then the cases each being an if statement, comparing the values against the expressions in the switch. So cases are also keyword. You also notice the colon after the case. So you have case and then you have your value. And then inside there you can have multiple program statements. And then at the end you have a break keyword. That's another keyword. So there's 3 keywords here, actually 4. There's the switch keyword, the case keyword, the break keyword, and then the default at the bottom. So these are the important things to notice. We'll go through a detailed example, but you can have different cases. And again, this is just doing like an if, else if, else if, else if. So if value 1 is equal expression, execute the code. Else if value 2 equals expression, evaluate that. Else if value 3 equals expression, evaluate that. Else if value n equals expression, execute the code inside that block. And the block for the cases start with the colon and end with the break. And if you don't have that break there, it's going to fall through the other cases. And we're going to talk about that again. And then the last thing here that's important is this default keyword. This is essentially the else. Else if, else if, else if, and then else at the bottom. So this gets set if none of the other cases evaluate to the expression. All right, so let's talk about some of those details that I mentioned. The expression enclosed within the parentheses is successfully compared against the values. All right, so again, if we go back to the syntax, expression is compared to all the values. And if it equates to any of the values, you execute the code inside that value. Cases must be simple constants or constant expressions. Expressions that evaluate to a constant. All right, so you could do x, switch on x plus y, because if x is 5, that would just switch on 10, and it would compare the values to 10. But usually you switch on a variable that's equal to some kind of number. If a case is found whose value is equal to the value of the expression, then the statements that follow the case are executed. When more than one statement is included, they do not have to be closed within braces. Right, so that's just saying that when more than one statement is included, there's no braces required for the case statements. Remember, for the if statement, we would always have to have those braces. That's not the case. You can just put them one line after the other. The key is the break there. The break statement signals the end of the particular case and causes the execution of the switch statement to be terminated. It jumps out. If you don't have the break there, the next case, it will fall through. So you want to include the break statement at the end of every case. When you don't include breaks, it usually means there's a bug or something. The only reason you wouldn't include a break is if you had multiple conditions that you wanted to execute code. So if you had multiple cases, basically saying if the expression was this case, or that case, then do the same thing, then you would take out the breaks. So be careful with the breaks, because the breaks can cause issues whether or not certain blocks are being executed in the next case. The special optional case called the default is executed if the value of the expression does not match any of the cases. It's the same as a fall through else. It happens if none of the cases are true. So here's a nice example where we're creating a switch to evaluate an enum. In this case, we have an enum type called weekday, which is just specified by all the weekdays. And then we create a variable of type enum weekday, and we set it to Monday. And then we switch on today. So depending on the value of today, the variable, one of the case statements is going to be executed. If today is equal to Sunday, it's going to print out today as Sunday and then jump out. If today is equal to Monday, it's going to print out today as Monday and jump out. If it's not equal to any of them, it will go to the default case. So let's run through this example in code blocks. Okay, here we have our sample code, and you're going to see that because today is equal to Monday, case Monday is going to be evaluated, and you're going to see output today is Monday. So let's go ahead and build this code and run it, and that's what we're going to see. Today is Monday. Right. Because what's happening here is today is going to be equal to Monday. You put the expression you want to evaluate, the variable, today, then it evaluates it. Key things to remember here are you have a bracket to start the switch statement on line 16 and an ending bracket to end the switch statement on line 29. You can have multiple lines inside each case statement without using brackets. Now let's see what happens if we take out the break statement after Monday. Because remember, break will jump right out of the case, but if we remove it, what's going to happen is it's going to fall through to Tuesday, and you're going to see both printfs executed for today is Monday and today is Tuesday. So now when we run the program, we see today is Monday, today is Tuesday. That's the importance of the break statement. The break jumps out. So this might be useful if you wanted the same output for Monday and Tuesday. So for example, sometimes you'll see case statements like this. Case Tuesday, because you want the same output, and it doesn't matter what the variable is equal to. So you may see things like that, but when you have separate case statements that have different execution, you have to add that break in there. Okay? So we're only looking at Sunday, Monday, and Tuesday. What happens if we set the today value equal to Sunday? Because there are no cases that are going to match that. Well, what's going to happen is it's going to fall through the default and it's going to print out whatever. So let's try running this again. And we see today is Sunday. I'm sorry, set it to the wrong variable. I want to set it to, let's just say Wednesday. We had a case for Sunday. So now we'll see that it actually prints out whatever, because it didn't match any of the cases. So all you have to do for switch is really memorize the syntax. The expression goes in the parentheses, that's what you're going to evaluate. The cases have to match the expression. So usually you're doing variables, that's why it has to be constants or expressions that evaluate to a specific constant value. And then you have cases for each thing, and then a default all case. And don't forget about the breaks. All right, let's go back and talk a little bit more, give another example of the switch construct with cases. In this next example, it's a little different. What we're doing here is we're getting data from the user and then switching on that. So in this example, in our main function, it starts off creating a couple floats, and then it creates a character operator, and then it asks the user to enter a value, an operator, and a value too. And it's using format specifiers to distinguish, and they all have an address of ampersands. So the operator, depending on the character you enter for the operator, whether it's plus, minus, or star, that's what you want to include in your switch case. So if the user entered a plus, so you see in the next column here, the switch construct, it's switching on operator. It's going to compare the value of operator, the value of the variable operator, to each one of these case statements. And you'll notice that these case statements have single quotes around them because we're comparing characters. So you can compare numbers, variables to values, specific constants, or characters to specific constants. And then inside each case statement, we're printing out a specific format, value 1 plus value 2, value 1 minus value 2. We're actually performing calculation in our print. And then again, you see those important break statements. Those are jumping out, and they're needed if you don't want to fall through any of the other cases. You also notice that in that last case statement where it has the /, the divider, we have an if statement. Right? We don't have any brackets around the case because we can have multiple statements in each case without brackets. So the last case, we say if value 2 is equal to 0, we're doing a little check to make sure we don't divide by 0. And if we don't divide by 0, then we're going to actually perform our division. And then at the very end of that case, we have another break. Our default case is saying you entered an operator that we don't know how to handle. But the case switch statement is very efficient. It's very quick to write whenever you're comparing many different values to a specific variable. And then you want to do different things. The last thing I wanted to mention was the goto statement in relation to decision making. It's not a direct decision statement. It's more of jumping to a different line of code using a label. But it is available in C. And that's why I wanted to mention it. There's two parts to the goto statement, the label and the goto keyword. Now, for those of you that have programmed before in Fortran or some other basic languages, you're probably going to recognize this. And you probably used it quite a bit. Now, coming to C, there's no need to use it, really. There's a couple cases where I saw it was pretty useful, which I'll explain in a second. But the goto is jumping out to some code, and you could go to any line of code. One of the reasons people don't like using it because it's very hard to follow. You know, when you're maintaining a program and it's sequential, you're going line to line, it's very easy to read it. It's bad enough when you have the if statements and the while loops. But now if you have something where basically you're on line 27 of your source code and you're going to jump to line 800 for no reason other than just the goto keyword, all of a sudden you're skipping a ton of code and it's very hard to maintain and follow. So the two parts, the goto and the label name. The label is named following the same convention for naming a variable. Alphanumeric characters, you can start with digits, you can't start with underscores. Can't start with digits, you can start with underscores. Basically, you just use the goto keyword and you go to some identifier, part 2. Part 2 is a label somewhere. So in order to actually jump to that line of code, you have to label that line of code. There has to be a statement that says part 2. Now, I'll go show you an example of this, but you really should never use this because of the problems associated with it, with maintenance. However, I wanted to mention it if you programmed before and you're used to using it. In C, you don't really need to use it as much. There's one use case that I saw that might be useful. I was working the other day with a fellow programmer, and he had a bunch of nested loops, or nested if statements. But the loops is really probably the better example. Loops, remember, we're repeating code. He had a lot of nested loops. And at the very inner nested loop, like the fifth one, he wanted to jump out of all the loops because he had some condition. And so he used a goto to jump out of all of those loops. Now, the other way to jump out of loops is using the break keyword, but the break's only going to jump out of the most inner loop. So there was really no effective way without him setting a bunch of flags and having a bunch of if statements to exit every single loop. So he used a goto. And that was one case I thought it was pretty useful because it reduced the amount of code that you had to write, and it was pretty clear on what was happening. You were just jumping out of all the nested loops because you met a certain condition. And that's one case. But for the most part, you don't really need to use goto. And for the reasons I mentioned, it's very problematic. It's hard to follow code when you're jumping all over the place. But the goto is just like, you use it just like you use in other languages. You have a goto keyword with the label name, and what will happen in your code is you'll jump to that line of code with the label. So you can skip all sorts of code. So in this example here, we have a label called top, and it has a colon. That's how you know it's a label. And top has some statements. And at the very bottom of that, you have an if statement, and you say if the char equals y, go to the top. So again, you see how you can just jump all around in your code, and that makes it very hard to follow. So don't use it, basically, unless you have many, many, many nested loops, and you want to jump out of all the loops. Thank you. Hello and welcome back. Still going to talk about a little bit about control flow, so let's dive right into loops, repeating code. First, we're going to talk about this for loop. The for loop is going to be all about repeating code. So just as a reminder, repeating code is a way to allow for not duplication, and you're actually maybe executing more than one line code at a time. So the C programming language has certain constructs designed for the language that you can use when you want to repeat code. And this allows you to repeat a block of statements until some condition is met. So it's similar to the for loop in that you're going to evaluate a Boolean expression, a condition. You can't run forever. When you run in a loop forever, that means it's an infinite loop. And there are only certain times you may want to do that. Usually, again, for like monitoring or listening to something. So the number of times that a loop is repeated can be controlled simply by a count. There are two types of loops that you can do. A counter-controlled loop or like a sentinel-controlled loop is what they call it. A counter-controlled loop means that the loop runs 10 times, 20 times, 30 times, a specific amount of time. It repeats the same statement block inside the loop a number of times. You can have another type of loop where it's not counter-controlled. It may run 5 times, it may run 100, it may run 20. It all depends on a condition, a variable or something. So for example, you can run a loop that says, I'm going to run my loop over and over and over until the user enters quit. So until the variable changes to quit. It's not counter-controlled. It's not dependent. Again, it may run 10 times. It may run 100 times. These are the two different type of loops. And so I'll provide examples of both. But just think of this at a high level. When would I want to repeat code? Oh, well, I may want to repeat code 5 times, a certain amount of time, definitive amount of time, or I may want to repeat code based on a certain condition entered by a user. And that's called sentinel. Our for loop has the for keyword. It's used to execute a given number of times. It's usually used for counter-controlled, but it doesn't need to be. You can use it for counter-control loop or a sentinel-control loop. It's up to you. But a lot of the examples and a lot of the practice is counter-controlled, a certain amount of times. If you want to display the numbers from 1 to 10, for example, you would use the for loop. You would not want to write 10 lines of code with the same printf statement in there displaying a different number. That's very inefficient. It's very time consuming. You would use a for loop to repeat code. What you would do is you would do something like this. Here's an introduction to what the for loop looks like. The syntax. You have the for keyword and then you have these parentheses again. The parentheses identify different things that are going on for the for loop. Then you have a bracket and you have statements inside the bracket. So again, the brackets represent the body of the loop, just like the brackets represented the body of an if statement. If you have one single statement in there, you don't need the brackets. But good practice to always use them. So in this example here, you see the for keyword. That should be the first thing you identify. The operation, how long it's going to run, is controlled in what appears between the parentheses after the for keyword, which we're going to go into specific detail. There's basically 3 different expressions inside there. And you can recognize them because they're separated by the semicolon. So the semicolon says this is an expression statement. So what are those 3 things doing? We're going to describe. The action that you want to repeat is inside the body of the loop. That's what happens so many times. In this example, the body of the loop is printf. So if a condition is evaluated to true, it will keep printing that number. And again, for single statements, you can omit the braces. So let's go through this in detail. The general pattern for the for loop is you have this type of statement. You have a for, and then you have a starting condition. This is pseudocode. This is not, I'm trying to describe the for loop here. So the starting condition is the first thing, everything before the first semicolon. The second thing is the continuation condition with a semicolon at the end. And then the last thing in the between the parentheses is action per iteration. And I want to describe each one of these. And then after that, inside the body is the loop statement. The loop statement is pretty easy. That's just inside the body. That's the code that's going to be executed. That's repeated each time. That's pretty basic. And again, you can either have braces if you have multiple statements, or a single one if you have, or you omit the braces if you have a single statement. The starting condition, that first thing inside the parentheses before the first semicolon, is usually, but not always, it usually initializes a variable called the loop control variable. That's the variable that you're going to start at looking at each iteration. So the loop control variable is typically a counter of some time. Not always, again, I want to emphasize that. It doesn't have to be, but a lot of times in a for loop it's a counter. And it tracks how often the loop has been repeated. That's what this starting condition and the loop control variable is doing. You can also declare and initialize several variables of the same type here with the declaration separated by commas. So you can have multiple initializations here, variables. Now, depending on what C compiler you use, you may not be able to declare those variables inside the for statement. If you use anything below the C99 compiler, you have to declare the variables outside of the for statement, and then you would just initialize them in where the starting condition says. But we'll go through some of those examples. But the starting condition is where you initialize variables. It's the loop control variable, and it's named for that reason because it controls how often the loop is going to execute. It's when you initialize it. The next thing I want to talk about is that continuation condition, the part that's after this first semicolon in the for loop. This is a logical expression. This is the condition that's going to evaluate the true or false. This is when you're going to jump in the loop or exit the loop. This determines whether the loop should continue to be executed. As long as this condition has a value of true, the loop is going to continue to execute. All the statements in the body are going to get executed. This will typically check the value of the loop control variable. So you initialize the loop control variable in the starting condition, and then you look at it in the continuation condition. You can put any logic or any arithmetic expression here as long as you know what you're doing. The continuation condition is tested at the beginning of the loop rather than at the end. This is referred to as a pre-test loop. You'll notice the difference when we talk about the do-while loop, which is a post-test loop. But what this means is that the loop statement may be executed once, it may be executed 0 times. It all depends on whether or not that continuation condition evaluates the true or false. If it evaluates the false, you're never going to execute the body. If it evaluates the true, you'll execute that body at least once. The action per iteration, which is at the very end of the for loop, after the second semicolon, that usually does some kind of modification of the loop control variable. It will increment it or decrement it if it's a loop counter, or if it's a sentinel loop, it may ask the user to enter more input. You can also do more than one modification of a variable. You can modify the loop control variable and you can modify other variables. You just have to separate them by commas. But to summarize everything I said, we have this little table that describes that. But before we talk about that, let's look at a little example. So here's an example. We have the for keyword, and then you'll notice that we have int I equals 1, j equals 2. That's where we're initializing variables. And we're actually initializing 2 variables here separated by the comma. Typically in a for loop, you usually just initialize 1, the loop control variable. But in this case, we're initializing I and j. And then after that semicolon, we have the condition. When are we going to enter and when are we going to exit this loop? We're going to enter as long as I is less than or equal to 5. That's our Boolean expression evaluates true or false. And then after that second semicolon, we're going to modify that loop control variable or any other variables we're concerned at. Here we're doing a plus plus I. This is an incrementation operator, prefix I. And then we're assigning j equal to j plus 2. That's going to be usually your X condition, modifying that loop control variable. And then the body of the loop just has a single statement, so we don't need the brackets. We're just printing out the values of I times j. So the output produced by this code is going to be the values 2, 8, 18, 32, and 50 on a single line. the first iteration of the loop, I is going to be equal to 1, j is going to be equal to 2. And so it's going to say I times j, which is 1 times 2, and it's going to display it. It's going to check to make sure I is not greater than 5. I is not, it's 1. So it's going to go back up and execute a second time. It's then going to say I is now equal, and we're also modifying that variable I in our last statement. So in the second iteration of the loop, I is going to be equal to 2. And j is going to be equal to 2 plus 2, which is 4. So now we're going to multiply 2 times 4, which is 8, and we're going to display it. And then we're going to check. Is I greater than 5? No, I is still 2. So we modify I to now be equal to 3 for the next iteration, and we modify j to be equal to, 4 plus 2, which is 6. And then for the third iteration of the loop, we multiply I times j, so we say 3 times 6, and we display 18. Before we execute the fourth iteration, we check to see if I is greater than 5. No, it's 4. And then we increment it. We say it's 5. It's not. It's equal to 5, so it will still run. And then we'll do 32, and then we'll do 50. So this is a for statement. You want to run this and execute it in the code browser and play around with it and change things. But what we're doing here is we're doing 3 separate things on a single line of code. We're initializing the loop control variable or any other variables. We're having our Boolean expression after our first semicolon, our exit condition. And then we're modifying the loop control variable and any other variables we want as that last part of the if for statement. So to summarize what we're doing, I found this nice little handy chart from a book, and I wanted to show you. This summarizes everything. That first semicolon initializes the loop control variable. After the first semicolon, we're doing our condition, our Boolean expression. And then after the second semicolon, we're modifying that loop control variable. And this is the typical example you see. This is a counter-controlled loop that starts at 1 and goes all the way to 10. So this is going to actually execute 10 times. The key being there less than equal to 10. So you're going to see relational operators as our conditions, just like we saw relational operators as our conditions in our if statement. The key here is you want to modify that loop control variable or you're never going to exit. So the plus plus count is very important. And as far as pre or post incrementation, whether that plus plus is before the variable or after the variable, you don't have to worry about it because it's only going to get incremented or decremented after the iteration of the loop. So it doesn't matter if you do plus plus count or count plus plus. And also, again, depending on the version of C that you're running for your compiler, you may be able to declare the variable count inside the for loop, or you may have to say int count equals 1, or int count outside of the for loop, and then initialize it in the first semicolon. C99 added the initialization and declaration in the same part of the for loop. But this is basically how for loop works. Now let's go into a little example. I want to show you the flexibility of the for loop. Here's an example where we're going to basically just sum some integers. And in this example, we're going to ask the user to enter a number of integers they want to sum. We're going to store that in a variable called count. We're now going to have a for loop that goes through all of those, depending on the number they entered, iterate through that many times. So here we say for, we have unsigned int, doesn't have to be unsigned. For int I equals 1, we're initializing the loop control variable. And then we're saying if I is less than equal to the count, that's when we're going to exit. And then we're going to modify that loop control plus plus I. So this is going to run, again, 1 to however number the user entered, 10 or 20. And all we're going to do is we're going to say sum equals sum plus 1. Now the for loop is so powerful because the for loop allows you to modify many variables. We don't even need to put that sum plus equal I in the body of the for loop. We can put it at the end of the last statement. So in addition to incrementing I by 1, we can just say sum plus equals I plus plus. So we did everything in a single line of code. And that shows you the flexibility. It's all because we can modify the variable in the for statement itself. We don't have to have that line of body. So let's take a look at this example in code blocks to show you how you can manipulate it and see what the output is. Here's our example that we had in the lecture. I want to go ahead and try to compile this. And when I compile this, you're going to notice that I have an error. It says I cannot declare my variable inside my for statement. This is because I'm running an older version of the C compiler. I'm running the C89. You probably won't have this. But to solve, if you ever see this type of error, all you have to do is declare it outside of the for loop. So you just say unsigned I, and then inside the for loop you initialize it. Something like this. Now let's try to build. And I just have to get rid of some of these format specifiers. All right, so when I compile successfully and I run this program, you're going to see how the loop works. It's going to ask me to enter the integers I want to sum. If I enter 5, it's going to sum up 1, 2, 3, 4, and 5, which is 15. And what we could do to debug this is we could add a bracket to the for loop, and we could want to just see how many times it runs. We can add a print statement. Not necessarily debug it, but just see what's going on. We could say inside loop. And this will tell us that the loop runs 5 times. Because it's going to run I to count. So what I want to demonstrate is how many times this is running. So now when I build it and I run it, I'm going to see what's happening for each iteration. So I'm going to say I say 8. Inside loop, inside loop, inside loop. I didn't add a line feed, so it's tough to read, but inside loop is displayed 8 times. And then I sum up each of those numbers inside loop, so the answer is 36. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. So you can play around with this, but again, we initialize our loop control variable. We check the condition to exit. We're going to exit once we hit whatever the user entered. If the user entered 8, we're going to run 8 times. And then we have to modify I. If we didn't modify I here, you'd have a forever loop. And what would happen when you ran the program, it would run forever. So you'd see after you entered the number, your program would never exit. So say we enter 6, I hit enter. Look at what's going on. It's just printing loop inside. It's never exiting. It's an infinite loop. So that last thing is very, very important. You always want to modify your loop control variable. And again, the loop control variable it determines the exit. In this case, I. So the for loop is used quite a bit. It's very easy to use, and it allows you to do 3 different things inside of loop. Initialize the loop control variable, check the loop control variable for the exit condition, and then modify that loop control variable. Those are 3 things that you have to do in a loop, and you can do in a single statement. Now let me just talk about the infinite loop real quick. So I just demonstrated an infinite loop. This is where you never exit, and you have no obligation to put any parameters in the for loop statement. You can actually write an infinite loop on purpose. The way that you would do that is you would just put the semicolons in there. So you would have a for loop with 2 semicolons. If you ever see that, that means you're writing an infinite loop. Now, typically you don't want to have infinite loops, but there are times. Because the condition for continuing the loop is absent, the loop will continue indefinitely. This is sometimes useful if you're monitoring data. So if you're monitoring data, you might have something in there. Typically, when you have a forever loop, you usually also have a sleep, which will pause execution of the program, maybe for a second, so you're monitoring something. The other use case where you might have an infinite loop is if you're listening for a connection. So if you're waiting and you're listening for a connection, or if you're polling something to see something, you may do that. Now, some people argue that you should never poll and you should never listen, but that's another argument. That's really the only case for some for loops that are infinite. Avoid infinite loops as much as possible by modifying that loop control variable. I hope this was helpful. This is the for loop. We'll utilize a for loop in one of our challenges so we become more familiar. Thank you. Hello and welcome. In this lecture, I'd like to talk about the while and do while loops. We've talked about the for loop, which essentially allows you to repeat code. There's other constructs in C called while and do while that do the same thing with just different syntax. So the while loop. The while loop is a mechanism for repeating a set of statements, and it allows execution to continue for as long as a specified logical expression evaluates to true. So more of the same here. Just like if statements will execute certain code, while statements will execute certain code based on a Boolean evaluation a number of times. Everything you can do in the for loop, you can do in the while loop. It's just different syntax. So what the while loops looks like is something like this. At a very high level, if we're looking at pseudocode, while this condition is true, keep on doing this. So to relate it to a more real-world example, basically, while you are hungry, eat sandwiches. Something like that. So you're going to repeat code. You're going to keep eating many sandwiches while you're hungry. The general syntax for the while loop is as follows. And this is showing you the syntax for one statement in the body. So you don't need to provide brackets or curly braces. I tend to use the terms curly braces and brackets in the same terminology. So here is what the syntax looks like when you have one statement versus multiple statements. Multiple statements, you have to have those brackets. A single statement, you don't. They're optional. You can have them or you don't have to have them. The expression goes inside the parentheses just like the for loop and the if statement. The expression here is different from the for loop in that it's a single exit condition. It's just the expression. You don't initialize the loop control variable. You don't modify the loop control variable in between the parentheses. It's just the expression, just the exit condition. The condition for continuation of the while loop is tested at the start. Right, so this is top of the loop. So what this means is it's a pre-test loop, and what that means is it could execute 0 times or it could execute multiple times in the body. And again, this is going to be relevant because the do while loop is doing something a little different. The if the expression starts out false, none of the loop statements in the body are going to be executed. So that's why it's at the top, test. So if you answer the first question, no, I'm not hungry, then you're never going to eat any sandwiches. You're going to move straight on to coffee or the next line of code. You're not going to enter the body of the loop. If the loop condition starts out as true, the loop body must contain a mechanism for changing this if the loop is to end. Otherwise, you're going to have an infinite loop. So with the for loop, where you modify the loop control variable in a single statement, it's the same thing in the while loop, except you have to do it in the body. So the body is going to initialize, or the while loop is going to initialize loop control variable somewhere, and then it's going to modify it inside the body of the code. So as I mentioned, the while loop can do everything a for loop does. It's just different syntax. And again, the for loop is shorter. You can do everything in one line, whereas the while loop, you have to do everything. You have to do those 3 things on separate lines. So in this example, we have int count equals 0. This is the loop control variable. This is outside the while loop statement. If you were using a for statement, this would go inside the for loop before the first semicolon. That's where initialized in loop control variable. Then you have the while keyword, and you have inside the parentheses the Boolean expression. This would be equivalent to the for loop, the second statement right before the second semicolon. So this is what you check for true or false. And if it's true or false, you enter the body of the loop. If count is less than or equal to 5, then you're going to print out the count. The next line of code after that is very important, the plus plus count, because that's modifying the loop control variable. You have to do this plus plus count or you're never going to exit the loop. Because the condition at the top is saying if the count is less than or equal to 5. If the count is always equal to 1, you have an infinite loop. So that plus plus count, very, very important. Plus plus count, remember, is an incrementation operator. It's just saying count equals count plus 1. This loop is going to run 5 times. It's going to run with count equal to 1, count equal to 2, count equal to 3, count equal to 4, and count equal to 5. Once count is equal to 6, it's going to jump out of the loop and it's not going to exit any more statements in the body. So it should be, again, you should be thinking in terms of the for loop. It's just the loop control variable, and the modification of the loop control variable is not in the declaration of the state of the actual loop. It's not all in one line like it is in the for loop. Here's another example where the logic is controlled to end the loop. So in that first example here that I showed, this is a counter controlled loop. It's going to always execute the same number of times, which is 5. In the next example, this is an example where the loop may execute 100 times or 0 times. The condition that we're evaluating here in our while keyword, num is not equal to -1, is all dependent on what the user enters, because num is what the user enters. So this loop may execute 0 times, it may execute 100 times. It all depends on the input from the keyboard. And this is called a sentinel control loop. It's not counter controlled. It's based on logic and variable that can change. So while num is not equal to -1, and then num gets stored the value that we enter in the keyboard. If the user never enters a -1 in the keyboard, then this loop is never going to exit. So same type of syntax here with our while, right? Our loop control variable here is num. We initialize the 0 at the top, and then we read in modify it to see if we're going to enter the loop based on what the user entered in the keyboard. Then inside the parentheses for the while keyword, we actually check it to see if it's a -1. And then in the body of the while loop with the brackets don't need to be there because there's a single statement, but I like to put them in there. Then we also read the next input, and we store it in num. If the user enters a -1 for that next input, it will jump out of the loop. If they don't, it will continue to execute and ask them to enter information. A do while loop is a little different from the for loop and the while loop because it's considered a post-test loop. So in the while loop, the body is executed while the condition is true. In the do while loop, where the body is executed for the first time unconditionally, the do while loop, because the test is at the bottom, means that you're always going to execute the loop at least once. You're always going to execute the body one time, at least. It could be more, but always one. It's never 0. Because the condition to test the exit is at the bottom. This is called a post-test loop. It's also called an exit-controlled loop. So you would use the do while loop if you wanted the loop to enter at least one time. Typically, you don't need to use a do while loop because you can still do the same thing in a for loop if you wanted to. You would just put the code outside the loop. So the do while loop is not really necessary, but there are cases maybe you want to use it. After initial execution, the body is only executed while the condition is true. So after the first iteration of the loop, it's going to then act just like normal loops. It will jump out if the condition is false. So here is what it looks like. The do is at the top, and then the testing for the condition is at the bottom with the while keyword. So do is a new keyword, and then you're going to either have brackets or non-brackets depending on whether or not you have multiple statements in the body. If you only have a single statement in the body, you won't have a bracket. You'll just have the do at the top, and then you'll have the while at the bottom of the loop, and inside the while, the parentheses, you'll have the Boolean evaluation. That will be the condition that you check. But again, because that condition is at the bottom, you're always guaranteed to execute the statement at least one time. And so the example on the left is one statement, the example on the right is multiple statements, so you have the brackets, the curly braces. And again, in this second example, you're saying you may have something like prompt for password, read the user input, and while the input's not equal to password, but you're always going to prompt for that password at least one time. So another do while loop example. The first top example here is an example of how the loop may execute one time, at least one time or many times, but never 0. It all depends on what the user enters. It's always going to execute at least once, but this is reading input from the keyboard. We see the scanf function, and as long as the user doesn't enter 20, they'll be executing this loop. A while loop can also be a counter-controlled loop. That means it's going to execute a certain amount of times. In this case, it's going to execute 4 times in this example. We have int number equals 4, and then we have do at the top, and then we have the brackets because we have multiple statements inside the body, and we're incrementing that loop control variable inside the body, number plus plus. And then that condition for checking is still at the bottom, so you're going to execute this 4 times. And you'll notice the while keyword doesn't have to be on the same line as the right curly brace. Typically it is though, but it doesn't have to be. And the while keyword at the bottom too ends in a semicolon. You should also notice that. So we've learned all about these loops, the for loop, the while loop, and do while. What loop should you use? Well, first thing you have to decide on what loop you want to use is first, do you want it to be pre-test or post-test? Do you want it to execute at least once? Or do you not want it to execute at least once? If you want it to execute at least one time, then you're going to use the do while. If that's not a condition, then you can use the for or the while or the do while. You can or the for or the while. Right? So for the most part, when you decide what loop to use, it's always going to be a pre-test loop. You should stay away from the do while loop. It's just a better option in most cases. It's much easier to read. It's much better to look before you actually loop. Just don't start looping. It's better to check that condition at the top. For readability's sakes, if the loop is at the test, it's much more intuitive. Okay, so have that loop check at the beginning. Use a for or a while. And in many cases, it's important that the loop be skipped entirely if the test is not initially met. Again, because that's the case, the test should be at the top. You shouldn't always be executing at least once. For the most part, you always may not want to execute. So you should use a for or a while. Now the question comes down to, well, which one should I use, a for or a while? It's really a matter of preference, personal preference. It doesn't matter because like I said in the beginning of this lecture, everything you can do in a while, you can do in a for. So if you just like the for loop better, the for is a little quicker sometimes because all statements, all the loop control modification and the initialization and the exit condition can all be in one line. but it's really up to you. Typically what I do is I'll use the for loop for counter-controlled loops. But again, you can use the same. If you actually wanted to use a for loop and make it look like a while, you just don't have the first and the third expressions. You just have the single one. So the for semicolon test semicolon is the same as while test. So this is just showing you that the for and the while can do the same thing. Just change the syntax a little. If you want to actually use a while loop, but you want it to act like a for loop, then you would preface it with the initialization and include update statements in the body. So what you would do is something like this, and you usually always do this for a while loop. But this is the equivalent of a for loop. The initialization is outside the loop of the control variable, the loop control variable. The condition to test is inside the parentheses, and then you're updating that loop control variable in the body of the while loop. And that's the same as the for loop, initialization, test, update, and then the body. There's no difference. Again, as I mentioned, I use the for loop maybe for counter-controlled loops a little bit more, but I'll use both the for and the while interchangeably, depending on how I'm feeling that day. So a for loop, like I mentioned, might be a little more appropriate if you want to initialize and update a variable in one line. A while loop is better when the conditions are otherwise. Again, counter-controlled loops for, sentinel-controlled loops, maybe the while loop. And here's an example of a while loop with a sentinel-controlled loop and a for loop that's doing the same thing again. Or a for loop for a counter-controlled. While loop can run many times based on what the user enters. The for loop is counter-controlled. So this is the while and the do while. Hopefully this is clear. Become familiar with these loops because you often want to repeat code. In the next lecture we'll talk a little bit about nested loops and also a little different mechanisms to exit a loop using a break or continue. Thank you. Hello and welcome. In this lecture I want to talk about nested loops and loop control. Nested loops, loops inside loops. Loop control has to do with the break and the continue statements. So nested loops, just mentioned it. There are times when you want to place one loop inside of another loop. It makes perfect sense. So for example, you might want to count the number of occupants in each house on a street. So what you would do, you would have an outer loop where you step from house to house, and then each house you're inside of, you would count the number of occupants. So I hope you can visualize or understand how that could be a nested loop. Again, the outer loop to go through all the houses, and then for each iteration of the outer loop, each house that you encounter, you would go inside the house and have a loop to count all the people. So that's kind of a little use case when you want to actually utilize a nested loop in C. Here's an example. It looks just like you'd think it'd look, a loop inside of a loop. Really not too complicated. In this example, we're using for loops. For loops are nice, right? Because we can initialize the loop control variable, have our condition check, and our modification loop control variable all in one line. So this outer loop, and we refer to it as the outer and inner loop. The outer loop is exactly what it implies. It's a loop on the outside. And you could have many, many different layers of nesting. You could have an outer, inner, many inner loops. In this case, we're going through, and it's counter-controlled loop. We're starting at 1 and we're going all the way to count. We don't know what count is here. It doesn't matter. In the body of the for loop, we're saying sum equals 0, initializing the sum for the inner loop. And then inside the inner loop, we see another for loop, for in j equals 1. J is less than or equal to I and plus plus j. We then say sum plus equals j. We're calculating the sum of the integers from 1 to I. So what this is actually doing is you're entering a number 5, and for the first iteration of the loop, you're summing 1, 2, 3, 4, and 5. For the next iteration of the loop, you're summing 2, 3, 4, 5. For the third iteration of the loop, you're summing 3, 4, 5, and so forth. So inner loops are necessary, especially just based on the use case. Just a loop inside of a loop. Perfectly fine to use. You're going to see it quite a bit. Don't shy away from it. Depending on what you need to do and what problem you're trying to solve, it's often used quite a bit. And to that point, it's not always a for loop inside of a for loop. You can have a while loop inside of a for loop. You could have a do while loop inside of a for loop. It doesn't matter. So in this example, Same exact example, except now inside the body of the for loop, we have a nested loop, an inner loop, called using the while keyword. So we're still calculating the sum of integers from 1 to I. We have some initialization outside of the while loop. We have our condition inside the while check. And we have our sums inside the body of the while loop, where we're modifying. That's the loop control variable that we're modifying. So sum plus equals, and then we're modifying loop control variable with plus j. So if we didn't modify plus j, we would have an infinite loop for the while loop. But it's doing the same output. It's just using a while loop as a nested loop instead of the for loop. So the nesting isn't really any different from when you're nesting anything. You nested if statements inside of if statements, nested loop statements, loops inside of loops. To get away from the nested loops concept, let's talk about the continue statement. Up until this point, when we've talked about loops, we've always executed the loop a number of times based on the exit condition, the Boolean expression that evaluates to false. However, there are times when you want to specifically end a loop early, or you want to continue on the next iteration of the loop without doing anything. In the latter case, continuing without doing anything, skipping essentially, you can use the current continue statement to do this. So the continue statement in the body of a loop does the following. And first of all, if you want to initiate this, all you have to do is put the continue keyword followed by a semicolon in the body of the loop. But what it's going to do is it's going to basically skip that iteration. So the continue, anything below the continue will not be executed if it's inside the body of the loop. So continue a lot of times will want to be at the top of the loop based on some condition. It's usually wrapped in an if statement. If this happens, special situation, I don't want to execute any of the code in the body of the loop. Just skip this one iteration and check the next time. And again, it's a little confusing because you're skipping an iteration and you're jumping around, but it's valid. And it's a way to do multiple checks. So even though you have your loop exit condition inside your Boolean expression, you can have another check. And that check is not going to jump out of the loop, but it's going to skip an iteration. So it's used again for the case when you want to skip an iteration. The advantage of it is you can use continue and it will eliminate a lot of nesting. It will also eliminate a lot of additional if statements inside your blocks of loops. So it can enhance the readability when the statements are very long or you have deep nesting. So if you find you're doing a lot of nesting, you may want to say, maybe I can use a continue instead. Or if you find that you have a lot of if statements that are doing certain things inside the body of the loop, maybe you want to do a continue. Don't use the continue if it complicates rather than simplifies the code. Don't use the continue if you don't know what you're doing. Here's an example of the continue. In this example, we're creating a new enum of type day, and we're saying that the valid values are Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And then we have a for loop where we're initializing our enum to Monday, and we're saying as long as day is less than or equal to Sunday, that's a condition to exit, and then we're saying plus day. You may ask yourself the question, how are we incrementing an enum? Well, remember that an enum under the hood is an integer. So you can say plus day on an enum, and that's just going to increment it to the next one. Remember, Monday is equal to 0, Tuesday is equal to 1, Wednesday is equal to 2. It's all the order of the list. So perfectly fine to increment enums. In this for loop, if it's Wednesday, we want to skip. We don't want to do anything. We don't want to print. So we say continue. If the day is equal to Wednesday, continue. It's going to skip the print line. It's going to go back up to the top of the loop, and it's going to execute the next iteration. And so it's then going to be Thursday. It's not going to be equal to Wednesday, so it's not going to skip. It's going to go right down and print out it's not Wednesday. So this is a common use case, common example of using continue. Very easy to use. Syntax, just a simple keyword followed by the semicolon. The other case where you may want to do something weird in the loop is if you want to exit early. So normally after the body of the loop has been entered, a program will execute all of the statements in the body of the loop, and for each iteration, and then it will check and jump out. And we know how the continue works, which is doing a little different. It's skipping. There's another statement that can alter the execution of all the statements in the loop. It's called the break. And this should be somewhat familiar because we used the break keyword when we talked about the switch statement. Remember when we had our cases, we would break out of cases that way. Well, you can also use the break keyword inside of a loop. And what this will do is it will just jump out of the loop. So the break statement is going to cause the program to immediately exit from the loop it is executing. Statements in the loop are skipped and the execution of the loop is terminated. So you're just jumping out of the loop. You're exiting early. If the break statement is inside nested loops, it's only going to affect the innermost loop containing it. You're only going to jump out of the loop that you're in. And to do this, you use the keyword break followed by a semicolon. Break is often used to leave a loop when there are two separate reasons to leave. So earlier I mentioned that you may have another reason where you want to skip an iteration, but if there's two reasons, two conditions where you want to jump out of a loop, you can use a break. If you only have one condition, then it's just the condition inside the loop itself, inside the parentheses of the while, or the second, before the second semicolon in the for loop. Break is also used in switch statements, as I mentioned, so I just wanted to remind you of that. Don't get them confused. They essentially do the same things, though. They jump out of code. Break in a switch statement will jump out of that switch statement entirely. Break in a loop will jump out of that loop. Well, here's an example. We have a while loop. We're printing out some integers. We're reading in some integers. We have a nested while loop. Inside the nested while loop, we check what was entered, and if it's greater than 100, we want to jump out of that inner loop. So we do. Then, in the outer loop, we have to do another check. If it's greater than 100, we break out of that outer loop. If you didn't have the break in the second break, you would never jump out of the second outer loop. So in this case, this reminds me of a place where you could use a goto. Imagine if you had 5 layers of nesting. While loop inside a while loop inside a while loop inside a while loop inside a while loop. If you would just use the break to try to jump out of loops, you would have all these if statements in each loop to jump out. Instead of doing all those if statements, you could have a goto. The goto would jump out of all the loops in one single command. So that's a use case for a goto. But in this case, we're just demonstrating breaks, and make sure you understand you're just breaking out of that loop that you're inside of. And in this case, we're breaking out of 2 loops. So these are the 2 examples, the 2 keywords where you can essentially not repeat code of what you expect it to. So if you ever see a break or a continue in the loop, make sure you understand what's going on, because you may not be executing certain code that you think is going to be executed. Again, usually wrapped inside of an if condition, so you can look at it that way. But you also want to provide good comments when you use break or continues. Hope this helps. In the next lecture, we're going to do a challenge where we're going to be able to utilize these loops. And it will demonstrate and help you learn all about while, for loops, and break and continue. Thank you. Hello and welcome. You guys up for another challenge? I know I am. Now that we're done talking about loops, let's apply them. Let's try to figure out how to solve a problem. So in this challenge, you're going to create a guess the number C program. It's going to be pretty cool. It's going to be a little game. What's going to happen is your program is going to generate a random number from 0 to 20. After you've generated that random number, you're going to ask the user to guess what it is. So the user should only be able to enter numbers from 0 to 20. If they try to guess like the number 50, you're going to display an error and say, hey, you can only enter numbers from 0 to 20. So that's one stipulation. But once the user actually gets a guess and it's a valid guess, you're then going to tell the user whether or not they were high, or too low. Or if they were correct, you'll display saying that they're correct and they will win the game. Now, they only have a certain number of times that they can guess the correct number. They can only guess the number 5 times. After 5 times, they lose the game. So this game is all about guessing the correct number. Any number from 0 to 20, you want to validate the input from the user to make sure they entered for 0 from 20. And if they entered something and they have less than 5 tries, you're going to tell them, hey, this was too high, or hey, this was too low than the number that they're supposed to guess. And those are the basic requirements of the program. A basic guess your number type game. Now, what's the output look like? To give you an idea of how I designed it, you may want to follow this. When I first started the program, I displayed a little message. I said, this is a guessing game, just so they know what's going on. I then told them, I have chosen a number between 0 and 20, which you must guess. You have 5 tries left to guess. I then said enter a guess. They were supposed to enter their guess. They entered 12, and I printed out, sorry, 12 is wrong. My number is less than that. And then I displayed, you have 4 tries left. Then they entered a guess of 8, and I said, well, 8's wrong too. My number is less than that. And then they entered 3. I said, or they had 3 tries left. They entered 4. I said 4 is wrong. And then they had 2 tries left, and they finally guessed my number, which was 2. Once they guessed the correct number, I told them, congratulations, you guessed it. So they won the game because they still had 2 tries left. It's a basic type of simple game where you're going to need to use if statements. You're going to need to use while loops. So you're going to need to use a loop in this because you have to keep asking for input until the user guessed correctly or until the number of tries was over 5. So one of the best ways to start a program like this is to write down how you're going to create the program on paper. And I would suggest you do that because if you write down how you're going to attack the problem on paper, it's going to be easier to solve. And you can write it out in pseudocode, so it's just English language, but you want to identify where you're going to have the loops and where you're going to have the if statements to check for conditions. Because if you look at this output, there's many conditions that you have to check for. Right? The while loop is going to check for conditions, or the for loop, it's going to check to make sure that it exits the loop if you guess correctly or if you're higher than 5 for tries. You're going to have conditions to also validate what they entered. So you're going to have an if statement to say, hey, you just entered a number, and if it's not between 0 and 20, and that may be, you also may want to have a nested loop for that case, right? Because you want to keep asking them to enter another number until they enter a valid number. Not the correct number that you guessed, but a valid number. So I could see for this program an outer loop. The outer loop would be the loop that asks the user to enter numbers until they have successfully guessed the correct number or until they have succeeded their number of tries. I could see an inner loop where it asks if the number is not valid between 0 and 20, they keep asking the user to enter a valid number. And then I can see if statements to basically check whether or not the number is too low, too high, or equal. You could also, because you have multiple exit conditions for your outer loop, whether or not you guess correctly or whether or not the number is equal, that may be a good case for using a break statement. Because remember, you use the break statement when you have multiple exits. And so you could have something inside your outer loop that says, if they guess correctly, jump out. And then the condition in the while outer loop itself, in the while loop or the for loop itself, the condition to exit would be whether or not the number of tries is greater than 5. So that's one design approach. I mentioned many things. The only thing left, you have everything at your disposal if you learned everything I mentioned except this random number generator. This is new. You know how to do if statements, you know how to do loops, you know how to declare variables, you know all these nice things. You know how to print output to the display, but you don't know how to do a random number generator. So I'm going to give you the code for that. You need to generate a random number because each time you run the program, you want to have a new number that they can guess. So to generate a random number from 0 to 20, these are the steps that you have to follow. First, you have to include 2 additional libraries, the standard lib.h, time.h. So you want to add these include directives at the top of your file. Standard lib.h will allow you to use the srand function, which allows you to generate random numbers. Time.h allows you to provide the seed for the random number using the time, getting the current time. So when we include additional libraries outside of our program, it just means we want to perform some additional functionality. We haven't talked about all the standard libraries that C comes with, but they come with 2 nice ones to get the current time and also to generate a random number that we're going to use. So we include those first 2 directives at the top. Then we're going to create a variable inside of our main function called time_t, and you can just name it t. You add that. Once you add your time variable, you can initialize your random number generator using the srand function. So what you do is you say srand. This provides a seed to the random generator. It's just used to initialize it. And here you just copy this line of code, srand, parentheses, unsigned, right parentheses, and then time, and then you pass an ampersand t. Don't even have to understand what this code does. Just copy and paste it. But it is generating it's initializing the random number generator. After you've initialized the random number generator, you have to generate the number. And all you do to generate the number is you say rand, you call a function named rand, and you say %21, that's a module. because you want it to be between 0 and 21, you use 21 hard-coded. You can store that random number in an integer, and that's the number you're going to compare against to exit the loop, whether or not they guessed correctly. It's also going to be the number that you compare against to determine whether or not you print too low or too high. So this should be a lot of fun. Again, a lot of concepts you're going to be exposed to. If statements, looping constructs, the break statement, inner and outer loops, nested loops, a lot of nice stuff. So good luck, have fun, and I'll provide a solution in the next lecture. Thank you. Hello and welcome. I'd like to provide a demonstration solution to our previous challenge, which was implementing a guess a number type game. So let's bring up code blocks, close my current project, and create a new one. This new project I'm just going to call guess number game. Oops. And it's going to be a console application. So I'm just going to call it guess the number. And what I'm going to do in this, to start this project, is I'm going to declare my variables. I always like to declare and initialize my variables at the top. But I also am going to use the random number generator, so I want to make sure that I have a couple includes. Standard lib is already there by default, so all I need to do is add my time.h. Because again, this is for random number generator. This is basically for the random number generator seed. The other variables that I'm going to need in this program is, I want to store my random number, so I'm just going to say random number. I'm going to initialize that to 0 until I get it from the actual library. So declare initialize. I'm going to create a variable to store the guess from the user, and I'm going to initialize that with 0. I'm going to create another variable which is going to be the number of guesses, the current number of guesses. Or actually, I should say maximum number of guesses. Maximum number of guesses. And I'm going to initialize this to 5 because they can only guess 5 times. And I also have to create a time variable so that I can use it for my random number generator. So I'm just going to say time t. First thing I want to do before I ask the user for input is I want to generate the random number. I guess I could do this after asking the user for input, but it's just as easy to do it the first thing you do it. So I'm going to initialize my random number generator. I'm going to put a little comment in there. Make sure you use good, meaningful names. And make sure you indent. So initialization, is it spelled wrong? Yep. Got an I again. And this is all this is going to do is it's going to use that srand function that I talked about in the lecture. You can just pass it in a seed, essentially. So I'm going to say unsigned, and I'm going to just pass in my t variable. This is going to get time as a function that gets the current time. I'm going to pass in the t so that it seeds it. And then I'm going to end it. Now I actually need to get my random number generator, so I'm going to say get the random number. And all this is going to do is assign a variable to what's returned from the rand function. So I'm going to say random number, which is my local variable, equal to, I'm going to use the assignment operator, say rand, which is calling a function. You don't need to know any of this, but I'm going to seed it with 21. This will ensure that my random number is only between 0 and 20. Okay? Now I'm going to just output a couple messages to the screen so that the user knows what they're doing. So I'm going to do a printf, and I'm going to say, I'm going to make sure I have line feeds. I'm going to say this is a guessing game. And then I'm going to also tell them that I have chosen a number between 0 and 20. Again, just so they're informed. And then 0 and 20, which you must guess, and end it with a line feed. All right, now that I told them what I want in the game, I'm going to actually start looping. And I'm going to loop until my number of guesses is equal to 5. So what I would actually rather do is, I want to declare my number of guesses up here, but I don't want to initialize it. I want to initialize it in my loop, just to show you that I can do that. If I did initialize it there, I could just keep the first before the first semicolon in the for loop, I could keep it empty. So for example, I could do something like this, initialize it up here, and then in my for loop, I would just put a semicolon because I don't need to do any initialization. Because remember, in our for loop, the first thing you have before the semicolon is the initialization of the loop control variable. I've already initialized it, so I don't need to do it. But I don't want to do that. I'm going to just declare it up here, and I'm going to initialize it down here. I'm going to say maximum number of guesses equals 5. That's my loop control variable. I'm going to initialize it. I'm going to jump out of the loop if my maximum number of guesses is reached. So here I would say actually, I'm going to write it a different way. I'm going to write it so that the loop goes from 5 to 0. So if my maximum number equals 5, then I can just say my maximum, and maybe it will be better to rename this variable. Let's rename it and say number of guesses. And the number of guesses is going to start off as 5. And when I get to, and I'm going to make this go backwards. And when the number of guesses is 0, I want to jump out of the loop. So in my loop exit condition, I'm going to say number of guesses is greater than 0. See what I'm doing here? I'm only going to jump out of the loop if I have no more guesses left. So if I'm greater than 0, I'm going to stay inside the loop. And then my last thing I want to provide in the for loop after the second semicolon is modification of that loop control variable. So I'm just going to do a minus number of guesses. And what you should notice in this for loop is that I'm going backwards almost. I'm starting at 5 and I'm going to 0. For all the examples we provided in the lecture, we start at 0 and we go up. But you can do both. It doesn't matter. You're still iterating here 5 times. Now I want to display a message telling them how many tries they have left. So I'm going to say printf, and this is just going to be and actually I'm going to incorporate the ternary operator here since we haven't used it. You don't need to do it this way, but I'm going to do it this way just to show you how you can use the ternary operator. So here I'm going to print out you have %d tries %s left. And I'm going to put %d is going to be equal number of guesses. And tr%s, it's going to change. It's either going to be tries or it's going to be try. And so I'm going to change what's displayed based on how many guesses I have left. If the number of guesses is equal to 1, I don't want to print out tries. 1 tries left? That doesn't make sense. I want to print out 1 try. So here I'm going to use the ternary operator, or more precisely the conditional operator. I'm going to say if number of guesses equal 1, then set number of guesses equal to y, else set it to IES. And I'm going to print it. That's what the %s is doing, whatever is returned here. So this is going to return either a y or an IES. And display the correct information. So I just did that just to be a little fancy, show you how you can use the ternary operator. Print out the right information. After I printed out the number of tries left, then I want to tell them to enter a guess. So I'll put some information and just say printf, please, or just enter a guess. And this will be a line feed, have a line feed. So enter a guess. And then I'm going to read in that guess using scanf. We know how to read from the keyboard. It's going to be an integer, so I'm going to do %d, and I'm going to put it in the guess variable. So I need to use the ampersand. There we go. Now I have to do my checking. I have to check if the guess is the guess that I'm concerned about. So here's where we can use we have another exit condition. I'm going to use an if statement. I'm going to say if my guess is equal to my random number, what do I want to do? Well, first I want to print out and tell them that they guessed correctly. So I'm going to print out Congratulations. You guessed it. What else do I want to do if they guess correctly? I want to exit the loop. So how can I exit the loop? I could put break. I could do a break. That will jump out of my loop. Now, if it wasn't equal, so I want to add an else if. If it's not equal, I want to check to make sure they validated their number. So before I said you could have a nested loop for validation so that they enter again. You don't need to do that. You can just have an if statement. So here I want to validate the number. If it's not equal to the random number, I want to make sure it's between 0 and 20. So if the guess is less than 0, or we're using a logical operator or two parallel bars, or the guess is greater than 20, which is basically checking for an invalid guess. If that is the case, and I'm not going to use a bracket because I only have one statement here. Brackets are optional if you only have one statement. So if they entered an invalid guess, all I'm going to do is printf. I'm going to print out, I said the number is between 0 and 20. And what will happen here is nothing. It's just going to print that out, and it's going to go to the next iteration. It's going to tell them how many tries they have left, and it's going to enter a guess. Now, if you didn't want valid numbers, if they entered valid numbers not to count as a guess, then you can have a nested loop. But since we're going to count if they entered something 25, it's still going to count as a guess. So I just say, I set a number between 0 and 20. If they entered a valid number, but it wasn't correct, that would be the else clause. Here, I'm just going to say, sorry, wrong number, and I'm going to tell them whether it's greater than or lower than. And I could use the ternary operator here, but I'm not going to. So let's add an if here too. Else if guess is, or I should say, if random is greater than guess, then what do I want to print? I want to print out, sorry, %d is wrong. %d will be their guess. My number is, %s is first word, is, if the random is greater, my number is greater. My number is greater than that. And I don't use the %s, and I just have a line feed. Right? Else, if the random number is less than guess, then I want to tell them it's lower. So I can do the copy and paste the same thing. I could say, sorry, number's wrong. My number is less than that. And again, you could actually put these two else ifs. You could have one else if, and you could actually make a ternary, a conditional statement here. You could have the ternary operator. But I'm going to use two else ifs and say it's less than that. And then that's going to be it. That's going to end the loop. And if we get outside of the loop and we didn't guess correctly and we exceeded our number of tries, then I'm just going to tell them that they had 5 tries and they didn't guess the number. And I'm going to tell them the number. So a last output to the user to tell them that they didn't win the game and tell them what the number was. So you have had 5 tries and failed. The number was random number. Okay, so does that make sense? We're doing a lot of things here. We're using if statements, else statements in a loop. And we're implementing the number game. And then the last thing is we return from the main function. So let's go ahead and compile. And what should you have been doing throughout this whole exercise? You should have been testing and working in small chunks. You probably should have started working first, just get the random number to work. And then test and compile. Compile and test. Then start your loop. Make sure your loop runs for only the number of guesses. 5 times max. And then get that to work and test. Then ask the user to enter some information. Get that to work and test. Then compare to when to exit. If they guess correctly, test. And then write your if statements, test. That's how I would implement. So let's build this and see if it compiles. Hopefully I didn't make any mistakes. I'm going to say build. I do have an error. I have a invalid number. It has to be random number, not random, because that's the name of my variable. Try it again. And this time I have 0 errors, 2 warnings. I have a %d expects a matching int. I forgot to put out the random number, or the guess. The guess here, and the guess in the other one. I want to tell them that their guess was, sorry, guess was wrong. Don't have to do this, but just a little nice thing. Now let's build it, because you always want to fix your warnings. You want to have 0 warnings, 0 errors. Now when we run this, we have to test. And there's many different test cases you want to run here. You'll want to run multiple test cases, because remember, it's never good to just test one thing. So here it says, this is a guessing game. I have chosen a number between 0 and 20, which you must guess. You have 5 tries left. So I'm going to put in 16. Sorry, 16 is wrong. The number is less than that. I'm going to try having it. 8. 8 is wrong, less than that. I'm going to do 4. 4 is wrong. My number is greater than that. Oh, I made a mistake. I didn't read that first. So it's greater than 8. Let's try 12. I only have 2 tries left. I guessed it right with 12. So it says congratulations. But you'll also want to test a failure. You'll want to test a few things here, but here let me test, and I'm going to say my guess, and I'm just going to put in 0. 0 is wrong. I'm going to keep putting in 0. And there, I guessed 5 times. I was wrong. It says you have had 5 tries and failed. The number that you wanted to guess was 3. So that works. Now let's test to make sure what happens if we enter invalid numbers. If I enter 45. I said the number is 0 and 20, so that's another test case. And it counted as a try. If I didn't want that to count as a try, I could have a nested loop. I think that's about it. We've tested all the cases. We tested the cases where you guessed successfully. We've tested the case where you didn't guess successfully. And we tested the case where you entered an invalid number. And I don't think... Maybe the only other test would be is if you... to make sure that it was saying greater than and lower than. Which I think we tested in the first one, what actually told us to enter lower or greater than. Right? So let's try that. So on this time, I'm going to enter 20. It says less than, which is good. Now I'm going to enter 10. Oh, and I guessed it. So I guessed it quick. But we should see less than and greater than in the same output. Try it again. And the random number is working because I'm generating different numbers each time I run the program. 20 is wrong. Now let's try 19. Okay, let's try 1. And it's greater than that. So I see greater and less than, so I'm pretty good sure it's working. Looks pretty good to me. One thing you should have noticed, there was a little bit of a bug in the program. I was kind of testing you. So when you ran it, because we have this break in here, it's still going to print out that I failed, even though when I succeeded, right? So you should have noticed that in the previous output. I guessed the right number. It printed out congratulations, but then it also printed out I failed. Well, that doesn't seem right. So the way to fix that is you don't want to have a break there. You want to have a return. And so now when it returns, it's not going to print out on line 39 if you win. It's not going to print out that you failed. So one last test, and you should have caught this earlier, but when we build and we guess correctly, it's not going to display an error. So we can save run. And when we run this one, you have 5 guesses. I'm going to say, 10. Less than that, we're going to say 6. And I guessed it. And you'll notice there it says congratulations. We don't see that extra output that says I also failed. So you want to make sure you add that return on line 30 so that the program runs correctly. You could add another if statement if you wanted to so that it doesn't print out the printf. You could have had a break here, and then at printf you could have checked how many guesses you had to also determine if it was less than 5, then congratulations. But a little bug there, and hopefully you noticed it in testing. The return will fix it. So neat little program. I hope this helped you learn a lot about the looping and all of your decision statements and really problem solving. Hopefully you got this out and designed this before you actually started writing code. That's always important. Hope this helps. I'll provide the source code so you can compare it and see and analyze it. Thank you. Hello and welcome. In this lecture, I want to talk about the concept of an array. An array is a concept that allows you to store many different values in a single variable, essentially. Arrays are common in most programming languages. They help simplify and make your program a lot more efficient. So we're going to talk about creating and using arrays in C. So an array, it's very common in a program to store many data values of a specified type. In a sports program, for example, you might want to store the scores of all the games or the scores for each player. Now you could, up until this point, we could easily implement that, but we'd have to write a different variable for each score. So imagine if there's a ton of games. In baseball, there's 162 games. If we were to write a program that was a baseball program that wanted to store some stats or something, we would have to create 162 variables for each game to keep the score. Now that is a pain in the butt. It would be very tedious, and it's really just too much. So this is where array comes into play. An array will solve this problem. You don't have to create 162 variables. You can create a single variable and access it a certain way. So arrays allow you to group values together under a single name. You don't need to separate variables for each item of data. So it's going to allow you to become a much more efficient programmer. An array is a fixed number of data items. They're all of the same type. So the only one issue with an array is that you can't change the size of the array. Once you create the array, it's always going to be that size. And the other restriction is that you can't store multiple types of data. If you declare an array and it's still going to store numbers and ints, it has to store ints. So a couple limitations. How do you declare an array? Remember that when you declare a variable, what are you doing? You're saying that this variable exists in the program, and when you're declaring these primitive data types, you're allocating memory for it. When you declare an array, the data items in an array are referred to as elements. So this is another concept when you think of an array. If I'm saying the term element, that means I'm referring to an item in the array. Because remember, an array is going to have many, many different values, but with the same name. And as we mentioned, the elements in the array have to be the same type. You can't mix and match data types. You can't have an array of 5 ints and 5 longs. There's no such thing as a single array of multiple data types. Declaring to use an array in a program is similar to a normal variable declaration. All you have to do is specify the name and then use brackets. So that's the only difference, this idea of square brackets following the name. Here's an example. This looks like a normal variable declaration, but what you see here is you have these brackets. That's the one thing that's not normal, and there's a number inside them. The number inside the brackets are specifying the size. So here we're just saying we're going to create an array named numbers of type long that's going to contain 10 elements. So it's pretty straightforward. This is an array declaration. Because the semicolon is at the end, it's just like a variable declaration, but you have those brackets and a number. And this is the size of the array or the array dimension. Once you've declared an array, you're then going to want to start using it. You're going to want to start accessing the data inside of it or writing data to it. In order to do that, you have to understand how the array is stored in memory and how it's actually going to be accessed. So an array, with each of the elements in the array, each of the data items, they're accessed using the same name. So you're still going to access it with the variable name. However, if you want a specific value in that array, you're now going to have to use something called an index or a subscript. Both of these terms are used interchangeably. This index or subscript value is going to be a number, and it's going to be inside the brackets as well to access an element in the array or write to that spot in the array, write a value following the array name. So index values are sequential integers that start from 0. All right, so when we talk about an array and its elements, and we talk about the indexes in an array, or the subscripts, all those subscripts start from 0. This is basically saying that the arrays are 0-based. So index values for elements in an array of size 10 would be from 0 to 9. 0 is going to represent that first array element. And 9 is going to refer to the last element in an array of size 10. So you have to understand this concept of zero-based arrays. Intuitively, you might think, oh, I want to access the first spot in the array. Okay, I provide index 1. No, because they start at 0. So it's very, very common to mistakenly try to access an array and be off by 1 because you think that they start at 1 and they don't start at 0. This is referred to as an off by 1 error. You can use a simple integer to explicitly reference the element that you want to access. When you access an element, for example, if you want to access the 4th value in an array, you would say the array name, and then inside the brackets, you would say 3. So array name sub 3 is going to access the 4th value because the array name is 0-based. So you just have to provide a number for the element that you want to access. And again, remember that it's 0-based. So to access the 4th element, it's 3. If you want to access the 8th element, you do index 7. You can also specify an index for an array element by using an expression. So you now only have to use a number. You can use an expression in square brackets following the name as well. However, the expression has to result in an integer value that corresponds to one of the possible index values. Right? So if you have an array of size 10 and you use an expression, that expression has to evaluate to either 0, any numbers from 0 to 9. It's very common also when you're storing elements in an array to use a loop to access them. And we're going to go through an example of that as well. So for example here, we have a loop, a for loop, and we're initializing our loop control variable to 0, I, and we're exiting once I is less than 10. And what we're doing here is we're just displaying the numbers in the array. And so we're saying printf number is %d and then numbers sub I. I is a variable. You can use a variable in a variable expression as long as that variable represents a number from 0 to 9. And in this case it does. It's very common to use for loops to iterate over an array, to either access the elements or write data to those elements. So to summarize, here's a nice little illustration that I found. This is how an array is structured. If I have an array called numbers, you're going to have the name of the array followed by brackets, which identify individual elements in the array. So I can declare an array by just specifying the type and the name, and then specify the size inside brackets. And then when I want to access it, I just use the array name followed by the index value. And so for an array that has a size 10, you're going to have indexes that are valid from 0 to 9. So what happens if you try to access an element in the array with an invalid index? For example, trying to access an array of size 10 using 11 as an index or 10 as an index. You're going to have an array out of bounds error. So if you use an expression or a variable or a constant for an index value that is outside the range of the array. And outside of the range array means what? Well, it means it's either a negative number or it's a number that's greater than the size. Really greater than the size minus 1 because they're 0-based. So if you have an array of size 10, size minus 1, if it's greater than 9, you're going to have an array out of bounds error. And the problem with an array out of bounds error, it can cause your program to crash. Or even worse, it can cause your program to look like it's acting normal, but then it doesn't act normal. So it doesn't produce consistent results. Sometimes you'll have garbage data that doesn't mean anything in the array. Again, it's very unpredictable when you have an array of bounds error. And the issue is that the array out of bounds error cannot be checked by the compiler because the compiler is not going to know if you're assigning something greater or if you're accessing something greater than the size. It's still going to compile even though you have this array out of bounds error. Essentially, the array out of bounds error is a runtime error. You're not going to find out this error until you run the program. And again, it can cause your program to be very unpredictable. So you want to be very, very cognizant of how you're accessing the array, what index values you're using, and how you're writing data to the array with the index value. Pay very close attention to the array indexes and also the bounds. if you want to write data to an array, it's very, very simple. You're going to do basically just use the index. So a value can be stored in an array element simply by specifying the array element on the left-hand side of the equal sign, and then using the brackets to specify the element that you want to write to. So for in this example, we have an array named grades. We don't know what size it is. It's got to be bigger than 100, or else we'd have an array out of bounds here. But in this example, we're saying grade sub 100 is equal to 95. The value 95 is stored in the element number 100 of the grades array. Very simple. You just specify the index, and then whatever value you want to assign, you do. You can also use variables to assign values to an array. So 95 could be stored in a variable, just like you assign other variables. Now let's go through an example of using an array. Here's an example of using an array that is going to read in 10 numbers, and then give me the average of those 10 numbers. So we're going to, as we're reading them in, we're going to calculate the sum, then we're going to display the average. So at this point, I want to take this example and I want to put it in code blocks and try to run through it and show you how it works. All right, we're in our normal view. We're in a simple project, and we're going to show you how an array works in code blocks. You'll notice that we're in our main function. This is the entry point to the program. And on line 12, we're declaring an array. We're going to declare an array of type int of size 10. The size is inside the brackets. We end it with a semicolon. This is an array that's going to store 10 values. If we didn't have this array stored, what we'd have to do is we'd have to say grades 1 int grades 2 int grades 3. You see how problematic that is and how very tedious it is. It's very nice that we can simply create a single variable that stores 10 items, and they're grouped together. When you store items in an array, you don't want the values of the data to be different, all different things. Like in this example, we're storing grades, so they're all grades. You don't want to name an array something and then say, oh, I'm going to store my grades, I'm going to store my whatever, my age in there, and my anything. Make sure you store the same type of data when you're in an array. The next variable in line 13 is a count variable. It's equal to 10. It's going to be the number of values to be read because we're going through the array. Sum is we're going to sum the numbers as we go through the values. And then average is going to be a float because we want to get the average of the numbers. First thing we're going to do on line 17 is we're going to tell the user that we want to enter 10 grades. And then we're going to read in the values. So on lines 20, and you notice how I'm indenting and I'm using good naming. Indent and use good blocking of code. For blocks of code, indent. Here on line 20, I'm declaring my loop control variable. I'm running an older compiler, C compiler 89, so I can't declare it and initialize in the same line. Normally you would just do this, but when I do it, because I'm running C89 compiler, I get an error. I have to update that. So I declare my variable on line 20, and then I use a for loop. We're familiar with for loops from our previous lectures. Allows you to repeat code. Here we're just saying we're going to have a counter-controlled for loop. We're going to start at 0 and we're going to go all the way until 10. So we're going to go through 10 iterations, but you notice the index is 0. That's important because we're going to be accessing an array using that variable I. And then you'll notice in the end of the for loop, we modify the loop control variable by incrementing it. So we're going to print out the value of I plus 1 as we go through the array to show you where you're at for the numbers. So it's going to basically say like enter grade 1, grade 2, grade 3, grade 4. It's then going to ask you to enter in the grade using scanf. We're going to store it in our array. You'll notice that when you store it in the array, it's just like a normal variable access. You just use grades and then you specify the index. Here we're using I as our index. So that's going to be equal to 0 the first iteration, 1 the second iteration, 2 the third iteration. And it's good we started with 0 because arrays are 0 based. And then we just use the address of operator, the ampersand. As we're going through, we're going to sum the grades together. So we're going to say sum equals sum plus grade sub I. Each grade is going to basically calculate a total. And then once we get out of the loop after running 10 times, we're going to set our average equal to the sum divided by the count and cast it to a float. We're casting here. This is changing the data type. Remember, sum divided by count. Sum is an long and count is an int, and we want to cast that to a float. And then at the very end, we're going to print out the average. So let's go ahead and run this and make sure we get no errors, which we have 0 error and 0 warnings. So now let's run it. And so it's going to do exactly what I mentioned. It's going to say enter the 10 grades, and then it puts a 1 in a little mark there so we know what number we're at. It's going to put in like 95, 32, 655. It's going to go in and just put any numbers in here. They don't make sense necessarily. That's okay. And my last number, 23. The average of those 10 grades is going to be 51.20. But it's really nice because we don't have to create 10 variables. We access the array using the subscript, and we can assign values to the array using the subscript. This is actually assigning, when we do the scanf, we're assigning data to that subscript. Now, if we were to change this and say we started at 1, and instead of going to count, which is 10, we actually set it equal. So actually, let's not change that to 1. Let's stay, we're going to start at 0, but now we're going to go all the way to index 10. Remember, index 10 is out of bounds because the size of the array is 10, but the index value is 0 base, so that the max index is 9. And again, we're going to be able to compile this because compilers do not detect out of bounds errors. The problem is when we run it. Now when we run the program, we're going to have a big problem when we try to enter an 11th grade. So we're going to be all good until when we enter 10 grades in. The problem is going to happen when we get to 11. Oh, now we have 11 and we're going to try to store data. Nothing bad happened, but our average is not going to be correct. And it's very unpredictable behavior when you have an out of bounds error. So you want to make sure that you have the I less than count, and you want to make sure that when you access the information, you don't go out of bounds as well. And this is the basics of the array. Declaring the array, specifying the size, so just data type, and then the size in brackets, accessing the array or storing data in the array, assigning values, just using the subscript, I, inside the indexes. And we could even print out the indexes using the subscript as well. Arrays are going to be used quite a bit. We're going to have many examples with arrays because it simplifies things. Just remember, arrays are a fixed size. You can't change the size of the grades array. It's always going to be 10 as you run the program. So if you assign any data above that, it's not going to expand. And also remember that grades have to be the same data type. I can't store strings or words in grade. I can only store ints. I can't store floats in there. Only store ints. Thank you. Hello and welcome. In this lecture, I want to talk about initializing an array. We know how to use an array. We know how to create an array. But specifically, what if you want to assign specific initial values to the array? How do you do that? So you want to assign initial values for the elements of your array most of the time. The reason that you want to assign initial values to an array or even to variables is because it makes it easier to detect when things are going wrong. When you don't have initial data and you try to do something, you can cause problems in your program. So initialization is a very good thing and you always want to do it. And using an array, there's many elements in an array. And so there's a specific way that you can initialize those elements. There's different syntax that you can use. But initialization is a good thing and you always want to do it. I wanted to quickly talk about how you can do it in an array because there's different ways to do it. So just as you can assign initial values to variables, when they are declared, you can also assign initial values to an array's elements when it is declared. To initialize an array's values, you simply provide the values in a list. The list is separated by commas and the entire list is enclosed inside a pair of curly braces. It looks something like this. Here we're creating an array named counters. It's of type int. It has 5 elements. And then what we're doing is we have the curly brackets and we're not using any indexes in here. You'll notice that we just have numbers separated by commas. What this is doing is it's setting all 5 elements in the counters array to 0. Each of the elements are 0. If we have another array, and we name this array integers, and it's also of size 5, and then we have in our curly braces after the assignment operator 0, 1, 2, 3, 4, what that is doing, it's assigning integer, the first element in the integers array to 0, the second element to 1, the third element to 2, the fourth element to 3, and the fifth element to 4. It's nice syntax where you can immediately initialize the array right when you declare it by just providing numbers separated by commas inside brackets, and you want to do this. It's also not necessary to completely initialize the entire array. So in those 2 previous examples, we initialized all 5 elements of an array of size 5. Well, what if you only want to initialize some of the values? If you provide initial values that are not equal to the size of the array, then the remaining values are set to 0. Okay, so if you do something like this, where you have an array called sample data of type float, it contains 500 elements. But in the curly braces, all you see here are 3 elements. What this is going to do is it's going to initialize the first 3 values of the sample data array to 100, 300, and 500.5. And then the remaining 497 elements are going to be 0. So you don't have to specify everything. I'm sorry. There's also this concept of a designated initializer. This was introduced, I believe, in C99. It's a nice little feature that where you can pick and choose your elements that you want to initialize. It's not supported. I think in C99 they added it, and then in C11 they made it optional. So depending on what compiler you have, you may or may not be able to do this. But I want to mention it because it is somewhat common. Some compilers will not allow you to do this after C99. But it's cool because you can actually just pick and choose. So you can enclose an element number in a pair of brackets and then specify the array elements that can be initialized. And you can do it in any order. So here's an example. Again, we have our sample data array. It's of type float. It's going to be 500 in size. But here, inside of our curly braces, we have additional indexes. We have our brackets in 2. It says brackets 2, sub 2 equals 500.5, sub 1 equals 300.0, and sub 0 equals 100.0. They're separated by commas. All this is doing is it's specifying the same thing that we had in the previous example, but it's doing it in a different order. But you're still going to have element 0, or the first element equal to 100, the second element equal to 300, and the third element equal to 500.5. But we're specifying what index to initialize right in the curly brackets. Another example here, we have an int array called ARR. It's of size 6, and when we declare it, we're initializing the 5th element, which is the last element, to 212. All the other elements are going to be 0. So here's an example of traditional initialization, where you just declare the name of your array, and you supply many different numbers. In this example, we're declaring an array, and it's going to store all of the days in every single month. And so when we go through this array and we print it out, which is very common, you typically use loops to print out elements in an array, or at least iterate over them. What we're doing here is we're just going to print out each month and how many days it has. So let's go through this in code blocks to show you the output. So here's our example. We have days and months, and we're initializing the array, the first element to be 31, next 28, next 31. You also notice up on line 10, we're using a define to create a constant. And by the way, in C, you can also use a constant keyword, which we'll talk about in other things. That's another way to create constants. But right now, we're just talking about arrays and initializing them. Very easy to do. Separated by commas inside curly braces. So what this is going to display is it's going to go through the array, and it's going to look at index plus 1, and then days index. So it's going to say month 1 has how many days, depending on what the values are. So we're accessing the index by the array name and then the subscript value, the index value. And we're using an array. So it's a variable that changes through each iteration. So when we try to run this, the output that you're going to see is month 1 has 31 days, month 2 has 28 days. It kind of represents January, February, March, April, but it just goes through the array and prints the days out. So this proves that the initialization works. And again, you will want to initialize your data. Now let's talk about another example and talk about repeating initialization elements. So here would be another example, but in this example we're going to use a designated initializer. We're going to specify the exact elements that we want to initialize. So the main line that you should notice in here is the one that says int days and months, where we're doing our initialization. You'll notice inside the curly brackets that the first element gets 31, the second 28, but then there's something inside brackets that says 4 is going to get values 31. It's going to get value 31. Then we have a comma. Element 5 is going to get 30. Element 6 is going to get 31. And then we have 1. This means we're now going to overwrite the 28 and we're actually going to put a 29, put it as 29. So it's kind of redundant here. We don't really need to do that, but you would really remove the sub 1 because 31 and 28, sub 1 is already assigned here. But it looks like we're saying it can also be value, sub 1 can also be value 29. So this is just using the designated initializers. What about if we want to repeat the same value? Now in C, you can always initialize the entire array of the same value if you specify 0. You can always initialize, that's like the null parameter. But other than that, C doesn't provide any shortcut mechanisms for initializing array elements, at least not in C89. You may see in C11, again, where you can initialize the same value to the entire array just using the brackets with no subscript, just the number. But right now in C89 and C99, there's no way to specify a repeat count. There's no way to say all the elements of this array should be the value 55, for example. So if it were desired to initially set all 500 values of the sample data to 1, all 500 would have to be explicitly assigned, which would be a big pain in the butt. So what you'll end up doing is you'll just put them inside of a loop. Easiest way to iterate through an array, use a loop. Well, here's a quick example of how you can initialize all the elements to the same value. In this case, though, we're initializing the first elements to 0, 1, 4, 9, and 16. So this is really just initializing all the remaining elements to a value. Elements, essentially the 6th element to the 10th element using index 5 to 9. So that's what this for loop is doing. The first for loop is saying that we're going to initialize elements from 5 to 9 to be I times I. And then the second for loop here, it should be indented. It's harder to read. The second for loop is actually going through the entire array and just displaying the data to show you that the last 5 values were actually initialized. So whenever you want to repeat the same value or initialize to different values, just use a loop. Again, initialization is important. You will want to initialize, so make sure that this syntax is second nature for you, because we will be using arrays quite a bit in C. Hello and welcome back. I wanted to give you another challenge, another assignment. Obviously, this one's going to be all about arrays. I want you to get familiar with how to use an array, how to access an array, and how to create an array. So you should write a C program that's going to find all the prime numbers from 3 to 100. And we're going to do it very efficiently, so we're going to use a little algorithm that makes you use an array. But very simple program. It's just going to display as output all the prime numbers from 3 to 100. And the reason you don't do 0 to 3 is because you're going to hard code those. It's pretty simple. First two prime numbers are 1 and 2, right? That are non-zero. So there's going to be no input to this program, just output. And the output's going to be each prime number separated by a space on a single line. It's pretty basic. All the way up to 100. You're going to need to create an array that will store each prime number as it is generated. You can hard code the first 2 prime numbers, which are 2 and 3, in the primes array. So what I envision here is that you would create an array, you would name it primes, and you would just hard code the first 2 in there. And it's important to hard code them too, because the algorithm that we're going to use to find prime numbers is going to compare for any other prime numbers. And I'll explain that in a second. You want to utilize the loops for this assignment to only find the prime numbers up to 100. So right off the bat, you should envision a loop at least to display the prime numbers that you found. So that would probably be the ending loop, the loop at the end of your program that just goes through the primes array and displays everything that's inside there. Now, if you're finding all the prime numbers up to 100, you're not going to need to make the size of the array probably more than 50, because I don't think there's more than 50 prime numbers all the way up to 100. But you're not going to be able to set it exactly correctly because you don't know how many prime numbers there are. So I would say when you create the primes array, just make a size of 100. So you're definitely going to need a loop to print them out at the end. You're going to need another loop to try to find the prime numbers. And you can find the prime numbers any algorithm you want, but what I would use is I would use something like this because there's more reason to use an array if you do this algorithm. So the criteria that can be used to identify a prime number is that a number is considered prime if it is not evenly divisible by any other previous prime numbers. And there's also more to that algorithm, but that's the starting point. You also want to only look up to a certain number. So you can use the following as an X condition in the innermost loop. So again, what you're going to need to have here is you're probably going to need to have two loops. We already mentioned the third loop at the bottom, printing out the data. But you're going to need to have two loops for this assignment. And the algorithm that I'm discussing here is a more improved algorithm. So this is why you want to do it. Now, if you want to find prime numbers in a different way, that's okay, as long as you use an array, because the whole purpose of the assignment is not to understand prime numbers. It's to understand how to use arrays. By looking at the previously generated prime numbers, that forces you to use an array. And you'd store that each prime number as it gets generated, as I mentioned. And the other way that you can make it even more optimal is that you don't want to look at even numbers. So if you're going through each number from 3 to 100 and you're checking if that's prime, you can ignore the even numbers because even numbers are never going to be prime. So in the outermost loop or the innermost loop, you can check to see if the prime is divisible by the other primes or make sure it's not even. You can check that and skip it. And then this other exit condition in the innermost loop is to make sure that the value of the p does not exceed the square root of the primes. That's the other part of the algorithm. So this might not make full sense, but basically these are some of the criteria that I want you to follow. Skip any checks for even numbers, and then the algorithm is to look for any previous prime numbers that were generated, and also to check whether or not p does not exceed the square root of the primes, because that's another way to check for a prime number. So you're going to need to have a for loop, which basically goes from 5 to 100. And then you can increment that by 2, so that you only look for odd numbers. And then in an inner for loop you have inside there, you're going to want to go from 1 until this other value, p divided by prime sub I, is greater than or equal to prime sub I. And you'll probably also want to make sure that the number is not prime. So you don't want to exceed a certain check, and then you also want to jump out of the inner loop if you actually found a prime number. And so the way that you can check for prime number, if your current number is divisible by any previous prime, so you can look at the primes array, and if the modulus for that is equal to 0, then you don't have a prime number. Otherwise, if you've done this whole check in this entire loop and you've got out of there with already exceeding the prime sub I is greater than prime sub I, the square root issue, and you not actually found a prime number, then that means that you can then add, you've actually never set it to false, you can actually add that prime number to your primes array. And then just print out the primes array. So the actual algorithm doesn't seem as confusing as I'm making it. Again, try to give you as many pseudocode hints there as possible with the outer for loop and the inner for loop. But you're going to need to access arrays, you're going to read arrays, you're going to look at an array to see previous values. It's going to get you really familiar with arrays. So good luck, and I'll provide a solution in the next lecture that will make a lot more sense. But these are the requirements and some hints. Thank you.